Hey everyone, welcome to this Machine Learning with Python full course by MindMajix, where we take you from absolute beginner to advanced machine learning expert. If you ever wondered how Netflix recommend movies, how Google translate languages, the answer lies in machine learning, and that's exactly what you will learn in this course. In this video, we will cover linear regression, decision trees, clustering, neural networks, and more. All explained using Python, the most popular programming languages for machine learning and data science today. But why machine learning is so important right now? Because machine learning is the backbone of artificial intelligence and it's being used everywhere like finance, e-commerce, cybersecurity and beyond. With every industry becoming data-driven, machine learning skills are now essential. And when it comes to the careers, the numbers speak for themselves. According to LinkedIn and Naukri, there are over 25,000 plus active job listings for machine learning roles in India. Companies like Amazon, Google, Flipkart, Infosys, and top startups are constantly hiring. As per Glassdoor and AmbitionBox, entry-level machine learning engineers in India earn around 6 to 10 lakh rupees per annum, and experienced professionals earn 20 to 40 lakh rupees per annum, especially if you combine machine learning with skills like deep learning or NLP. So grab your laptop, stay till the end, and let's build real machine learning models using Python. And if you want to learn paid machine learning training with certification, then check out our course where we will cover latest industry curriculum, hands-on projects, mock interviews, and more. Check the link in the description below. And now let's get started with our free course.
So what type of things we have to learn over here? So here in this particular module, we have to talk about machine learning use cases. In other words, you can also understand like machine learning use cases. Second thing we have to see about based upon a machine learning process. After, we have to discuss about how to become a machine learning engineer, also companies using machine learning techniques or the machine learning technology similarly look like artificial intelligence domain. And at the end, we have to discuss about pattern recognition. So let's start with the first thing, and that is based upon a machine learning use cases. Also, you will get an idea look like a machine learning application. So basically, machine learning are applied in the field of image processing, robotics, data mining, video games, text analysis, and healthcare. Also, many more domains are already available in the field of the machine learning technology. So let's get idea about one by one in a step ways. So let's start first of all with the first thing, and that is the image processing. So how machine learning can helpful in particular domain of image processing. Some of important application of image processing in the field of science and technology include the computer vision, remote sensing, feature extraction, face detection, forecasting, optimal character recognition, fingerprint detection, optimal sorting, augmented reality. It's also known as AR, also virtual reality VR. It's also similarly to look like that one. Microscope imaging, lane departure cautions, image tagging and recognition, OCR. So lots of popular applications are available with the image processing in the domain of machine learning technology. After talking about the image processing, next domain that is based upon a robotics. So how in the field of the robotics machine learning can helpful? Machine learning helps robot with dynamic interaction and obstacle avoidance to maintain productivity. Data with the help of the artificial intelligence and machine learning both help to robots to understand physical and logistical data patterns to be proactive and acting accordingly to their programming. So that's how machine learning can also gives lots of benefits in field of robotics. Second application, if you can see over here in a robotics, that is a car manufacturing. So nowadays, with the car manufacturing, the KUKA robotics company is much popular with the machine learning and artificial intelligence with the domain in part of the hardware of robotics. After talking about robotics, next application is based upon a data mining. So, the data mining is the process of uncovering patterns and finding anomalies and relationships in large data sets that can be used to make prediction about future trends. It is primarily concerned with discovering patterns and anomalies within data sets, but it is not related to the extraction of data itself. So that's how data mining is again one of the important part of the data science and the artificial intelligence. So that's why here we have to talking about some anomaly detection. Again, anomaly detection, this type of stuff is also part of the machine learning. Next application or the next use case is it's based upon a video games. So how machine learning or artificial intelligence can helpful in the game domain. So the most publicly known application of machine learning in game is likely the use of deep learning agents that compete with professional human players in complex strategy games. There has been a significant application of machine learning on games such as Atari, ALE, Doom, Minecraft, StarCraft, car racing, Pokemon Go. So there is lots of games are available nowadays on a on a Play Store that is based upon artificial intelligence and the machine learning. Next application that is based upon a text analysis. So let's talk about the text analysis and how it can relate it to the some sentiment analysis or some social media platform. Text analysis is also known as text mining. It is the process of automatically classifying and extracting meaningful information from unstructured text, and it was involved detecting and interpreting trends and patterns to obtain relevant insight from data in just a few seconds. So you already know what type of the social media platform is available like Facebook, Instagram, Twitter, Skype, and there is lots of LinkedIn is there and many more Tinder. So lots of applications are available in a social media platform to do some analysis based upon a sentiment analysis. So after talking about this all application, now we have to talk about the last use cases, and that is based upon a machine healthcare. So now we have to evaluate the things like how healthcare is important with the machine learning. So if we are talking about the current scenario, or if we are talking about the 2019 to 2020, 21, so still the 106 startups are transforming healthcare with AI. Today, machine learning is helping to streamline administrative processes in hospitals, map and treat infections, disease, and personalize medical treatments. It can also be used to demonstrate and educate patients on potential disease pathways and outcomes given different treatment options. So that's how we have to talk about the six main applications based upon the machine learning or also use cases of machine learning. So first we start with the image processing, then we talk about the robotics where KUKA robotics can do some hardware and software both with the machine learning type of techniques. Then we discuss about the anomaly detection or anomaly systems based upon a data mining. In video games, we have to talk about like how Pokemon Go and Doom and many more games are available that is based upon a machine learning and artificial intelligence. In text analysis, we have to talk about like how Facebook, Instagram, LinkedIn, Twitter are based. We can able to do some sentiment analysis. And in the last healthcare, we already know nowadays lots of startups are available based upon a healthcare, and they are also using machine learning things. So in the next session, we have to learn about the machine learning process. Let's start to discuss about machine learning process. Basically, machine learning process should be worked within 7 steps. So let's start it with the first thing related to the machine learning process. The machine learning process involves building a predictive model that can be used to find a solution for a problem statement. To understand machine learning process, let's assume that you have been given a problem and that needs to be solved by using machine learning techniques or the machine learning formula. The problem is to predict the occurrence of rain in your local area by using machine learning. The steps are followed in a machine learning process. So here let's talk about the step number 1 or the process, how to start the process. So step 1 or the part 1 is based upon a define objective. At this step, we must understand what exactly needs to be predicted. In our case, the objective is to predict the possibility of rain by studying weather conditions. At this stage, it is also essential to take mental notes on what kind of data can be used to solve this problem or the type of approach you must follow to get in the solution. So that's why whenever we have to talk about the defined objective, at the same time, we have to work upon a problem statement. After completion of step number 1, now we have to talk about the step number 2. Step number 2 that is based upon a data gathering. At this stage, you must be asking such a question like what kind of data is needed to solve this problem? Is the data is available? And also how can I get the data? Once you know the types of data that is required, you must understand how you can derive this data. Data collection can be done manually or by web scraping because sometimes we have to take in data from the website. That's why. However, if you are a beginner and you are just looking to learn machine learning, you don't have to worry about getting data. There are hundreds of data resources are available on the web, and you are easily download the data sets and you can go ahead with that particular one. So coming back to the problem at that hand, the data needed for weather forecasting includes the measures such as humidity level, temperature, pressure, locality, whether or not you live in a hill station or etc. Such data must be collected and stored for the analysis as well as. So after talking about the step number 2, now it's time to talk about the step number 3. And step number 3 that is based upon a preparing data. The data you collected is almost never in the right format. You will encounter a lot of inconsistencies in the data set, such as missing values are there, redundant values are there, duplicate values, and etc. Many more type of the impurities are available in a data set. Removing such inconsistencies is very essential because they might lead to wrongful computations and prediction. Therefore, at this stage, you scan the dataset for any inconsistencies and you fix them, and there you can done the same thing. So that's how in a preparing data part you have to work with the data, and at the same time your hand should be dirty to work with the data. Next step or the in this process, the next part that is based upon a data exploration. You can also understand this part as a exploratory data analysis. Grab your detective glasses because this stage is all about diving deep into data and finding all the hidden data mysteries. So here we have to find out some inside edge from our data sets. EDA or the exploratory data analysis is the brainstorming stage of the machine learning. Data exploration involves understanding the patterns and trends in the data. At this stage, all the useful insights are drawn and correlation between the variables are understood. For example, in the case of predicting rainfall, we know that there is a strong possibility of rain if the temperature has fallen low. So such correlations must be understood and mapped at at this type of the stage. So whenever we have to work with the exploratory data analysis or the data exploration at the same time, we have to given some more concentration to develop some exciting visualization and also find out some inside proper information. After completion of this step number 4, now we are going to talk about the step number 5, and that is based upon a building a model or building a machine learning model, because now it's time to coming to make some machine learning model. So all the insights and patterns derived during the data exploration are used to build the machine learning model. This stage always begins by splitting the data sets into two parts: training data and the testing data. The training data will be used to build and analyze the model, and the logic of the model is based on the machine learning algorithm that is being implemented. In the case of predicting rainfall, since the output will be in the form of the true, for example, if it will rain tomorrow, or false if no rain it's coming to tomorrow. So we can use the classification algorithm such as logistic regression, because logistic regression are working as a binary classifier. So we can get an idea if the output will come, so rain will come. Otherwise, if output will zero, so rain will not come. So that type of stuff you can make it in based upon a logistic regression. Choosing the right algorithm depends on the type of problem you are trying to solve, the dataset, and the level of complexity of the problem. In the upcoming sections, based upon different topics, we will discuss the different type of problem that can be solved by the machine learning techniques. After discussing about the step number 5, now it's time to talk about the step number 6, model evaluation and optimization. So let's talk about what type of stuff we are able to do in this part. After building a machine learning model by using the training data set, it is finally time to put the model to a test. The testing data set is used to check the efficiency of the model and how accurately it can predict the outcome. Once the accuracy is calculated, any further improvements in the model can be implemented at this stage. Methods like parameter tuning and cross-validation can be used to improve the performance of the model. Also, grid search technique and random search type of techniques are also used to find out some proper accuracy or some proper optimization. So that's how we can complete the step number 6 based upon a model evaluation and optimization. And at the end, now we have to talk about the step number 7 that is based upon a prediction. So let's see what type of stuff we are able to do over here. Once the model is evaluated and improved, it is finally used to make prediction. The final output can be a categorical variable or the continuous variable. When we have to work with the categorical variable, at the same time we are having some condition based upon binary classification like 1, 0, true, false, yes, no, that type of thing. Or also it can be happen within some continuous quantity. For example, the predicted value of stock or also the weather condition like how much weather can coming tomorrow. So in our case, for predicting the occurrence of rainfall, the output will become a categorical variable like rain will come or not. So that was the entire machine learning process. Should start from the defining objective. At the same time, we can work upon a problem statement. Then we have to struggle with the data. So that's why data gathering. So we have to collect the data at the same step. Now we then we have to talk about the preparing the data, like how and which format of data we want. After we have to find out some insight. After getting insight, we have to spend some time based upon machine learning model making. Then we have to go with the evaluation and optimization, and at the end we have to coming with the prediction, like we are getting some output or not. So that's how machine learning process should be worked within this seventh step. In the next session, we have to talking about some real world thing related to how to become a machine learning engineer. Let's talk about how to become a machine learning engineer. Machine learning engineers are sophisticated programmers who develop machines and systems that can learn and apply knowledge without any specific direction. So let's simplify that one first of all. So you are getting better idea how to become a machine learning engineer. Also, we have to talk about if you want to become a machine learning engineer, so what type of things you have to develop in your own, in your thinking level. Okay. So first of all, let's talk about some basic things, and then we are going with the some thing and technical words as well as. So they are enthusiasts, like machine learning engineers are the enthusiast computer programmers, but their focus goes beyond specifically programming machines to perform specific tasks. They create programs that will enable machines to take actions without being specifically directed to perform some those of the tasks that is designed by machine learning algorithm. Well, we already know that the data science team is always coming with the full of ideas, because whenever you are talking about how to become a machine learning engineer, so as well as data science term is also very important are there, because the data science and machine learning are not having some long differences are there. There is they are having some similarities are there. Okay, so that's why we have to also understand about like how data science as well as should work. Okay, so the team of the data science is always coming with the full of ideas, and you have to make sure that no technology is limited them. As good and customizable as the current machine learning frameworks are, sooner or later your teammates will have interesting use cases that is not achievable with any of them. So well, not with the standard APIs, but when you dig into that internals, tweak them a little bit and mix another library or two, you make it possible. So you abuse the frameworks and use them. They're full of the potential things, and that requires the both extensive programming and machine learning knowledge, something that is quite unique to your role in the team as a machine learning engineer. And even when frameworks provides all you need programming wise, there still might be issues with the lack of computation power. Large neural networks take a large amount of time to train. This precious time could be reduced by an order of magnitude if you use GPU frameworks running or powerful machines. You are the one to scout the possibilities, see the prospects and also the concepts of various cloud options, and choose the most suited one based upon that one. Also, we have to talk about what are the highlighted things related to the machine learning engineer jobs. So, researching new technologies and implementing them in machine learning programs, finding the best design and hardware to use when building the robot or computers. Also, we have to developing the tangible prototypes to show the stakeholders, also putting the machines throughout the various tests to ensure the function are working as planned or not. So the first and the most important role to create the artificial intelligence product for the team, as well as when this is achieved, when we are able to create a machine learning models of our own. So for that we have to understand about some responsibility that will taken by machine learning engineer. So first responsibility is that as a machine learning engineer, we need to able to study some prototypes and then transform them into the applications. Second thing, it's related to the like we have to able to design and build our own machine learning systems. Third responsibility is that we have to be in position of machine as a machine learning engineer, where we put in some research to find the appropriate algorithms and tools necessary. Fourth thing, yes, we will be developing machine learning application based upon what's we required. The next responsibility is again depends upon what is important is to select the right data set and to find the correct data representations method. We also need to run machine learning tests and experiments to keep improving on our implementation for the use case. And last responsibility is again depends upon like we need to train the system for top notch accuracy, but sometimes you will have to retain them again based upon the changes of the requirement. Well, sure, now it's time you are easily getting idea about like how to become machine learning engineering, a machine learning engineer, and what are the responsibility are. Once you start the learning and begin cracking the basics, it's very simple, and time by time you are getting some better idea. So here if you can see, I had just only written over here some of the important things. It's related to the technical term related to the machine learning engineer, like you have to have good command based upon understanding data, also interpret and regulate the data, like how to you can do some work based upon a data preparation. Okay, so here, what 6 or 7 topics I've written over here, that is again depends upon a machine learning process. Because if you want to become a as a good machine learning engineer, at the same time, you are having some good experience with the good machine learning process. So that's how things are remaining over here. After getting idea about how to become a machine learning engineer, next we have to talk about which companies are using machine learning. So then you are getting an idea. So which companies are also requirement for machine learning engineer or the artificial engineer. Okay. So the number of opportunities is exponentially growing, and this is amazing because you will be trending when you are a machine learning engineer, and you will be a really well paid as well as. So in India, that the salary of machine learning engineer or the data scientist, it's around like 50 to 60K per month. But if you are going to outside of India, like USA or the Germany or another country, so you are getting some good amount of salary per month in terms of more than $1 lakh. So it's amazing out there. So everyone from Apple to Uber, Facebook to Salesforce, all these big players in the market are on a constant higher spree, and they are big dollars as well as investing in the machine learning technology. Next up on this, like we already talk about like how to become machine learning engineer, so we can get some more idea about like how to join these companies as well as. So there are already so many fields impacted by the machine learning, including education, finance, computer science, and so much more than are there. So I'm not able to find out everything in this one single slide. But if you can find out like how many companies are working in a machine learning, so you are getting more than more than 500 plus companies in terms of the MNCs. Also the local startups nowadays in India, the many more local startups are running in the section of like in the Bangalore, Mumbai, and as well as in the Delhi. So nowadays some small cities are also coming with some startup with the machine learning technology or the artificial intelligence technology. So that's how this session is ended over here. In the next session, we have to talk about pattern recognition. Let's talk about pattern recognition. Patterns are recognized by the help of algorithms used in machine learning. Recognizing patterns is the process of classifying the data based on the model that is created by training data, which then detects patterns and characteristics from the patterns. Pattern recognition is the process which can detect different categories and get information about particular data. Some of the application of pattern recognition are voice recognition, weather forecast, object detection in images, etc. So pattern recognition is again one of the important application of the machine learning. So also let's talk about the feature of pattern recognition. So there are 4 features are available in a pattern recognition. First is the pattern recognition learns from the data. Second is automatically recognize patterns even when partially visible. Third is the it should be able to recognize patterns which are familiar. And the fourth one, that is the pattern should be recognized from different angles and shapes. So that's how we are getting idea about the pattern recognition. We are not going very deep with the pattern recognition topic because I want to just describe what is the meaning of pattern recognition. So here in this module, we have to learn about what is artificial intelligence. Then we describe about definition of machine learning. After that, we have to describe the difference between artificial intelligence versus machine learning versus deep learning. And at the end, we have to talk about artificial intelligence tools and learning models. Let's start with the what is artificial intelligence. But before that, I want to discuss about one or two of the important things based upon artificial intelligence. So that's why we have to start it with the emergence of artificial intelligence. The data economy, with its vast reservoir, is enabling the unprecedented innovation in data sciences, the field which deals with extracting useful information and insight from the available data. Data science is going towards a new paradigm where one can teach machines to learn from data and derive a variety of useful insights. This is known as artificial intelligence. So, based on a data economy or with the use of data economy, we are able to build a data science or artificial intelligence product. So, let's check it out with the artificial intelligence definition. So, what are the definition of artificial intelligence? Artificial intelligence refers to intelligence displayed by machines that simulates human and animal intelligence. Basically, with the help of this definition, we are getting idea like artificial intelligence product gives output look like a human or an animal, but still, in the world of artificial intelligence, experts are believing many things like they are believed AI is depends upon a four factor. First is the human thinking, second is the human acting, third is the rationally thinking, and fourth is the rationally acting. Okay, so let's go get to know about some real world application based upon artificial intelligence. So this topic is based upon artificial intelligence in a practice. Self-driving car is again a part of or all the application of the artificial intelligence. So this product is built upon a machine learning, deep learning, and computer vision. In other words, deep learning and computer vision, also machine learning, are the part of the artificial intelligence. Because machine learning, deep learning, and computer vision, these all are the subset of the artificial intelligence branch. And that's why second application like a Siri that will understand and respond to human speech. So this product is again built upon a machine learning and natural language processing technology. Again, natural language processing is again a part of the deep learning, computer vision, natural language processing. This all type of stuff are the subset of the deep learning. So that's why deep learning is again subset of the machine learning, and machine learning is a subset of the artificial intelligence. So artificial intelligence in a practice, so we are getting everywhere artificial intelligence products. Google AlphaGo AI has defeated many Go Pro champions such as the Keyjibe. So this product is again based upon a deep learning. Next is the Virgin Australia Airlines. This company works based upon a machine learning recommendation systems. Amazon Echo product like home control chatbot device like Amazon Alexa is there. So Amazon Alexa is again it's built upon a natural language processing technology. And the last application or the last artificial intelligence in a practice, that is a Flipkart shopping website. Flipkart or Amazon or a Snapdeal, whatever the e-commerce shopping website you should take in, this is the type of the sales company used a recommendation system from a machine learning technology. So that's how we are using artificial intelligence in a practice or also day to day regular life. Next, after discussing about artificial intelligence in a practice, now it's time to discuss about the relationship between artificial intelligence and machine learning. Till now, we are getting full idea about the artificial intelligence, but now we are going to take deep dive. Machine learning is a subset of artificial intelligence. Also, you can get idea like machine learning is a child of artificial intelligence. Machine learning is an approach or subset of artificial intelligence that is based on the idea that machines can be given access to data along with the ability to learn from it. Both technologies are having their own capabilities, so we are not able to compare that in terms of capabilities because it's not fair. Artificial intelligence works on Turing test genetic algorithms, further systems and agents or first order logic, but the machine learning works upon a regression and classification techniques in linear regression, decision tree, k nearest neighbor, or the support vector machines. So that type of thing are working in machine learning, and the other things are working in a artificial intelligence. Now let's find out the main thing related to the machine learning, and that is the definition of machine learning. The capability of artificial intelligence system to learn by extracting patterns from the data is known as machine learning. Other experts are also defined machine learning like a computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task in T is measured by P and it improves with experience E. So that's how we are getting idea about the machine definition of machine learning. So now we have to discuss about the features of machine learning. Machine learning is computing intensive and generally requires a large amount of training data. It involves repetitive training to improve the learning and decision making of algorithm. As more data gets added, machine learning training can be automated for particular new learning data patterns and adapting its own algorithm. For example, learning from new spam words or a new speech, it is also called as a incremental learning. So that type of stuffs are working in the features of the machine learning. So till now we are getting idea about the artificial intelligence and machine learning. But related to machine learning, again one of the important term, that is the data science. So now let's talk about the some of the things based upon that one. So for that we have to talk about the relationship between data science and machine learning. Data science and machine learning go hand in hand is there. So if we have having the two hands, so two hands are also equal. So similarly the data science and machine learning are little bit equal, little bit not little bit, it's more and their little bit equals are there. So data science helps to evaluate data for machine learning algorithm. Data science is the use of statistical method to find the patterns in the data. So statistical machine learning uses the same math and techniques as a data science, and these techniques are integrated into the algorithms as well as. So according to that one, we have to learn and improve their own. Machine learning facilitates artificial intelligence as it enables machine learning to learn from the patterns in that data. And data science is a broad term for a multiple disciplines. Machine learning fits within the data science. Machine learning uses various techniques and such as regression or the supervised things are there and many more stuffs are there. Also, on the other hand, the data science may or may not involve from a machine learning or any type of the mechanical process. So that's how the thing are there. But if you can find out the overall thing, so again you can get an idea. Machine learning is again one of the small part of the data science because data science are having big world because they are having some more things related to the big data and Hadoop and many more things are there. But machine learning are just only one part of the data science is there. Also, you can consider deep learning is the, again part of the data science as well as. So in this session, we are just only talking about what is the AI, machine learning, and then we have to discuss about the difference or the relationship between data science and machine learning. In the next session, we have to talk about the little bit about the deep learning. In this part, first we have to discuss about what is deep learning. Deep learning is a specialized form of machine learning that uses supervised, unsupervised, or semi supervised learning to learn data representations. It is similarly to the structure and function of the human nervous system. Deep learning is an AI function that mimics the working of the human brain in processing data for use in detecting objects, recognizing speech, translating languages, and making decisions. Deep learning artificial intelligence is able to learn without human supervision, drawing from data that is both for the unstructured and the unlabeled as well as. So after getting idea about the definition of deep learning, next we have to talk about why deep learning is important as well as what are the necessary for the deep learning. Experts have discovered multi-layered learning networks that can be leveraged for deep learning as the learning layers. The vast availability of big data enables machines to be trained Scientists have figured out that high performing graphics processing units, it's also understand like a GPU can be used for a deep learning. GPU allow parallel computing unlike a conventional central processing units like CPU central processing units that uses sequential processing as well as. So when there is a lack of domain understanding for a feature introspections, deep learning technique outshines other as you have to worry less about the feature engineering. Deep learning really shines when it comes to complex problems such as image classification, natural language processing, and the speech recognition. The ability to process large number of features makes deep learning very powerful when dealing with unstructured data. However, deep learning algorithms can be overkill for less complex problems because they require access to a vast amount of data to be effective. So that's how things are working over here. So after learning all the terminologies like artificial intelligence, machine learning, and deep learning, now we have to find out the relationship between them. So for go with the next topic, and that is based upon a relationship between artificial intelligence and deep learning. Machine learning is an approach or a subset of artificial intelligence that is based on the idea that machines can be given access to data along with the ability to learn from it. Deep learning takes machine learning to the next level. Machine learning refers to an artificial intelligence system that can self learn based on the algorithm. Systems that get smarter and smarter over time without human intervention is machine learning. Deep learning is a machine learning applied to the large data set. Most of artificial intelligence work involves machine learning because intelligent behavior requires considerable knowledge. So that's how we are getting relationship between the artificial intelligence and the deep learning. So next topic is again based upon a deep learning, and that is the deep learning at a glance. Deep learning has become very famous in the last few decades after 2010, and currently we are running on a 2021. So from the last 11 years, the deep learning are getting lots of growth thanks to the hundred of applications that are changing the way we interact with many electronic and non-electronic systems. Speech, text, and image recognition, autonomous vehicles are there, and also intelligent boats are there. So just to name a few, like a common application, normally based on a deep learning models and have outperformed any previous classical approach as well as. So there are many aspects of deep learning as shown over here in this diagram, and this will be covered in detail in subsequent chapter of particular in this module. So let's talk about on what type of things we are getting at a glance of deep learning. So multiple level of the hierarchical representations are there. Multi-layered neural networks are there, like multi-layered neural networks in terms of the artificial neural network with the multiple neural network is there, as well as we are getting some convolution neural network or the backpropagation neural network, and also we are getting recurrent neural networks. So training at large neural networks are there. Multiple nonlinear transformations are there, pattern recognition, feature extraction, and then we are also getting high level data abstraction model is there. So here in particular in this course, we are not going to learn about some high level data abstraction model because they are coming with the deep learning courses. But here we are just only discuss about the some of the deep learning popular model like artificial neural network or the backpropagation or the CNN and RNN, because in a high level data abstraction model we are also getting some GANs model is there, like general adversarial neural network is there, also auto encoders and multiple more advanced level of things are there. So that's why deep learning at a glance we are getting some lots of things at the glance of the deep learning. So in the next session we have to discuss about some of the artificial intelligence tools and learning models. In this session we have to talk about artificial intelligence tools and learning models. So, from the dawn of mankind, we as a species have always been trying to make things to assist us day to day tasks. So, from stone tools to the modern day machinery to tools for making the development of programs to assist us in a day to day life. So, some of the most important tools and frameworks are there. That is the scikit-learn, TensorFlow, Theano, Caffe, MXNet, Keras, PyTorch, CNTK, AutoML, OpenNN, H2O open source artificial intelligence platform, and as the last one, that is the Google machine learning kit are there. So that's how lots of tools and machine learning models are available in a nowadays day to day life, as well as to doing some companies, or if they are not want to do some coding with the Python programming or whatever the other programming language. So also tools and models are available. So now we are getting idea about each and everything step by step. First of all, we can start it with the scikit-learn. So how scikit-learn is this and how it can helpful to us? Scikit-learn is the one of the most well-known machine learning libraries is there. It underpins many administrated and unsupervised learning calculations are there. Its precedent incorporated direct and calculated replaces choices trees are there, bunching k implements are there like k nearest neighbors and many more things scikit-learn libraries can provide to us. It expands on the two essential libraries of Python, NumPy, and SciPy, and it includes lots of calculation for a regular artificial intelligence and data mining assignments. It includes bunching, replaces are there, and orders are there. Indeed, even undertakings like changing information, feature determination, and ensemble techniques can be executed in a couple of lines. For a fledgling in machine learning, scikit-learn is a more than adequate instrument to work with that until you begin actualizing progressively compute a complex calculation based upon a machine learning algorithm. Second library or the second framework, that is the TensorFlow. TensorFlow, that is made by the Google and very popular name is that is a TensorFlow. So on the off chance that you are in the real of the artificial intelligence, so you have most likely to find about the TensorFlow and attempted or executed some type of the profound learning calculation is there, and is it accurate to say that they are essential or they're not constantly, and is it accurate to say that they are cool when done right or write the things every time. So the fascinating thing about the TensorFlow is that when you compose a program in Python, you can arrange and keep running on either your CPUs or GPUs. So you don't need to compose at C++ or the CUDA level, CUDA level to keep running on the GPUs. And it utilize an arrangement of multi-layered hubs that enables you to rapidly set up, train, and send counterfeit neural systems with the huge data sets. This is the thing that enables Google to recognize questions in a photographs or comprehend verbally expressed words in its own voice acknowledgement applications. So that's how TensorFlow is very helpful to us whenever we are talking about the artificial intelligence based upon some type of the artificial intelligence based type of the application or the learning model. Next learning model or the next tool, that is the Theano. So Theano is wonderfully folded over Keras and abnormal state neural system libraries there that runs nearly in parallel with the Theano library. Keras fundamental is favorable positions is that is a particularly a working with the moderate Python library for a profound discovering that can keep running over Theano or a TensorFlow. It was created to make actualizing profound learning models as quick and simple as feasible for innovative work. It keeps running on Python 2.7 and 3.5 and can consistently execute on GPUs like graphical processing unit and central processing units. What sets Theano separated is that is exploits the PC's GPUs, and this enables it to make to information escalated counts up to multiple times quicker than when kept running on the CPU alone. Theano speed makes it particularly profitable for profound learning and other computationally complex undertaking. Next tool, that is a cafe. So cafe is profound learning structure made with the articulation, speed, and measured quality as a top priority. It is created by the Berkeley Visions and the Learning Center BVLC and by network donors. So Google Deep Dream depends on a cafe framework, and this structure is BSD authorized C++ library with the Python interface. Next tool, that is a MXNet. So what is the importance of MXNet? It allows for trading computation time for money via the forgetful backprop, which can be very helpful for recurrent nets or on very long sequence. Built-in scalability in mind that can fairly easy to use support for the multiple GPUs and multiple machine learning things. Lots of cool features are available with the MXNet, like easily writing custom layers in high-level languages. Unlike almost all other major frameworks, it is not directly governed by a major corporation, which is a healthy situation for an open source community developed framework. So it is not depends upon any type of the price. If you want to use MXNet framework, you are able to use because it was open source. Next tool or the next learning model is Keras. So Keras is a very popular deep learning framework is there, and also in this course we are using most of time Keras whenever we are trying to develop something based upon a deep learning. So if you like the Python way of doing things, Keras is for you. It is a high level library for neural network using TensorFlow or Theano, its backend. Okay, so if you want to work with the Keras library, so you have to use TensorFlow as an backend. So same concept we are using whenever we are doing something based upon a deep learning. So we have to go with the Keras library, and and its backend we are using a TensorFlow. So the majority of practical problems are more like it's related to the picking an architecture suitable for a problem for image recognition problem using weight strain on an ImageNet, configuring a network to optimize the results. So in all of the cases, Keras is a gem thing of libraries there, and also it often as an abstract structure which can be easily converted to the other frameworks, and if needed for compatibility, performance, or anything, Keras, it's the best type of things are available in a deep learning framework. So next tool that is based upon a PyTorch. So how PyTorch can helpful to us? So PyTorch is an AI system created by a Facebook, and its code is accessible on GitHub, and at the present time has more than 20K stars are available. It has been picking up a great deal of energy since 2017, and it is an relentless receptions developments are there. So PyTorch is also available, but as compared to Keras or TensorFlow, PyTorch is not much popular. Keras is very much popular out there. Also, people are learning PyTorch, I think, before 1 year, but nowadays the PyTorch is not much popular. Is there? So after PyTorch, the next tool that is the CNTK is there. So CNTK it allows user to easily realize and combine the popular model types such as feed-forward deep neural networks or their convolutional neural networks, recurrent neural network, or the long short-term memory neural network are there. It implements the stochastic gradient descent (SGD) or the backpropagation neural network with the different type of the automatic differentiation and parallelizations across the multiple graphical processing units and also the servers. Okay, so CNTK is available for anyone to try out under an open source license. So it is an open source, but you have to take a license. But still, people are not using this library too much. But because people are having the too much faith upon a Keras library, that's why. So after CNTK, the next thing that is the AutoML is there. So out of all the tools and libraries listed, what we discussed till now, till CNTK, so AutoML is probably one of the most of the strongest and a fairly recent addition to the arsenal of tools available at the disposal of machine learning engineers. As described in the introduction, and optimizations are of the essence in the machine learning task, while the benefits reaped out of them is lucrative success in determining optimal hyperparameter is no easy task. So this is especially true in the black box like neural networks, where determining things that matter becomes more and more difficult as the depth of the network increases. Thus, we enter a new realm of the meta wherein the software helps us with build software. So AutoML is a library which is used by many machine learning engineers to optimize their models. Apart from the obvious time saved, this can also be extremely useful for someone who doesn't have a lot of experience in the field of machine learning and thus lacks of the intuitions or past experience to make certain hyperparameter changes by themselves. So that's why AutoML is very important libraries. The next tool or library that is the open neural network is there. So jumping from the something that is completely beginner friendly to something meant for experienced developers, OpenNN offers an arsenal of advanced analytics. So if you want to do some advanced analytics based of stuff, you can go with the OpenNN. Next tool that is the H2O open source AI platform. So it is again important tool is there H2O open source. H2O is an open source deep learning platform. It is an artificial intelligence tool which is business oriented and help them to make a decision from data and enables the user to draw insights. There are two open source versions are available. One is standard H2O and other one is the paid H2O version is there, like sparkling water is there. So it can be used for predictive modeling, risk and fraud analysis, insurance analytics, or advertising technology, healthcare, and also the it can use for the customer intelligence as well as. So that's how we are using H2O as an open source AI platform. So till now we already discussed about the more than 10 plus artificial intelligence based model or the tools. Also we in that particular one we can discuss about the scikit-learn, mxnet, theano, cafe, keras, pytorch, tensorflow, AutoML, and H2O. So lots of things we already discussed over here. In this practical session, we have to see about how to download Anaconda Navigator for Windows, Mac OS, and as well as for the Linux. Basically, currently I am using a Windows. That's why I can show you based upon a Windows, like how to download Anaconda Navigator for the Windows. So basically, for that, you have to just search only one thing, and that is the Anaconda Navigator download. You can also just go with the download, and if you want to go with the download for Windows, you can also go with the same thing. But here I just go with the Anaconda Navigator download. So once you can type the Anaconda Navigator download, here you are getting these things like individual edition of the Anaconda. So you have to click over here. Once you can click over here, you are getting this type of pages over here, and then you have to just little bit scroll down. Also here you are getting some basic information related to the Anaconda Navigator software. Now after that you have to just click over here, and once you can click over here, automatically this Anaconda installer, then scroll down, you can see these things. So now if you are using a Windows operating system, you have to go with the 64-bit graphical installer 457 MB. If you are working with the Mac OS, then you can go with this installer, and if you can use the Linux, so you can go with this installer. Now I'm using the Windows operating system. That's why simply for downloading the Anaconda Navigator, simply I have to click over here. Once I can click over here, so the automatically the Anaconda Navigator downloading should be start over here. So thank you for downloading, but here no need to apply anything for the buy now, because this is for the some standard things are there. That's why they are just only showing you this type of information over here. Otherwise, you have to wait it for the particularly 1 minute, because in my internet speed is high. So that's why within 1 minute the downloading should be completed. So once download should be completed, then we can go with the installation process. So here, once the Anaconda Navigator is already downloaded over here, now it's time to install the Anaconda Navigator. So that's why we have to click over here, and then we have to just go with the open. So once it should open, we have to get in one pop-up to open for that one. It should take some time, and now we are getting this pop-up. So already in a presentation I already provided the screenshot for the installation process, but still I can show you over here how you can try to install the things. So first of all you have to click over here the next, then you have to agree the terms. Also you have to go with the just me with the recommended, where you have to follow over here the recommended approach, and here you are getting the space, like particular Anaconda Navigator required 2.7 GB of space, and the total space is available 106 GB. So that is okay for me. And now that is the important part over here. So that is the recommended approach is there. But if you can click on over here, so that's not looks good, because add Anaconda 3 to my path environment variable. I don't want this one for this particular for now purpose. I just only go with these things like register Anaconda 3 as my default Python 3.8. So no need to click over here. This is the recommended approach, and I just go with the same approach. And now I just go with the install the things. Basically, this type of installation should take time around 10 to 20 minutes. It should take, because in beginning process will go the very fast, but at the beginning of this part it will take too much time to install the process. So we have to wait for the 5 minutes to complete this whole process. So if you can see over here, the process is complete. So now we have to go with the next, and particular with the next, they are asked to you if you want to use Anaconda Navigator with the PyCharm, so you can also use it the same thing. But I don't want to use, but still we are running with the process, so that's why I can go with the finish. So at the end, they are asking for Anaconda Navigator in tutorial. You want? No, I don't want any type of tutorial. And getting started with the Anaconda. So again, I can unclick over here, and I just finish the things. So that's how our installation and download of the Anaconda Navigator was completed over here. Particular from the next session, we have to see how to open the Anaconda Navigator, and after opening the Anaconda Navigator, how we can process for the further things. So now it's time to open Anaconda Navigator for the first time. So that's why here we have to search Anaconda Navigator, and here we are getting this particular app over here. So we have to open this app from over here. App should take on 30 seconds to open the things. But you have to remember, when you open the Anaconda Navigator, the first time it will open look like this type of the command prompt. But no need to handle anything the things, just please wait for the 30 seconds, and after the 30 seconds automatically Anaconda Navigator application should be open. So we have to wait it for that like around 30 seconds. So the loading condas and everything is tried to loading over here. And now if you can see the icon of the Anaconda Navigator, once I can click over here, so I'm getting an idea how the things are coming over here. So basically, in the particular past, in the past, the Anaconda Navigator are basically popular with the Jupyter Lab, Jupyter Notebook, and Orange and Glue and Spider, or the RStudio. But in the latest version of the Anaconda Navigator, now you are also getting the IBM Watson Studio Cloud, as well as you are also getting the Data Lore and the PyCharm Professional. So day by day, Anaconda Navigator is trying to become very smart and very smart. So that's how there is a first look of the Anaconda Navigator. After applying this one, the next step, that is the environment. Basically, when you install the Anaconda Navigator, they are providing the one basic environment, and the environment name, that is the base of root. So that is the base of root are there. But nowadays, if you want to develop any type of application or any type of stuff based upon the Anaconda Navigator, so that's why you have to create your own environment. In particular, in your own environment, you have to import the new libraries or install and download the new libraries according to you. So let's see what are the basic needs required over here. So first of all, here we have to say how to create an environment. So create the environment. First of all, you have to coming over here. So here we are getting an idea. Just base of root environment are over here. But now if you want to create the environment, you have to click over here. And now after that, you have to provide the one name for your particular environment. So here I can provide the environment name, that is the Python with data science and the ML. Just simple name I can provide it over here. I think that looks very big, but still I can take Python with data science and ML for showing to you. After getting this idea, you are also getting one location over here, like C, users, admin, Anaconda 3, and then Python with data science and ML. So this type of location you are getting over here. So what are the files you can save, or like what are the library you can download or install? All the libraries are saved over here. But also, if you want to store your work on a different location, you can also able to do that one. Basically, Anaconda Navigator is also used for the R programming language. So that's why the Python is also, the Anaconda Navigator is also able to work with the R language. But here, our main focus, that is just only Python. So that's why I can go with the Python. So that's why already over here that we have to click on Python, and from here we have to select the current version of Python, that is 3.8. After completion of these things, now simply we have to click on the create. Again, it will take 3 to 4 minutes to create the environment. And once the environment should create, then we can see about how to install or how to download the different libraries, or what are the first basic library. So we have to wait it for the creating the environment stuff. So if you can see over here, the environment is already created over here. Now after the environment, so still it should take time. I'm getting an idea like environment should complete it, but still I think some loading was remaining. So that's why still it should take a time. So we have to provide the proper time. Do not need the hurry with this type of stuff, because if you are doing everything look like very fast, so at the same time it should create an issue once you can complete the installation of environment. So now I think everything is looks perfect, and now we have to see how to install a library for now over here in the particular environment. So first of all, they are also recommending like what are the installed packages are there, and what are the non-installed packages are there. Once you can click on the not installed, so you are getting all the not installed packages over here. Also you can search from over here. Also you can update the index from over here. So once you can update the index from over here, you are getting some better idea regarding to what you are having. So again, it will take 1 2 minutes to update the index over here. During this one, yes, now I just update the index, and now I'm getting lots of libraries over here. So out of that first library, that is a basic library for Anaconda Navigator, that is the Anaconda custom. So now I have to just typing the Anaconda. So here with the Anaconda, if you can see, the third thing are there simplifies packages management and deployment of Anaconda like custom. So once you can install this Anaconda custom library, at the same time Anaconda can fulfill your all the basic requirement according to the library. So they are not fulfill like all the libraries requirement like TensorFlow or Keras, but they are also providing the basic requirement related to the NumPy or Pandas type of stuff. So that's why we have to click over here. Once after clicking over here, we should go with the apply the things. And after applying the sum, the what are the total packages we are getting, particular with the Anaconda, that list we are getting over here. So again, we have to wait it for 1 2 minutes, and they can update the list over here. If you are using the particular with the Windows, if you're using the i3, so at the same time it should take lots of time to do this stuff in your system. If you're using i5 or the i7, then and then the Anaconda Navigator will run smoothly in your system. So now if we can see the Anaconda depends, then many more libraries are working over here. These all are the basic modules and basic packages are there. Also here we are metadata and many more basic things we are getting over here. So after that we have to just simply click apply, and after apply, now the download and installation of this library is starting over here. And during the coding things, we are just only try to import this particular type of the libraries. Anaconda Custom is a very large library or the package. That's why it should take lots of time to properly install all the packages that is considered with the Anaconda. So after Anaconda, we have to also import many more the basic things related to the NumPy or the Pandas, because these all are things we had to learn in particular with the Python libraries. And after so on in data analysis topic as well as in machine learning and deep learning, we can learn about the more and more with that libraries. So now if you can see over here, the all the packages are imported over here. And if once I can click over here, like install to the not install to the install. So here I'm getting an idea. The Anaconda custom is already imported over here. So that's how we have to see some more packages like NumPy. So let's check it out. What are the other packages that is required for particular for this module or the whole course? So now I want to import the NumPy. So if you can see, we are not getting over here NumPy because NumPy is already installed with the Anaconda custom. So if you can see, NumPy is installed over here. Basically, NumPy is also the basic library and that is part of the Anaconda custom. But with the help of NumPy, if you want to do some additional things, so you can also install the library look like a Blaze. So Blaze is also work for the NumPy and Pandas interface to big data. Here we are not working with the big data, but still you can import these things if you want to necessary to import these libraries. So you can easily import the library if you already download and install the packages. So now we have to try to import these packages over here. So whenever during the coding, whenever you can feel like in particular in your model or particular you are getting an error, okay, like this particular things is not installed in your package. So at the same time, you can write down that package over here and you can try to import that package as well as from over here. So again, it should take time. And if you are using or if you are working with the i3 version of the Windows, so at the same time it should take 1 day to complete whole things related to the download and install the packages, as well as it should take lots of time to install the Anaconda Navigator in your system. So that's why you have to very careful when you should work with the i3 version of the Windows. So if you can see, still it should trying to solving the package specification. So that's why if you don't want to import this library, you should click on the cancel, because I have to wait it for still 10 to 15 minutes to complete this one. So that's why I can close this one, because you already know now like how to import the libraries over here. Also, the scikit-learn is again important libraries over here, but I think still in an Anaconda custom package it is already imported. So that's why no need to provide this one. But also based upon a TensorFlow, the some libraries are there, so you have to import this library as well as like Keras. So Keras is a deep learning library for Theano and the TensorFlow. So that is very important libraries over here. Also here the second thing, that is a TensorFlow and TensorFlow base. So these three libraries very important to apply the deep learning. So that's why we are trying to apply in here. And also again it should take lots of time to solve this query as well as, because that is totally depends upon the internet speed. So currently I think internet speed was down. That's why it should take lots of time to solving this package specification. So still it should take lots of time to import the library. So that's why we can skip for now this library as well as, because I think the internet based, that's why we are facing an issue. But don't worry, you can follow the same step and try to install the library daily. 2 3 libraries you can install, but first of all, basically to do some basic Python programming, there is no required to any type of the library. Now let's to take a look about the Jupyter notebook, because we have to do all the work based upon the Jupyter notebook. That's why we have to click over here for the launch option. But the main thing you have to remain, that is the what are the work you can done. So every work you have to do with the Python, with data science and machine learning environment. If you can click the base root, because already those are the libraries as necessary. I already imported that all library in a Python with data science and machine learning environment. So that's why now if you have to first of all check it this one over here, and then you have to click on the Jupyter notebook to launch the system. So once you can launch the system, you are getting this type of environment over here. That is not basically this environment is again similarly, that is a look like what you already done with the part of the in your system. So in your system are having this type of things are the documents, download, Dropbox. So this type of folders is already are having in your system as well as. So further related to the Jupyter notebook, like how to create the folder and how to create many things, we can see in the next session. So in this session, we have to see about like how to create the folder, particular in a Jupyter notebook or in your document. So first of all, this is your document section is there. So you have to click on over here the document, and particular in the document, you have to here two options is there, upload and new. So you have to click on new, and you have to try to create a new particular folder for your whole coding. So that's why here I have to create a new, and particular new, they are showing a new coding file. But here if you don't want to apply that, say you are also, if you want to create a folder over here, so how you can create that folder as well as over here. For that, what you have to do, you have to open your file sections, and from your file section you have to go to the document, and particularly in your document you have to create one folder. Like you have to go with the new, and new folder name, that is the training of machine learning, or whatever the name you want to provide, you have to apply the enter. So what are the things you had done, everything is saved in your training of machine learning folder. So let's again go with your particular browser. So basically the Jupyter notebook is automatically open with your particular default browser. So that's why everything is open over here with the Microsoft Edge. And now in the document, let's find out our folder. Where is our folder? Yes. So that is my folder over here. I can close this file because no need to apply that file over here. And particular, once you create the folder, if you want to create the multiple folders over you want to create over here, you can create. But now let's see how to create a new file over here. So then again you have to click on the new, and from the new you can also click on the Python 3. If you want to create the folder from over here, so you can click on the folder, so automatically here the new folder should be created. So let's create that folder, and now we have to click on over here, and we have to apply the rename over here, and I have to provide the folder name, that is the Python programming. So now I have to rename the things. So let's check it out. This update will come in our this folder or not. Yes. So here also we are getting the Python programming folder. So let's create one file particular in this folder, or also over here. Let's create over here Python 3. So if here we can create this file like untitled file is there, but I want to provide the file name that is the introduction file. So that's why I can provide the file name that is the introduction. So let's check it out. Same thing update over here as well. So here also we are getting the introduction.ipynb. What are the work we can done with the Jupyter notebook that all work is looks it's saved as a .ipynb format. There is a Jupyter notebook format is there. That's why. So here we have to write down some code over here, and according to the code, we are getting output. So for example, just take an as a simple 5 plus 6, and now I'm trying to run this code. So you are trying to run this code in a two-way. First way, that is a shift plus enter, and in a second way, you have to click over here and you have to just click on the run option. So in a both way, you are trying to run this code in Python programming with the Jupyter notebook. Still here, there is many more options is there. So let's check it about all these taskbar here in this particular option bar. We are having lots of options is there. So let's talk about that all the options over here. If you want to save your file, so you have to just click on over here, so automatically your file should be saved over here, like a last checkpoint a few seconds ago. If you want to add some shelf over here, so you have to click on the plus, and if you want to remove the things, you have to click on the cutter. If you want to apply the something based upon a copy and paste, so you have to first of all apply over here copy, and then you have to do the paste over here. So that's how you can also do the copy and paste over here. If you want to go up bar or if you want to go down, you can go look like this one. If you want to run something large code, and if you are still running with the large code, and in middle, if you want to stop that code, you have to click over here. So at the same time, you are trying to interrupt your kernel as well as. So if also you want to run these things, or if you want to restart your kernel or your coding file, so basically this coding file is also known as a kernel. So that's why if you want to restart your kernel, you can click on the restart. So that's why again, if I think that is any type of other issues you are facing during the kernel, so you can also do the same thing. Now we have to see what is the meaning of this one, like code. So during this particular shell is working as a code, but if you can provide this shell as a markdown, so we are getting just basically information look like this one. So whenever you should provide some main heading, and after you wants to provide some information, so do you have to use this markdown as well as. Also there is third option, that is the row and basic convert. So if you can click the row and basic convert, so after that you are also using the row and basic convert, like if you want to have multiple codes, and if you want to run all the code step by step, so you can run like this one, so it will save in particular with the shelf. And the last option, that is the particular heading. So what is happen with the heading? So in a heading you have to provide the heading, and it will come with the bold fonts. So let's see how it can apply it over here. So for that, if I want to apply it over here the introduction, so now I have to write down the introduction, and now it's time to run this code. So if you can see over here, the introduction is look like this one. I have to run these things, and now I'm getting the introduction in this way. So that's how we are using the particular these basic things related to the Jupyter notebook, like how the Jupyter notebook coding file should work. So if you want to apply the heading, at the same time you have to select over here the heading. If you want just only apply the basic information after the introduction, you can use the markdown. Also, if you can see over here the file, so in this file option you are getting some similar option like how to create new notebook. If already some file is exist in your location, so how to open that file, how to make a copy of your file. Also save and checkpoint, revert checkpoint. What is the meaning of revert to checkpoint? In that particular point of the revert to checkpoint, at the same time what is happening, like if you can done some work and if you already saved, but if you want your work before the saving work, so that's why you have to click on the revert to checkpoint. At the same time you are getting the previous version of your code. So if I can click over here, so they are revert the things, so I can apply the revert. So before saving, I'm getting just only this output. So that's how revert should be worked over here. So after that, there is many more options like that, print, preview, download as. So in which format you want to download, you can download from over here. You can also download the same thing with the .py extension as well as. In particular edit, you are getting some same option like copy, paste, and that type of things are there. How to apply the upward, downward, how to delete the cells, insert cell, kernels. You are getting some same options. What your option, the popular option you are getting lower than that, like run cells select below. So that is also working in some type of the shortcut as well as like control enter, shift plus enter, run cells and select below. That's how run all. If you want to run whole file together, so you can go with the run all. If you want to go with the particular kernel type of stuff, so you can go to restart and clear output, restart and run all. So this type of things are working over here. So that's how this is the basic introduction of the Jupyter Notebook basic file and like how to create the files. Because from the next session, we are starting with the Python programming first topic with the Python objects and data structure on the basic level. And in that, first of all, we have to discuss about the arithmetic and the numbers. In this practical session, we have to learn about Lambda expression, map, and filter. Now it's time to quickly learn about two built-in functions, filter and map. Once we learn about how to these operators should work, we can learn about the Lambda expression, which will come in handy when you begin to develop your skills further. So let's start it first of all with the map function. The map function allows you to map a function to an iterable object. That is to say, you can quickly call the same function to every item in an iterable, such as a list. So let's see same thing with an example. So for that, we have to create one function with the def, and we have to create the square def functions. So here also we have to take a first argument, and that is the number. And based upon that number, we have to provide one semicolon to follow the indentations. And also it should return with the number of power of 2. So the code was perfect over here. Then we have to provide something, or we have to provide one list based upon the numbers. So here I have to create one list, and the list name, that is the my numbers, and particular in that number we have to take 1 2 3 4 5. Okay, so after applying that one, now we are using a map function. So with the help of map, here we have to provide two arguments. First is the square, because that is the function name, and the second thing, that is the my numbers. Once I can run that part, so it was applied over here. But for seeing that particular things, we have to again call to list. So for that, we have to simple write down the list of map of, again, square and my numbers. If once I can run these things, I'm getting all the numbers, those who are available in my numbers with their power 1, 4, 9, 16, and 25. That's how map function should work. Now let's talk about the filter function, or how filter should work over here. So first talk about what is a filter. The filter function returns an iterator valuing those items of iterable for which function is true, meaning you need to filter by a function that returns either true or false, then passing that into the filter, and you will be get back only the results when it would return true and when it passed to the function. Let's check same thing within one example. Again, I have to create one function, and based upon that function, I have to create the function name, that is the check number of the number. After that, I have to apply semicolon to follow the proper white space or the indentations comes within written, and particular in the written spelling was wrong, written. And after that, we have to provide the number with the module of 2, and width is equals to 0. So here function is already prepared over here. Now again I have to create one more list that is based upon a numbers. So I have to take numbers is equals to square bracket, because it represents with the list. That's why we have to taken that one. So till 1 to 9, and last number is that you have to take on a 10. So number list is already created over here. Now again I have to use filter, but similarly look like a map filter is again shows the same thing. So that's why we have to take on a filter of, sorry, we have to first of all take a list of filter of, again we have to take a check number and the numbers. So we have to take check number and the second argument, that is the number. So once we can run these things here, the numbers, yes, the numbers are there. So that's why the issue will create it over here. Now if you can see, so we are getting 2, 4, 6, 8, and 10 again in a similar way. So that's how these things is helpful for us to get the filter function. After learning about the map and the filter function, now the next topic, that is the Lambda expression. After discussing about map and filter, now let's start it with the Lambda expression. One of the Python's most useful And for the beginners, it looks something confusing, but it is a main important tools is the Lambda expression. Lambda expression allow us to create anonymous function. This basically means we can quickly make ad hoc function without needing properly define a function using the def or define the function. Function objects written by running Lambda expression work exactly the same as those created and assigned by the defs. There is a key difference that makes the lambda useful in a specialized role, and the lambda's body is a single line expression, not a block of statement. That's why the lambda body is similarly to what we would put in the def body written statement. We simply type the result as an expression instead of explicitly returning it. Because it is limited to an expression, a lambda is less general that of a def. It means define the function things. We can only squeezes design to limit the program nesting. Lambda is designed for coding simple functions and def handles the larger task. So let's slowly break down a lambda expression by deconstructing a function. So first of all, we can try to construct simple function, and based upon that, we can move forward with the lambda expression. Also, you can build up lambda expression in multiple ways, so we can also see about that part. But first of all, basically I have to create the define the function for the square name. So already function was created with name of square, and we have to provide something in terms of the numbers. And here I have to create the parameter, that is the result is equals to number power of 2. After that, we have to coming with the return of result. So here what are the answer we are getting in terms of the results. So whenever I'm just applying the square of 2, so I am getting the answer, there is a 2 square 2, that is the 4. So for applying a power, we are using this first method. We could also simply look like this one. So I've currently I show the second technique to apply the square things. You can take it square of number. The first solution should become within a 3 line, but now I'm trying to provide the solution within a 2 line. But with the lambda expression, we should see the solution within a single line. So that is the advantage of the lambda expression. So here same thing again we can apply it over here, the square of 2. So that's how we are getting the answer, that is the 4. And now still I can show you one more thing with a single line with the define the things without any lambda expression. So define square, define the function that is an image the square with the number. So same code we can apply it over here, and simple we can return with the number of power of 2. So that's how we can apply the things. And again, once we can run this code, so again we are able to copy this code and we are trying to paste it over here, and we are getting the same results. But this is the form of the function that a lambda expression intends to replicate. A lambda expression can be written as the with the lambda. So that's how now we will see how to apply the lambda. So lambda number semicolon, again you have to provide number with the power of 2. So that's how simply you can create the lambda expression. Let's add some more lines over here to get a practical idea. So similarly, based upon that, now if I want to create the square, so this is just simple lambda expression are there. Okay, so we are not going with the continuing thing. For particular for finding out the square, now look like this one. We are using a lambda expression. So again, we have to provide the number semicolon number power 2. So that's how simply we can create the lambda, and there is no need to apply any type of the define the function, no need to apply any returns, also don't need to provide any type of the white space or the indentations. And simply if here I can provide the square of 2 and run these things, I'm getting the correct answer. So that's how you are trying to use lambda expression, so that can really helpful to you. So why would we are using this one? Many function calls need a function that passed in, such as a map and filter. So we are also able to use map and filter with the lambda expression. So often you only need to use function you are passing once. So let's see how it can possible. In previous sessions, we already seen how to apply the maps and filters. So let's use again that part with the list. In the bracket of list, we have to provide the map, and in particular map we have to provide this one again like lambda, then we have to provide number, then semicolon number of power of 2. So that's how we are able to this one. And for particular for this list, we have to provide our list name. So we already create the my numbers of that list, so we are using the same thing over here, and then we have to run this code. So after running this, we are getting an idea 1, 4, 9, 16, and 25 how we are getting, because already in my numbers list we are having the value of 1, 2, 3, 4, and 5. So based upon that, we are getting over here all the power of that my number of list. So that's how lambda expression should be used. You can also get an idea like how lambda expression should be work with the string of indexing and slicing. Lambda expression is also work with some normal addition or multiplication, that type of stuff. You will find yourself using lambda expression often with the certain non-built in libraries. For example, the Pandas library for data analysis works very well with the lambda expression. So that part also we will see in the future sessions. In this practical session, we have to learn about the nested statements and the scope. Now that we have gone over writing our own functions, it is important to understand how Python deals with the variables names you assign. When you create a variable name in Python, the name is stored in a namespace. Variable also have a scope, and the scope determines the visibility of that variable name to other parts of the code. Let's start with a quick thought about the experiment and imagine this particular code. So what type of issues will created whenever you can create the function with the particular same name like print or printer, like that one. So let's check it about how the things are working over here with this practical. So for that, here I have to take one value for the x, and that is the x is equals to 25. Based upon the value of x, I have to create one new definition or new define the function, and the function name that is the printer. And based upon this printer, I have to provide one code and semicolon for following the proper indentations. Now in this function, I have to provide the value of x is equals to 50, and now it things can return with the x. After getting idea about that, the two questions are generated over here. If I'm trying to apply the print of x, so what is the answer, the 25 or the 50? So here whenever I should apply the print of x, the answer of print of x, that is the 25. But if I can apply the printer of x, so at the same time I'm getting the answer in terms of the error. But I think that is depends upon some spelling. I have to check the same thing. Yes, not in spelling. Why we are getting an error? Because I just only applied the printer of x, that's why. For getting the value of printer, we have to provide the print of printer. We have to provide the print of printer of x. But still, if I can apply it with the x, still I'm getting an error. So for that, what we have to do, we have to simply remove that one, and now we are trying to run this code. So at the end we are getting an output that is a 15. So this type of things we are facing during this particular nested statements. So we are solving these issues now. This is interesting, but how does Python know which x you are referring to in your code? So that is the question, is that like how we are getting the idea to answer related to the x is equals to 25 or x is equals to 50. This is where the idea of scope will comes in. Python has a set of rules and it follows to decide what variables such as in x in this case and you are referencing in your code. Let's break down the rules. This idea of scope in your code is very important to understand in order to properly assign and call variable names. In simple terms, the idea of scope can be described by three general rules. And the first rule, that is the name assignments will create or change local names by default. Second rule, that is the name references search for scopes. These are the local enclosing functions, global and built-in. That is also called as a LEGB rules. That part we can understand further in this session. And the third, that is the names declared in global and non-local statements map assign names to enclosing the modules and function scopes. So according to the LEGB rules, let's talk about that part. L, it stands for the local, and in particular with the local, names assigned in any way within a function, define the function or the lambda function, you can use whatever you want, and not declared global in that particular function. E will stand for the enclosing function locals, names in the local scope of any and all enclosing function from inner to outer. G will stand for the global, also looks for the module, names assigned at the top level of the module file or declared global in a define the function within the file. and the last B will stand for the built-in, and particular for that names pre-assigned in the built-in names module. For example, open, range, or the syntax error. So that's how this type of stuff is working over here. So according to that one, let's take out some practical samples or examples based upon a LEGP rules. And first will stand for the local. So how you can apply things based upon a local. So first of all, for that I have to create the variable of f with the help of the lambda expression. So I have to use lambda over here, and we have to provide x semicolon x power 2 over here. So that's how the things are working over here, and we have to run this code. So after running this code, we are getting second thing. So that is the very basic things are there, and that is also known as the local. That's why it will all simply applied over here. But the second thing that is the important, enclosing the function locals. So this occurs when we have a function inside a function. It is also understood as a nested function. So let's see how we can apply this nested function over here. So first of all, for that I have to create one name, and particular in a name I have to create one string, and that is this is a global name. So based upon that we have to do everything. And in the next way we have to apply the definition or the define the function, that is depends upon you. If you also want to go with the lambda expression, that is your individual choice, and you can also follow that part. But here I should use define the function methods. And now it's time to enclosing the function. So I have to provide the name is equals to, here the name is the Sam, and based upon that particular name, now I'm trying to create a next function, because here we have to see about a nested function, that's why. And here we have to provide the hello with the same techniques, same things we have to provide over here. And again over here we have to provide the print function. In a print we have to provide the hello, and with hello I want to concat the particular name of Sam. That's how you can create a nested statements, or with the particular with the help of the function. After applying that part, the next thing that is a simple, we have to provide of hello, and after hello we are going to apply with same thing with the greet. So whenever we can apply the same thing at the same time in the answer, I'm getting the final things, and that is the hello Sam. Also, if you want to provide the space between the hello and spam Sam, so for that what you have to do, you have to provide the space in this particular hello with these quotes. So once I can run these things, now I'm getting a difference or the space between hello and Sam. So that's how out of LEGB, L and E should work. In the next session we can talk about how the G will stand and the B will stand. After talking about local and enclosing function, now it's time to talk about the global and built-in. Global. Luckily in Jupyter, a quick way to test for a global variable is to see if another cell will recognize the variable. Let's see how it should work. So it should work with the print function. Whenever you should apply the print of name with the particularly what are the particular code we can create for the enclosing function. We have to test it similarly to that one. And that's why we are getting the print of name. That's why we are getting the particular global things, and that is depends upon the this is a global name. Similarly, in the built-in, these are built-in functions names in the Python. Don't overwrite this one. If you run this code again and again, length for particular for length, so it will not give an proper output. So here it will give just only particular function of length, and particular they are showing objects. After talking about the LEGB role, now it's talking about the variables. Basically, two type of variables here we are getting. The local variables are there, with the global statements are there, as well as at the end we have to also see about the conclusion. Let's talk about the local variables. When you declare variables inside a function definitions, they are not related in any way to other variables with the same names used outside the functions. For example, variable names are local to the function, and this is called the scope of the variable. All the variables have the scope of the block, and they are declared in a starting from the point of the definition of the name. Let's check it out to one simple example based upon that. If I should take x is equals to 50 over here, and same thing we are already seen in the starting of this session based upon a nested statement and scope related to the print and printer. But let's check it about the same thing over here. X is equals to 50. I already taken over here. And in the next, I have to create the function, and the name of the function, that is the func of x. So after applying as x, we have to apply it over here the semicolon for follow the indentations. Now it's time to apply the print function with some comment like x is what is the currently value of x, you are also have to mention that values as well as. So here we have to mention that value x over here. Now in the next things, again we can if you want to provide some particular value of x is equals to 2, like here again I want to provide the value of x is equals to 2, and based upon again over here I want to apply some print function, and in a print I want to apply it like changed local x to current value of x. So that type of things you can also happen to do over here. And after that we have to just simple call the function func of x over here, and then we have to print the current value of x. So x is till it represent the current value of x. So that's how we have to run this code. So here we are getting an idea. In a starting, the x is equals to 50, but after change local to x to 2, after still x is still 50. So here the 2 is not reflected in the value of x because we have to always call the x with the function of x. That's why the first time that we print the value of the name x with the first line in the functions of body. Python uses the value of the parameter that declared in the main block above the function definition. Next, we assign the value 2 to x and the name x is to the local to our function. So when we change the value of x in the function, the x defined in the main block and it remains unaffected. With the last print statement we get the display in particular display we are getting the value of x as defined in the main block, and thereby confirming that is actually unaffected by the local assignment within the previously called function. So after getting idea about the local variables, now it's time to talk about the global statement. So let's see what are the global statement. If you want to assign a value to a name defined at the top level of the program, for example, not inside any kind of the scope such as the function or classes, then you have to tell Python that the name is not local, but it is the global. We will do using the global statement. It is impossible to assign a value to a variable defined outside the function without a global statement. For particular that you can use the values of such variables defined outside the function, assuming there is no variable with the same name within the functions. However, this is not encouraged and should be avoided since it becomes unclear to the reader of the program as to where that variable's definition is. Using the global statement makes it amply clear that the variable is defined in an outermost block. So let's see the same task with the help of the coding. And particular for that, we have to write some big code, not in small code. So for particular that, again, I have to use some particular code from the last program over here, and I want to edit this code for particularly global statement. So in particular starting, I have to take an x is equals to 50, define the function, but after over here, I want to apply something based upon a global, and that is the global x. So when you want to work with the global statement, you have to provide this type of stuff over here. And particularly in a print, you have to apply something over here. So that's why we have to remove this one and we have to add one statement over here. Like this function is now using the global x. This function is now using the global x. After apply this printing, we have to apply another print function. And particular in this print function, we have to apply the because of the global x is, and we are trying to apply some another values of x. So because of global value of x, now we have to apply the another value of x. And after applying that one, we have to again use x is equals to 2 and again print with the ran function of change global x to the x. So here, I think we can go with the same thing. Okay, we are not applying any type of the things. A random function, if you want to add, so you can also add that part. A random function will change local x to the x, and again same thing is complete over here. And now after completion of this one, we have to again apply one time we have to apply the print function. And particular in the print function, we have to apply same thing before calling function x is x. Before calling function x is, again here we have to provide the x, and now we are going with the same still condition function of x. We have to remove this function of x over here, and last thing is x is still x. Yes, that was correct. Here we are getting an error for particularly over here because name x is parametric global. Okay, so we are getting an error. Let's check it out on what level we are getting an error. After applying x is equals to 2, we have to check that error. Then we are getting some perfect things over here. Okay, so I think the error is based upon x. I think in previous one we are using x, but still x is parametric model. Yes, we have to remove the x from over here as well as over here. Yes. Why the error will come? Because we had copied the last code. That's why we are getting an error. Okay. So the before calling functions x is 50. This function is now using the global x because the global value of x is 50, and the random function will change the local value of x to the 2, and x is still 2. So that's how this thing was things was changing over here. So particularly in the global statement is used to declare that x is a global variable. Hence, when we assign a value to x inside the function, that change is reflected when we use the value of x in the main block. You can specify more than one global variable using the same global statement. For example, global of x, y, and z. Particular after conclusion in this particular session, you should now have a good understanding of scope, and you may have already intuitively the felt right about the scope and which is the great things are there. One last mention is that you can use the globals and locals function to check what are your current local and global variables. So another thing keep in mind is that everything in Python is an object, and I can assign variables to function just like I can think I can do work with the numbers. So this is the first lesson based upon a practical of NumPy library. In this session, we have to say about creating an arrays. So basically, that is the very basic things in particular with the NumPy. So how to start to work with the NumPy? So for that, first of all, we have to library. We have to import the library, and that is the NumPy. So we can also run this code like import NumPy, and also for creating as a shortcut, we have to use a creating import NumPy as NP. So that's why whenever we want to work with the NumPy library, we can also use a shortcut of NumPy library. Next things we have to see how to create an array. So basically, array will create in two ways. First way, that is you can directly easily create array with the help of the NumPy library, and second form to create, that is the first of all you have to create an list, and then you can convert list into the arrays. Let's see with the first of all with the list, and then we can see about with the help of the directly creating array. So here my first list, that is you already know how to create a list. So particularly for list we have to use this type of parameter: 1, 2, 3, 4, 5, and 6. So this is my list number, my list. Okay. So now it's time to create an array. So now I have to provide my array 1, and then is equals to np dot array. So why we are using np dot array? Np is stand for the numpy, and this numpy shortcut, that is the np. That's why we are using np. But why we are using an array? Because here we have to create a array based upon a numpy library. That's why we are using np dot array. Array is the function of the numpy library. That's why we are able to use easily like np dot array. Then we have to provide simply my list. What are the list we already created over here, and then we have to run that part. Now it's time to call our array what we had already created over here, that is the my array 1. Once I can run these things, we are getting an array 1, 2, 3, 4, 5, 6. So that's how you are able to create an array. But if you want to create array directly like this one, now I will show you how you can able to create directly array. So just a simple, the name is the arr, and now I will show you how you can create np dot array, and you have to take these brackets. Particular in this bracket you have to take this type of square bracket, and now you can create 1, 1, 2, and 3 and 4. So that's how you are able to create a simple array. directly with the array, because before I show you how to create an array with the help of the list, but now I will show you how to create array just in terms of direct things. Now let's talk about how we can go with the, if we are creating multiple lists, and based upon a multiple list, if you want to create a two-dimensional array, so that things now we can see. I already created my list over here, so I can replace this one as a my list one, and now again I can run this one, so I'm getting my array one over here. And now it's time to create a my list two. The my list two I already taken over here, and this square bracket I have to taken some values like 11, 22, 33, 44, 55, and 66. That's how we can create my list too. Again, if you want, you can also use this code as well as. So here for that, I have to again provide over here the one. So here, just a second, I have to copy this code and I have to again paste it over here. And simply I have to replace this one, my array 2, in replacement of my list 1 as compared to my list 2, and I have to run this code. And here I have to provide simply my array 2. So the here we are getting both the different arrays, but if you want to make it one list, and in particular that list, if you can combine the my list 1 and my list 2, that is also okay. So let's see how we can apply the same thing over here. So for that I can add one code over here based upon that, and that is based upon a my lists is equals to, here we have to take two lists, my list 1, and then second one is the my list 2. So based upon that I have to call the my list, and I have to run this code. So here I'm getting 1 2 3 4 5 6. Also parallelly I'm getting 11 22 33 44 55 and 66. Now in terms of my list 2, here I can only replace the my list. So here that will affect over here, and now I'm getting the array in two dimensions. So here row and column, both the things are present over here. So that's how you are able to create a single dimensional array as well as multi-dimensional array. Also, if you want to find out some basic things related to your array, you can also find out like shape and data types. So let's see how we can add that part. So that for that we have to use first of all this one, and I have to copy this one, I have to paste it over here, and then we have to take a my array 2 dot shape. So shape was 2 and 6. So what is the meaning of 2? So basically there is two rows are there and six column are there. 2 is stand for the rows and 6 is column for the 6 is stand for the columns. Also you can find out the data type. You are easily getting an idea if this data type is represented with the integer type of things. So that's why data type, that is the integer 32-bit. Also, with the help of the NumPy library, if you want to create a number of zeros in terms of only particularly in terms of rows, so you are also able to create that one in terms of rows as well as columns. So that's why there is particular one function is there, like np of zeros of what are the particular number of zeros you want. You can type that number over here. If you want 5 zeros, you can take it like this one. Similarly, you can also take it like np of ones of 5. So here you are getting the, sorry, I already take it 4. So here 4 ones you are getting over here in terms of column. So basically again you are getting the floating the data type of this one. So till now what are the my array 2 is there, that data type, that is the integer. But what are the things we are created over here, that data type it should be shown and shown as an floating point. So let's check it out how it will show. So for that I have to given some other name over here, array 3 is equals to, and now I have to run this one, and then here I have to provide my array 3 dot d type. And if I can run this one, I'm getting float 64. So the meaning of float 64, that is they all are the floating point with the 64-bit. So next things with the basic of NumPy, we have to see about how to create a matrices of the particular dimension like 5 cross 5 or 4 cross 4 with the zeros and ones. So for that we have to simple use np dot ones in the particular circle bracket. We have to take on one square bracket, And here we have to provide some dimension, how many rows you want and how many columns you want. So I want to create 5 cross 5. So that's why I have to take 5 and 5. So here same thing I'm getting over here. So similarly, based upon np.zeros, you are also able to do the same thing. So let's check it out how we can do np.zeros. In particular bracket, we have to take on 4 and 3. So I have to change the dimension. And according to dimension here, what are the change we are getting over here? And particularly in the creating array, last thing that is based upon a arrange. So how you can arrange the things based upon a array. For that, we are simple again use np dot arrange function. So arrange function will provide the particular one type of the number, and throughout number we are getting the output like 0, 1, 2, 3, 4, because we are providing the range of 5. That's why you can also apply it similarly as a range, because whenever we can talk about the useful operator, at the same time we discuss about how to apply the range. So same concept we are able to apply it over here. Np dot arrange of, you have to provide the starting point, that is a 5, ending point here is a 50, and the step size, that is the 2. So here you are getting all the odd numbers between 5 to 15. So that is the answer. So that's how you can go with the creating arrays. So that can helpful to get the basic idea about the NumPy library. In our next topic, we have to discuss about the using arrays and scalars. In this practical session, we have to see about using arrays and scalars. So first of all, whenever we can work with the NumPy, first thing that is the import NumPy as NP, and we have to run this code. So after running this, we have to just recap one or two things what we already learned in the basics of data structure based upon a modulo. So 5 divided by 2, that is a 2.5. So that type of things we are getting based upon a remainder. Also we seen about like if I have to take in 5 modulo 2, so what is the answer? So answer, that is the what. So that type of things is always important things when you can try to run some of the coding things based upon libraries. So let's create first array based upon np.array. So now array1 is equals to np.array, and particularly here I have to select something. Here, if I want to create a two-dimensional series, two-dimensional data in terms of this two-dimensional array, so I have to take a square bracket over here. So particularly, I have to take a two square brackets. The one square bracket will not run. So particularly in the first square bracket, I have to take it 1, 2, and 3, and then I can also take it 4. Okay, so now we have to take an another square root, sorry, square bracket. So and another bracket, we have to provide the 8, 9, then 10 and 11. So this should become an array number 1. If I can provide I have to run this code like array 1. So I'm getting an answer 1, 2, 3, 4, 8, 9, 10, 11 in the two dimension. So that is the very important thing in a two dimension array. Now we have to see about the basic arithmetic operation in terms of array, like array 1 multiplies array 1. So once I can run this code 1, 4, 9, 16, 64, 81, 100 and 121, answer we are getting over here. If we should take array 1 minus array 1, we are getting the answer 0, 0, 0, 0, and then again 0, 0, 0. So almost many more operation we are able to do, like 1 divided by array 1. So here 1 divided by array 1, it means 1 divided by 1, 1 divided by 4, 1 divided by 9, 1 divided by 16. This type of things we are able to do with the arithmetic operation. Also we are able to do array 1 power 3. So here we are getting all the cubes based upon the array number 1 or the array 1. So now you are getting the idea how to work with the using arrays and scalars with the NumPy library. Next, we have to mention about the functions of arrays and many more things. In this practical session, we have to talk about indexing array. Again, in the NumPy, indexing and slicing it will play an important role. So let's see how we can apply indexing and slicing particular on the array. First thing, that is the import NumPy as NP. So with that, we are starting the things. Now let's create one simple array. So array is equals to np dot array, but as compared to a array, now I want to take np dot arrange. So with the help of the arrange function, now I want to create an array in between 0 to 11 numbers. So here my first array was created over here. So in multiple ways you are able to create an array. So in this way you can also able to create an array. So now let's check it out some indexing concept over here. Already after learning about the indexing and slicing, you already get an idea. So indexing based things are always based upon a position. So let's find out the array of zero position, what things are stand over here. So on zero position, zero number will stand because indexing will starting with the zero. So basically, if I have to put down the array of -1, so here I'm getting answer that is the 1 because array should work in positive and negative, forward direction and backward direction. In both direction it should work. Also, we already seen like how to grab the particular information if I want to access the number between 1 to 6. So that's why I have to write down the 1 to 6. So I'm getting the number in between 1 to 5 over here. 1, 2, 3, 4, and 5. So that's how array indexing should work. But there is one advantage are available in array indexing. You are also able to replace the things that is not easily available with the string and list. But that things you are able to do with the array. So let's see how we can able to do that three things. Array of 0 to 5. So in 0 to 5 we are having 0, 1, 2, 3, 4 numbers are there. Now I want to replace the 0 to 5 numbers with the replacement of 100. And now after running this code, now I want to check the array. So here the 0 to 5, it means 0, 1, 2, 3, 4 numbers are already replaced with the 100 and remaining numbers are look similarly. Let's check it out one more thing and we can see the same thing based upon a slicing. So now I want to create a new array. So array is equals to np. Okay, let's do not create need to create a new array. We can implement the change in similar this array. Okay, so that will looks very complex and it's also give an idea about the slicing as well as slice of array is equals to array 5 to 11. Now it looks better. And then again here slice of array, we have to run that code. Slice of not defined. Okay, 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 okay. Yes, now it's perfect. Yes. So we are getting the 5, 6, 7, 8, 9, and 10 numbers. We are just only getting from 5 to 11. Now what are the things we have to do? Among that number, first of all, I have to copy that number. So among of this number 5 to 10, I have to equal that all the number in terms of 99. So for that we have to take semicolon and here we have to apply 99 when we have to run this code. Now if I can provide the array, so you are getting the difference over here. The 0 to 5 are look like 100 and the remaining number are look like a 99. So that type of things we are able to see based upon the indexing and slicing of array. Also array are having their one main function, that is a copy function. So now let's see how to apply a copy of array. So for that we have to simply take a array that is already array created and we have to use the copy function over here with the blank bracket, and then the array of copy was already ready over here, array copy, and here we are getting the copy of our previous one array. So after getting idea about the indexing and slicing of array, now let's talk about the how to create two-dimension array. Already whenever we should learn about the list, at the same time we are seeing the one concept that is a nested list, and particular in that part we are creating many lists, but that list are not looking in terms of the particular matrix. But here we are create one for a proper matrix. So let's create a variable for the matrix with the help of the array. So for that we have to take np dot array. In particular in that array we have to take normal bracket. Particular in that we have to take all the things based upon a square bracket. But whenever you should try to create a two-dimension table like matrix, so you have to take a 2 times brackets, circle brackets. So that's why it will given two outer dimension, because whenever you want to work with the 2D, you have to provide two outer dimension. If you want to create 3D, so you have to provide three outer dimension. So particularly in that I want to provide the two outer dimension. That's why. So we have to create first list. Now second list is 20, 25, and 30. And again, third list is 35, 40, and 45. So that is the, so we have to check it out. Everything looks perfect or not. Yes, everything now it's perfect. And we lastly we have to call up matrix and we have to run that part. So here we are getting an idea 5, 10, 15, 20, 25, 30, 35, 40, and 45. Also, we are able to apply a indexing and slicing concept based upon two dimension of matrix. So let's see how we can see. So if I can provide the matrix of 1, so here I'm getting an answer look like a over here 20, 25, and 30 because 5, 10, and 50, 5, 10, and 50 it will stand for the 0 position. This one will stand for the 0 position. This will stand for the first position, and this will stand for the second position. So now here I'm getting an answer 20, 25, and 30. If I have to take an same thing and provide it over here, and in a second bracket I have to take an again one, so I am the getting an answer that is a 25. Because again, if we are having this one, so again we have to start it with 0, 1, and 2. So the final answer that is the 25. So that's how matrix should work. Let's find out some more thing like matrix of, again we have to first of all provide the semicolon and then we have to provide the 2. So here we are getting answer in terms of the 5, 10, and 15, 20, 25, and 30 because it should work in terms of the rows and columns. So whenever you should take this one, so meaning of that they are just only taken the particularly semicolon 2 rows. So that's why they are considered 0 and 1. Okay, so if they are just only considered 0 and 1, that's why we are just only getting this one as a output. But if you've taken just like only first two rows and first two columns, so for that you have to again create one logic for particular that one. For example, if in the answer I just only wants to get 10, 15, 25, and 30, so for that I have to create one logic, and particularly first logic I have to made it for the rows, and second logic I have to made it for the column over here. So when I have to take a semicolon and 2, it means I just only wants to take first two column, first two rows like 5, 10, 15, 20, 25, and 30. Let's check it out with the same thing. So here if I can apply the same thing, I'm getting 5, 10, and 15, 20, 25, and 30. But among that, I just only wants to get 10, 15, 25, and 30. So for that, what I have to do? Again here, I have to apply the 1 and semicolon. So that's why I'm getting 10, 15, 25, and 30. Because these 5 and 20 is related to the 0 position of column, 10 and 25 will stand on the first position of column, and the 15 and 30 will stand on the second position of column. So that's how this whole thing was working in terms of indexing and slicing of arrays and the matrices. Also, if you want to do some more practices, so you can also create a different type of the with the help of the zeros and ones, you are also able to create many more things based upon this type of the matrices. In this practical session we have to learn about the array transposition, and also we have to see about some different techniques to create an matrices or the array. So for starting, first of all we have to import numpy as np. So here NumPy was already imported over here. Now we are trying to create a new array, but with the different things. Till now we already seen how to create an array based upon a arrange function. So here the arrange function is already taken by me, and particularly in the arrange I have to selected 50 numbers. 0 to 50 numbers I already selected, but particular 0 to 50 numbers I want to reshape, or I want to apply in the particular shape of the 7 cross 7 or the 10 cross 5. So there are particular shape are there. If you should take 7 cross 7, so it means 7 rows and 7 columns of matrix you want to create, and particularly in that matrix you want to use 0 to 50 numbers, but here I want to create a 10 rows and 5 columns of matrix. So that's why here I have to selected 10 cross 5, and I have to run this code. So here you are getting an idea how you can apply the same thing. Also, if you want to make it a 7 cross 7, so you should use like 7 cross 7, and now you should run this code. So here whenever you should take 7 cross 7, so they are given an error, cannot reshape array of size of 15 to 7 cross 7. So for that you have to take on 49, and with the 49 you are getting the correct answer. So that's how you can implement, you can first of all create the array with in terms of the reshape option. Now it's time to apply the array transposition. To apply array transposition, you have to simple take write down the array with the transpose t, and then you have to run that code. So automatically with the help of this code, the array will transpose over here. Now if you can check, you can get an idea. Basically when we can apply the transposition, so in a transposition, rows are considered as a column and column should consider as a rows. Let's check it about how to create a dot product with the NumPy. So to create a dot product with the NumPy, you have to use np dot dot, and particularly in that you have to provide the array and array dot transpose, and you have to run this code. So at the same time, you are getting dot product between array transpose and the array. So in last particular session, we can talk about how to create a two-dimensional matrix. Now it's time to show about how to create a three-dimension array. So for that, we have to create a next array based upon array three dimension. And in that array, we have to first of all take an np dot arrange, and based upon np dot arrange, we have to provide some shape. So here I want to just take a 5 as a shape, and based upon that 5, I want to apply also the reshape. And in reshape, I want to take it 5 cross 2 matrices. So 5 is the basically we have to take on 5 rows and 2 columns, but as well as here that is the 3 dimension are there. So also we have to decide how many total matrices you want to create. So total I want to create a 5 matrices in 3 dimension. So whenever you are to trying to create a 3 dimension matrix, at the same time you have to provide the 3 arguments. First argument is based upon how many matrix you want to create in third dimension. Second thing is based upon a rows, and third thing based upon a column. And again, once you can complete this one, then we have to call the array three dimension. So here we are getting an array cannot reshape array of size into the shape of 5 cross 5 cross 2. So let's check it out. What are the errors we had done? Yes, actually the error is not based upon that error, because whenever we are trying to do this one, we have to provide one more bracket for providing the outer dimension. So that is an error is made by us. So again we are getting an error. I have to check it out. What are the issues? Okay, it is not working or not. We have to check np dot arrange reshape 5 cross 2. We have to check it out. What are the things are coming over here? Okay, so let's see. We can change this number because I think I can provide the 50, but here there's just only 5. So we have to run this code. Now it's getting a proper answer. So when we're trying to apply the third dimension, so we have to provide total 50 numbers. So according to the 50 numbers, we are getting the proper result over here. And that's how this thing should working over here. So basically among the 0 number to the 49 number till 49 number, we are getting the final result over here. So based upon that, we are able to create a three dimension matrices. Also, if you want to apply the transpose of the three dimension, you are also able to do the same thing. So that is depends upon you, like how you want to create the same thing. So for that, what we have to do, let's check it out how to apply the transpose with the third dimension. So for that, you have to take array of three dimension dot transpose. You have to take dot transpose, and with particular that you have to take it 1 0, and then you have to take a 2. So according to 1 0 and 2, you are getting the proper things in terms of the array of transposing. So here these all are the brackets will represent the outer dimension. So outer dimension is very important whenever you are working with this type of things. So in the next things, we have to see about the universal array functions. In this session, we have to talk about universal array functions. So basically with the NumPy library or the array function array, what are the universal functions are working as a appropriate. So first of all, we have to import the library, import NumPy as np. And after importing the NumPy library, we have to make it one sample array based upon the np of arrange with the particular number of 11. So here the array is already created over here. So let's talk about the universal array function. So what are the universal functions are available with the array? So first function is based upon the square root. So we have to take an np dot square root, sqrt square root, and under the bracket we have to provide the array. So here we are getting an idea like 0 square root, we are getting 1 square root, 2 square root, third 3 square root. So all the square root value we are getting over here. So what are the value here we are getting over here? All the values are coming in terms of the floating of 64-bit. Let's see about how to exponential value we are getting. And here we are getting idea about the exponential function. So with the help of the exponential function, we already provide the things onto the array, and here we are getting the same answer over here. Let's create one more array based upon some random thing like a is equals to np dot random dot rand n. Rand n will stand for the random numbers, and random will stand for the random library. And then among that I want to find out the total 10 random numbers. So here with the help of a I'm getting the 10 random numbers. Similarly with the b I want to apply the same thing over here. So that's why we have to write down the random dot rand n of, again here we have to take on a 10 numbers, and that will stand for the b. So the A is also random numbers of set, and B is also the random number of set. So based upon this random number of set, I want to find out the binary function that is based upon a addition function. So for that we have to take an np dot add of A and B. So if I can run this code, I'm getting the addition of A and B, and both A and B are the random things are over here. Also we are able to find out the maximum things among that, like np dot maximum of a and b. So here we are getting the maximum thing, but still here I'm getting an error. So the error is due to the, I think the maximum, I think m was the capital according to that one. So we have to check that things like what are the issues in spelling. Okay, so the here error is based upon the maximum, and I just write down the maximum. So yeah, so I'm getting the correct answer over here. So that's how based upon a universal function we are getting the maximum number, as well as we are also able to find out the minimum number over here, like within the a and b. So again the minimum, yes, the same error I can done. Yes, so that's why we are getting the same thing for the maximum as well as for the minimum. So the NumPy library, what are the things we had to learn based upon the NumPy library? All the basic or all the important things we already learned based upon that part. And in the next things we have to learn about the array processing, like how the array should process. And basically that topic is looks very based upon some trigonometry type of things are also shown over here. So we can learn on that topic, particular that one. In this practical session, we have to learn about array processing. So array processing is the last practical topic in the particularly Python libraries with the NumPy. After that, we have to learn about the Pandas library. So let's start it with the array processing. First of all, we have to import the library as import NumPy as np. But here, just only NumPy library is not efficient or the enough. We have to import another library, and that is the Matplotlib library. So for that, we have to write down the code import matplotlib dot pyplot as plt. So why here matplotlib library should be used? So with the array, what are the array we are getting? If you also want to make it some plot based upon that array, so at the same time we have to use matplotlib library. And also for making some reference, we are also providing one more line based upon a matplotlib, that is the matplotlib inline. Because if you are not providing this matplotlib inline type of course, at the same time at some time you are getting an error based upon the pixel. That's why. So let's create some point for particular that for array processing. So point is equals to, we have to use some np.arrange. You already aware about the np.arrange. We have to take on some point from -5 to +5, like -5 to +5, and we have to provide some step size around 0.01. So based upon this point, we are able to create dx and dy. So here, particularly with the dx and dy, what we have to do, we have to create one mesh grid. It's a one type of the blank chart I want to create. That's why we have to use np dot mesh grid. And if you want to develop this mesh grid at the same time, also the matplotlib should be helpful. So we have to take in points. So both the times we have to take points. I have to take just only point. That's why we didn't use s. So we already created dx and dy. So let's check what is the value of dx and what is the value of dy. So here, based upon the value of dx and dy, we are getting an idea. So all the values are coming in between 5 minus 5 to plus 5 with the step size of 0.01. Based upon that, from the trigonometry, you are also able to develop some sine function as well as cos function and tan function. So let's see how to develop sine function. So for that, I have to create a z, and z is equals to, we have to write down in a circle bracket, np dot sine of dx, and then we have to provide the plus np dot sine of dy. So that's why np of sine of dx plus np dot sine of dy. So based upon that, we have to find out the z over here. So this is the value of z. So that's how, with the help of the NumPy, you are also able to make it some trigonometric things. And now, based upon this one, now I want to plot the simple plot based upon this calculation or this value of z. So plot dot im show of z. Whenever you are using the Matplotlib library, and based upon this Matplotlib library, you want to show some type of the charts or plots. At the same time, you have to use plot.imShow. Show or the plot.show, it is also available with that part. So if once I can run this course, so at the end I'm getting this type of visualization. So basically, this type of visualization will it just only represent the particular calculation of the z, that is based upon a sine of x and sine of y. So here, particularly array processing, that was completed over here. And in next part, we have to talk about, or we have to see some practical things based upon the pandas library. In this practical session, we have to learn about the pandas library. Basically, from the pandas library, we have to learn about the series concept. So let's first of all import the pandas library. Before going to import the pandas library, we have to import the NumPy library. So for import the NumPy library, we are using a NumPy import NumPy as np. And for import the pandas library, we have to use import pandas as pd. So pd is the standard shortcut for the pandas. Also, from the pandas, we have to learn about the series and data frame. In theory part, already we discussed about what is the meaning of series and what is the meaning of data frame. Series is again look like a single dimensional or the one dimensional array, and the data frame is look like a two-dimensional array or the double dimensional array. Let's import again that part. From pandas, import series. So here, when you apply the series, so s should be the capital, and second thing, that is the data frame, whereas d was the capital data frame. And now we have to run this code. After running this code, here I'm getting an error from pandas. Series and data frame is that cannot import name data frame. So we have to find out what are the issues we are facing. Yes, here again f is also the capital when we import a data frame. So you have to mention, and you have to don't forget this part as well. As like data frame, f should also be the capital one. Now it's time to create a series. Okay, so first of all, for that I have to take an object and the particular variable name, that is the object. And for creating series, we have to take a series as with the capital S. And for creating series, again we have to take normal brackets, but inside the normal brackets, similarly to the single dimensional array, we have to take on a square bracket. So first series is depends upon like this one. So that is why first series, you can also call that this series, and you are getting this one object 3, 6, 9 and 12 are over here. Also you can find out throughout the values, like if you can provide some function like values with this object, so you are getting 3, 6, 9 and that, and 9 and 12. And these all data types are the integer 64. All numbers are the integer. Okay, if I can provide the 3.0, then it should become a floating point. If I should provide 3.0, now the answer is look like this one, and now data type should be the change, and it should become a floating 64-bit. Okay, so after getting idea about that one, we can also send some more function based upon this one, and next function, that is the object of index. So after applying index, we are getting the starting point and the stopping point. So how many numbers are available in this part? So 0 position, that's the starting point, and the 4th position, that is the last point. and step is equals to 1, so particular within one step size. So it's not related to like 369. They are not finding out the 3 plus 3, it's a 6, 6 plus 3 it's a 9. They are not finding out that type of step, they are just find out based upon the sequence. Okay, so that's how we are able to create a simple series. After getting idea about the series, now we have to see how to create a simple data frame. But because before starting to data frame, still we can see some more complicated series. Okay, so that's why I have to create over here the df stand for the data frame. But now I'm not trying to create the data frame, just I have to take a parameter name or the table name, that is the data frame. But still I want to create the series over here. And particular in this series, I want to make it some large series. That's why I can take it this type of parameter. Like I want to make it some population based things. Okay, that's why I have to take 1770. Also some type of number I want to select, that's why I have to take in this type of things over here. And then okay, so already 5 number I already taken. Okay, so that is the first one is there. And the second in this particular series, second thing, that is the index. Index is basically the country name. I want to take it over here. Again, we have to take a square bracket. Particularly here we have to use some country name. First is the India, second is the USA, third was the China, fourth was the Japan. Again, I forgot to apply single quotes. And the last country, that is the Germany. So basically the simple df was created over here, and also we can call up this df. So here according to df we are getting some population. I think that is not a correct population, but I just only simple take some type of the population. So when you create this type of small series, you can provide some numbers, and according to that numbers you can also provide some index, like index can representative of that particular number. So once you can create this type of thing, so based upon the data frame or the df function, df variable, you are able to find out many insight. Like you are also able to find out df dot usa, so here you are getting the numbers related to the usa. Also you can find out the things like, for particular in this data frame or particular in this table, how many numbers are greater than 1000, or how many numbers are greater than 4000. That type of analytics you can do. So for that you have to take a df greater than 4000. So what are the countries are greater than 4000 you are getting over here. If you can increase the limit like 4500, so you are getting some more analytics over here. Also particular, whenever we should learn about the python programming concepts, at the same time we are also using the in operator. So you can also apply the in operator over here, like usa in df. So if usa is present in our data frame, then you are getting answer it's a true. But if you find out like if you can take a sudan country, okay, so if you can take this country sudan in df, so false, sudan is not available in this particularly df. You can also convert this df to the dictionary. So let's see how we can convert that part. So for that I have to create like dict1 is equals to, you have to use this function df dot to, you have to provide slash and then dictionary, and with this bracket, and then again you have to create the dictionary one, and then you can run this code. So here you are getting every information in terms of the dictionary. So that's how this thing should be helpful to you with the help of the dictionary. So many type of format you can provide, like in terms of series, if you want to things, you are also getting the same way as well. As now let's check it out one more example based upon the same concept. Now I want to create one list based upon the country. Okay, so country is the name of the column, and in this particular thing I want to apply some country like china, then germany, then next country is the japan, then I have to take on a usa. Okay, so I don't want to take some more countries, and last is the india. Okay, so that's why country column was already ready over here. Now I want to take it the things based upon like object 2 is equals to series of, already created the dictionary one, and particularly in terms of index I want to take it a country column, country. Here I have to take a few 5 country, and in my data how many country I was taken, also there is 5 countries is there. Okay, So that is okay. So here this one created, and now again I have to find out that part as well as. So here you are getting the China is nan, Germany nan, the Japan, USA, India. So some type of things we are getting some facing problem issues over here, because I think it shouldn't be correlated with properly. That's why, because USA is properly over there. Okay. I think some capital and small letter issues we are facing. Yes, because here in particular spelling of China I have to take in capital C, so that's why there is some issues are there. Here also G are there, here also the J is there. So now everything is looks better. Yeah, now it's correct. Also, if you want to add some more countries, okay, let's add one more country, and that is the UAE. Okay, so I want to add the UAE. So whenever I just added new country, and that is the UAE, so UAE are having the values of NAN, not available any number. So what is the advantage to add these things? So here we are getting the idea, whenever the number is not available or the blank number is there. So at the same time, we are also create some parameter like is null or not null. Okay, so that is the object number 2 is there. So let's make it same thing based upon the same part. So with the help of the pandas, here I want to write down one code, pd dot is null, pd dot is null. Okay, we have to find out any null values are there or any zero values are there or not, and object 2. So here everywhere null values false. But at the time of the UAE, they are showing the value that it look like a true, because UAE are having no value, and that's why here we are getting the true. Also similarly to this one, we are having one more function is over here, the pandas, and that is the not null. This is the is null, but we can also make it the things based upon a not null. And whenever we are getting the not null, at the same time UAE are getting the false, and rather than other countries are getting the true. So this type of things we are able to see based upon this series. Okay, so also if you want to explore more things based upon that one, you are getting more idea about that. Particularly in the next session, we have to see about the how to apply the index objecting things. In this session, we have to talk about how to apply indexing on a particular series. So for that particularly, first of all, we have to import the libraries, import the NumPy as NP, import the pandas as PD, and import from the pandas we have to import series and the data frame. So let's create our first series particular for this topic. So series name, that is the my series. Okay, so I have to provide the name of the series is my series, and here we have to use the function of series over here, and particular in this function we have to take in some number like 1 2 3 and 4. And the next thing in that particular index, so index is equals to nothing but a b c and d. We have to take an a, then we have to take a b, to take an c, and then last we have to take a d. So that is my series, and now I have to just call up this series over here. Okay, so that is the series a b c d 1 2 3 4 are there. Also you can provide the as a you can also consider the series as an index. Okay, so I can consider the same thing, my index is equals to my series. So once you can apply the same thing, so after that you are getting the my index over here with the integer of 64 bits. So that here we are not getting any type of the difference over here. But again, you can also provide this when you find out that this type of index. So you can, if you want, you can also provide the index function with your series. So once you can apply that particular index function in your series, so output should be here the different. So now they detect index of a b c d as a data type of the object. So according to this one, you can also, now you are trying to solve the indexing concept over here. So let's check it out. Once I can apply the my index, and particular in square bracket you have to apply 2. So here the answer is 0 1 2. So on a 2 position the c will stand over here. If you can provide the same thing with the -1 or many more concepts we already seen, particular with the topic of the indexing. So here we are getting the d. If particular with the same thing, if I can provide the 1 semicolon 3, so 1 semicolon 3, so what are the answers? 0 1. So answer is starting from the b, 0 1 2 and 3. So answer is related to b and c. So b and c is the correct answer. So that's how we already seen many times how to apply the indexing and how to apply the slicing. We already seen upon the same thing concept on a string, list, tuples, dictionaries, and many more times. And also here we can see same thing with the NumPy and in the particular matrix of 2 dimensions. And the similar things we already seen on a series. But in next we can also see in the indexing concept with the data frame as well as when whereas you are having some good data set with the columns labeled and particularly things we have to see based upon that part. In this practical session, we have to see about the reindex concept. Till now, what are the things we already seen? That is, all the thing is based upon a series. Now we have to see how to apply the reindex concept based upon a data frame. So before applying that one, we have to use some library like Pandas, NumPy. With the NumPy, we have to use series and data frame. And also now here we have to use one new library, and that is the random number library. So with the help of the number library, we are able to generate some random number over here. So let's run this library, and now it's time to create one first data frame. So data frame shortcut is the df, and for particular this one here we have to take a data frame. In the data frame there is total two things are there. First is the index and second thing that is the column. But before that here we already imported a random number library, so here we are using some random numbers. So for that, first of all we have to apply some random numbers. So rand n, so that's represent with the random numbers. So particularly up to 25 random numbers I want, so that's why I have to take 25. Also you have to provide some reshape. It means you have to provide some matrices size. So here I have to taken like 5 cross 5 matrices. So 5 cross 5 matrices I should use over here. After getting this one, next thing that is I want to add it over here, that is the index. So particular in terms of index, I want to take it A, B, C, D. So first that is the A, second that is the B, third one that is the D. After that that is the E is there, and then at the end final that is the F is there, and then F is there. And now I have to close this box, but still I forgot to start this box with the square bracket. Yes, now it's done. After getting idea about this one, next thing what we have I have to create, that is the column is there. And particularly in this column I have to add something like column number 1, 2, 3, 4 and 5. So that's why again I have to create the square bracket, and here I have to take a column number 1. Second thing, that is the column number 2. So I have to copy the things because every time you have to write down the codes and many more things are over here. So we have to apply this comma. Okay, so according to that we are taken column number 1, column number 2, then we have to taken column number 3, then we should use column number 4, and then we have to use column number 5, A B C D, A B D E F. So that is the 5 things, and also here we are having the 5 things. So after completion of this we are just only write down the DF. Okay. I didn't follow the space. Yeah. Now it's perfect. But again, they are finding an error, particular in what level? DF level. Okay. Let's check it out. This one was wrong or not. Okay, so here I think the bracket was not closed. That's why. Now it's a bracket was closed over here, and now we are trying to get the DF over here. So we are already getting the DF, first DF. Now if you want to create the second data frame, so you can take a df2. We have to take it over here. The df2 is equals to, again we have to use data frame, or as a shortcut you can also use dframe. But here already we are already create one first df. So if you want to create a new data frame based upon your existing df, so you can also use that particular df. And particular in that you can apply the reindex concept over here. So once you can apply the reindex, and now you can again apply the square bracket over here. And in particular square bracket we have to take an A B C D E F. So the same thing we have to apply it over here. Just only one things I have to add it over here, and that is the C. I have to add a C over here, and then again we have to take a comma. Also that is a markdown, and we have to convert as a code. So now it's perfect. Now it looks perfect, and we have to run this code again. Why we are getting an error? Yes, again I forgot to close the brackets. Yes, and now we have to write down over here the df2, and we are getting the correct thing over here. So if you can see in my previous data frame I have just only a b d e f, and column 1 2 3 4 5 is there. But here in data frame 2 I have a b c d e f, and also column 1 to 5 is there. So column C are having all the values related to the NaN. But now if I should add a column number 6 over here, so what are the answers? So again, I'm getting in column number 6, I'm getting the values related to the NaN. So here I have to add the new column based upon that. So I have to first of all create the new column over here. Before that, again, I have to use the same thing from over here, that is the brackets are there. And now I want to just simple, I have to add the one thing, and that is the column number 6. And based upon that, I have to create the new column over here. So new column, that is the column number 1 to 6. And again, we have to add this new column into our data frame 2. So for that, we have to provide the df2 with, again, I have to provide the reindex things. And with the reindex, I have to apply the columns is equals to new column. So I have to check, I have to take a column or columns. Yes, columns I have to take, and now I have to run this code. Yes. So here also column number 6 was added over here. So that's how we can apply the reindex concept. Whenever you want to apply this type of stuff, it is based depends upon the reindex. Also further, whenever we should take some practical based upon a data set, we are getting an idea how we can apply these NN values to the zeros, because there is multiple methods is there. And now final my current DF, that is this one, column number 1 to 5. So that's how you can compare the things and you can get the better idea. Still, we have to see in many more topics based upon the Pandas library, like drop entries and missing values handling. We have to see many more things based upon the Pandas library. In this practical session, we have to learn about the drop entry. So let's start it with the first thing, that is the import the libraries. So first of all, we already known in previous sessions according to like what are the necessary library for making these things. First of all, import NumPy as NP. Then second thing, that is the import pandas as PD. After that, we are also taken the from pandas import series and data frame. In a last thing, in our index topic, we already seen about like how to use or how to create a data frame. So now we can see some more example based upon a data frame, as well as some things based upon a series as well as. So I already imported a data frame and the series over here. Now let's create one simple series, and based upon series, now in this particular topic we have to see about how to drop entries. So now I have to create the series number 1, and for that I have to take on a series, and particularly we have taken these things, and also we have to using NumPy library to create one range, and particularly we have to take a range of 3. That depends upon you. If you want to take a range things, you can also take that one as well as. After taken number of 3, it means 0 1 2 3, like that type of number I was taken 1 2 3 or 0 1 2. Okay, because we have to take a range of 3, so it will automatically select the 0 1 and 2. It will not select 1 2 and 3. Okay, so now next we have to create one index according to that one, and particularly index we have to create A, B, and next thing, that is the C. Series 1 is already created over here, ABC 0 1 and 2. Now we have to see in how to apply or how to drop the entries from this particular series. So for that we have to use the drop function, like series 1 dot drop, and particularly in the drop we have to provide one particular index. So here I want to select the B index. Okay, because we in index we are having A, B, and C. So from the A, B, and C I want to select the B over here, and now I'm trying to run these things. So from the output you are getting an idea. From this series, B was already dropped over here. Same concept we have to see based upon a data frame. So let's check it out how we can apply the same thing based upon a data frame. So for that, I have to just simply take an df, and then we have to use a data frame function for particularly that one. Also, we have to take a bracket, and particular in bracket we have to provide again np dot arrange function. With the help of arrange function, I want to choose the 9 because I want to create the 3 cross 3 matrix. That's why. And then we have to apply the reshape and bracket. We have to using, or we have to create the 3 cross 3. That's why we have to take on this type of dimension over here. Then we have to provide the index, and particularly in the index we have to provide some country's name, or if you want you can also provide some city's name of India or whatever the country. Okay, let's take a first thing, that is the Delhi. Second thing we have to take an Mumbai, and the third thing we have to take that is the Kolkata. Okay, so there is a three things are there, and whenever we are trying to create the data frame at the same time, we have to provide first of all the array with the arrange and reshape. We have to just provide the numbers, like how many numbers we have to take in. But whenever we have to create a data frame at the same time, we have to rename, or we have to provide the label for our rows as well as for the columns. So that's why index will represent the rows, but now with the help of the columns we have to create our column names. So column name, that is the pop size and year, we have to take on that part. First one, that is a pop. Second thing, that is the size. And third thing, that is the year over here. So now almost data frame was created over here. We can also call it as a df, and now we can run these things. I think we have to check what type of things, reshape. We have to check it out, any type of the things. Okay, reshape not defined. Okay. By mistake, I have to use that one. Yes, now it's clear. So the DF was already created over here. So based upon a DF, we are trying to drop some rows as well as columns from here. So first of all, let's remove the Mumbai rows from here. So let's see how we can apply the same thing. So for that, we have to take df dot drop of, in single quotes we have to provide the, we have to write down the Mumbai over here, and now it's time to run this code. So when I should run this code, so if you can get the idea, like when supply the drop things with the Mumbai things, so at the same time the Mumbai rows is removed from our data frame. But still if I can provide the df over here, so still again I'm getting the same thing. So we are getting an idea what are the drop comment we can provide, that is applied for particular one output, but it is not saved in the data frame. If you want to same thing, if you want to save the same thing in the data frame, that's why you have to call up with particular data frame name, like df2 is equals to df dot drop of Mumbai. Now you can run this one, df are getting these things, but if you can write down over here the code like df2, so you are getting the just only Delhi and Kolkata in your answer. So that's how thing was working over here. Let's see some more things based upon same thing. Now again we are having the df, again I can make it the df. Okay, so now I want to change one more thing. I want to remove, or I want to drop the size column from over here. So for that, what I can do, I have to provide the df dot drop. But in particularly drop, I didn't write down directly size. Okay, for that, what I have to do, also here I have to provide the axis is equals to 1. Why I have to provide the axis equals to 1? Because on a 0 position pop is there, on a 1 position size is there, and on a second position 0 1 2, like on a second position year is there. Okay, so we have to provide, if you want to drop the size columns at the same time, you have to provide df dot drop of size and axis is equals to 1. Now it's time to run this code, but still we are getting an error. We have to check what type. Yes, yeah, now that is correct, because I directly write the things without applying the comma, that's why. So here we are getting the size was already removed from our column. So that's how you can drop the entries in terms of columns and also in terms of the rows from your, with the help of your Pandas library. In this practical session, we have to learn about how to select the entries from your data set or the data frame or the series. So let's start it with the first thing, that is the import the libraries. So before here, I have to import the libraries, that import NumPy as NP. Second library is import Pandas as PD. And the third thing, that is the from Pandas import series and the data frame. So that's how we have to import first of all library. After importing the library, now you already know how to create a series. So that's how we have to create series number 1, and that's why we are using first of all series function. And with this series function, we have to provide some np dot arrange to get some numbers, 0 1 and 2 numbers I want, that's why to take a range of 3. And also we have to provide index similarly to like a b and c. So here I have to take A, then I have to take B, and then I have to take a C. So series 1 is created over here, but you can still make something based upon a series 1. Like if you want to reassign the series number 1, like series 1 is equals to 2 into series 1, so you can also make it the same thing. Like series 1 is equals to 2 into series 1. So now the series 1 is look like ABC with the 0, 2 and 4. In previous one we are having series 1 that is a 0, 1 and 2, but now we are having the series 1 that is a 0, 1 and 4, because all the things are getting the multiplication with the 2. Now how to select the entries? So according to series number 1, we are using a square bracket to select the entries. Like for example, I want to access the value of B. So that's why I have to just simple return of like series of 1 square bracket with B. So I'm getting the value of particular the B value like 2. Also you are getting, if you want to access the same thing from their position, you can also find out the same thing like series of 1 with the square bracket. If you can write down to 1, so on a 1 position we are having a number 2. So that's why same answer we are getting over here. Also the selecting entries is another way. It's similarly to look like the indexing concept, because indexing concept and the selecting entry concept are looking like similarly to grab the thing. If I can put down the 0 semicolon 3, so here I'm getting the answer is related to the VC 0, 2 and 4. So that's how I'm getting an answer over here. Similarly, you can also provide the series 1, and particular with the series 1, you can also take it the like A and B over here. Like A, and the second thing that is depends upon the B. So that's how you can find out the things, but here I'm getting an error because I already written everything in a capital format, and now I'm trying to write down the things based upon a small format. That's why. So again, I'm getting an error. So we have to check it. Yes. So again, we are getting an error based upon a, because here I want to access the two information. So that's why when you want to get the two information at the same time, you have to provide the two outer dimension. So based upon outer dimension, they can provide the things. So that's why we have to provide the 2 times square bracket. And now we are getting the perfect output over here. Also, if you want to find out the things like related to the here, total three values are there, 0, 2 and 4. If you want to grab the information is greater than 3, so at the same time you have to provide series 1 greater than 3. That type of logic you can create over here. So let's see how we can make it that one. Like series 1 in bracket you have to take on series 1 greater than 3 over here, and now you have to run this part. So you are getting value only C, because only C are having that value that is greater than 3. You can also put down like greater than 1 or greater than 2, so you are getting some more values because 0, 2 and 4 values are there. That's why based upon that we are getting the same thing. Also, if you want to replace something like those values are greater than 3, and if you want to replace that value with the 10 or 20 or whatever the number, so you can also do the same thing. So let's see, those values are greater than 3. I want to replace that value with the number of 10, and then I have to check it series number 1, and now I have to run this code. So 4 is replaced with the 10. So those numbers are greater than 4. Those are automatically replaced with the number of 10. So that's how logic you can create it for selecting the entries over here. Same concept you can also apply it with the data frame as well as. So in the next thing, we have to see about how to apply the data alignment based upon a series. In this practical session, we have to learn about the data alignment. So first of all, we have to use the library. That's why I already imported the libraries over here. And next things, we have to create one series, and based upon that series, we have to see how to apply the data alignment. So for making a data alignment, we have to first of all create a two series. So that's why first of all, I have to create the series number 1, and that's how we have to take a series of. Again here that is depends upon you. If you want to go with the np.arrange with the 2, you can also go with that part. And also if you just simply what you want to take it 0, 1 and 2, you can also take it the same thing, because both things can provide you the same results. In the index, again we have to take an A, then B, and then C. So series number 1 that was created over here, and now it's time to create the series number 2. So for creating a series number 2, I'm just copying the series number 1 to get better idea with some parameter level. So here we are taken 0, 1 and 2, but now here I want to take a 0, 1, 2 already taken. So 3, 4 and 5 I want to take over here, and as replacement of A, B and C, I just only wants to take A, B, C, and but I want to take it over here the D. Okay, because in series number one we have to take an A, B, C, but here I want to take A, B, and D, and now again we can call up the series number two as well as. So if you can see over here, in series number one we are having the A, B, C with the 0, 1, and 2. In series number two we are having the A, B, and D with the 3, 4, and 5. So in a data alignment, we have to provide some concatenation between series number one and series number two. So now I have to provide that concatations. So the series number one are having A are having the 3, because see here what is happening over here, like 0 plus 3. So we are getting the answer that is a 3. Then 4, here the value of B is a 4, and but here it is a 1. So 4 plus 1, that is a 5. But C is already present in our first series, but C is not present in our second series. So that's why we are getting NaN, not available any number. And also D is available in series number 2, but D is not available in series number 1. So that's why we are getting again NaN, not available any type of the number. So you have to don't forget this type of stuff over here. Let's make some more changes in this particular series. Now after 3, 4, 5, and 6 I want to add over here, and also over here I want to take it C over here, and then I want to make it a D over here, and now again I want to run this code. So now the C value is also available in series number 1 and series number 2. So that's why 2 plus 5, 7. So here I'm getting the idea, the C is equals to 7.0. And these again still shown are not available any type of the number. So you have to remember this type of data. I mean, whenever you should provide this type of the concatenation in particular terms of the series. Same concept you should also apply it in particular type of the data frame. Basically wherever you can solve some project based upon a data sets. Okay, so at the same time you are getting an idea like how you should work with the data frame as well as all the things I just only shown with the series, because I think you can try to understand to your own self in terms of the practice to how to do same thing with the data frame. Whenever you should work with the series, so in a series just only index should available, but whenever you should work with the data frame at the same time index and column, both the things are available, but the logic is again same. You have to create the first data frame, also you have to create the second data frame, and based upon the first and second data frame you are trying to solve this type of things, and you are also getting some source at the in the selection of source you are getting all the solution based upon the data frame as well as. So it's not look like that if you are stuck at somewhere, so how you can get the help. But still here I will show you how you can do the same thing with the data frame. So that's why we have to create a df number one, like data frame one. And to create a data frame we have to first of all use the data frame function. With the data frame function we have to provide many more things. First of all we have to provide the np dot arrange of, we have to take a 4. Also within this 4 we have to provide the reshape, and reshape we have to take 2 cross 2 because we have taken 4 number of arrange thing, that's why. Now after completion of this one, here we have to provide again the columns over here. So in the columns we have to provide the column name, so that is depends upon you. But now again I will show you one more different and new things. You are also able to create the list of column. So at the same time what has happened, there is no need to apply individual undercodes of a and b. You can directly apply one undercode and you can just simply type a and b. So when it's provided in column, so a and b looks individual. Now after that we can see how to apply the indexing. So indexing you already know how to apply the indexing over here. And for indexing we are using, we have two things, and that is the first is the Delhi. So Del will represent with the Del. Okay, I can take the full name of Delhi. And then second name that is the Mumbai. Okay, so that's how two cities I already taken over here, and then I have to close this square bracket as well as this circle bracket over here. Still again we have to check it everything we can provide the correctly way or not, because whenever you are doing this type of things, there is at the same time you are using multiple brackets. So that's why you have to clear with your all brackets. So now df1, and now you have to run these things. So here if you can see Delhi and Mumbai A and B. So we particular whenever I just apply the input for A and B, I have to just simple use list of A and B. So that's why it can provide one type of the advantage over here. Let's create a df2. But for creating df2 I'm also using the same thing from over here. Okay, I'm not taking many two things right down over here, but I have to change something from over here. a range of, I have to take 9. That's why my reshape of the matrix, that is 3 cross 3 over here. So I have to take 3 cross 3. List is equals to A, B, C, as compared to take, I have to take A, D, and C. And for the index, I have to take on Delhi, Mumbai, and the next thing that I have to take on, that is the Bangalore. Okay, so I have to take on 3 cities over here, and again I have to write down the DF2. Also now, again, what we have to do, we have to apply the DF1 plus df2, and now to run these things. So whenever I should apply the df1 plus df2, so just only the column A, that is the common things in between Delhi, Bangalore, and Mumbai in both the table. But in first table we are just only having the Delhi and Mumbai, but in second table we are having Delhi, Mumbai, and Bangalore. So that's why if you can see the addition of the df1 plus df2, you are getting an idea. You are just only having the values on the place of Delhi with the A and Mumbai with the A, because first data frame the b will present, but in second data frame b will not present, and as a replacement of b and b we are having d and c. So that type of stuff we are getting over here. So let's see some more thing based upon that, like how we can work with this particular NaN values, and how we can solve this type of things over here. So let's see, I will show you one more thing. Like if you can see df1 over here, so we are getting just only these things, but we are having one more function, that is the add function. So with the help of the add function we can make it something based upon df2, and whenever we are having the NaN value, so we can provide at the same time the fill value function, and with the help of the fill value we can provide over the zeros. So that's how now to run these things. And now if you can see just only Bangalore with the b, I am having the NaN, but rather than all are having the values. Why they all are having the values? So here what I should do, first of all, I have to use the data frame 1, and particularly in the data frame 1, I have to use the new entries from the data frame 2. So Delhi, Mumbai, and Bangalore related to the D and C, all the entries are suitable over here, because D and C is not present in the table number 1 or the data frame number 1. So that's why with the help of this type of technique, you will get an idea how to fill the values with the not available any type of the number. In this practical session, we have to learn about how to apply the ranking and sorting with the series and data frame. So first of all, we have to import the library. So library is already imported over here, and now it's time to create the series number 1. So I have to create the series number 1. For creating series, now I think you are getting some better idea to how to create a series with the different and multiple ways. So again, I will show you here one different way to over here. You can also apply the np.arrange of 3, and it is also look like similarly to this one, like list of range of 3. So both can provide the same output. So that's why don't be confused if you want to work with that particular approach, like np.arrange of 3, and also with the reshape or many type of things are there. So you can also follow that. But here for just showing a different ways to apply the same thing, that's why here I have to take this one. So now I have to provide the index is the C, B, A, and B. So I have to use some random order. Okay, I'm not using A, B, and C, because here we have to apply some short function. That's why I have to taken already some random things. Now we have to take A, and now we have to take a B. So that is our series number 1, and then we are getting an out. So series number 1 are having C, A, B, 0, 1, and 2. So how to apply the shorting on a series? So we have to take series number 1 dot with the, we have to use the function of series short with the particular of the index. So that's why you have to provide the short of index. So then and then you are getting the proper shorting based upon your series. So here you are getting the ID output related to the A, B, C, and the output is 1, 2, and 0. So here the meaning of sort of index, that is the meaning is that like what are the sorting is applied over here, that is depends upon a index. Okay, index it means C and B, that is depends upon the index. If you can use the same code, but you can replace with the index if you are using a values, so at the same time it can give the sorting based upon the values like 0, 1, and 2. So answer is depends upon a 0, 1, and 2. So now C, A, B, the answer is based upon a 0, 1, and 2. So that type of things can happen with the help of the ranking and sorting. Now let's see some more thing. And for applying more thing, now I want to import one more library, and that is the NumPy dot random to get some random numbers. So you already known about how to use a NumPy random with the import some random numbers. So that's why we have to use rand n. to get some random numbers. Let's create a series number 2, and particular in the series number 2, first of all we have to use the function of series, and with the series we are using the random number of 10 because I want to generate the 10 random numbers. That's why I want to take this one. So these are my random top matlab, means particularly 10 random numbers are over here. So based upon these 10 random numbers, you can also provide them some sorting based upon the values. Okay, so let's see same thing. For that, we have to take on series 2 dot short, and then we have to take on values. And okay, so we have to just simple taken out values look like the first series, and we are not providing anything inside this one. Okay, so we are getting this type of values over here. You can also provide the rank with these things like series 2 dot rank function. So with the rank function, what is happening over here? So when you apply the rank function over here, so you are not getting the values like minus 1.48. You are just only getting the values like 3.0, 2.0, 4.0, 10.0. That's how you are getting. Okay, so that type of things you are getting with the rank and short things. If you want to create third series based upon some new random numbers, so you can also make it the same thing. So for that, what I should do, I can copy this code over here and I have to paste it over here, and I have to take a series 2 as replace to series number 3, and again we are getting some more random numbers. So every time we are getting some random numbers. And also if you want to use again this same code similarly, so you can do the same thing. And here we have to take just only 3 and we have to apply the same thing. So again many more things are there. If you want to create a data frame, and based upon a data frame you are just only take the df.rank or df.short values based upon particular column or the particular rows, you are getting the same things. So in replacement over here, what I should apply the index and values, so you can also apply the column names. That type of things you can also done with the data frames. In this practical session, we have to see about how to handle the missing data with the Pandas library. So first of all, important thing that is import the libraries. So library is already imported over here, and now it's time to create a series. So here I have to take a series name that is the data, and I have to create first of all first series. And now in series I'm not provided any type of the number like 0, 1, 2 because it will comes automatically with series, but now just only provide the index. So that's why if you just only wants to provide the single index at the same time, no need to call as the index. We have to just only create the simple thing. So here I want to create some strings 1, 2, and I'm not taking 3, but here in the placement of 3 I have to take in just simple np.nan. So it means that will represent the missing values over here, because here we have to see how to handle the missing value. That's why first of all we have to create one small data, and particular based upon in data we have to create some missing values. Okay. Yes. So here we are not importing the from pandas import series and data frame. That's why we have to use pd.series. So at the same time we have to provide over here the pandas extension with the series function. Now the data was already prepared over here, and once data is getting over here, we have to find out when we are getting the is null value. It means null values. So for that we have to write the function the data dot is null, and for that the help of that we have to run this code. So here we are getting an idea. With the 0 we are getting false, 1 are also getting false because 0, 1 and 3 was already not null values, and just only one null value we are having that is based upon a position number 2 nan. So that's why at the same time we are getting over here the true over here, because is null value that will satisfy this condition. So here those values are null values. It means zero values or the missing values. So if you want to drop that values, so at the same time you have to use drop na function. So with the help of drop na function, if you run this function, so at the same time the position number 2 are having the null value, and here easily position number 2 value was dropped over here. You can apply the same concept with the data frame. Once you create the data frame, and once your data frame was created, then you can also take it like that df.drop in it. So at the same time those values are related to the null values or the missing values, that values are easily removed from like this one. So let's see create one data frame, and let's check it out how it's work in a data frame things. So for that we have to just create the one thing that is a df, and based upon a df we have to create the data frame, because whenever we are creating data frame we have to write down very long codes for particular for the data frames. Also we have to take on some outer dimension, because we have to first of all take some parameter. After applying parameter we have to also provide some values over there. That's why, so values, in particular values we are taking some n values to provide some missing values. That's why, so here I have to provide some values over here. Again we have to take one brackets, and particularly again we have to provide many more values. Also with that I can also provide the missing values as well. As in last row all the values I can provide as a missing values. So when we are having the more missing values, so you are getting better idea for learning about how to handle the missing values. So now let's check. Yes, 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 yes. Again here we have to provide the pt dot. Yes. Let's check it out. The brackets, I think one or two bracket was missing, or some type of the, yes, comma was missing over here. And yes, now it's perfect. So we are getting our data frame over here. So if you can see our data frames, you are having 0, 1, 2, 3 in terms of rows, and 0, 1, 2 column is there. And also you are seeing the many type of the not available, any values or also missing values you can consider. So let's create one more data frame based upon this data frame one or this data frame. So now the next data frame, that is the name is the clear df. So clear df is equals to, we have to provide just simple df with the drop na function. So after applying drop na function, we have to again call up this clear df. So we are getting an idea what are the correct output without, if we are remove all the missing values, what is the next output we are getting over here. So here we are getting the values like 1, 2 and 3. Just only the 0 position of rows we are getting over here. As compared to other, we are not getting anything from over here. But still there is many more techniques are there to solve these missing values, or how to handle these missing values. So let's see one another method. So in that particular method, we have to again use drop na, but with the drop na, we have to provide some condition like how is equals to all. So when we provide the how is equals to all, so the meaning of that, whenever your rows as well as column both the values are having nan, so at the same time just only that part will remove over there. Like if you can see over here, just only this. So if you can see the third column, the whole rows, particular third row, third position rows are having all the values related to the not available any number. So that's why just only that particular row will remove over here. Expect to that we are not particular, we are getting one error. We have to check that, okay, everything, yes, 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 we did one mistake. We have to provide this all within a quotes. So that's why we are getting an answer. Yes. So if you can see the position number 0, 1 and 2, at the same time we are getting an answer over here. And particular in the position of the third position of the rows, we are not getting any type of the answer, and the particular row was removed over here in terms of the missing or handling the data. So that's how many things related to the particular, the many functions we already seen with the help of the pandas library. I can also provide some of the exercise based upon this pandas library, so you can solve this exercise to your own knowledge. Okay, so that will really boost to skills related to the data analytics or the data science things. In this practical session, we have to learn about Matplotlib. Basically, Matplotlib library is used for the data visualization at the basic type of charts and plots. Similarly to the MATLAB, the Matplotlib should work. It work well with Pandas and with the NumPy and Seaborn as well. As Seaborn library should also work for the data visualization, and it also provides some statistical analysis. So let's start with the Matplotlib library. When we work with the NumPy pandas, we have to import the NumPy as NP and pandas as PD. But when we work with the Matplotlib library, we have to import matplotlib.pyplot as plot. So let's see how to import the Matplotlib library. So for that, we have to write down the import matplotlib dot pyplot as plot. And also for the aspect to the pixel things, we have to also taken some backend line, and that is the based upon a matplotlib inline. Matplotlib inline. So the library is imported over here, and in the next thing, first of all, we have to make some basic things. Here we are not providing any type of space in between this one. By default, I can provide the things. That's why we are getting one warning. Okay. So let's import one small plot. For creating plot, first of all, we have to create our variables like x and y. So the creation of variable of x and y, that is depends upon NumPy. So with the help of the NumPy library, we can create, or we can make it some random numbers as well as. So let's see how we can make it that part. So for that, we have to import the NumPy library as np. And once we can import the NumPy library, then next step we have to create the x variable. So x is equals to np dot linspace. So linspace is nothing but a line space. So what are the tasks for the line space? So in the line space, we have to provide the three arguments. So we have to provide the first, it's a zero or starting point we have to provide. Also, we have to provide the ending point, and particular in between starting point to ending point, how many intervals you want. So also you have to provide that number. So here I have to take an 11. It means in between 0 to 5, I am getting just only the 10 numbers. So that is the equation of x. And now for the y is always depends upon the x. So that's why x power 2. So what are the x? So y is also depends upon the value of x. So let's check it out. What are the values we are getting in terms of x, and what are the values we are getting in terms of y. So we are getting some better idea. So here when the x was 0, y is also 0. X is 0.5, y is 0.25. When x is 1, y is 1. X is 1.5, y is 2.25. So always a y is the power of x. So let's make it one simple plot based upon the parameter of x and y. So here I want to just a simple plot to create a line chart based upon x and y. So for that, first of all, we have to take a plot dot plot y. We have to take a plt. We have to take a based upon the Matplotlib library, because Matplotlib library shortcut, that is the PLT. So that's why. And dot, we have to use the plot function. Plot function should be stand for the line chart. That's why. And now we have to take on the parameter of x and y. Also, once we can whenever we can create the plot between x and y. At the same time, we have to also provide the x label and y label, as well as we are trying to provide the title. But first of all, we should run these things. After running these things, we are getting this type of plot between x variable and y variable. So now let's see how to provide the x label and y label. To provide the x label and y label, again we are using the plot as a shortcut of Matplotlib library, and then we can provide the function of x label. And particularly with the codes, we can provide the label of x label. So simple, I can provide over here the x label, or whatever the things you want to provide, you can make it over here. Also similarly, we have to again make a y label, and based upon the y label, we should take like this one, y label over here. And then after applying the x label and y label, now it's time to provide the title of the plot. So plot dot tit LE title, and also we can provide the title of the plot. So I can mention one message, title of plot. And after doing everything, now we have to run this code. So here I'm getting one error. Matplotlib.pyplot has okay, the spelling mistake. This also here label is there. Now it's perfect. Yes, now we are getting x label and y label in terms of the title of the x label and y label, and also at the end we are getting the title of the plot. In the next session, we have to see how to plotting more than one plot in on one execution. Now we have to see how to apply plotting more than one plot on an one execution. So let's see how to make it that things. For that, we have to use subplot function or the subplot theory. Already in a theory session, we already discussed about how to use the subplot and how was the logic are working behind that topic. So let's see with the subplot things. So first of all, again, we have to use shortcut of the Matplotlib library, and also we are using the function of the subplot over here. So in a subplot, we already seen like one argument it stand for the position, and another two argument it stand for the rows and columns. So that's why here I have to first of all provide one, then two, and one. So one will stand for the for one rows are there, and two column are there, and one position are there. So one rows are total is there, two column are there. In particular, this plot will show as the first position of the column. Like first row, just only one rows are there, and in particular two column, the first in the particular first row and first column combination we are getting in this diagram. So based upon that, what we have to do, also we have taken again plot function or the plot shortcut of the Matplotlib library. Again, we are using the plot things over here, and we have to take a combination of x and y already we created in the last thing, that is y depends upon the x values of power. And now it's also we have to see one more thing. So how to represent the line chart? In previous code we can see the line chart is coming in a blue line. If you want to change the color of the line, you can also change. For changing the color, you have to just shortcut, you have to use just shortcut of that color. So if you want to work with the red color of line, so you can just only put the r over here. So the one thing was completed over here. Now we can try to create the another things, like another plot, because here we have to plotting more than one plot on an one execution. That's why. So again, I have to use the same thing like subplot. Also here we have to take on one, two, but currently on particular first row and second column, I have to work with the second position. That's why here I have to take one, two, and two. And similarly here we have to take a plot of plot dot plot. First we have to use the shortcut of Matplotlib library. That's why we have to take an everything PLT, and now we have to provide x, y, and the last color is depends upon the blue color. Okay, and now I'm trying to run this code. So the output is look like similarly to this one. But if you want to change something, like if you want to take it x as a independent, y as a independent parameter, and y as a dependent parameter, you can also take it like this one. You can also change the relationship between x and y and x. So your graph is looks inversely proportional. So if you can see the red line and if you can see the blue line, it's both the lines looks very different as compared to all. So that's how things you can create it over here. Also we can see in some more types of plot whenever you can provide the one execution, and within one execution you are getting many plots. So for that, let's create a one type of the figure. So now we can also see like what are the figure you can generate, how to create that particular figure at the image. Okay, so that's why we have to also create one parameter for that figure. So that's how we have to use create a figure, and with that we have to create one parameter figure. Basically this figure parameter will saved in your particular location of this coding file. So that's why you have to remember your coding file location, and particularly in your location that figure should be saved. So figure dot plot dot figure with a blank bracket. Okay, so that's how you are getting the figure saving things. Now here what we have to do, till now we are just only applying the x and y, but now I don't want to directly apply x and y. Before applying x and y, I want to make it I want to finalize the what are the x's in terms of x and y. So I want to set the size of my images. So that's why let's see how we can adjust the size for that. I can also provide the comment for that, like place a list of x's, and for that x's is equals to figure dot add axis, and particularly in that you can provide the axis of x and y according to your size. So here first of all I have to take 0.1. So here basically the axis you have to provide like around 1. Okay, so 1 minus 0.1, so they are taking 0.9 type of size. Okay, so that's how things was working over here. So here 0.1, 0.1, again you have to take, now next side you have to take 0.8 and 0.8. So that's how you have to settle the axis. Once we can get the idea, then we can also change the axis. So we are getting an idea how the change will affect particular for that one. And now it's time to plot the data. So that's why we have to take axis dot plot of x and y, and then similarly every time we are using PLT as a shortcut of Matplotlib, but here we are using axis as a shortcut because according to the axis I want to make the plot. That's why, that is the reason behind that. Set x label, particularly that we have to provide the x label. Similarly we have to set with the y label, and we have to provide over here the y label over here, and at the end we have to provide the axis dot set of the title, and also we can provide the title of plot over here. Now it's time to run this code, but we are getting an error. So let's check on what line we are getting an error. So we are getting an error based upon 0.1, 0.1. then 0.8 and 0.8. So let's check it out what type of mistake we had done over here. Yes. Actually, I have to take a FID. So sometimes the spelling mistakes should come over here. Yeah. So now we are getting this type of plot. Let's check it out. What are they happen if we can apply any type of the change over here in replacement of 0.8. If I have to take in 0.4 over here, then this type of change are coming over here. So automatically width of the plot should be the decrease over here. So again we have to take in 0.8, and when if I can take it 0.4 over here, so this type of change we are getting like width and length type of things we are change depends upon over here. Also, if you can see here, I have to take on 0.1 replacement to 0.5. So at the same time, this type of things we are getting over here. So yeah, that is just depends upon the size of the things. Okay. So but mainly thing is 0.8 and 0.8. If I can also provide you with 0.7 over here. So you, if you can see, there is nothing but change you are getting over here, because that is depends upon the X label and Y label of size. Okay. So that's why the not major difference you are getting from over here 0.1 and 0.5, but mainly difference you are getting over here like in according to the length and width of the plot. So that's how you can do the many plots according to that one. But now still we have to see one more exciting thing based upon the same part. So for that, what I have to do, I have to copy this part, because now I want to show you like within one plot how to create the another plot inside the first plot. Okay, so that's why we have to create the two axes over here. So that is my it will become my first axis, and now I'm trying to create my second axis over here with the same thing like figure dot add axis, but now I should change the dimension. And our dimension was 0.2, 0.5, 0.4, and 0.3. So that's how I have to take on this dimension over here. And then axis 1 dot plot of x and y. Similarly, we have to take on axis 2 dot plot. If you want to take in y and x, that is also okay for getting some change. So now I have to run this code. So now you are getting idea. This axis number 2 is depends upon this small chart. So what are the things we are getting over here? That is depends upon the axis number 2. So that's how this type of stuff is are getting over here. So length and width is depends upon the 0.4 and 0.3, and also the size of the fonts and parameter we are getting based upon 0.2 and 0.5. So that's how with the help of the Matplotlib there is many more things are there. And also in the next session we have to talk about what this shows is you can iterate over the subplot. Okay, so you can provide some type of the for loops or the while loops during the data visualization. So that type of how much type of the outputs you are getting over there. Now we have to see what this shows you can iterable over the subplots. So now let's see how to apply the matplot with the for loops. Okay, so for that, first of all we have to take on a figure, and second thing that is the axis. We have to take on these two things, figure and axis, and based upon the figure and axis we have to first of all use the shortcut of matplotlib. And with that we want to create some subplots for making multiple plots. And also now we have to create some number of rows, how many number of rows of subplot you wants to create. So based upon that we have to first of all find out how many number of rows, and based upon we have to also find out how many number of column you wants to take it to make a subplot. So similarly same thing, I have to take a number of rows is equals to 1 and number of column is equals to 3, because then based upon that we have to create some more logic as well as. So now apply the for loop. So for current axis or the current AX, whatever the mention you can take it, that is depends upon you, like a current axis in axis. And also we have to provide the semicolon to follow the indentations. Also we have to provide the current axis dot plot of x and y. So based upon x and y we are getting the idea. So according to for loop it should work, but here I'm getting an error. So let's check it out on what things I'm getting an error, because you have to read the things like what things was correct and what are the wrong things we can use it. We have to use figure, that is also the correct thing is there. Current AX is already correct thing is there. Also figure dot axis plot dot subplots, and number of rows is equals to one, number of columns. So here we have to use the number of columns is equals to 2, and now it's perfect. We have to take a wrong spelling of columns as well as just only have to written the current x. So we have to run current axis. So that's how, according to for loop, you can make it the same thing over here. And now we have to see about how to save the figure, because already we seen like if I just only write on the figure and if I can run this code, so I'm getting the current figure. What are the we can implement till now, or currently we can what figure we can till now. Also, you can save it your figure location according to your thing. Like you have to write down the figure dot save fig, this type of function you have to use, and particularly you have to provide the name of your figure. So I can provide the name of the figure, that is the first figure, and then I have to run this code. But still you have to take in a format of your image, that is a png effect image, or the png extension with the image. So now if you can check it your location, so particularly based upon in your location you are getting this first png. So if you can see over here, I'm getting this first figure png, and if I can click on over here, so I'm opening that image as well as. So that's how what are the image you are getting from the matplotlib, and you can save that image look like this one. Now let's check it out one more plot based upon a multi-plot on one plot. So till now we've seen about the subplot in multiple things, but now I want to use just only the one grid, and according to the one grid I want to make it a multiple relationship according to the x and y, and based upon that with the different color I want to explore the different plot as well as. So let's start it with the multi-plot on one. First of all, I have to create the parameter, and that is the figure parameter. If you don't want to create the figure parameter, you didn't create, just I just create this figure parameter for showing to you like how you can save the figure particular on the on your location. Now it's time to create the axis. So for that you have to take figure dot add axis, and then we have to take a square bracket, and we have to provide some dimension like 0 0 and 1 and 1. So after completion of this one, now we have to take an x dot plot, and particular for that we have to provide some x relationship. Like in x we have to take an x, so here in x we have to take a x, and then also we have to take a x power of 2. After applying x power of 2 we have to take an the label, and here no need to apply the label as a different things like plot dot x label is equal, and also within quotes like x label or y label you can also apply the label look like this one. So what type of label I want to apply, like x squared, so that is my labeled over here, and always label should come within a quotes. So after completion of this one we have to write another line, and another line is similarly look like this line. Again we have to take x, and then again we have to take x of cube. Now I don't want to take x of power, but now I want to take a x of cube, and now again we have to take like x and then cubed within quotes. So everything is looks proper, but here there is no need to this one. Was once before running the code I have to check everything like what are the things we have taken, all things is correct or not, and now it's I think it's correct, and we are getting the output as well as. So the blue line and the orange line is there, so two line is there, so orange line will represent the cubes and the blue line will represent the squared. So that type of difference we are getting over here. Also if you want to provide any type of the line style, like if you want to get some dotted line or some particular plus line, so you can also make it the same thing in the change of the code like this one. You have to take an x dot plot, and then we can apply same changes based upon x raised to power of 4, and then we have to take x of power of 4. Also we can provide the color, and now the color of the line, that is the green. You can also take it whatever the things like in capital, you can also write the same thing. You can also provide the size of the line in terms of the line width. So here line width, that is the 3, and you can also provide the line style over here. So line style, it depends upon you what type of style you want to provide over here. If you want to take it is equals to this type of line, you can also take it this one. And now I'm trying to run this code. I'm getting an error. Why I'm getting an error again and again? I think some type of the things I just forgot to apply. I have to check it out. Line width is equals to 3. Line style is also providing in same way. Let's check it out. This line style is not working or not. Yes, the line style is not working over here. So that's why again at the end we have to also show the things. So for showing the output, we have to run this code of figure. So after applying figure, we are getting the same thing. So you can use this one. Also somewhere the is equals to type of line style is also working. Let's check it about. Yes, again this type of thing is not working over here. That's why. So you can just only follow with this line style. So this line style is just only appropriate with the Matplotlib. But if you can work with the Seaborn library or other data visualization libraries, at the same time this type of stuff is already working. But in Matplotlib, the different type of line style is not working over here. Okay, so the Matplotlib related to the what are the learning related to the Matplotlib library that is ending over here. Now you can go with the some source section, and from the source section you can find out the exercise based upon the Matplotlib. The solution is also provided there, so you can check solution as well as like probabilistic graphical model. Probabilistic graphical model provides a graphical representations to understand the complex relationship between a set of random variables RV. RV represent the nodes and statistical dependencies between them is called an edge. PGM provides the structure where we can leverage the independence properties to represent the high dimensional data in a more compact way. It is a powerful tool to draw inferences on some unobserved variables given the evidence on observed variables. To summarize, probabilistic graphical model provides a graph-based representations of compactly modeling the underlying association between the RVs like random variables in the form of joint distribution. Probabilistic graphical models are rich frameworks for encoding probability distribution over the complex domain. So for that, there is the first is compact graphical representations. So probabilistic graphical model are framework used to create and represent compact graphical models of complex real world scenarios. Second is intuitive diagrams of complex relationships. So PGMs gave us intuitive diagrams of complex relationship between stochastic variables. And the third one is the convenient from computational aspects. The probabilistic graphical model are also convenient from computational point of view since we already have algorithm for working with graphs and statistics. So after getting idea about why do you need a PGM, let's talk about what is PGM. So consider you have four binary variables WC, P, G, and F. So what is the meaning of that one? So for that we have to take a small example. Like WC, it will stand for the spot in the World Cup, like yes or no. All four are considered as a yes or no. It's a binary variable is there. So WC, it will become yes or as well as no. P will stand for the performance in the pre-World Cup tour. So for World Cup, if I can talk about the 2019 World Cup and previous World Cup can be stand on 2015. So we have to take on some criteria between 2015 World Cup and 2019 World Cup. The good genetics means yes or no, like who can play the previous World Cup and who can also play this World Cup. Also good form, like if those players are playing current World Cup, those who are coming in form or those in form or not form. So that type of thing we are getting over here. So consider you have four binary variables is there. So G and F are there. So based upon G and F, it means based upon good genetics and good form, we are getting an idea about the P, like performance based upon a previous tour. So how much what performance can given by the previous tour, and based upon what performance they are coming on previous tour. So at the same time, we are getting idea what performance can coming in this tour. So everywhere or everyone will predict, like if I'm talking about like how what are the performance of India in 2019 World Cup, that is based upon the performance of India's 2015 World Cup. Also expectation can build up 2015 World Cup in based upon a 2011 World Cup. So that type of stuff are working over here. So component of the graphical model, and that is based upon nodes are look like a random variables. Also edges are there, and edges is considered like in terms of the internodal dependencies are there. But basically whenever we are talking about this type of PGM things, so at the same time, first of all we have to clear about PGM. It stands for the probabilistic graphical models. So we have to clear our idea about the probabilistic graphical and model. So that's why let's start it with the probabilistic. the nature of the problem that we are generally interested to solve, or the type of the queries we want to make, are all possibly probabilistic because of uncertainty. There are many reasons that contribute to it. So that is called as the probabilistic. So probability, we have to find out based upon a probability look like become probability because uncertainty. So next thing is graphical. So graphical representation help us to visualize better and so better. So we use graph theory to reduce the number of relevant combination of all the participating variables to present the high dimensional probability distribution model more complexly work. And the third one, that is the M, it stands for the model. A model is a declarative representation of a real world scenario or a problem that we want to analyze, and it is represented by using any mathematical tools like graph or even simply by an equation. So that's how things are working over here. But now it's time to combine all three things like probabilistic graphical model. So how we can combine these three things? So probabilistic graphical model, it stands for the PGM. So PGM is a technique of compactly representing a joint distribution by exploring dependencies between the random variables. It also allows us to do inference on joint distribution in a computationally cheaper way than the traditional methods. So that's how they want to work with the PGM, like probabilistic graphical method. After getting idea about the probabilistic graphical method, now we have to again come with the probability, like what is the meaning behind the probability more, and which the different type of probability are available in the particular probability domain. So the probability of an event is a measure of the likelihood that the event will occur. The sum of the probabilities of all the samples point in a sample space is equal to 1, and the probability of event A is the sum of the probabilities of all the samples point in event A. The probability of event A is denoted by P of A. So that's how thing is working over here. So what is the probability of A? So count all A's and divided it by the total number of possibilities. So P of A is equals to hash of A and divided by the hash of A plus B plus C. So based upon that three things, the probability of A will depend over here. After getting idea about the probability, next thing, that is the conditional probability. So conditional probability is defined as the likelihood of an event or outcome occurring based on the occurrence of previous event or outcome. Conditional probability is calculated by multiplying the probability of the preceding event by the updated probability of the succeeding or conditional or event. So whenever we talk about the conditional probability, we have to take in some probability of A and probability of B. So B should occur when A is already happening. So that's why probability A and B is equals to probability A multiply by with the probability B by A, or the probability B into multiply with probability A by B. So that's how think conditionally probability should be worked over here. After getting idea about the conditional probability, now we have to talk about joint probability or the marginal distribution. The joint probability distribution describe how two or more variables are distributed simultaneously. Joint probability is a statistical measure that calculates the likelihood of two events occurring together and at the same point in the time. To get a probability from the joint distribution of A and B, you would consider the probability A is equals to the probability of capital A is equals to small a, and the capital B is equals to B. And the conditional probability distribution looks at how the probabilities of A are distributed given a certain value, say for B, like probability of A is equals to E and B is equals to B. So the marginal probability distribution is one that results from taking mean over one variable to get the probability distribution of the other. So for example, marginal probability distribution of A when A and B are related would be given by the following. This equation is the integration with the B. So at the same time, we are getting probability of A out of B multiply with the probability B with the derivative of the things. So that's how we are getting the things related to the like how the probability of graphical model should be stand over here. So after completion of the probabilistic graphical model, now we have to discuss about the Bayesian network. Again, when we talk about the Bayesian networks, at the same time, first of all, we have to discuss about the Bayesian probabilities. So Bayesian probabilities is an interpretation of the concept of probability in which instead of frequency or propensity of someone phenomenon, probability is interpreted as reasonable expectation representing a state of knowledge or a quantification of a personal belief. So the probability of one event out of another event. So we can see in earlier like probability A and B, same concept we are seeing over here. Like from here, we could isolate either probability of B out of A or the probability A out of B and compute from the simpler probabilities. So whenever we talk about the Bayesian probability, also we have to discuss about the Bayesian theorem because the Bayesian probability is many more part of the stuff is related to the Bayesian theorem. So Bayes theorem named after 18th century British mathematician Thomas Bayes. So that is the founder of Bayes theorem. So the Thomas Bayes is a mathematical formula for determining the conditional probability, and the conditional probability is the likelihood of an outcome occurring based on a previous outcome occurring, and the Bayes theorem provides a way to revise existing predictions, predictors, or theories given new or additional evidence. So in finance, the Bayes theorem can be used to rate the risk of the lending money to potential borrowers. Bayes theorem is also called as Bayes rule or the Bayes law, and it was the foundation of the field of the Bayesian statistics. Whenever we have to talk about the Bayes theorem or the Bayesian probability, also we have to getting some of the key takeaways according to this topic. Like Bayes theorem allows you to update predicted probabilities of an event by incorporating new information, as well as the Bayes theorem was named after 18th century mathematician Thomas Bayes, and it is often employed in finance updating a risk evaluation. And we already seen earlier like probability of A out of B is equals to probability B out of A multiply with probability A by probability B. The same vice versa equation we have to use in next one as well. As let's talk about some of the things based upon a Bayes network. A Bayes network is a structure that can be represented as a DAG, direct acyclic graph, and there is some of the consideration is there. Like first is it allows a compact representation of the distribution from the chain rule of Bayes network, and second thing is it observe conditional independence relationship between random variables. A DAG is a finite directed graph with no directed cycles. So that's how these things should be worked. So based upon that, we already discussed about Bayes network, Bayes theorem. So according to that one, here we are having one of the diagram is there. So here we have to find out some of the thing regarding to that one. I already provided this what type of thing we have to think about this one like does a spot in World Cup team depends upon the genetics like G stand for the good genetics, F will stand for the good forms performance 2015, and the WC will represent 2019 is there. So genetics is good and bad is there. So for good probability 0.2 and bad genetics probability 0.8 is there. Form is there 0.7, 0.3 is there. Current World Cup condition is bad performance, okay performance, brilliant performance, no spot given. So there is all probabilities are there. Also based upon good form and based upon genetics and form, there is one table will created performance in 2015. So good gen is good form, good gen is good form. So that will represent on that. So once we are having this type of table and this type of probabilities are there. So according to that, when we have to think, what should you think about some of the question we have to think. So what are the question? Does a spot in World Cup team depends on genetics if you know someone in good form? Does a spot in the World Cup team depends on genetics if you know the performance in the pre-World Cup tour? For example, if we take on the 2015 World Cup and 2019 World Cup, in the 2015 World Cup, the MS Dhoni will play, but 2019 MS Dhoni still play. So in both the World Cup, the form will different. As well as in 2015 World Cup, the some of the player will play, but 2019 that player will not play. Okay, so that type of the difference will come over there. Also, the 2015 World Cup, the Virat Kohli will come in good form. 2019 Virat Kohli still in good form, but both the World Cups Virat Kohli have good form, but still the India will not winning any World Cup in 2015 and 19 as well as. So this type of thing are working over here. And also we are creating some of the question like how it works. So each node in Bayes network will have a CPD associated with it, and if the node has parents, and the associate cpds are represent like probability of value by parents value. So that's type of base theorem we can apply it over here, and we can find out some of the answer like it will happen or not, that type of thing. So that's how in this session we have to talk about the PGM, what is the PGM, why we need PGM. After that, we have to talk about Bayes theorem and Bayes probability. After both, we can converge into the Bayes networks. So in the next part, next session, we have to discuss about the Markov's random fields. In this session, we have to talk about Markov's random fields. So a Markov random field is a graph whose nodes model random variables and whose edges model desired local influences among pairs of them. Local influences propagate globally, leveraging the connectivity of the graph. Here, the first thing what we are getting over here, that is undirected graphical model. An undirected graphical model represents a distribution of the probability of x1, x2 till xn, and defined by an undirected graph h and a set of the positive potential functions associated with the clues of h. So let's get idea about this one. So here we are getting some point like a, b, c, d, e. So we are to getting some probability of a, b, c, d, e, and according to the undirected graphical fields, we have to take a set of two parameters like a, b, b, c, b, d, c, e, and d, e. So probability distribution of the variables in the graph can factorize as individual clues potential functions. So let's see how it will converge within clues. So here we have to take in some clues. So in a clues, first of all, I have to take in just only b and c. So same equation it will comes with everywhere like b, c, d, e, b, d, c, e. So it will transform for everywhere according to the potential function. And p of x 1 upon z pi clues theta c of xc, it will converge over here. So that's how thing was working over here. So here we have to take on b, c, d, e, and b, d. Now we have to take on c, e. Also we have taken some more clues according to the parameter like a, b, c, d, and e. So that is totally depend to us. So again we have to coming over here based upon a Markov random fields like again here if you can see like path between a and c to a, b, c, a, b, d, c. So there is multiple path is there, but still before that I want to discuss more about the Markov random fields like how we can explore more about the Markov random fields. Okay, so basically a Bayesian networks are a class of models that can compactly represent many interesting probability distribution. However, we have seen in the sum of the thing related to the distribution may have independence assumptions that cannot be perfectly represented by the structure of the Bayesian network. In such cases, unless we want to introduce false independencies among the variables of our model, we must fall back to a less compact representations, which can be viewed as a graph with an additional unnecessary edges. So this leads to extra and unnecessary parameters in the model and makes it more difficult to learn parameters and to make predictions. So that's type of stuff we are facing over here. So there exists, however, the another technique for compactly representing and visualizing the probability distribution that is based on a language of undirected graph. So whenever we talk about the clues are there and also undirected things are there. Okay, so multiple things are and multiple variations are there. So complexly representing and visualizing a probability distribution that is based on a language of undirected graph. And this class of model is known as a Markov random fields and Markov random fields MRF. So there is a short form of Markov random fields, that is the MRF is there. So that can completely represent independence assumptions that directed models cannot be represent. As a motivating example, suppose that we are modeling voting preference among a person of A, B, C, D, A, B, C, D. So let's see with the AB, BC, CD, ADA. So there is multiple combinations are there. So based upon that, these influences can be naturally represented by an undirected graph. And one way to define the probability over the joint voting decision like A, B, C, D, A, B, C, D, 2 is assigned to scores to each assignment to these variables, and this define probability as a normalized score. A score can any function, but in our case, we will define it to be form of the things. So that's why here we are getting some path between A and C. So A, B, C, A, B, D, E, C. So again, if you can go with the next slide. So again, A and C is individual. So B, D, B, E, B, D, E is there. So that's how things are working over here in a Markov's random fields. After that, let's talk about some of the use cases or some of the application based upon a PGM. So let's start it with the first application of PGM. Google is based on a very simple graph algorithm called a page rank. Okay, so this page rank is there, and according to that, you can use probabilistic graphical model over here. The second application is like Netflix, Amazon, Facebook, all use PGMs to use recommending what is best for you. So whenever we are using some IMDb ratings, okay, and which genre of movies you are liking, so they will recommend that range of that genre of movie. Also, Netflix, Amazon are doing same thing. Like also you are using YouTube, so on YouTube what type of videos you are liking, so they are just only recommend that type of videos. So that type of stuff are working over here in application of probabilistic graphical model. So PGM can also apparently infer whether one is Modi supporter or a Kejriwal supporter is there. So that is depends upon you. If you are Modi supporter, then they are just only showing you the things related to Modi. If a 538 is a company that makes a prediction about the American president poll using PGM, so that type of thing are working over here. Also, if image generation, painting, languages generation, translations, audio super resolution, speech synthesis, healthcare medicine diagnosis, everywhere PGM should be used. Like probabilistic graphical models should be used to recommend something or to adjoint anything type of the things. So that type of thing we already seen over here. So basically in this module we have to first of all talk about the PGMs, like why PGM should be needed. After we have to find out what is PGM, then Markov random fields, then in between we can also find out some of the things related to the probability concepts, because this chapter is based upon a graphical modeling. Okay, so in a graphical modeling we had done just only the theory part. Okay, so we are not directly implement this graphical modeling type of thing in practically. Okay, because practically somewhere on some part this type of stuff should be worked. Like probability concept we are using, the graphical modeling type of concept we are using, it's not look like a machine learning type of technique. At the same time, with the help of scikit-learn we can develop this type of stuff over here. In this module we have to first of all talk about statistics, like introduction to statistics, what is the meaning behind the statistics. Then we have to discuss about statistical analysis consideration. In particular, that we have to find out some basic terminology in field of the statistics, population and sample, and many more things are there. After that, in a statistical analysis process, we have to find out some data distribution, normal distribution, and many more measure of central tendency like that one. And then we have to find out two types of the statistics, like inferential statistics and descriptive statistics. So first thing, that is the introduction to statistics. So let's start it with the what is the meaning behind the statistics. Statistics is the study of the collection, analysis, interpretation, presentations, and organization of the data. So basically, statistics is an area of applied mathematics concerned with the data collection, analysis, interpretation, and the presentations. This area of the mathematics deals with understanding how data can be used to solve complex problems. Here are a couple of example problems that can be solved by using statistics. Like your company has created a new drug that may cure cancer. So how would you conduct a test to confirm the drug will be effectiveness? Second example, you and your friend are at a baseball game, and out of the blue he offers you a bet that neither team will hit a home run in that game. Should you take that bet or not? So that is a question mark is there. So the latest sales of the company, like the sales data have just come in, and your boss wants you to prepare a report for management on places where the company could improve its business. What should you look for that, and what should you not look for that one? So there is a multiple type of situations are there, and according to that situation we have to implement the statistical knowledge in terms of the analysis, interpretation, presentations, and organization for particular data. In the statistics, let's talk about some of the more thing related to that one, like tools available for the analyzing the data. So like statistical principles are there, functions are there, algorithms are there. So what you can do using as a statistical tool as well as so analyzing the primary data whenever the statistics are there, building a statistical model is there, as well as predict the future outcome. So whenever we are talking about the statistics, so in outcome of statistics we want this type of thing. So first of all, what are the data will exist, we have to do some analysis based upon that, and we are trying to predict the future outcome as well as. Let's talk about some more information about the introduction to statistics part. So that's why let's go with the statistical analysis and non-statistical analysis. So statistical analysis is the science of collecting data and uncovering the patterns and trends. It's really just another way of saying statistics. After collecting data, you can analyze it or summarize the data. For example, make a pie chart. Also, statistical analysis is considered as a scientific, and it is based upon a number or statistical values, and it will useful in providing complete insight to the data. If we talk about a non-statistical analysis is based on very generic information exclusive of statistical or quantitative things. Although both form of the analysis provide results, quantitative analysis provides more insight and a clear picture about this one. This is why statistical analysis is important for the business as well as. Same domain in introduction to statistics, or if you can go with the very deep with it with the statistics, let's talk about some of the major categories of statistics. The field of statistics is divided into two major divisions. Descriptive statistics are the essential, inferential statistics are there. Each of these segments is important and offering different techniques that accomplish different objectives. Descriptive statistics describe what is going on a population or a data set. Inferential state analytics use the probability theory to arrive at a conclusion. Random sample is drawn from the population and it uses to describe and make inference about the population. So that type of thing are working over here in major categories of the statistics. Inferential analytics is valuable when it is not possible to examine each member of the population. So that's why it is again important part of the things. Continue with the major category of statistics. We have to study of the height of the population. So here again we have to describe more about inferential method and descriptive method. At the end of this session we can also discuss more about these two methods, but currently here we are not going with the very depth of these methods. We are just taken overview of the inferential method and the descriptive method. So inferential statistics makes inference and prediction about a population based on a sample of data taken from the population in question. Inferential statistics generalize a large data set and applies probability to draw a conclusion, and it allows us to infer data parameters based on a statistical model using the sample data. So, if we consider the same example of finding the average shirt size of student in a class, in inferential statistics, you will take a sample set of the class, which is basically a few people from the entire class. You already have had a group the class into the large, medium, and small things. So, in this method, you basically build a statistical model and expand it for the entire population in the class. Categorize heights as tall, medium, and short. Take a sample to study from the population. Second thing, that is the descriptive method. Descriptive statistics or descriptive method is a method used to describe and understand the features of a specific data set by giving short summaries about the sample and measures of the data. Descriptive statistics is mainly focused upon the main characteristic of the data, and it provides a graphical summary of the data. Suppose you want to gift all your classmate t-shirt. To study the average of shirt size of student in a classroom in descriptive statistics, you would record the shirt size of all the students in the class, and then you would find out the maximum, minimum, and average shirt size of the class. Record the height of the each and every person, provide the tallest, shortest, and average height of the population. So that's how we can find out the inferential method and the descriptive method. Let's take a look out about the statistical analysis consideration. So what type of consideration we have to take during the statistical analysis? So there is four type of analysis is mainly important. First one, that is the purpose. So clear and well defined purpose we have to create. Second one, that is the document questions. So prepare a questionnaire in advance. So whenever we are trying to do some statistical analysis, at the same time prepare a questionnaire. That is the important part. Third thing, that is the define population of interest. Select population based on the purpose of analysis. And the last one, that is the determine sample. So based on the purpose of study. So that's how we have to take on some statistical analysis consideration before statistical analysis. After discussing about this one, let's take a look about population and sample. So what is the meaning of population? A collection or a set of individuals or objects or events whose properties are to be analyzed. That is called as a population. So what is the meaning of sample? So sample, it's a subset of the population, is called sample. A well chosen sample will contain most of the information about a particular population parameter. Also, a population can consist of various of samples, and the samples together represent the population. A sample is the part or piece drawn from the population, the subset of the population, a random selection to represent the characteristic of the population, representative analysis of the entire population. So that's how we are getting idea about the population and samples. Let's take a discussion, some of the discussion based upon a statistics and parameter. Statistics are the quantitative values calculated from the samples, and the parameters are the characteristics of the population. So here, based upon statistics and parameter, we are getting some three terminologies over here: mean, variance, and standard deviation. So what is the meaning of mean, and what is the meaning of standard, and what is the meaning of variance, and what is the meaning of standard deviation? Already population parameter, sample statistics, and formula is provided over here, but first of all we have to find out what is the meaning of these all three. Mean, it means measure of the average of all the values in a sample, that is called as a mean. The variance is a measure of variability. It is calculated by taking the average of squared deviations from the mean. Variance tell you the degree of spread in your data set, and the more spread the data, the larger the variance is in relation to the mean. And the third thing, that is the standard deviation. So the standard deviation is a statistic that measures the dispersion of a data set relative to its mean, and it is calculated as the square root of the variance. If the data points are further from the mean, there is a higher deviation within the data set, thus the more spread out the data, and the higher the standard deviation. So that's how mean, variance, and standard deviation will give an idea. Let's talk about term used to describe data. So basically here we are working within typical terms used in data analysis are there. So there is search, inspect, characterize, and conclusion are there. So let's talk about this. First of all, this for parameter. Search is used to find the unusual data, like data head does not match the parameters. So that's why we are using a search. Typical term. Search is one type of typical term. Second typical term is inspect. So at the same time, inspect, we have to find something, or inspect refers to studying the shape and spread of the data, like how much vary the data and how much spread the data according to data set. Third thing, that is the characterize. Characterize refers to determining the central tendency of the data. And last term, that is the conclusion. So conclusion refers to preliminary or high level conclusion about the data. So that's why these are the typical terms are there. Also, as compared to these four terms, there is still many more terms are available. We have to find out like what are the terms are there. But now this session is completed over here. In the next session, we have to learn about some statistical analysis process. Let's talk about statistical analysis process. There are four steps into the statistical analysis process. Step one, it is coming with the find the population of interest that suits the purpose of the statistical analysis. Step number two will refer draw a random sample that represents the population. Step number three will represent compute sample statistics to describe the spread and shape of the data set. And step number four will refer make influences using the samples and calculation, apply it back to the population. So that's how within this four step of process, statistical analysis should be done. But it is not just simply done within these four steps, but within these four steps, we have to do many more things based upon population, sample, and also we have to find out some of the data distribution. So let's talk about data distribution. The distribution is a mathematical function that describes the relationship of observations of different heights. A distribution is simply a collection of data or scores on a variable. Usually, these scores are arranged in order from smallest to largest, and then they can be presented graphically. the collection of data values arranged in a sequence according to their relative frequency and occurrence. The range of the data refers to minimum and maximum values. It is the given measure of how spread apart the values in a data set are, and the range can be calculated as particular in the equation of range is equals to maximum of the input side, maximum of the input side subtract with the minimum of input sides. So range of the data refers to minimum and maximum values. So that is the what are the subtraction can be happen in between the maximum value of x and the minimum value of x. And then when we talk about the frequency is indicates the number of occurrence of a data value, and the third thing that is the central tendency that will indicates data accumulation towards the middle of the distribution or towards the end. In statistics, a central tendency is a central or typical value for a probability distribution. It may also called a center or location of the distribution. So co-equally measure of central tendency are often called the averages as well as. So let's talk about the measure of central tendency. When we talk about the measure of central tendency, so again three important things will generate over here like mean, median and mode. Previous session we already talked about what is the meaning behind the mean, but still we have to talk about what is the meaning behind the median and mode. So let's talk about the measure of central tendency. Measure of the center are the statistical measure that represent the summary of a data set. There are three main measures of centers are there: mean, median, and mode. So first thing that is the mean. Measure of the average of all the values in a sample particular that is called as a mean. So that's how mean should define earlier as well. So here if you can see this example, so here we are having some nine values. So according to the nine values we have to simple take an average of these nine values. So at the same time we are getting mean of this particular sample. Second thing that is the median. Measure of the central value of the sample set that is called as a median. So here what are the middle number is there, we have to arrange everything in terms of the ascending order to descending order, and according to the ascending order, and according to the ascending order we have to find out the middle number, so that is known as a median. And the last thing that is the no mode. Mode is the most frequent value, so the most frequent or recurrent in the sample set that is known as a mode. So here if you can see the 3 times 80 what it will be exist, so that's why 80 was be a mode. So that's how measure of central tendency should be worked. Next, we have to see about percentile in a data distribution. So what is the meaning behind the percentile, as well as what is the meaning behind the first quartile, second quartile or median, and the third quartile. A percentile or a centile indicates the value below which given percentage of the observation fall. So if you can see over here, the quartiles tell us about the spread of a data set by breaking the data set into quarters, just like the median breaks it in half. Also here we have to more discuss about the what is the meaning behind the first quartile, second quartile and the third quartile. So first quartile it refer the lowest 25 percentage of the number. Second quartile it will refer the 25.1 percentage and 50 percentage of number, and third quartile it will represent the 51 percentage and 51 percentage to 75 percentage of the numbers. So that's how we can understand about the first quartile, second quartile or the median, and then third quartile. So after getting idea about the percentile and data distribution, next we have to say about the dispersion. Dispersion denotes how stretched or squeezed distribution is that. So the dispersion is a statistical term that describes the size of the distribution of value expected for a particular variable. Dispersion can be measured by several different statistics such as range, variance, and standard deviation. So let's talk about some of the things related to the range. Already we talked about like range is the difference between maximum value of x and the minimum value of x, like particular feature. Interquartile range, that is the difference between the 25th and 75th percentile. It is also known as difference between first quartile and third quartile. Variance, data values around the means, and the standard deviation, square root of the variance measured in small units. So that's how we are getting some of the parameter from the dispersion sides. So let's talk about to bell curve or the normal distribution. It is again one of the most important statistics concept, that is a bell curve or the normal distribution. The bell curve is characterized by its bell shape and two parameters, mean and standard deviation. A bell curve is a common type of distribution for a variable, also known as the normal distribution. The term bell curve organized or the it's organized from the fact that the graph used to despite a normal distribution consists of a symmetrical bell-shaped curve. The highest point on the curve or the top of the bell represent the most probable event in a series of data. For example, its mean, median, or mode in this particular case. So while all other possible occurrences are symmetrically distributed around the mean, creating a downward sloping curve on each side of the peak. The width of the bell curve is described by its standard deviation. So that's how bell curve should be made. Also, the bell curve is symmetric around the mean. It is also symmetric on both sides of the center, having equal mean, median, and mode values are there. Denser in the center and less dense in the tails or sides, defined by mean and standard deviation, and it is also known as the Gaussian curve. So because the shape is look like a Gaussian, so that's why it is all much popular with the Gaussian curve as well as. And whenever we should learn about the bell curve, so at the same time I was thinking you have to take in some key takeaways. Like a bell curve is a graph like a depicting the normal distribution, which has a shape of a reminiscent of a bell, and the top of the curve shows the mean, mode, median of the data collected. Its standard deviation depicts the bell curve's relative weight around the mean. Also, bell curve are used commonly in statistics, including in analyzing economic and financial data. So that are some of the important key takeaways are there. I hope you have to taken this type of normal distribution related key takeaways. Still, we have to talk about some of the more important thing related to the bell curve, and that is based upon a left skewed and right skewed. First of all, we have to discuss about what is the importance of left skewed. So skewed data distribution indicates the tendency of the data distribution to be more spread out on one side. Okay, so at the same time we are getting an idea like one side it will more spread. Okay, so a normal curve, left skewed curve or the left skewed distribution has a long left tail. So left skewed distribution are also called as a negatively skewed distribution. That's because there is a long tail in the negative direction on the number line. So that's why data is left skewed. So mean is less than median, and the distribution is negatively skewed, and left tail contains larger distribution. So if you can see left hand side you are getting some more information like more examples are there, and right hand side there is so there is a low measurement is like a very less is there, but frequency is very high on a left side, on a right side. Okay, so that's why it's a left skewed is there. Similarly, opposite thing we are find out in the right skewed bell curve. So the right skewed distribution are also called as a positive skew distribution. That's because there is a long tail in positive direction on the number line, and the mean is also to the right of the peak, and the normal distribution is the most common distribution you will come across. So skewed data distribution indicates the tendency of data distribution to be more spread out on one side. So the data is right skewed, so at the same time the distribution is positively skewed. Mean is greater than median. In a last situation, mean is less than median, but here mean is greater than median. Right tail contains large distribution. So this type of stuff we are getting over here in a right skewed bell curve. So here normal distribution should be over to complete to over here. In the next session, we have to talk about like how kurtosis should be worked over there. Let's talk about the kurtosis. So, what is the meaning of kurtosis and what is the type of kurtosis? And we have to take in some brief discussion about kurtosis. Kurtosis is a statistical measure that is used to describe distribution, whereas skewness differentiate extreme values in one versus the other tail, and kurtosis measures extreme values in either tail. Distribution with large kurtosis exhibits tail data exceeding the tails of the normal distribution, for example, 5 or more standard deviation from the mean. Distribution with low kurtosis exhibits tail data that are generally less extreme than the tails of the normal distribution. Kurtosis describe the shape of the probability distribution. Also, kurtosis measures the tendency of the data towards the center or towards the tail. So basically, three types of kurtosis are available. Platykurtic is negative kurtosis. Mesokurtic represent a normal distribution curve, and the third one is the leptokurtic is a positive kurtosis. But now we have to discuss a brief in this type of the kurtosis. There are basically three kurtoses of the categories of kurtosis that can be displayed by a set of data, and all measure of kurtosis are compared against a standard normal distribution or a balco that we already completed in your last session. The first category of the kurtosis is a mesokurtic distribution. This distribution has a kurtosis statistic similar to that of the normal distribution, meaning the extreme value characteristic of the distribution is similarly to that of a normal distribution. The second category is a leptokurtic distribution. Any distribution that is leptokurtic displays greater kurtosis than a mesokurtic distribution. Characteristic of this distribution is one with long tail, and the prefix of lepto means skinny, making the shape of the leptokurtic distribution easier to remember. The skinness of the leptokurtic distribution is a consequence of outliers which stretch the horizontal axis of the histogram graph and making the bulk of the data appear in a narrow vertical range. And the final type of the distribution is a plecurtic distribution. This type of the distribution have a short tail like paucity of the outliers. The prefix of the platy means broad, and it is meant to describe a short and broad looking peak, but this is an historical error. So that type of thing we are finding out during the kurtosis. After talking about the kurtosis, now it's time to talk about the three types of the variable. So basically, we are having normal variable, ordinal variable, and the association variable. So first of all, let's start with the nominal variable. A nominal variable is a type of variable that is used to name, label, or categorize particular attributes that are being measured. It takes qualitative values representing different categories, and there is no in-string ordering of these categories. Some example of nominal variables include gender, name, phone, and etc. Values with no logical ordering, variables are independent of each other, and sequence does not matter. Second parameter or second variable, that is the ordinal variable. Ordinal data is categorical statistical data type where the variables have a natural ordered categories and the distance between the categories is not known. Values are in a logical order and the relative distance between two data values is not clear. So that's how ordinal variable should work. And the last type of variable, that is the association. Association between two variables means the values of one variable relate in some way to values of the other. So association is usually measured by correlation for two continuous variables and by a cross tabulation and chi-square test for the two categorical variables. So two variables are associated or independent of each other. So that should come within a association variables. In the next session, we have to learn about correlation matrix. Now let's discuss about correlation matrix. A correlation matrix is simply a table which displays the correlation coefficient for different variables. The matrix depicts the correlation between all the possible pairs of value in a table. It is a powerful tool to summarize a large data set and to identify and visualize pattern in the given data. Correlation matrix consists of rows and columns that shows the variables. Each cell in a table can contain the correlation coefficient. In addition, the correlation matrix is frequently utilized in conjunction with other types of statistical analysis. For instance, it may be helpful in the analysis of multiple linear regression models. Remember that the models contain several independent variables in multiple linear regression. The correlation matrix determines the correlation coefficient between independent variables in a model. So a correlation matrix is a square matrix that compares a large number of variables. So correlation matrix is a square matrix. It will come within n cross n matrix. Very large number of rows and columns are there. Correlation coefficient measures the extent to which two variables tend to change together, and the coefficient describes both strengths and direction of the relationship. So particularly in with the correlation matrix is a square matrix that compares a large number of variables. So there is two things are available over here. So Pearson product moment correlation are there, and second one is the Spearman rank order correlation are there. In the particularly Pearson product moment correlation, it evaluates the linear relationship between two continuous variable. So the linear relationship means that a change in one variable result in a proportional change in other. If we can talk about the Spearman rank order correlation, it evaluates the monotonic relationship between two continuous or ordinal variables. It also consider within monotonic relationship means that the variable tends to change together through not necessarily at a constant rate, and the correlation coefficient is based on a ranked values for each variable rather than a raw data. So that's how things are working over here whenever we have to talk about the correlation matrix with the Pearson product moment correlation and the Spearman correlation, Spearman rank order correlation. So after talking about the correlation matrix, in the next things we have to take on some little bit again idea about the inferential statistics as well as the dispersion statistic. So let's taking some idea about the inferential statistics again and again. Again, we before in last session or before last session, we are just only getting about basic idea about the inferential statistics as well as this descriptive statistics. But now we are taking some more depth idea about the inferential statistics. So the inferential statistics uses a random sample from the data to make inferences about the population. Inferential statistics can be used only under the following condition, like a complete list of the member of population is available, or a random sample has been drawn from the population. Using a pre-established formula, you determine that the sample size is large enough. Inferential statistics can be used even if the data does not meet the criteria. It can help determine the strength of the relationship within the sample. If it is very difficult to obtain a population list and draw a random sample, do the best you can with that one. After discussing about the inference statistics, let's talk about some of the application based upon a inferential statistics. So if we can talk about the inference statistics application, so it has uses almost every field such as business, medicine, data science or data analytics, and many more things are there. So it is an effective tool for the forecasting, time-based forecasting or the weather type of forecasting. It is also used to predict the future pattern because forecasting is also coming in a part of the future patterns based upon that. So inferential statistics are often used to compare the difference between the treatment groups. Like inferential statistics use measurements from the sample of subjects in experiment to compare the treatment groups and make generalizations about the larger population of the subject. So that's how we can work with it application of the inferential statistics. So basically, in this particular module of statistics and probability, we have to first of all starting with the introduction to statistics. Then we can take an idea about the measure of central tendency. Then we can get an idea about the bell curve, normal distribution, right skewed, left skewed. After that, we can discuss about the kurtosis, and last we have to discuss about the correlation matrix. And again, we can wind up within inferential statistics. In this session, we have to see some coding based upon statistics and probability. So here, let's check it out some of the basics test. Okay, so that is also known as the normality test is there. So main objective of performing the normality test is to validate the Gaussian distribution data, because during the theory part we have to discuss about a normal distribution as well as data distribution, bell curve, how Gaussian distribution should be worked. Okay, so based upon that we have to see about the Shapiro-Wilk test as well as then a test whether a data sample has a Gaussian distributions are there, and for that we have to take on some type of the assumptions as well as like observation in each sample are independent and distributed identically. Okay, so let's first of all give some heading related to that one, like we have to see in some normality test because that is important for us, that's why. And for that we have to assume some of the hypotheses, okay, like h0 and h1. So basically with the h0 the sample has a Gaussian distribution, and whenever we have to talk about the hypothesis one, so it should look like the sample does not have a Gaussian distribution. Okay, so in one side we are having Gaussian distribution, in another side we are not having any type of the Gaussian distribution. So let's start the code with the library. Okay, so first of all, we have to see about the library, like which type of library should be helpful for us. So first library, that is the SciPy. Okay, but here we are not directly using NumPy pandas, but here we have to use SciPy library because the normality test should comes with the Shapiro Wilk test. Okay, so we are having already the one of the algorithm based upon the Shapiro. Okay, so that's why from the SciPy dot states we have to use. Okay, so from the SciPy states we have to import a Shapiro, so they can recommend the things or not. Yes, now the Shapiro, yes, they can recommend after some time. Yeah, so we have to import the Shapiro over here. Okay, so after that one, we have to create first of all some data for that, and as well as we have to create some states for that one. So first we have to create a data. So we have to create a data parameter, and in that data we have to take in here data. In that, for that we have to create a list. So basically we have to take in some random numbers of data. Okay, so we have to take like 0.87, then we should take 2.18, as well as 0.121. I just taken some random data. Okay, that data is not fixed. Also we have to take in some negative data as well, as like 0.94, like that. Also we are able to take like 0.055. Okay, also let's take it 0.05 in terms of minus, so that should give some better idea like how the normality should work over there. Then minus 1.43. Also let's take it minus 1.66. Then we have to take an minus 1.89. So I think up to minus 2 we are having some values are there. Okay, and that's better. So once we can create the data, then next in we have to take on some states over here. We have to take on state, and with that state we have to consider the p is equals to Shapiro. Like already we are having the algorithm for the Shapiro. Okay, so that's why we do no need to take some more stress over there and Shapiro of data. So we are getting easily idea. And to get the output based upon a print function, so that we have to take on over here the state is equals to, also we have to take on curly brackets, and inside the curly brackets we have to fill some values, like 0 semicolon. With that we have to take on 3 in terms of the decimal over here. After we have to take on p is equals to, again same things we have to take on over here in terms of the decimal point over here. So once we can take in this one, so at the end we have to use the format function over here, and inside the format function we have to take in state as well as the value of p. The both the things we have to take in over here. Once we completed this one, then at the end we have to take in the if condition over here, like if p is greater than 0.05 with the semicolon. So again we are trying to print with the probability Gaussian, so that's why we have to take an probability Gaussian over here, and that should complete it over here. And at the end, we have to take on one else condition over here, and in that else condition, we have to put it some more thing related to the print. If this condition is not fulfilled, we have to get probability not Gaussian. So that is our hypothesis, nothing but a hypothesis. Like probability is not Gaussian. So that is the insight from that one. And now we have to run this code. So at the same time, we are getting an idea of what state, that is a 0.931, and the probability that should be a 0.931. So both are looks are similar over here. So that's why it's a probability Gaussian is there. So that is depends upon our data. If I can change again data, so again I'm getting some different type of stuff over here. So that is a basically normality test is there. With the normality test we can see about the Shapiro Wilk test. Okay, so that is the one type of normality test is there. The second type of normality test, that is the D Agostino test is there. So D Agostino test is there. So that is again complex is there in terms of the normality, because again we have to create some states, and just we have to replace the normal test at the same time to get some Agostino test. Okay, so let's see how to Agostino test should be work over here. For that, the name is the D Agostino test is there. Okay, and it is not. It is also located as a normal test. But before that, what we have to do, we have to copy this whole code over here from over here, because we are not trying to make it all the things newly. Okay, Like as replacement of the Shapiro, we have to just only we have to take normal test over here. Like normal test we have to take on over here. Again, when we talk about the p is equals to Shapiro, at the same time again we have to design as a normal test over here. Otherwise we no need to apply anything different over here. So again, we have taken normal distribution, and now again we're trying to run this code. So at the same time, according to the Agostino test, we are getting states is equals to 0.998. Similar probability is there, and probability is again Gaussian. So at the same time, the main concern that is the probability is Gaussian or not. So that is the important things over here. After that, the Agostino test, now we have to sing as we are now we have to sing Anderson Darling test. Okay, so this test whether a data sample has a Gaussian distribution. So again, we have to take in some assumptions like observations in each sample are independent and distributed identically. So that type of things we have to again evaluate it over here. And again, during the coding of this one, again we have to take in some two hypotheses like the sample has a Gaussian distribution or sample does not have any type of the Gaussian distribution. So that type of things we have to evaluate it over here. So let's start it with the Anderson and Darling test. Okay, so that is also part of the statistics and probability. Again, we have to made it paste it over here the same thing like from SciPy test. At the same time, we imported the Shapiro, but now we have to simple imported the Anderson easily. Okay, also over here we have to just take an Anderson again over here. Okay, so we have taken Anderson of data, but the main thing is we have to change it over here. Like whenever we have to take an state is equals to 3 with the decimal point of f, here now we have to take an g, and we are not providing any type of the probability things over here because here we don't want any type of the probability. Here we are just only working with the states. Okay, we are not working with the probability. So just a second, we have to end this bracket over here. Okay, yeah, now it's ended. And in this format of we have to just simply take states. Okay, so no need to take in this simple state. We have to take in some like result of statistics is there. Okay, and also here we have to remove this state as well as. Okay, so here it is known as simple result because no need to work with the states, that's why. And here simply I have to take an result dot statistic over here. Okay, so that should end it over here. And here we have to provide one for range over here, like how it is in within for range it should work. So for a particular input sample we have to work, and in this particular input sample, within this input sample we have to take on some range. Range is also should comes within a length, and particularly in that length we have to again take on the critical things. Like with that we have to find out some critical values as well as, because that is again important thing is the like critical values. So after that we have to provide this semicolon over here, and then we have to just taken SL and CV over here, and similar thing I have to compare with the again result with the significance. Okay, so I have to taken, I have to find out for that one. Yeah, so that is a significance level. So significance level should comes within all the inputs. So that's why I do select the I, and as well as with the result with the critical values are there. So already we taken, yes. So that is the critical values. We just only wants values. Okay, again with the I or number of samples. Okay, and here we have to just simply change this condition, otherwise the thing is perfect. Okay, probability with the things like if the results comes within some statistics are there. Okay, so it should follow the statistics. Okay, and it should less than the CV, that is again important part is there. Then we want to see like probability Gaussian at the particular probability Gaussian should be work at a particularly 1% of level. Okay, so that's why we have to complex. We have to write down the particular percentage of syntax as well as. So for that we have to take a percentage of 1 within some decimal points, and then again we have to take that particular level over here, and then again we have to provide the percentage in terms of the SL. The same thing we had to done over here, like probability is not Gaussian. So what type of chances are there? It shouldn't be a Gaussian. So again, for that we have to use this same one over here. So I have to remove that one. So let's try to print this code, or yes, we are getting an error. Okay, so okay. So whenever we are using, yes, so that is not required. I forgot to remove that one. Also, yes, for I in range is there. So at the same time, result are coming with the critical values. Okay, so that should be correct. But why we are getting an error? We have to again check the code as well as. Okay, so it's one more spaces is there. That's why. Yes, now we are getting the perfect thing over here, like how it should worked over here in terms of the states and as well as probability quotient at the 1% of level. It is also depends on if you can provide some more input, so you are getting some more things. Okay. Also, in the statistics and probability, if you want to do, you can also do the some correlation tests are there, as well as the Spearman rank correlation are the Kendall's rank correlation are there. So many type of statistical tests are available with the statistics and probability concept. Basically, in this module, we can start from the supervised learning. Then we have to see about different type of supervised learning types. And then particular from the supervised learning, we have to talk about classification and regression. After that session, we have to discuss about what are the importance and what are the logic behind the linear regression and the logistic regression. So from this module, the two key concepts are the linear regression and logistic regression. After discussing about linear regression and logistic regression, we can move forward to the unsupervised learning. From the unsupervised learning, we have taken a little bit introduction about k-means clustering. So let's start with the first part based upon a supervised learning. And from the supervised learning, we have to discuss about supervised learning case study. Ever wondered how Amazon make recommendation? Amazon divides or the devise an algorithm that begin looking at items themselves. It scopes recommendations through the user's purchased or rated item and paired item to similar items. Using metrics and composing a list of recommendations, that algorithm is called item-based collaborative filtering. A recommendation system that is the main part of the machine learning, and that's why with the machine learning it will consider as a supervised learning. Amazon uses a supervised learning algorithm to predict what item the user may like based upon the purchase history of similar classes of users. If from your Flipkart account or the Amazon account, if you in your past history, if you can search related to some computer systems, so after some time, also Amazon and Flipkart, based upon their recommendation system, they will recommend to you like pen drive or mouse or keyboard type of accessories based upon a computer. So that's how supervised learning with the recommendation system should be worked. So let's check it out. What is the meaning behind the supervised learning in terms of definition in proper way? Supervised learning is a type of machine learning used to learn models from labeled training data, and it allows us to predict output for future or unseen data. In other words, supervised learning is the machine learning task of learning a function that maps an input to an output based on input output pairs, and it infers a function from labeled training data consisting of a set of training examples. The great examples of supervised learning is a text classification problem, and in this set of problem, the goal is to predict the class label of a given piece of text. One particularly popular topic in this text classification is to predict the sentiment of a piece of text like a Twitter or a product review. So that's how supervised learning will should work. Now we have to look about some more example based upon a supervised learning. And among that, the first example is based upon a voice assistant. Voice assistant like Apple Siri, Amazon Alexa, Microsoft Cortana, and Google Assistant are trained to understand human speech and intent. Based on human interaction, this chatbot take appropriate actions. Let's talk about the example number two. Second example is based upon a Gmail filters. Gmail filters a new email into inbox like a normal or a junk folder. It is called as a spam based on past information about what you consider as a spam. Sometimes some companies are sharing some mail with you, you can consider that mail as a spam. But if your colleague will share on any type of the mail, that you consider as a not spam or the normal spam, normal thing. It's not spam like that. So it will come in a inbox. Let's talk about the third example, that is the weather apps. The prediction made by weather apps at a given time are based on some prior knowledge and analysis of how the weather has been over a period of time for a particular place. So we all are using the weather application in our smartphone. So we are getting an idea like how accurate weather application are working based upon a prediction of machine learning or prediction from regarding to the supervised learning. Till now related to the supervised learning, we already getting lots of idea. Now let talk about something based upon a types of supervised learning. So basically two type of things are over here. First is the classification, and second one is the regression. In this part, first of all, we have to discuss about or the meaning behind the what is classification. Classification is a type of supervised learning, and it specifies the class to which data elements belong to. It is best used when the output has finite and discrete values. It predicts a class of an input variable. There are two types of classification are there, binomial or the binary and the multi-class classification. In machine learning, classification refers to a predictive modeling problem where a class label is predicted for a given example of input data. For example of classification problem include given example like classify the mail is spam or not spam, given or what are the handwriting character is there, that the handwritten or the printed are there. Also, we have to classify it as one of the known character or not. So here if you can see in this diagram, there is some type of spaces are there, like dog spaces are there, genesis are there, families is there, then order is there, class is there. So we are getting different type of animal according to that one, like who are the kingdom, like oh, total animals are there, like how it should relate it, like there is different type of animal classes are there, though some animal are flying in air, some animal will walking in a land, and some animal are do swim in water. So that type of thing is there. Okay, so after a discussion about the classification or the meaning behind the classification, let's little bit go with the some machine learning language type of stuff with the classification, like what class, like according to the classification what class applied when the output has finite and discrete values. Example like social media sentiment analysis has three potential outcomes like positive, negative or neutral. In machine learning, classification refers a predictive modeling problem where a class's label is predicted for a given example of input data. So that's how we are getting some more idea. Like here we are having some binary chart is there or binary graph is there. So the green sample is represent like mail are not spam, and the red crosses are represent like mail is spam. So according to that one, we have to create one line. According to that line, we are getting an idea which are the plus one and which are the minus one thing are there. So let's talk about some example in deep with the classification example. Social media sentiment analysis has two potential outcome like positive or negative. So whenever you are getting some on a Twitter or on a Facebook or an Instagram, if you are getting some positive comments like the peak was good or peak was nice and peak was not good or whatever the comment is there, comments are also coming in positive way, as well as comments is also coming in a negative way as well. So that's how we can get some better idea like what are the positive comments and what are the negative comments. So that we have to classify throughout this boundary line. So boundary line is represent with the classification. So this is type of the classification for working for the binary classification. But whenever we are having some four classes are there or five fifth classes is there, so we can consider as a multi-class classification. So after discussing based upon this one, like we can also take in some iris classification. So iris is the one type of flower is there, and the flower we consider within three classes like 0, 1, and 2 is there. So there's different type of classes are there like Virginica is there, Satosica is there, Imagica is there. So that type of thing are working over there. And the test set dots represent the assignment of new data points to one class or the other based on the trained classifier model. So that's how thing was working in a classifications. After getting basic idea about the classification, let's talk about some of the thing based upon a regression. Classification are working with some discrete values like within discrete class like 0, 1, 2, 3 like that, to based upon their classes. but regression should work within some continuous parameter. Okay, so applied when, like answer is again how much, and applied when the output is continuous number. So a simple linear regression algorithm, it's a y is equals to wx plus b in terms of example, like a relation between the environmental temperature and the humidity level. Okay, so because we have to predict the weather, so that's why environmental temperature and humidity level, it's both are required. So based on the value of one or multiple predictor variables, briefly the goal of the regression model is to build a mathematical equation that defines y as a function of x variable. So based upon y, we are trying to define x like that one. Okay. So because here the x is the independent parameter and y is the dependent parameter, and y depends upon the x. Okay. So always x is defined but y is not defined. We have to find x based upon a, sorry, we have to find y based upon the x. Okay, so that's other thing is that just in this session we are just getting basic idea about the how supervised learning should work and what are the types, and in the types what are the basic meaning behind the classification and regression. From the next session we have to take some deep dive within what is the regression, and we can see some real world application based upon a linear regression. And in the linear regression we can also evaluate the how mathematics behind the linear regression should work over there. In this session, we have to learn about what is regression. Also, we have to find out the types of regression, and from the linear regression, we can see about how linear regression should work and what are the mathematical representation behind the linear regression. So let's start it with the what is regression. Regression is a statistical method used in finance, investing, and other disciplines that attempts to determine the strength and character of relationship between one independent variable and a series of other variables. In statistical modeling, regression analysis is a set of statistical process for estimating the relationship among the variables. So here we have to define the relationship between x and y. X will be stand as an independent parameter and y will be stand as a dependent parameter. Always y is depends upon x. So we are whenever we are trying to do some project or coding, so x is already defined, and from the x we have to define y. So after understanding of what is regression, now let's talk about the type of regression. So the basic and first type of regression, that is linear regression. The second type, that is a multiple linear regression. So once you can learn about the linear regression, then it is very easy to learn about the multiple linear regression, because the inside method and mathematics are similar for the linear regression and multiple linear regression. Just the difference is that whenever we can talk about a linear regression or a simple linear regression, at the same time we are only taking one independent parameter and one dependent parameter. But whenever we have to talk about the multiple linear regression, so at the same time we are able to take lots of independent parameter and one dependent parameter. So lots of x are there and just only one y is there. After third thing or third type, that is the polynomial regression, and the fourth one, that is the decision tree regression. So let's start it with the linear regression thing. So linear regression is a linear approach for modeling the relationship between scalar dependent variable y and independent variable x. So that's how it should work in a linear regression, like relationship between x and y. So here if you can see in this equation, like y hat is equals to w transpose into x. So x will stand for the input and y will stand for the uh, dependent parameter. But what is the meaning behind the w transpose? Okay, so this is the standard equation is there, but first of all, before going to standard equation, we can derive or we can get some basic idea about like 12 standard signs, like y is equals to mx plus c. I hope everyone will know about the y is equals to mx plus c. Okay, we can discuss about that one, but still we can talk about some basic thing related to the linear regression. Linear regression is the next step after the correlation. So whenever we are trying any type of the project, or we can find out how to apply the correlation matrix and how to check it out correlation matrix, or how to find out some basic things related to that, then we can go with the linear regression. It is used when we want to predict the value of a variable based on a value of another variable, and the variable we want to predict is called the dependent variable, or sometimes the outcome variable. Simple linear regression is used for finding the relationship between the dependent variable y and independent variable or the predicted variable. Both of these variables are continuous in nature while performing the simple linear regression. We assume that the value of predictor variable x are controlled. Furthermore, they are not subject to measurement error from which the corresponding value of y is observed. The equation of a simple linear regression model to calculate the value of the dependent variable y is based upon the predictor variable x. So again, we have to find out the things between x and y. So again, come over here from the y hat W transpose x. So where x, y, where the vector of real numbers and W is a vector of weight parameter. So the equation is also written as y is equals to wx plus b, where b is the bias or the value of output for a zero input, and x will play as a input, and w is the weight parameter is there. Let's see some real world application based upon a linear regression. Like based upon linear regression, what are the real world application we can explore? So the first application is based upon a weather prediction application. The goal of multiple linear regression is model to relationship between the explanatory and response variable, and it was found that the proposed model is capable of forecasting the weather condition for a particular station using the data collected locally. In weather application, we have to apply multiple linear regression because we have to apply multiple inputs. So after linear regression, we can talk about the multiple linear regression, and that multiple linear regression we are easily applied in real world regression examples. Second application is based upon a housing price prediction. So prediction of housing price using the regression algorithm for machine learning. It's a machine learning has been used for years to offer image recognition, palm detection, natural speech comprehension, product recommendation, and medical diagnosis. So lots of applications are based upon a machine learning. But whenever we talk about the housing price prediction, so at the same time, nowadays, like many applications are available, like housing.com, then broker.com, and many applications are available if you want to find out the what are the correct price of the house according to their locality, what are the facilities available according to their house. So nowadays lots of websites are available to prediction of this one, so that's why based upon that we are getting an idea like housing price prediction as well as the next application is based upon like employee salary prediction. So what type of thing we can getting from the employee salary prediction? In the employee salary prediction, according to the employee performance from the few of years like 5 years or 7 years, we are getting an idea how much increment should become in employee salaries. So how much of growth employee can get from over the years, what are the level of work is given by the employee. So that type of thing we can get over there. So basically mainly thing is based upon employee experience and employee classification. So that's how we can get an idea like how employee salaries prediction should help to predict with the machine learning or the linear regression. And the last real world application, if we take like there is a Virat Kohli run prediction. So based upon a Virat Kohli current performance, stadium experience, performance against the opponents or current year performance, current year numbers. So based upon many type of stuff are working over here, and based upon that we are getting an idea like how much run today Virat Kohli will made in this particular ground or in this particular match. So that type of thing are there. So basically we have seen about the four real world application based upon a linear regression. So after getting about this, now it's time to go with the some mathematics based upon a linear regression. So let's start it with the mathematics thing based upon a housing price prediction. In this table, there is two column is present. One is area and second is price in INR. When the area was increased proportionally, prices also increased. But at the one level, only area will increase and suddenly price will decrease. But these things it's come due to the threshold. Let's put all the sample in this graph. So here y is dependent variable. It is also known as criterion variable or the regression. Whereas x is known as the independent variable. It's also known as the predictor variable and the regressors are there. So once all samples are plotted in this graph, then you will get an idea related to the linear relationship, like how area will increase and price will also increase. So, but now we have to see some more additional thing based upon this one. Like now, based upon this one, like if I assume like 10,000 square feet meter is there, area is equals to 10,000 square feet meter, and according to that sample value is around 1 crore in INR, but according to the linear relation price is just only 60 lakhs. So based upon that, we are getting difference around 40 lakhs. And in machine learning language, it is called as the difference between actual output and predicted output. It's known as mean square error or particular type of the error. So here, once here it's the actual output and 60 lakhs is the predicted output. So 40 lakhs are become an error. So here, if you can see, y and y hat is there. Okay, so we have to find out difference between y and y hat, and what are the difference we are getting in between y and y hat. It's become a mean square error in terms of it is difference between actual output and predicted output, because actual output is like, or whenever the 10,000 square feet meter is there, according to the actual output is I think 1 crore. But whenever we have to talk about like linear relationship and the linear regression, so this green line will draw come from the linear relationship, and that linear relationship will just only represent the value 60 lakhs. So here we are getting an error. So this type of problem we are trying to solve during this linear regression, and that is the again important part is comes over here. So let's do one small activity based upon the same topic of variable affecting upon a regression techniques. Here we can see some equation, but we already discussed about this equation. Like our ultimate goal is minimize y minus y at its difference between, like what are the error we are getting over here. Like MSC, we have tried to reduce that one. So let's see this activity. If we apply the value of m and c in this equation of y is equals to mx plus c, so at the same time we are getting output y. So what are the green line I was drawn over here? So that is nothing but a green line. That is nothing but my y is there. So I have to take y is equals to mx plus c, and I have to evaluate the y. So my m value is 0 and plus x value is 1, 2, 3. So multiple values is there. So it's not just only one or two values there. Here there is a multiple values is there. X is equals to 1, 2, 3, 4, 5, up to 10 we are having value. So we have to provide m is equals to 0 plus x is equals to 1 and c is equals to 40. So 40 into 1, 40 into 2. That's how the thing are working. But and then my m is equals to 0. So y is equals to mx plus c. So every time x should become a 0. So that's why we are getting output. It's a, constantly 40. So that's how thing was working over here. If you can see the second diagram, so in this second diagram we are seeing like the things are coming up linearly. Okay, so we are getting over here the linear relationship. We are getting linear relationship like x 1, 2, 3 are there. So at the same time my value of m is equals to 0.8, but value of c becomes 0. So c are silent over here. So that's the type of thing we are getting over here, like how the thing are working in first diagram and second diagram. Now I just give you the 30 seconds to analyze the thing based upon the third diagram, and we can talk about like what are the things we are getting from over here. Okay, so I hope you can get an idea like how it should run over the third diagram. Okay, so whenever we are talking about the third diagram, so again y is equals to mx plus c. So here m is also present and c is also present. So if you can see, if you can combine the whatever the value we are getting over here for the first one, y is equals to 0, so it should starting with the from this 40 and it will complete it till 100, because that is a combination of first diagram and second diagram, and based upon first diagram and second diagram we are getting the third diagram, because in a first diagram we have to take an m is equals to 0 and c is equals to 40. In second one I have to take an c is equals to 0 and m is equals to 0.8, but in a third diagram we have to combine everything, and based upon that we have to try it out something prediction. So here we have to just only evaluate the things like how variable affecting a regression equation. So that is the important part over here. So after completion of that one, now let's talk about some of the things based upon a solving linear regression. You already seen over here the equation is there, but before that we have to learn about something like similarly look like the previous slide. Again we put the value of theta 0 and theta 1 over here. So here we are not doing anything new. We are just only replacing y is equals to mx plus c as replacement of theta 0 plus theta 1 into x. Every time theta 0 and theta 1 should be presented, and based upon a theta 0 and theta 1 we have to try to predict like what is the value of h theta of x, because that is the important part is over here. So first of all we have to take in that h theta of x is equals to theta 0 plus theta 1 into x. So x value is 0, 1, 2 and 3, but theta 1 value is 0. So similarly look like previous slide, like c is equals to 40 like constant. So here we are also getting theta 0 is equals to 1.5. So in a first graph we are getting constant 1.5 line. Similarly in second thing we are getting idea like z theta 0 should be constant. So now it's time to 0.5 into 1, 0.5 into 2 and 0.5 into 3. So that's how linearly relationship we are getting. But if we combine the parameter of theta 0, which is 1.5, or the theta 1 is equal to 0.5, that type of thing if we can combine, so we are getting third diagram. So if you can see over here, so you can get the idea like how it should work over here. So that's how the thing are working in this solving the linear regression. Then we can also talk about like how it should work, and we basically that's how based upon h theta of x is equal to theta 0 plus theta 1 of x, based upon that the total linear regression should be worked. So that's how this session should be over here, because in this session we have to talk about like how regression should be worked, and particularly we have to discuss about some real world application. We have to take on some housing price example, like how it should goes and how it should work. From the next session we have to talk about like mean square error and multiple cost function. And in this practical session we have to learn about the simple linear regression. So let's start with the simple linear regression. In a first step, that is the import the library. So firstly, I also mentioned over here like as a step 1. So step 1, import the libraries. So which libraries we have to import it over here? First of all, basically we have to import over here NumPy as NP. Second library is import pandas as PD. After importing NumPy and pandas, the next library, that is the import matplotlib dot pyplot as plt, and then we have to provide the backend line for that, that is the matplotlib inline. So we already imported all the libraries, and the last library that is important library, and that is the cbon. So import cbon as sns. So here all the libraries we had imported over here, we have to just make it one mistake, import pandas as pd over here, cbon as sns. Okay, so all the libraries are imported over here. In a step 2, what we have to do, in a step 2 we have to import a data set, import a data sets. So all the data sets related to the our course are provided into the source section, but still how to provide your data set to out the coding. Okay, so that's the things we have to see over here. So basically you have to create one folder, and the folder name, that is a simple linear regression. And particular in this linear regression, I already make it over here the data, and my data, that is the salary data.csv. So you have to create one folder, and particularly in that folder you have to provide your file, your dataset file, as well as what are the coding file you are creating now, that the source location is also the same file are there. So if you are doing the same thing, so at the same time it is easiest way to import the data set. So let's see how we can import the data set over here. So that's why first of all we have to take data set is equals to pd.read plus csv. Data sets are available in the csv format, so that's why we have to apply data set is equals to pd for the pandas library and read csv, because data set are coming in the csv format. That's why we have to make it with the csv format. That's why read csv are there. And simply we have to provide the particularly data set name. So data set name, that is the salary slash data dot csv. So that is the data file is there. And now once you can run this code, so you are getting the data set. So first of all I can show you how you can do the same thing. So here, that is my data set. So data set are having the years of experience and salary. There is total 2 parameter is there, and salary is depends upon the years for experience. So that's why years experience are performing as an independent parameter of x, and salary is the dependent parameter based upon the x. But still before that, let's do some basic analysis of this data set. Like we have to find out what are the basic functions that provided with the pandas to do this type of analysis, like dataset dot head of 5. So at the same time we are getting top 5 sample of the data set, as well as if we can provide the function like dataset dot info. So at the same time we are getting all the information based upon the data set, like how many number of columns are there, how many number of rows are there, and also years of experience as well as salary are having which type of the data type, and how many null object are there or count are there. So how many missing values are there, you are also getting that idea based upon this data set information. You can also find out the dataset dot size or dataset dot info. Dataset dot size, you are also getting the information based upon over here. NumPy integer is not callable, so that's why we are going with the dimension of that part. So dataset dot size. So here total size of this dataset, that is just only the 60. So that's how many more functions are there to analyze the data based upon simple things related to the pandas library as well as with the NumPy library. So let's create x and y parameter. So we want to consider x as a year of experience and y as a salary. So for that we have to provide some type of the indexing things or the graph things over here. So whenever you want to provide this type of thing with the particularly with the pandas library, you have to use iLocation function. So that's why iLocation is stand for the integer location. So now if you want to select all number of rows, so that's why you have to use the semicolon for the rows. And if you want to just only use the particular first column of your data set, that is a year of experience, so you can also provide some type of the logic like -1, or you can also take it over here the 0 as well. So that depends upon you. If you want to take it 0, you can also take it that one. And if you want to take it this one like -1, so that is the meaning of this column is also years of experience. Same thing you have to apply for particularly y as well, and then we have to provide the values. For y we have to take in some same parameter or same logic like dataset dot iLocation, and with that particular again we have to use all the rows, and from the column we have to use just only first column or the first position of column. So that's why we have to take on 1 over here, and after applying this one we have to find out that these things. So here we are getting our x as well as we are getting our y. So x is like years of experience 1.1, 1.3. This type of data we are getting over here. And in terms of y, we are getting this much of salaries are there. So that's how we are able to create x and y dependent parameter and the independent parameter. Next things we have to see about how to split the data set into the training set and the testing set. Now we have to see how to split the data into training part as well as testing part. So basically, we already known like training part is also considered with the 70 percentage of data as standardly, and the testing part are coming with the 30 percentage of the data. So let's see. Particular for that, we have to create 4 parameters: x train, x test, y train, and y test. X train basically coming from the test training set that is based upon some or all of the independent parameter of x side, and x test is depends upon the particularly independent parameter of the testing side. Similarly, y train should come from the training set, and particularly in the training set, those are the dependent parameter from the training side. So, and also at the end, y test is coming from the testing side. With that, we have to predict the particular final answer that is depends upon the y test. So let's check it out the step number 3. And here the step number 3 is training and testing data set. So that is splitting is based upon a data set. That's why we are already created x and y. So based upon that, we can try to over make it over here something. So first of all, for applying training and testing set, we have to import one library, and that is depends upon the scikit-learn. So here we are using one library, and first of all, we have to import the library like from sklearn dot model. From sklearn.model, from sklearn.model, we are using one linear model. So that's why not a linear model. Linear model we have to use for the linear regression, but here we have to use model selection. So that's why we have to apply it over here the model selection. After applying the model selection, we have to import over here the train, test, and split. So we have to write down over here for train, then test, and then we have to write down for the split. So after applying the library or after importing the library, next thing we have to create xtrain, ytrain, xtest, and ytest. So let's start to write down same thing. So here we have to take on first of all xtrain, then we have to take on xtest. Second thing that is the ytrain, and then that is the y test over here. is equals to, we are again call up our library, that is the train, taste, and the split. So based upon train, taste, and split, now we have to decide how many percentage are coming as a training and how many percentage are coming as a tasting. So first of all, we have to take an x and y that already decided, like what are the independent parameter or variable, or what are the dependent variable. Now we have to select the tasting size. If we can take tasting size is equals to 0.30, it means we have to take a 30 percentage as a tasting size and 70 percentage as a training side. You can also take it 0.33, so that will also look like similarly to 1 divided by 3. So many ways, many terms of ways you can provide the taste size over here. You can also provide the train size, but out of train size and taste size you have to provide just only one thing. You can also take it as a 1 divided by 3, so it's look like a 0.33. And at the end we have to provide some type of the random state. So here basically for now we are taking random state is equals to 0, and now it's time to run this code. We are getting an error. Let's check it out on where pages we are getting. Yes, we forgot the one thing over here. We are not able to any type of the parameter with the blank space. We have to provide this underscore over here, and now this step is already running over here. Now in the next step, what we have to do here, we have to create our linear regression model with the help of the scikit-learn. So let's start with the linear regression model. So first of all, we have to import the scikit-learn model from the linear regression. That's why we have to write down scikit-learn dot linear slash model, because I want to take a linear regression from the linear model part. That's why we have to take in this one, and then I have to write down the linear regression. So library is already imported over here, and after importing the library, now it's time to create a model, and model is equals to simple what we had to make it over here, that is the linear regression. After applying that one, now we have to try to fit our model with our x train and y train. So that's why we have to take a model dot fit and particularly fitted with the parameter of x train and second parameter, that is the y train. And now we have to run this code. Here we are getting an error. I think I'm getting an error based upon some type of the spelling over here. Let's check it out. What are the issues we are facing over here due to the spelling? Scikit-learn linear linear model. Then we have to take an linear regression. So I think everything is shows proper over here. Let's check it out. Still, what are the issues we have? We cannot import the name linear regression. So I think linear is complete with this part. We have to check it the error, like what type of error we are getting over here based upon our model. Okay, so we have to forward over here this bracket, and based upon this bracket we are getting an error. So now the error was solved over here based upon the linear regression, because I just forgot to provide this bracket over here, because without bracket the linear regression is not able to work with the x train and y train. So that's how the model is already built over here. But still, in between of training set and testing set, after the linear regression model, if you want to find out what are the values of x train y train, so you can check it over here. Like x train, you can write this code for everywhere, like x train, y train, y test, and y train. After getting idea about the linear regression model, the model is already prepared over here, and now it's time to prediction. So let's take a next step. Already we done a third step, that is based upon a training and testing set, and the step number 4, that is the machine learning model, like linear regression model. Now we have to see in step number 5. So step number 5, that is the prediction of y test based upon the test result. So prediction of y test based on a testing set. Okay, so for that, here we have to find out the y prediction. So y prediction is equals to model dot predict. We have to use model dot predict function with the help of the x test that we already created over here. And now we have to run this code, and again we have to overwrite down the y prediction, the answer we are getting over here. So based upon the years of experience and the particularly the salary, we are making one training set, and based upon that training set here, we are getting the Y prediction. So what are the X tests according to we are getting over here the Y prediction. So let's find out what are the X tests are there. So whenever the years of experience is 1.5, the salary is around 1 40,835.105. So that's how we are getting this type of salary over here. Whenever the experience is 10.3 years, so at the same time salary is 1,23,079. So that's how things are working over here. So based upon training set and testing set, now and then let's see in a particular step number 6, it's time to make a plot between training set result and testing set results. So step number 6 is depends upon the visualizing the training results. So now let's take it out. First of all, we have to use plot function, and with the help of plot function, we have to try to make it a scatter plot. So scatter plot here build up an X train and Y train, and also we are having one option to set the color for the sample. So we have to take an X train, next we have to take a Y train, and after we have to take an color, and color that is the red color. That is the red color. I want to take it as a sample. After applying this one, now we have to take an plot dot plot, and particularly in that next thing we have to take an again we have to take an over here the X train, because here we have to select our parameter scatter plot that is based upon a X train and Y train. But at the end here we have to create one hypothesis line in regression or the linear regression that is built upon the X train and the our linear regression model. So that's why here we have to use the model. That's why we have to take a model dot predict, and particularly with predict we have to take on the input parameter thing that is the X train, because these all things we can do for the training results. Whenever we can do everything for the testing result, at the same time we have to use input from the testing set. And now the hypothesis line will represent in a blue color. After completion of these things, now it's time to provide the X label, Y label, and the title. So let's start it with the title over here. And the title of this plot, that is the salary versus experience on a training set. Similarly, same thing we have to do for the next one. Next, we have to make it a plot dot X label. In particular, for the X label, we have to provide the years of experience. And in a Y label, we have to provide the salary. Here we have to provide the salary. So all the thing was completed over here. And now it's time to show the plot dot show. Let's check it out. We are getting error of the graph. Yes, we are getting a graph over here based upon a training set results or training set visualizations. Similarly, in a step number 7, we have to do same thing but based upon a test set results. But let's check it out. What are the things we are getting on a training set results? So these all are the samples are there, and according to these samples, we are getting one proper hypothesis. But whenever after applying a machine learning model on a testing set, we are getting some proper result as compared to the training set. So let's go for the step number 7, like visualize the testing set. Again, here we have to use the same code. At the same time, we have to change some of the parameter. Otherwise, whole code from the visualization that is looks similar for the visualizing the test results. So as compared to, first of all, you have to take an X train and Y train. As replacement of that, we have to use X test and Y test. Here we have to use Y test, and also from here we have to use X train. But also here there is a thing was similar over here in particularly testing side. Just only one change we have to apply over here, that is X test and Y test. So as an input we have to provide the data from the testing side. So as compared to the training set result of visualization, the testing set results of visualization gives the better idea according to the hypothesis. Also, if you want to do the evaluation of the performance, you can also create the y-test prediction based upon the regression of prediction based upon the x-test. So that's how in a simple linear regression we can see about the 7 step of the machine learning and also the linear regression model. So in a step 1, first of all we have to import the library. After importing library, we have to import the data set. After importing data set, we are finding out some basic information of the data set. If you want to do some data analysis things, so you can also do the data analysis thing after the step number 2 with the data exploration. But here we are concerned on a machine learning, that's why I'm not doing any type of the data analysis over here. But for your practice you can did. After that, we can make it a training set and testing set based upon a 66% and 33% as a testing side. After that, we are making linear regression model, and based upon model, we can make it prediction, and based upon the prediction, we can visualize the training set result as well as the testing set results. So that's how simple linear regression is completed over here. In the next things, we have to see about multiple linear regression of theory. In this session, we have to learn about mean square error as well as how cost function should be applied in a linear regression as well as many extraordinary term related to the after evaluating the linear regression. So let's start with the mean square error. In standard words, the mean square error of an estimator in terms of you can also understand like of a procedure for estimating an unobserved quantity measures the average of the squares of the errors, and that is the average squared difference between the estimated values and what is estimated. Mean square error is used to measure the performance of a model. So here we are having two terminology. Y hat test is equals to prediction made by the model on a test data, and Y of test, that is the expected output. So Y test and Y hat test, it's both are the important thing, and both are getting as the actual output and the expected output. So based upon that, we are trying to find out the difference between y hat test and y test among all the samples. So that's why the objective is to design an algorithm that decreases MSE by adjusting the weights W during the training session. And the above function is called the loss function or the cost function. The value needs to be minimized. So that's why after discussing or after talking about the MSE, let's something talk about related to the how solving linear integration in terms of the cost function. So after finding parameter theta that minimize the least square equation like OLS, like operating list square is there, its order is as well as and also called as a loss function. So j of theta will stand for the loss function. So here we have to take on this equation mathematically, but whenever we are going to learn same thing on a practically during the programming, at the same time, no need to take on any type of equation. Everything can coming with the scikit-learn library. So j of theta is equals to 1 upon 2 summation of I is equals to 1 to m. So here during the summation of I is equals to 1 to m, we have to take summation of all the samples from first sample to the last total number of sample. And it is not just only work for one sample, it should work like we have to find out the difference between actual and predicted for all the samples. And after all the samples, we have to provide that sum as well as. So this decreases the difference between the observed output h of x and desired output y. So that's how we can get some more idea about like how cost function should be work like, because j of theta will represent as a cost function, and that's why once we are trying to reduce this cost function at the same time, it should improve the accuracy as well as. So now we have to talk about like how to learn the parameter and what are the learn the parameter. So parameter learning error, whenever we are trying to apply any type of learning with the parameter, so it should improve the accuracy as well as it should improve the cost function. Like in terms of g of theta cost function, it should reduce, but the quality of that one that should be improved. So there are two ways to learn this parameter. The first way, that is the normal equation. Set of derivative in terms of slope of the loss function to 0, and this will represent the minimum error point. Normal equation is an analytical approach to linear regression with a least square cost function. We can directly find out the value of theta without using gradient descent. And following this approach is an effective and time saving option when are working with a data set with the small features. So normal equation is a basic type of things are there, but now we have to talk about one of the important learning parameter techniques, and that is the LMS algorithm. The LMS algorithm, it should be stand for the least mean square algorithm. And the minimization of the MSE loss function is called the LMS least mean square rule or a withdraw half learning rule. So the some of the people are using as LMS technique, or some of the people are also known as a withdraw half learning rule. This typically uses the gradient descent algorithm, but in technicality of machine learning, the gradient descent word is very popular. So the LMS algorithm introduced by Widrow and Hall in 1959 and is an adaptive algorithm. So the LMS incorporates an iterative and the procedure that makes successive correction to the weight vector in the direction of the negative of the gradient vector, which eventually leads to the minimum mean. So as compared of the both the ways for the learning parameter, the LMS algorithm is much popular due to the gradient descent concept. So let's do how we are going with this LMS algorithm and in future with the gradient descent. In case of linear regression, the hypotheses are represented with the y is equals to h theta of x. So h theta of x and hypothesis and y, both are the similar thing are there. So based upon that, we have to getting some idea about the theta 0 plus theta 1 into x1 plus theta 2 into x2. So where the theta will represent some of the parameters. Okay, so is our thetas are the parameters for number of samples or the weights. So thetas can be also be represented as theta 0 into x0, where the x0, x0 is the initial input are there. So always we have to consider initial input is equals to 1. After that, we are getting this h theta h of x. So it is again similar like h theta of x is equals to theta 0 plus theta 1 into x is there. And here we have to apply these whole things to each sample. So that's why the standard and easily understandable format is theta transpose into x. So what are the weights are there? We have to provide the weights to that and we have to take a normal input. So the combination should become in terms of matrices. So after that, the cost function, also called as ordinary least square or the OLS, that should define is especially the mean square error. The one half is just to cancel out the two after derivative is taken and is less significant. So cost function is equals to one half summation I is equals to 1 to m h theta of x of I minus y of I. We have to take at the square bracket. So same thing we already discussed during the cost function, like g of theta it's represented with the cost function, and it is advisable to start with random theta, then repeatedly adjust theta to make g of theta smaller. But once we can getting some values of j theta, then it's time to implement LMS algorithm. So here at the same time, if we can develop LMS algorithm in terms of gradient descent technique, so at the same time we have to provide the derivatives to particular cost function. So gradient descent is an algorithm used to minimize the loss function. So when we about the loss function, so gradient descent, it's a very good thing is that. But what is gradient descent in general words? Gradient descent is a first order iterative optimization algorithm for finding a local minimum of a differentiable function. So with the help of differential function, we are trying to find out local minimum or the optimal minimum or the global good solutions. The idea is take to repeated step in the opposite direction of the gradient or the approximate gradient of the function at the current point, because this is the direction of the steepest descent. So these are the things are considered over there. So let's talk about some of the fact related to the gradient descent. Like in the gradient descent, j of theta in dj of theta, it's a derivative of j of theta and represent the cost function or error function. So cost function are having multiple names there. So one of the name is the error function that you wish to minimize the OLS or the minimize the mean square error. That is your final target is there, because we have to reduce this mean square error. So minimizing this would mean that y hat approaches y. In other words, observed output approaches the expected output. So at the same time, we are trying to make it same number as actual output and predicted output. For example, today I can predict like Virat Kohli will make 100 run, 110 run, and in actually Virat Kohli will make 105 runs. So that's good, but the error will start from big. I can predict like Virat Kohli will make 110 run, but Virat Kohli just only make a 10 run. So at the same time, my prediction will go very wrong. So other example of loss or cost function include cross entropy, that is y hat, y log y hat, which also tracks the difference between y and y hat. So that's how things should be worked over here, and we are getting some idea about the how gradient descent should be worked over there. Now let's talk about algorithm in step of algorithm, like how gradient descent should be worked in terms of LMS algorithm. So first of all, it should start from the slope of j of theta. It's the slope of cost function versus the theta parameter. So after that, we have to provide the derivative of that function. So we are getting perfect slope. After that, we have to adjust the theta repeatedly, and alpha is the learning rate. Again, alpha will play a major role when we talk about LMS algorithm. So this algorithm repeatedly takes a step towards the path of steepest descent. So steepest descent, or the when we talk about the equation of the theta j learning rate equations, at the same time it should prefer the learning rate as well as. So calculate derivative term for one training sample x and y to begin start this one. Again, I telling to you whenever we are talking about this mathematical. So mathematical are just only looks good when it's on slide or on paper, because during the practical we are not doing. There's lots of mathematics things because we have to implement. We have to use libraries to complete this type of stuff. So last step is based upon update rule for one training sample. So for that, again, we have to go with the theta j is equals to theta j plus alpha of y of I minus h theta of x of I into x j of I. So that's how things are working over here in terms of how to update a one learning rule. Still, let's some of the more thing we have to talk about, like how the with the LMS algorithm gradient descent learning should work. So the graph here, we are getting this one graph. So in this graph, we are getting some blue dots and yellow dots. So what is the meaning behind the blue dots and yellow dots? So this blue dot step size is depends upon the learning rate. So again, we have to learn about what is the meaning behind the learning rate. And the yellow point will represent the optimal global point. So whenever our blue point meets to this yellow point, so at the same time, our accuracy it should become 100% and error should become 0. So at the same time, we are getting mean square error is equals to 0. So the gradient descent is an optimization algorithm. So that's it's used when training a machine learning model. It is based on a convex function and tweaks its parameter iteratively to minimize a given function to its local minimum. So that's how things was working. But still, we have to lots of things are remaining based upon a learning rate and many more things are there. So now let's do some of the things like how it should go. The things or cost function are working under the iteration. So if you can see the rate point, it should represent the global maxima, and we have to touch down throughout the global minima. So global minima, whenever we are getting some global minima, so at the same time it should become my error should be a 0. So global minima, it's a perfect thing are there. That's why we are trying to near throughout the global minima. So that's why we can start a journey from red point to the blue point or the red area to the blue area. But if you can see this diagram, in this diagram, one more global minima is there and one more global maxima is there. So let's see how it goes for the global minima again. So that is the second global minima is there. So both the things are important when we are trying to find out what are the global minima. But these are the 3D diagram. That's why we are getting this type of thing. But when we are working with the 2D diagram, it means like when we are working with two dimension thing. So it looks very proper because it just only use as a like inverse bell curve type of thing are there. Let's talk about the learning rate. So gradient descent are totally based upon learning rate. But what is the importance of learning rate and what are the popular values of learning rate? Basically, this learning rate or the gradient descent, this type of thing are also popular in deep learning. So deep learning neural networks are trained using the stochastic gradient descent optimization algorithm, and the learning rate is a hyperparameter that controls how much to change the model in response to be estimated error each time the model weights are updated. So gradient descent is important in machine learning as well as in deep learning. So what happens whenever the learning rate is low or the small? Whenever we are having learning rate is very very small. So at the same time, it should take lots of time to reach at optimal point. And also whenever it's try to near with the optimal point, it should take some more time or more extra time. So for that, we are trying to like we have to take learning rate as large. But whenever we are trying to learning rate is large, so at the same time, it should not easily converge with the optimal point. It should take like very small, large steps and may not converge to minimum, and error might keep increasing for further improvement. We are doing this gradient descent or cost function and this type of stuff to reduce the error. But whenever we have to take an large learning rate, so learning rate should be large as well as fast. So at the same time, the error should increase, but our goal is error should be reduced. So that's why slow learning rate or the small and fast and large learning rate are not possible. So for that, we are having just some of the values are there to make some learning rate. So that's why we have to follow some of the value like zero point 0.5 or 0.05, that type of things we have to use every time. So same thing are applied for the both the things, and that's why an epoch refers to one pass for the model training. So after talking about these things, let's discuss more similar situation based upon a learning rate. So these are the another situations are there. These are not based upon a large or small learning rate. These are the some condition whenever we are getting in data as well. So not all cost functions are good balls. There are maybe holes, ridges, plateaus, and the other kind of irregular terrain is there. So if you can see this figure, if random initialization of weight start on the left, it will stop at a local minimum, and if start on the right, it will become a plateau, which will take a long time to converge to the global minimum. Fortunately, the mean square error cost function for linear regression happens to be convex function with a bowl with global minimum. So that type of thing are working over here during the gradient descent learning rate. So this session is ended over here. Basically, in this session, we have to mainly time spent within LMS algorithm and the gradient descent. Started with the mean square error. In next session, we have to just simply talk about what are the objective of linear regression and the real world application or the use cases based upon a linear regression. Let's talk about objective of linear regression. The establish if there is a relationship between two variables, independent variable and dependent variable. For example, relationship between housing process and area of house, number of hours of study, and marks obtained, income and spending, etc. And the second thing is prediction of new possible values that is based on the area of house prediction, predicting the house price in a particular month based on number of hour studied, predicting the possible marks, sales in the next 3 months, and that type of things we are getting during the prediction of new values. After seeing about the objective of linear regression, let's see some of the more linear regression application or the use cases. So the first use cases should become from the real estate. In the real estate, to model residential home prices as a function of the home living area, bathroom, number of bedrooms, or lot size, or and many more thinking are available over there. Like when we are talking about this type of thing, so many housing price prediction applications are available over the net. If you can see, so you are getting some more application over the net based upon housing price prediction. The second thing, that is the medicine or the healthcare, like in field of medicine and healthcare, how the application of linear regression should develop to analyze the effect of a proposed radiation treatment on reducing tumor size based on a patient's attributes such as age or weight. The third application is demand forecasting to predict demand for goods and services. For example, restaurant chains can predict the quality of food depending on weather. And the last application based upon a linear regression, that is the marketing, with the to predict companies sales based on the previous month's sales and stock price of the company. Whenever you are having some large problem based upon a stock price, you can also go with the neural network, because some of the neural network are also work within this type of stock market price prediction. Simple linear regression is completed over here, and now from the next session we are trying to learn about multiple linear regression. So next session is based upon a multiple linear regression, and then so on we can also discuss about the polynomial regression. In this session we have to discuss about multiple linear regression. So with the multiple linear regression, we can learn many more terms like one hot encoding, dummy variable trap. With the last, we can also see one more type of the regression, that is called as a polynomial regression. So let's start with the multiple linear regression. So what is the multiple linear regression? Multiple linear regression, it's also known as MLR, and it's also known as multiple regression. It is a statistical technique that uses several explanatory variables to predict the outcome of a response variable. Multiple regression is an extension of linear regression that uses just one explanatory variable. It is a statistical technique used to predict the outcome of a response variable through several explanatory variables and model the relationship between them. It represents the line fitment between multiple inputs and one output, typically W1 into X1 plus W2 into X2 plus B. So here we are able to use multiple inputs. When we are talking about the simple linear regression, at the same time, we are just only taken W1 into X1 plus B, like Y is equals to MX plus B. But here we are able to use multiple inputs. And the graph shows dependent variable Y plotted against two independent variable x1 and x2, and it is shown in 3D dimensional. More independent variable involved will increase the dimensional further as well as. So let's see one hot encoding the multiple linear regression. Like when we are needed for one hot encoding, and first of all we have to find out what is the meaning of one hot encoding. A one hot encoding allows the representation of categorical data to be more expressive. Many machine learning algorithms cannot work with the categorical data directly, so the categories must be converted into numbers, and this is required for both input and output variables that are categorical. When some input are categories rather than numbers, we need to represent the category value as a numbers so they can be used in our regression equation. So here we have to find out on which, based upon which column we are able to apply one hot encoding. So from this table we are able to apply we have to apply one hot encoding based upon a state column, because in the state column we are having New York and California, two type of state is there. So after one hot encoding, the next step, that is dummy variable. So in a dummy variable, we are continue the process of one hot encoding. In statistics and econometrics, particularly in regression analysis, a dummy variable is one that takes only the value 0 or 1 to indicate the absence or presence of some categorical effect that may be expected to shift the outcome. So from this table, based upon a New York and California, we should create a dummy variable. So here, if you want to neglect one column from these two, that is also possible, because both column can should become each other inversely proportional. Because when New York are having one, also California are having zero, and whenever New York are having zero, California are having one. So that's why we are getting an idea both the things are inversely proportional to each other, because in a state column we are having just only two things like New York and California. Within continue this topic, we have to also evaluate the things like whenever it should become inversely proportional. At the same time, you can also consider the dummy variable as a switch variable. So on and off is there. Whenever the New York will on, at the same time California should off, and whenever New York should off, so California will on. Now let's talk about the one important thing related to the dummy variable, that is the dummy variable trap. So what is the meaning behind the dummy variable trap? The dummy variable trap is a scenario where there are attributes which are highly correlated or multicollinear, and one variable predicts the value of others. When we use one hot encoding for handling the categorical data, then one dummy variable can be predicted with the help of other dummy variable. So from the equation of d2 is equals to 1 minus d1, we can prove inversely proportional thing. And to avoid the dummy variable trap, always omit one dummy variable. So you can always go with the just only one dummy variable. You are not able to going with multiple dummy variables. So dummy variable is just only applied whenever your column are having like state and just only New York and California. This type of two states are available. Otherwise, you are not apply the dummy variable. So there is no necessary to rise like a dummy variable type. So otherwise, in this multiple linear regression, gradient descent working similarly like a simple linear regression. So that's how over here, the multiple linear regression should be completed over here. And let's talk about the polynomial regression. So polynomial regression, what is the polynomial regression? But polynomial regression, everything is depends upon a degree. In statistics, polynomial regression is a form of regression analysis in which the relationship between the independent variable x and the dependent variable y is modeled as an nth degree polynomial in x. So all through this model allows for a nonlinear relationship between y and x. So polynomial regression is still considered linear regression since it is linear in the regression coefficient. So in a linear polynomial regression, everything is based upon a degree. So during the coding or programming, whenever you are applying different types of degrees, so at the same time, the shape of the curve should be different. Whenever degree should be 0, the shape was horizontal, and whenever we have taken degree is equals to 1, at the same time, shape should be linearly increased. So that's why according to our data, we have to provide some different cubic function, quadratic function, and quintic function. So we are getting some more idea about the polynomial regression. Polynomial regression is applied when data is not formed in a straight line. See, whenever the data is coming look like a linear relationship, so no need to apply polynomial regression. But when data should be different or data should be in like non-linear type of things are available, so then we are going with the polynomial curve or the polynomial regression. So it is used to be fit a linear model to a non-linear data by creating new features from powers of non-linear features. So that's why we are going with some quadratic features in terms of squares, cube roots, and 4 power, 5th power, or 6th power. So again, in polynomial regression, gradient descent should be worked similar to the simple linear regression. But whenever we are trying to apply polynomial regression, so at the same time, most of time, no need to apply any type of the gradient descent or LMS algorithm, because whenever we apply the polynomial regression, almost time we according to the power we are getting some proper accuracy. So no need to apply more LMS algorithm or the gradient descent type of thing. So this session should be ended over here, and from next session we can starting something with the classification algorithm. In this practical session, we have to do some practical coding based upon a multiple linear regression. In previous one, we had already seen about a simple linear regression, but now we have to see about the multiple linear regression. So first step, that is the import the libraries. So first of all, we have to import the library, and that is the import NumPy as NP. Second library, that is a Pandas library, import Pandas as PD. After that, we are also using a Matplotlib library. That's why we have to import the code. Import Matplotlib dot pyplot as PLT, and also we have to use this backend line, that is the Matplotlib inline. So after importing all the libraries, now we have to import the data sets. So particularly for this multiple linear regression, I want to work with the 50 startup data CSV. So basically data set is already still provided in this my particular location, and in multiple linear regression folder, data set is already provided particular with the location. Now that's why it is easiest task to import the data set with the particular location. Now I have to create the data set over here, and again I want to use the CSV data set. That's why we have to use pd dot read slash CSV, and with that we have to import the things related to the 50 startups. So the dataset name is the startups dot CSV. So after providing the name, now it's time to import the dataset over here. So dataset is already imported over here, and now let's check it out. The dataset is imported completely or not. Basically here we have to work with the multiple linear regression. That's why we are using multiple independent variable and just only one dependent variable. So let's find out what are the independent variables. So here we have to take an R&D spend, administration, marketing spend, and state we are using as an independent variable, and as compared to that, profit should be play as a role of the dependent variable. So that's why it will stand on the 0 1 2 0 1 2 3 and 4. So fourth position is represented with the y. So let's create x and y first of all, and after that we should create a training set and testing set. But here that is a multiple linear regression. That's why we can also see about how to apply the one hot encoder and the dummy variable. And also for avoid to trap of dummy variable trap, we can also see about that particular code. But before that, we have to first of all find out how to create as x. So for that, we have to take dataset dot I location, and with that particular I location, we have to use semicolon, and then also we have to use semicolon of -1. So that's why aspect to the profit column, all the other column are look like a independent variables. So after applying x, now it's time to apply the y over here. So particular in a y, we have to take on a data set. Here the data set, again we are using the I location, and particular with the I location, we have to provide the select the all the rows, and with that we have to just only select the last column, and at then we have to provide the values over here. So after applying this code, now we have to run this code. So now x and y is already find out over here. In the next step, what we have to do, in the next step we have to apply the encoding to our categorical data. If you can see in the third column, that is based upon a state, and particularly in this state I have New York, California, and Florida. So these three states are there. So based upon that, we have to create a one hot encoding concept over here. So for that I can provide one comment, and that is the encoding categorical data. So after applying that, first of all, to apply the encoding, we have to import the one library based upon the encoder, that is the label encoder and one hat encoder. But in this library, we are getting from the scikit-learn. So scikit-learn dot pre-processing, scikit-learn dot pre-processing, and from that we have to import a label encoder, and the second thing we have to import, that is the one hot encoder. So one hot encoder. And now we have to again run this code. So here we are getting one error, cannot import a name one hot encoder. It's a oner, not a oner. It's a just only one hot encoder. Now it's running the library over here. Now let's start it with the coding part of the particular thing. So here first of all, for that we have to create a variable related to the label encoder is equals to, we have to take on this one label encoder of bracket over here. And then in the next step we have to take an x, because we have to select this particularly state column. So that's why according to the indexing and slicing concept, we have to select all the number of rows and just only the column of state, and with equal to we have to take an label encoder. And after applying label encoder, in the next thing we have to transform these things with the particular of the input. So that's why we have to use feet slash underscore transform. So after applying feet underscore transform, we have to take an x, and particular with the x we have to take a number of all the number of rows, and particular for the column of 3 we have to take. So now we already provided our input to over here, and after in this step, next step we have to find out, or we have to create a variable for the one hot encoder. So let's create a variable for the one hot encoder. So one hot encoder is equals to, again we have to use our source name one hot encoder over here, and after applying a one hot encoder, just a second, I have to take on some capital and small, and you have to follow the capital and small according to the libraries. And under that one, you have to apply the categorical feature to particularly one hot encoder. So we have to apply the categorical features. Categorical features is applied, and that is applied based upon the input number 3 or the position number 3. And after at the end, in the last thing, we have to apply this encoding to our input. So that's how we have to apply the same thing over here, and based upon that we have to fit it the things, and at the end we have to transform the thing as well as. Also we have to apply it of x. We have to apply the same thing over here. So we have to apply the x over here, as well as to particular with the array we have to join the same thing. So for that we have to use to array. And now it's time to run this code, but here we are getting an error. I think the error is based upon some type of spelling mistake. We are getting an error in second line, the label encoder. Okay, the second line we have to take a label encoder dot fit, and we have to take an fit transform, but I think we have to take over here the space. Let's check it out. Still we are getting an error, so we have to check it out what type of error we are getting over here based upon the what things, because there is spelling mistake. If you can make it the one spelling mistake, that will at the end it will gives you the error. So it's a spelling mistake like label encoder. We have to use this same one. For that I have to copy that one, and I'm trying to paste it over here because somewhere that cannot just only work like similar to that way. Let's check it out what are the errors. We can change, we can apply some more changes over here. Okay, so here the error is based upon the transform spelling trans, and the mistake is based upon that again. The name one hand and one hot encoder is not defined. We have taken, yes, one hot encoder is equals to, again there is a r is there, so sometime yes. So now the code will run over here. The library is already running over here, and also the code was correct over here. Now we have to take step to avoid the dummy trap. Now we have to take on a step, avoid dummy trap, because if we are just only having the one where just two categoricals, so at the same time it should also work look like a switch function. We already seen all this concept in particular theory of the multiple linear regression. And now to avoid the dummy variable, we have to provide the function over here that is look like this one. and now we have to run this code. So after doing all these things, the next step that is based upon a training set and the testing set. So for that, we have to import the sklearn.model selection. So let's import the sklearn model selection, and based upon that, we have to import train, test, and split. We have to import train, test, and the split. So after doing that one, now it's time to create X train, Y train, X test, and Y train. So first of all, we have to create X train. Next, we have to create the X test. Then we have to create the Y train, and then we have to create the Y test. So after creating all four parameter, now again we have to use train, test, and the split. So after getting this all one, now we have to take on X values, Y values. After X and Y, now it's time to decide what are the test sizes. So here I want to take it, test size is equals to 0.28, means 80% of training data and 20% of the testing data I want to use over here. And at the end, we have to take a random state is equals to 0. Basically, random state should apply to getting what, how to split the data into training and testing. If we can take in some type of random state at the same time, some at the some instance, they are selecting the X train, X test, Y train, and Y test. So that's how random state should be work over here. And now it's time to create a multiple linear regression. So for that, we have to import the library from sklearn model, sklearn linear model. Here we have to use the linear model. Here we are not using any type of the particular model selection, but here we have to use linear model, linear slash model. And also here we have to provide one dot, sklearn dot linear model, and from linear model we have to import a linear regression. So similar things we have to import over here, but we can use the last linear regression practical. So after importing linear regression, next thing we have to create a model, and model is equals to linear, then regression of the bracket. Don't forget this bracket. And at the end, we have to fit the model with the X train and the Y train. So that's why we have to use X train over here, and then we have to use Y train over here. So after applying X train and Y train, we are getting the output, but still here we are getting an error. I think there is again spelling mistake is there. SK learn dot linear model. So here I just take the capital L, but here there is a small L is there, and the model is already prepared over here. So similarly, look like a simple linear regression. That is your home task, or that is your homework. You have to create the training and testing visualization based upon this model. Now, in a lastly, I just only make it just one thing, and that is I have to create the parameter based upon the Y prediction, and Y prediction is equals to the regressor, or you can also take it a model dot predict of X test. So based upon X test, you are able to make it a Y prediction. So in the Y prediction, you are getting the final answer. You can also parallelly create over here the X test. So you are getting an idea what are the inputs. So input are the different type of inputs are there. But still, if you are having an question, why input are getting 1.00 and 0.00, this type of input you are getting due to the label encoder and the one hot encoder. Whenever you are using the label encoder or the one hot encoder, and it is also look like a data pre-processing things. So that's why your input should be transforming within some standardization and normalization type of things. We already learned about the data pre-processing topic related to the standardization and normalization. So one hot encoder or the label encoder should work similarly, particular with the multiple linear regression. So next topic, that is the polynomial linear regression. In this practical session, we have to learn about polynomial regression. So already library was imported over here, and dataset is still code was ready to over here. Again, we have to use pandas.read.csv because we have to work with the CSV file and the dataset name, that is the position salaries. So now we have to run this code as well. Let's check it out how data is looks. So for that, we have to find out the data set dot head. So based upon data set dot head, we are getting an idea how the data set should look. So data set dot head. So here basically in this data set we have three columns: position, level, and salary. Basically, you can also apply in the particular polynomial regression as a, you can also consider as a multiple linear regression. So you should take position and level as an independent parameter and the salary as a dependent parameter based upon the dependent parameter. So now it's time to find out what are the x and what are the y. So here we have to first of all take x is equals to dataset dot I location. It means integer location, and based upon that integer location we have to provide first of all here I have to use all the rows. So that's why I have to use semicolon, and after applying semicolon we have to select some of the particular column. So for here I want to use as an input, I want to take it one semicolon two. It means 0 1, so starting from 1 and it will end it before 1. So just only label column I want to use it as an input currently. So 1 semicolon 2, and based upon that I want to take it a values over here. Now it's time to select the y, and in particularly y I want to use it y as a salary. So here I'm not using the position column for the this parameter, so that's why the x is equals to label and y is equals to salary. So again we have to provide the data set dot I location, and particular with that I location we have to provide the semicolon, and with the semicolon we have to use the second parameter as a column. So second column, that is the salaries, and after that we have to take it values for that. And now it's time to run this code. Let's check it out. What are the x? So x are 1 2 3 4 5 6 4 5 6 7 8 9 10. That is depends upon the level, and y is depends upon the salary. So we are also getting the results based upon that salary. Particular in this problem, we are not applying any type of the encoder or the one hot encoder, because we are using single variable as the input or the single variable as output. Now it's time to apply the training set and testing set. So let's see, you already know how to apply the training and testing set. For that, first of all, we have to import scikit-learn dot model selection, and based upon this model selection, we have to import the library that is based upon train, test, and split. So we have to import train, test, and split. After applying that one, so here we are did spelling mistake sklearn, and then we have to find out xtrain first of all. Second thing we have to take on, that is the x test. Third thing, here again we have to even two times test. Now next we have to take on y train, and last we have to take on y test over here. So y test is the last thing, and here now we are taken train, test, and the split, and based upon train and split we have to select x, y, and we have to find out the what are the test size. So here I want to take it test size is equals to 0.2. It means 80% of training data I want to select over here. So that's why here we have to take random state over here is equals to 0. So now it's time to run this code, and this code is running properly. But still, if you want to apply any type of the feature scaling, so we can able to apply feature scaling over here based upon the level like 1 to 10, because according to the salary we have to assign the things. That's why. So let's see. First time we are seeing about how to apply the feature scaling topic. So that's how we are applying a feature scaling. Basically, in a feature scaling, we have to use standard scaler. So for that particularly, we have to import the library from the sklearn preprocessing. So first of all, from sklearn preprocessing, we have to import a standard scaler. So for that, we have to use capital S, then standard, and then we have to take a scaler. So standard scaler. So according to the standard scaler, we have to take an sc underscore x is equals to standard scaler. But you have to mention one thing: the s was capital in particularly standard scaler variable. So here in this particularly standard scaler, we have to take on one bracket, and also you have to good familiar with the spelling of standard scaler, because ler is there. Okay, so after applying that, we have to provide the standardization to the x train and x test. So that's why we have to fit the data with the x train first of all. So x train is equals to sc underscore x dot fit and transform with the old x train, because here we are trying to create a new x train. That's why. Similarly, we have to apply the same thing with the x test is equals to sc underscore x, and dot we have to fit. Here we have to take fir, we have to take fit, and then we have to take transform, and also here we have to take an x test. And now we have to run this code. So code is properly run over here, and in the next stage we have to making a model. So first of all, we are trying to make a model based upon a linear regression, and once linear regression should applied, then we should convert linear regression into the polynomial regression. Let's make a code for the linear regression. So for you making a linear regression, first of all, we have to create the linear regression. That's why we have to import the model for the linear regression. So from sklearn dot linear model, sklearn dot linear model, we have to import a linear regression and import a linear regression. So linear regression is coming over here. After applying that one, we have to create a model. So that's why now I'm providing the model name, that is the linear regression, and also we have to equate the model over here, linear regression. And after making that one, next thing that is based upon a linear regression with the fitting the model of x train and y train. So linear regression dot fit of x train and y train. So that's how we can do over here. After making this one, now we have to run whole the code, and linear regression is already prepared over here. Now in the next step, we have to fitting a polynomial regression to the data set. So that's why we are trying to convert linear regression into the polynomial regression with the help of the polynomial feature or the degree of the polynomial. So let's do the same thing over here. So again, to importing the polynomial regression or the polynomial features, we have to use sklearn preprocessing library. So from sklearn preprocessing, sklearn dot preprocessing, we have to use sklearn dot preprocessing. We have to import over here the polynomial features. So polynomial, so we have to take features. After applying polynomial features, we have to create one or more parameter, that is the polynomial regression are there. And the polynomial regression are there. So here based upon that one, we are using a polynomial feature with the degree of 4. So we have to write down the polynomial features with the degree is equals to 4. So after applying degree is equal to 4, now here we have to provide the x of poly is equals to poly. Poly is the function for that. So you have to remember the what are the poly things you can use till now, like poly and with the regression. And now you are trying to polynomial regression is fitted with the transforming of the x train. So till now we are already pre-created the x poly, and in the next step we have to fitted the polynomial regression is fitted with the x poly and the y train. So here basically we have to replace x train with the x polynomial. So that's why here we have to provide what are the inputs with the degree of 4. So that depends upon you. You can also provide the degree of 4, 5 or 3. That is depends upon the problem statement. So according to our problem, the degree number 4 or degree is equals to 4. That is the appropriate things over here. So now we have to taken like poly and then regression dot fit of x poly, and second thing that is the y train. So based upon x poly and y train, we have to make this task. And now we have to make it linear regression of 2. Linear regression of 2 is equals to, here we have to use this linear regression. So that's how we are getting idea over here. And at the end, we are making a new parameter or new variable that is based upon a linear regression 2. So what we already created, like linear regression 2 dot fit. So here basically I can use the polynomial features with the linear regression. So that's how we are getting output related to the polynomial regression. So that is the best way to get the polynomial regression in the output. So now it's time to run, and good thing that is that we are not getting any type of the error, and we are getting the perfect output over here. So after applying this one, now it's time to make it the visualization of data based upon the polynomial function. So we are getting an idea what type of things we have to do over here. So let's do first of all visualizing the linear regression results, and after that we can see the visualization of the polynomial regression of the things. So let's start it with the first of all linear regression things. So for linear regression, we can starting with the plot dot scatter because we are using the scatter plot over here for the input, and we have taken x train over here. So here I have to take an underscore over here, and we have to take an x train. Then we have to take an y train. And after applying x train and y train, we have to take a color. Color is equals to here. I want to take it a red color in terms of the samples. After applying that, now we have to take plot dot plot, like plot for the function of the matplotlib, and now we have to fit it the things related to the linear regression over here. So first of all, here I have to take x train. Second parameter, that is the linear regression dot predict. Linear regression dot predict of x train. And after applying this one, we have to use one color, and color is equals to here the blue. So blue color we are using in terms of the hypothesis line. After doing this one, now next thing, that is the provide the title, also the provide the x label and y label. So I'm not providing that things, that is your homework. Whenever you should do the same thing, you can create the title. So here I just mentioned the comment over here. So create a title, x label and y label. Now just directly I can apply the plot dot show, because we are getting the visualization is the important thing out there as compared to the title, x label and y label. So here we are getting the output is look like this one. So here we are getting an idea how the thing should work over here when we should apply the linear regression on this particular data. If we can apply the polynomial regression on this data, so what type of output we are getting over here? Let's check it out the same thing over here. So for that, I have to again use these things over here to getting this one. For this one, we have to use this one over here. After applying this, I again want to use this one, but at the same time, we have to provide some of the changes over here. So based upon that changes, we are getting an idea how the polynomial regression should provide any type of the effect to over here. So first of all, here we have to take an x train, and also we have to take an here linear regression dot predict. But as compared to linear regression or dot predict, we have to use linear regression of the two. So we have to use linear regression underscore two. Again, I have to check the name of what are the name we had created over here. Yes, to predict with the particularly x train. Let's see, we are getting an error. Yes, we are getting an error. I think we have, yes, the samples are getting correct, but I think hypotheses are getting some stuff. Okay, no problem. We can change it, the particular one. Yes, we have to change this one as well as, like after providing this one, we have to rechange like this one. After providing the linear regression to predict, we have to also provide the polynomial regression line. Okay, so that's why we have to take an polynomial regression dot fit, and with that fit we have to also use the transform function to get these things. So we have to provide transform of x, and also we have to provide the double bracket to complete this one. Let's see, still we are getting an error. I think we are getting an error based upon the input. I think yes, the dimension are not matched. Okay, so dimension are not matched. I think we have to take an over here as well as x dimension. Yes, now it looks perfect. So now it looks perfect. Okay, so that's how the things are over here. So if we can take on this type of samples, and with that samples, if we can provide the polynomial regression, so the we are getting the perfect line in particular in terms of the prediction. Here we are working with the training set, sorry, the testing set. That's why we are getting the less samples. Okay, but if you can do some more practice based upon this type of data sets, or you can change some parameters, such things, so you can get some proper output with the polynomial regression. Next, we have to see about the decision tree as a regressor. In this practical session, we have to learn about the logistic regression. Already theory of the logistic regression that should be over, and now we are going to learn about the practical aspects of the logistic regression. So in the starting, we have to follow the first step to import the libraries over here. So you already know what are the important library we are used in particularly regression topic. Same library we have to use it over here in terms of NumPy, Pandas, and Matplotlib. So first of all, we have to import NumPy already imported over here, and second library that is the Pandas as PD, and third library that is based upon a Matplotlib. So we have to import matplotlib dot pyplot as plt, and we can also take in some backend line like matplotlib inline. So after providing all the libraries over here, in the next step, we have to provide the data set. So you already know we have to create one folder, and in that particular folder, we have to provide the data set as well as this logistic regression file we can also create in that particular folder. So basically, for this practical, I want to use it a data set that is the social network advertisement data set. So based upon social network advertisement data set, I want to predict or I want to classify the things look like, okay, like the person will purchase the product based upon the advertisement or not. So we have to solve the binary classification. So let's pd dot read CSV because data set is available in the form of the CSV. So here we have to provide the social, then network advertisement. So the short form that is ADS, and then we have to use the CSV extension over here. And we can also see in dataset dot head. So top 5 samples of dataset we are getting over here: user ID, gender, age, estimated salary, and the purchase one. So after applying this one, the next task we have to do some data analysis as well as we are also able to create X variable and Y variable. So basically, you can take it a gender, age, and estimated salary in terms of the X variable, and for Y variable, we have to use the purchased. So particularly when you can work with logistic regression, so it does not look like that we are not able to take more than one parameter in terms of X. So we are able to take more than one parameter or two parameter particular for the X. So let's take it X is equals to age and estimated salary, and particular for the Y we have to use a purchase column. So for that we have to take an X is equals to dataset dot iLocation, and particular that one we have to provide the semicolon to access all the rows, and to access the column we have to take it 2 and 3. After we have to apply the values over here. Once we can done this one, then we have to take it y is equals to dataset dot iLocation. Also we have to use this bracket, and also we have to access all the number of rows, and with that we have to just only access the particular fourth column that is depends upon the purchase. On zero position we are having the user ID, 1 gender, 2 age, 3 estimated salary, and on the fourth position we are having the purchase column. So after applying these things, we can also find out is there any missing values are available in this data set or not. So for that, we are using isNull function. We already aware about the isNull function, particular when we should work with the Pandas library. So with the isNull, we are getting an idea, is there any missing values or not. So everywhere I'm getting the false, it means no missing values are there. If you want to get some data set information, you can also follow the same thing as well as like dataset dot info. So throughout that you are getting an idea how many missing values are there. So always, if you can see over here, in every particular column we are having 400 non-null count. So it is the meaning is that we are not having any type of the single missing values. So after applying importing libraries and the data set after making x and y, now it's time to create a training set and testing set. Again, here we are using the same technique to create a training and testing set similarly to the regression approach. So for that, first of all, we have to import the scikit-learn model selection, and based upon that model selection, we have to import the train, test, and split. So here we have to import train, test, and the last thing that is the split over here. After applying this one, we have to create the x train, x test, y train, and y test. So first of all, we have to write down for the x train, then we have to write down for the x test, then y train and y test. So here I have to take a underscore over here, and after applying all the parameter x train, y test, and x test. So now we have to take on over here the train, test, and split. Here we have to take in this underscore. Yes. Now we have to select the x and y. So here x is already selected, y is already selected, and also we have to provide the test size over here. It means what are the data set or how many sets you want to take it as a testing size. So now here I want to take a test size is equals to 0.25. So automatically it means training is equals to 75% of data and testing should be depends upon the 25% of the data. After applying these things, we have to provide the random state over here. So particularly in the random state, we have to take a 0 over here. Now it's time to run this code and we are getting still the code was running. We have to check if the code everything is perfect or not. Yes, everything is perfect and code is properly running over here. So in the next things, we have to see about the feature scaling. Now in the next step, we have to see about the feature scaling. When you are trying to solve the problem based upon the classification approach with the logistic regression or whatever the classification techniques, at the same time, you have to first of all provide the feature scaling. Feature scaling is always needed when you are trying to solve the problem based upon the classification. But if you can solve the classification problem based upon a decision tree, so at the same time, feature scaling is not required. Otherwise, in other technique like logistic regression, KNN, as well as support vector machine and random forest, many other techniques are always needed the feature scaling. So let's see how to apply a feature scaling in a classification problem. And also we are getting feature scaling idea already in the module number 3 based upon a machine learning part. At the same time, we can learn about the data pre-processing things. So let's see, first of all, import a library based upon the feature scaling. So from sklearn dot pre-processing. So based on sklearn pre-processing, over here we have to import standard scalar. So that's why we have to take standard and then we have to take a scalar. So scalar you have to mention like scalar spelling is the LAR. So after that we have to create over here the shortcut of standard scalar SC. By mistake here we can provide the base. Okay, yes. So SC is equals to, again we have to take standard and again we have to take scalar, standard scalar. Also don't be forgot this blank bracket, otherwise you will get an error. Now we have to apply these standard scaling things on terms of training set. So that's why from the training set we are having two parameter xtrain and xtest. So let's apply the same thing over here. So xtrain is equals to sc dot fit underscore transform with the xtrain. After applying this one, now we have to apply with the xtest is equals to sc dot fit underscore transform of xtest. So we already applied the xtrain and xtest, but here we have to take the underscore. Yes, now it's complete. So already the standard scalar is applied over here, and in the next step we have to create a logistic regression model, similarly look like the linear regression. So first of all, we have to import a library from the sklearn model. So from sklearn dot linear model, again we are using over here the linear model, and from this linear model we have to import the logistic regression. So we have to import over here the logistic regression. So after applying this one, now we have to try to create a model, and model is equals to, here we have to taken the logistic regression of. Also, if you don't want to make it random state is equals to 0, so you can also make it a blank as well, as that depends upon you. If you don't want to write anything in between this bracket, basically this type of bracket is used whenever you want to make it some specialized model in terms of some type of the overfitting or some type of the multi-class things, and if you want to provide some type of the value of the class weight, and that's why we are using this type of stuff over here. And after that, now we have to make it model fit with the x train and the y train. So here we have to take an over here the x train, and second parameter is the y train. So the model over here, the model is already prepared over here. In the next things, what we have to do, we have to predict the test results. So we already know once model was prepared over here, then we are trying to make it a y prediction based upon a x test. So for simple code over here, are there y prediction is equals to model dot predict, because we have to prediction, we have to make it some prediction based upon our model. So model dot predict of the x test. X test is already created over here, and based upon that we have to create the y prediction. But when we learn about the theory, learning the theory, at the same time, we had seen one thing that is based upon a confusion matrix. So let's see how we can make it a confusion matrix over here. So for making a confusion matrix, first of all, what we have to do, we have to import one small parameter or one small module based upon a scikit-learn matrices. So we have to use again scikit-learn library over here from sklearn sklearn dot matrices import the confusion matrix. Import the confusion matrix over here, and then we have to take an cm is equals to, we already imported over here the confusion matrix, so that's why we have to take a confusion matrix is always created based upon a y test and y prediction, because here we have to find out the true positive, true negative, false positive and false negative, and all the terminologies are coming from the predicted output and the actual output. So that's why we are getting y test as the actual output and y prediction is the prediction output. So that's why these two parameters are very necessary to find out the confusion matrix over here. So here we are getting an idea what are the true positive and what are the true negative and what are the false positive and what are the false negative. So 63 will play as a role of the true positive. So that's how false positive and false negative are there, and also the 25 is the false negative is there. So that's how thing are working over here. Basically the true positive are having the highest number, because if the model is tried to predict the actual output is equals to the predicted output. That's why we are getting 63 is equals to true positive. So also here one main thing we have to say about that is the visualizing the training set result, and also we have to visualize the testing set result. But here for visualizing the testing and training set result, the code is very lengthy. But before that, you have to look at about the how to create a model of the logistic regression. In next session, we have to discuss about how to create a training set result based upon the data visualizations. Let's see how to create a visualization to training set results. To making any type of the visualization, first of all, we have to import the library that is based upon a Matplotlib. But here we already imported a Matplotlib library. But particular when you are trying to visualize the things at the same time, just Matplotlib is not enough. Particular from the Matplotlib library, there is many more parameter are there. Look like or like a listed color map. So when you want to work with the different type of the color, and also you have to work with particular one type of the grid at the same time, you have to use this listed color map. So from the matplotlib library, so here we have to use matplotlib dot colors library are there, and from this matplotlib dot colors library, I want to import over here that is the listed color map. So that's why we have to import over here the library, and that is the listed color map. Once library was imported, now what is the next step to make it over here? The training set visualization or the testing set visualization is not a simple look like the linear regression. Here we have to create some complicated code as well as, so that's why it's a little bit different as compared to the linear regression training visualizations. So here what we have to first of all make it, first of all here we have to create the x set and y set, that is based depends upon the x train and y train. Once we can make it that one part, then also we have to create the things like what are the range for the x-axis and what are the ranges for the y-axis. Also, for example, if I have some points based upon x-axis, like starting point is 1 and ending point that is the 9, so that's why we have to take an the starting point is 0 and the ending point is 10, because the minimum point minus 1 logic we have to use, and also at the last point we have to use maximum point plus 1, that type of logic we have to use. Also in between that, we are also trying to provide any type of the step size as well as. After applying these all things, after that we are trying to fit it our parameter into the particular grid, and at the same time we are trying to also make it the linear regression line in between that, and then we can make it a title, x label, y label, and also here we are trying to classify the two classes like class 0 and class 1. And when we are having these two different type of parameters are there, or these two different type of classes are there, so we have to represent both the classes with different color. Also we have to provide the one type of the legend, so legend will show the which color represent the which classic. So this type of things we have to do, and that's why the visualization coding is not easier as easy as to linear regression. Particularly if you are trying to solve the linear regression problem with the visualization, so that looks easy. But if you can do the same thing with the logistic regression, so it's not look easy. So let's see how we can start. So first of all, we have to create the first parameter, that is the x set 1, and the second thing was the x set 2, but you can also take it x set and the y set over here. So x set and y set is equals to, here we have to take an x train and y train. We have to take underscore x train and the y train over here. So after applying x train and y train, the next thing we have to take it a mesh grid, and mesh grid is depends upon the x1 and x2. Once you can provide the x1 and x2, then we have to use NumPy function to provide the mesh grid over here. So particularly we should take an np.meshGrid. Also, particularly in that bracket, we should take an np.arrange, because also we have to take in some numbers from according to the our input of x set and y set. So that's why we have to use the arrange function. Particularly in the arrange function, we have to provide the start function. So that's why we have to take in start is equals to x set. X set is nothing but a x train. So x train, particularly from the extent I want to select all the number of rows, and with particular rows I want to select the zero position of column. After applying zero position of column, we have to take in the minimum number but from that particular column, and once we get the minimum number of that column, also we have to provide the -1 over here. So after applying -1, we are getting the first of all x-axis starting point according to the legend or according to the particular the x-axis values. Once we can apply the starting point, now in the next we have to apply it over here the stopping point. So stop is equals to, again we have to use same logic like x set. Again we have to use all the number of rows, and with particular all the number of rows we have to take on a zero column, it means zero position of column. And now from that column we have to find out the maximum number, and after getting the maximum number we have to take on a +1. So after applying +1, we have to take a maximum number +1 value to stop at the end. So at the same time we are getting some proper graph. Okay, once we are getting the visualization output, then we can also compare the things like what are the importance of these things over here. So after applying this one, next and last thing, that is the step size. So here I want to take the step size is equals to 0.01. So that is again depends upon you, if you want to take it any further things or any different things, you are able to take. Now the comma, because still we are just only provide the one parameter. Now it's time to create the second parameter, in particular that bracket. We can take it some proper arrangement over here like this one, so it looks better for analyze the things. Again we have to take on over here the np dot arrange, and particular in that arrange function again we have to take a start function. So now we have taken start is equals to, in previous one we have to take an x set, again here we have to take an x set over here. So that's why again here I want to take it a x set, so the code is again similarly to look like previous one. Now I want to select the number of rows over here, but in previous one we have to take on a zero position of column, but now I want to take it a one position of column. Why we have to take on one column? Because our classification is predict upon two input variable x1 and x2. X1 will stand on the position of 0 and x2 will stand on the position number 1. That's why. Now after completion of this one, we have to again provide the same coding over here like minimum in bracket, we have to take on a -1, and then we have to provide the stop as well as. So first of all we have to provide the stop, and then we have to take an x set. Again in a square bracket we have to take a number of rows. After applying number of rows, we have to take on a zero position, sorry, here we have to take on a 1 over here, because we are doing everything for the particular first column. And then we have to take on a max of 1 plus 1 we have to take on over here. After applying +1, we have to take on a step is equals to 0.01. So again, same step size we have to use over here. And also we have to close over here the bracket. So also we have to check it out all the brackets are closed or not, because here we are using many type of the brackets. That's why we have to careful with that all the brackets. That's why you have to careful with if anyone extra brackets are there, so that will harmful to your code. So now I think everything is looks better, but here there is no required for this bracket, because there is extra bracket out there. Because here we are providing the first bracket that will end for this bracket, and also here the start bracket, it will end over here, and also this bracket is ended over here. Also we have to check here, so we are applying one more bracket over here, that is not necessary bracket. Now it's perfect. and all the things are looks correctly over here. If you want to run this code, you can run, but there is no any guarantee we are getting an output or not. So we are not getting any output because still we have to add many more things. So that's why what we have to do in a next line. In a next line, we have to trying out what are the model we can create it over here, and we have to fit it that model in with the particular this grids. So that's why we have to use plot function, that is a shortcut of Matplotlib, and here we have to use the contour. So contour is a one type of the graph is over here, and we have to take in contour f. So we have to taken some correct spelling of contour, contourf. So down that is the correct, yes. And then particularly we have to take an x1, and second thing that is the x1 and x2 is already created over here. And after applying that, we have to take a model dot predict. And after applying model dot predict, again we are trying to create one array based upon a NumPy. So that's why we have to take an np dot array. Again, we have to take in some brackets to apply the ravel of x1 and ravel of x2 to applying any type of the reshape over here. So that's why again we have to take in the square bracket, and particularly with this square bracket, we have to use the ravel function, x1 of ravel, and second thing that is based upon a x2 of ravel. So you have to careful whenever you are trying to do this type of the problem, because there is many type of brackets are there, and also there is many type of stuff is also there over here. So and then also we have to provide one more bracket over here, and out of the square bracket as well as this bracket, because we have taken many type of bracket over here. So please don't be confused during this one. And also we have to provide over here the transpose as well as. So after applying a transpose, again we are trying to use a reshape function to arrange the things particular with the input of x1 shape. So that's why here again we have to take in one bracket, and with that bracket we have to provide x1 dot shape. After applying this shape, next things we have to provide the size of the particular circle or the scatter plot, because here first of all we have to import it all the samples from the training set and training set. We have to import it over here. So we have to select the size of the particular sample, like in terms of the dot points, or the when we are taking some large size at the same time large circle we are getting, but if we are taking the small circle, so at the same time the sizes matter very well. So here we have to select the size, and the size that is the sizes depends upon the alpha. So alpha is equals to, I want to take it over here, the 0.75. So 0.75 that is the alpha, and we have to take on a C map. So C map is equals to, we have to take on over here the again according to the our listed color map. I want to select over here the C map or the color map, and now we have to decide the color for particular that one. So the color to provide over here that one, that is the red and green. So first color is the red, and second color that is the green. So after applying, if you can see the three brackets are over here. Now I'm trying to this code, and you are getting this one still now. So till now we are just only able to create this one. So we are getting an idea. One region will be shown as a red color, and the second region will be shown as a green color. And now if you can see, so we are taken this -1 and +1 for according to this one. Basically our all the samples are running in between -2 to +2, but still here we are taken 0 over here, and also here we are taken up to 3 over here. So that's how the +1 difference we are getting over here. Similarly also over here, the minimum value is around -3. So our sample is always considered in between -1.5 to +2.5. So that type of stuff we are getting over here. So still we have to make it some more change over here based upon that particular limit over here. So now we have to decide the plot of the x limit and y limit. So first of all, I'm trying to do with the x limit, and in x limit we have to take on a number of x1 dot minimum. So now we are to doing what are the things, that is everything is based upon our data set. So here I have to select the x1 dot minimum, and now we have to take an x1 dot maximum over here. And after applying this one, now we have to take a plot dot ylim of x2 minimum, because first parameter based upon that we already taken, and second parameter is look related to the x2, and now we have to take an x2 dot max. So now again I'm trying to run this code, and let's see what are the output we are getting over here. The sum of type of the number we are getting over here, like -2.58 and also 3.32. Let's add some more things based upon that. And now we have to add last thing, but very, very important thing according to the our data set or based upon also the model. So here I am trying to provide one for loop, and the loop is related to for I and j, particularly I and j in enumerate function I want to use. We already learned about the for loop and enumerate in Python lectures. So for enumerate, and now I want to find out some unique things from the NumPy library. So that's why I have to use np.unique of y set. So from the y set, it means from the y train, I want to find out some unique samples. So that's why I have to use y test. And also we have to provide the semicolon to follow the proper indentations. And based upon that, now internal to this one, I want to make it a scatter plot based upon the x train. That's why I have to use x set over here. After applying x set, also in a square bracket, I have to take it y set is equals to the j, and the particular we have to provide the some condition like j and the 0. And after that, also we have to provide the x train limitations like x set is equals to x set of we have to take an y set, and then we have to take an is equals to j and particular for the 1. So 0 and 1 it stand for the 0 position of column and the 1 position of column. So after applying this one, now we have to take another value of c over here. So the c is equals to, it depends upon the color, so listed color map we have to take on over here. So particularly here we have to take on a capital C, because spelling mistake are created very big issues during this type of stuff. So here we have to decide the things. One type of sample is related to the red color and second type of samples is related to the green color. So that's why again we are tracking over here. So here we are providing color two times. First of all, we have to provide the color for the outer side region, and second time we have to provide color for the inner side region. So after applying red and green color, in the last we have to just simply take off some type of this samples over here. And after applying the sample over here, we have to take a label is equals to j. So all the most important and main necessary thing is already completed till now, but still we are trying to run this code. Let's check it out, any type of the error we are getting over here or not. Here we have to take an double is equals to, yes. So that is the first output is there, but still here the some type of things we all still missed it. So let's complete first of all that one. But here you are getting an idea. So all the samples are coming in between -2 to +2.3. So that's why here we are taken last limit, that is a 3.3, and here the last limit is -3. Also from here you will get an idea, in this area there is no one plots and no one samples are there. That's why if I can make it +1 in compared to if I can make it +2 at the same time, the grid will look very large. So that is the advantage of to write down these whole things together. Still the code was not over, because still I want to provide over here the title, legends, and as well as the x label and y label. So let's provide the title of particularly that one. In testing set we are using the same code, but as a replacement of that we have to change some parameter. But before that, let's apply the plot.title, and internally title we have to provide logistic regression training set. So after applying that one, the next thing, that is the plot dot x label, particularly in the bracket we have to take on as the age in a x parameter, or and also in a y label we have to take on over here the estimated salary. So both the thing was completed over here, and last we have to use the plot dot legend. So legend is very important function over here. So with the help of the legend, we have to check if the spelling of legend, LEGE and ES, that is correct. And at the end we have to provide the plot dot show. So we are getting an output very good and very correctly. So if you're getting an idea, with the help of the legend things we are getting this one, there is a logistic, we are getting the logistic. Otherwise the remaining thing was correct. Yes, now it's correct. Logistic regression training set, in a y-axis we are getting the estimated salary, in a x-axis we are getting the age. So that's how things are working in particular for the training set. Now we are trying to make it the same thing for the testing set as well. As to applying the testing set, we are not writing any type of the new code, we are just copy and paste this code, but we have to change some parameter things, so we can change that parameter, because now you already know how to apply these things particular for the testing set. So in a testing set, we have to replace x train and y train with the x test and the y test. But the structure of code is looks very similarly to the training set as well as. So in a second things, we are taken 0 and 1, so that is no need to apply any type of changing over here. Just we have to apply that type of change that is depends upon the x train and y train. So automatically x set and y set is replaced to everywhere. And now we are trying to run this code, but still before that we have to check it out. Is there any other places are there where I can use the training set or the x train type of the function? So let's run the same thing, and now we are getting idea with the 25 percentage of the data. This sample is related to the 75 percentage of the data because that is the training set result, and these are the testing set results. So this that's why we are getting samples related to just only the 25 percentage. And based upon the lesion, we are getting over here the things like a red sample related to the class 0 and the green sample that is related to the class number 1. So that's how we are able to do the logistic regression with the particularly Matplotlib library for basically to do the data visualization. And with the scikit-learn, we are able to do the same thing for the making the model. In the next things, we have to see about the k nearest neighbor. K nearest neighbor is a very easiest method. First of all, we should learn about that theory, and then we can jump on the practical of the k nearest neighbor. Let's talk about the objective of logistic regression. Logistic regression work for both, but it is much popular for binary classification. So let's see what are the things related to the binary classification. Given the subject and the email text predicting email spam or not, sunny or rainy day prediction using the weather information, and based on the bank customer history predicting whether to give the loan or not. So they are also working based upon some independent feature like inputs. So based upon inputs, the bank will get an idea like they can issue the loan or not. But then we have to concern upon a logistic regression. So logistic regression are much popular for the binary classification due to the sigmoid probability or the sigmoid function. So that's why logistic regression is not much popular for the multi-class classification. But now we have to see about like what are the cases are available with the multi-class classification. So with the multi-class classification, like given the dimensional information of the object, like identifying the shape of the object, identifying the different kind of vehicles, identifying the different kind of animals, as well as based on the color intensities, predicting the color type as well. So that type of stuff we are getting from the multi-class classification. But if you want to do multi-class classification, so at the same time, like decision tree, support vector machine, random forest, then many more techniques are available to do multi-class classification. But for binary classification, logistic regression can provide the good output as well as. So now let's check it out how to do model evaluation with the confusion matrix, because confusion matrix it's again and again it's a very important part over there in the classification algorithm. Whenever you are working with the classification algorithm, if you want to evaluate your model, so at the same time you have to develop or you have to create a confusion matrix. So what is a confusion matrix? A confusion matrix is a table that is often used to describe the performance of a classification model or a classifier on a set of test data for which the true values are known. So, the confusion matrix itself is relatively simple to understand, but the related to the terminology can be confusing. So based upon confusion matrix, in my mind, again question will rise, that is how to calculate confusion matrix. How we are able to calculate the confusion matrix. That is again and again important thing are there. So you need to take a test data set or a validation data set with expected outcome values and make a prediction for each row in your test data set. From the expected outcomes or the prediction count, the number of correct prediction for each classes should be generated over there. And after understand of the confusion matrix, let's check it out. What is the representation of other terms? So basically, in the confusion matrix should be based upon a TP, FP, FN, and TN. So what is the meaning behind all these things? So TP stand for the true positive, FP stand for the false positive, FN stand for the false negative, and TN stand for the true negative. So let's start it with the first thing, and that is the true positive. It means it should become look like correctly identified. So a true positive is an outcome where the model correctly predicts the positive class. Similarly, a true negative is an outcome where the model correctly predicts the negative class. A false positive is an outcome where the model incorrectly predicts the positive class. So true positive, it should stand for the sick people correctly identified as a sick, like class 1, it comes in a class 1. So expected and the predicted, expected and actual both are equal. After true positive, second thing, that is the FP, false positive, it is also understood by incorrectly identified. A false positive is usually called as a type 1 error, and a type 1 error is when you incorrectly reject the null hypothesis, and this creates a false positive for your research, leading you to believe that your hypothesis is true when in fact is not. So false positive, it should also take an example like healthy people incorrectly identify as sick. So class 0, it should represent as a class 1. So that's why its mistake should done over here. Next thing, that is the true negative, it is the correctly rejected thing is there. So here a true positive is an outcome where the model correctly predicts the positive class. Similarly, a true negative is an outcome where the model correctly predicts the negative class. A false positive is an outcome where the model incorrectly predicts the positive class. And true negative will take an example like healthy people correctly identified as healthy. Class 0 is identified as a class 0. So that type of thing we are getting from the true negative. After true negative, the last thing based upon a confusion matrix, that is the false negative. False negative understand as a incorrectly rejected. A false negative error or a false negative things is a test result which wrongly indicates that a condition does not hold. For example, when a pregnancy test indicates a woman is not pregnant but she is, or when a person guilty of crime is acquitted, these are false negative. So false negative can come with the example like sick people incorrectly identify as healthy. So class 0 by default identify as class 1. So that type of thing can generate during the confusion matrix in the model evaluation. But among these confusion matrix, still there is some of things are available to do evaluation, and that is the precision or recall trade-off. So what is meaning behind the precision and recall? Let's talk about that one. Like, what is recall? Recall is the number of relevant documents retrieved by a search divided by the total number of existing relevant documents, while precision is the number of relevant documents retrieved by a search divided by the total number of documents retrieved by that search. To detect age appropriate videos for kid, you need high precision or low recall to ensure that only safe videos make the cut, even though a few safe videos may be left out as well. As to detect age appropriate videos for your kids, you have to go with the high precision and low recall. That is the important part over here, and you have to follow that one. That's why precision and recall trade-off, it is important thing over here. So after getting about almost everything related to the logistic regression or the classification things, now let's talk about some of the classification based application or the use case. Like if you want to find whether an email received is spam or harm, like not spam, so this application is based upon a logistic regression and support vector machine. If you want to identify the customer segments, like customer coming which from which segment in e-commerce thing, also in banking sector to find a bank loan is granted or not, or in this particular school to identify if a kid will pass or fail in examination. So that type of thing if you want to find. So at the same time, logistic regression should be the good thing are there. And in the last, we have to take one use cases based upon a spam filter. The idea of this post is related to spam filters, understand step by step working of spam filter and how it helps in making everyone life easier. Also, next time when you can see you have won a lottery email, rather than ignoring it, you might prefer to report as spam. So also whenever we are working, we are having email IDs is there or Gmail IDs there. So during that daily you are getting the messages like your loan is granted, you are getting these lotteries are there, you are getting these benefits, this and this. So all are the spam are there. If you can consider these mails as spam, so from next time you are not getting that type of mails. So spam filtering is a beginner example of the document classification task, which involves the classifying an email as a spam or not spam. And spam box in your Gmail account is the best example of this one. So that's how you are getting idea like how the spam filter can build based upon a logistic regression when it should be worked within spam or not spam. So again, this particular session is completed over here, and from the next session, we have to learn about the basic idea about the unsupervised learning. Now we are going to start this session with the unsupervised learning case study. So what is the meaning behind the unsupervised learning, and as well as that thing we can see in this session later. But first of all, we can take one small case study based upon that. Ever wondered how NASA discovered a new heavenly body and identified that is different from a previously known astronomical object, or it has no knowledge about these new bodies but classifies them into proper categories? So that type of thing should raise in unsupervised learning. So NASA uses unsupervised learning to create a cluster of heavenly bodies, with each cluster containing objects of a similar nature. So whenever the cluster are not defined or not identified, but it looks small, small or large, large, so they can make in some cluster based upon small objects or the large objects. So let's find out the definition of unsupervised learning to get some better idea about the same thing. Unsupervised learning is a type of machine learning algorithm used to draw the inference from dataset consisting of input data without labeled response. The most common unsupervised learning method is cluster analysis, which is used for exploratory data analysis to find hidden patterns or grouping in data. In other words, the unsupervised learning is a subset of machine learning used to extract inference from dataset that consist of input data without labeled response. So after getting idea about the unsupervised learning, let's find out what are the types of unsupervised learning. Basically, three types of unsupervised learning is there. First is the clustering, second is the visualization algorithm, and third one is the anomaly detection. Among these three types, the clustering is very popular technique from the unsupervised learning. So let's talk about one of the overview related things based upon k-means algorithm or the k-means clustering. Clustering is the task of dividing the population or data points into a number of groups such that data points in the same group are more similarly to other data points in the same group than those in other groups. In simple words, the aim is to segregate groups with similar traits and assign them into cluster. The most common unsupervised learning method is cluster analysis, and it is used to find data clusters so that each cluster has the most closely matched data. For example, an online news portal, segments, articles, and many more things are there that can consider within a clustering. Because whenever we are working, we are seeing some online news or online news applications. At the same time, different type of sections is there, like world-based thing are there, business, technology, entertainment, sports, finance, science, health. Many more type of categories are there. So that all thing can based upon a clustering or Clemens clustering. So again, this session is a it's very small session is there based upon a unsupervised learning. But from next session, we can also take in some more idea about this type of small terminology in the machine learning ideas or the machine learning types. Let's start with the last part of this session, and that is semi-supervised learning and the reinforcement learning. And in the last, we can take in some idea about some important reconsideration in a machine learning. So let's start it with the first thing, and that is the semi-supervised learning. So what is semi-supervised learning? It is the hybrid approach, and it is also understood as a combination of supervised learning and unsupervised learning with some labeled data set and some non-labeled data set. So whenever we are having labeled, non-labeled, and the combination of supervised and unsupervised, it is known as a semi-supervised learning. Also, let's check it out some of the examples based upon a semi-supervised learning. So you will get a better idea about semi-supervised algorithms. First thing, that is the Google Photos automatically detects the same person in multiple photos from a vacation trip. So that is based upon a clustering or unsupervised. But one has to just name the person once, like supervised, and the name tag gets attached to that person in all photos. For example, I have 10 photos is there. In one photo, I just provide my name. That is my name is this one. The person A is my name, so according to that it can correlate it with all the photos, but in other photos I cannot attach my name, but still in one photo is similarly to another 9 photos, and in one photos I already provided my name, so it's auto correlated to all the photos. So that's type of thing should working in example of semi-supervised learning algorithms. After semi-supervised learning, let's talk about some of the thing in reinforcement learning. Here we are not spending lots of time based upon a reinforcement learning because one of the whole module is represented with the reinforcement learning. So at the same time, we can spend more time based upon a reinforcement learning. Still, here we are just only getting some basic idea about the reinforcement learning. Reinforcement learning is a type of machine learning that allows the learning system to observe the environment and learn the ideal behavior based on trying to maximize some notion of the cumulative reward. So that's how, based upon a feedback and reward, the reinforcement learning should be work. Let's talk about some of the features of the reinforcement learning. The learning system, like agent, observe the environment, select and take certain actions, and gets reward in return. The agent learns the strategy or policy that maximize its rewards over the time. In a manufacturing unit, a robot uses deep reinforcement learning to identify a device from one box and put it in a container. And the robot learns this by means of reward-based learning system and which intensives it for the right action. So that's how we are getting some idea about how feature of reinforcement learning should be worked in this over here. So after discussion of features of reinforcement learning, let's talk about some of the example. We already discussed about this example during the features, like how the robotics should work based upon this type of reinforcement learning. Like KUKA robotics are good with the machine learning and as well as some robotics knowledge as well as. So that's how, if they both combine, so there's a good product for the reinforcement learning. Now we have to talk about some of the important consideration for the machine learning technique, and that is based upon a bias and variance trade-off. Bias refers to error in the machine learning model due to wrong assumptions. A high bias model will underfit the training data. Variance refers to problem caused due to the overfitting, and this is result of oversensitivity of the model to small variations in the training data. A model with many degrees of freedom, such as high degree polynomial model, is likely to have a high variance and thus overfit the training data. So similarly, the bias is simplifying assumptions made by the model to make the target function easier to approximate, and variance is the amount that the estimate of the target function will change given different training data. So trade-off is tension between the error introduced by the bias and the variance. So that's how thinking are working over here. So that's why we can also evaluate the thing based upon a bias and variance dependencies. So increasing a model complexity will reduce its bias and increase its variance. Conversely, reducing a model's complexity will increase its bias and reduce its variance. This is why it is called a trade-off. A linear machine learning algorithm will exhibit high bias but low variance. On the other hand, a nonlinear algorithm will exhibit low bias but high variance. Using a linear model with a dataset that is nonlinear will introduce bias into the model. So that's why bias and variance both are having their own independence and own importance in the particular machine learning model. So after discussion about the same consideration, in the end of this session, we have to talk about representation learning. So in machine learning, representation refers the way of the data is presented, and these often make a huge difference in understanding. So the representation learning are not the actual world in terms of the algorithm. This is just only for information. I can provide you the thinking behind the representation learning. So basically, in this whole module of machine learning type, we have to explore about the supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning, and then representation learning. Whereas we have to briefly discuss about the linear regression and the logistic regression. So first of all, we have to take in some basic idea about what is the meaning behind the k nearest neighbor, and then we have to see one of the example based upon KNN classification. So let's get to know about k nearest neighbor. Basically, the k nearest neighbor, it is a part of the classification part. Okay, so in a classification, we already learn about the logistic regression. So in a next way, there is k nearest neighbor is there. Also in a classification part, the decision tree, support vector machine, and many more techniques are there. But here we are just only focused based upon a k nearest neighbor. K-nearest neighbor algorithm is used to assign a data points to cluster based upon a similarity measurement. It uses a supervised method for a classification. K-nearest neighbor is a simple algorithm that stores all available cases and classify new cases based on a similarity measures, for example, distance function. KNN has been used in statistical estimation and pattern recognition already in the beginning of 1970s as a non-parametric technique. In statistics, the k-nearest neighbor algorithm is a non-parametric method proposed by Thomas Cover used for classification and regression. In both cases, the input consists of the k closest training example in the feature space as well as. So let's check it out. What type of steps we have to taken during the KNN algorithm. So first is the choose the number of k and distance metric. So at the same time we have to find out how many k was necessary. K is equals to 5, 3, 6, 4, whatever the number we have to select. So that is the k. Second thing, there is a find k nearest neighbor of the sample that you want to classify. And third one, that is the assign the class label by majority what. So similarly, we are seeing some example or we are seeing some practical example based upon the k nearest neighbor. So we are getting some better idea about these steps. So let's get to know something more about for the KNN classification or the KNN techniques. A new input point is classified in the category such that it has a greatest number of neighbors from that category. So one of the simplest decision procedure that can be used for classification is the nearest neighbor rule is there, and it classifies a sample based on the category of its nearest neighbor. So the nearest neighbor based classifier use some or all the patterns available in the training set to classify a test pattern. For example, classify a pattern as a high risk or a low risk, as well as mark email as a spam or not spam. So let's understand KNN example from the real world life. So here I have one problem statement. So first of all, we have to read this problem statement, and based upon this problem statement, we have to try it out how we can explore the KNN classification method technique to over here to get some solution. Suppose we have a height, weight, and t-shirt size of some customer, and we need to predict the t-shirt size of a new customer given only height and weight information what we have already in this table. So the data including height, weight, and t-shirt size information already provided over here in this diagram or a table. So for that we have to go with the step number one. So first of all we are going to solve about the step number one. In a step number one, calculate the similarity based on a distance function. So there are many distance function, but we have to refer the Euclidean distance. So but the Euclidean is the most commonly used measure distance is there. It is mainly used when data is continuous. Manhattan distance is also very common for a continuous variables. Whenever you are working like KNN K nearest neighbor technique with the continuous variable or the regression type of problem, you have to go with the Manhattan distance. But particular KNN technique is much popular with the classification part. So that's why whenever we are going with the classification, we are using the Euclidean distance. The idea to use distance measure is to find the distance or similarities between new samples and the training case, and then finds the k closest customer to new customer in terms of the heights and weights. New customer named Monica has height 161 centimeter and weight is 61 kg. So based upon Monica parameter, we have to do some subtraction between this parameter, or we have to take in some things related to the table parameter. So Euclidean distance between first observation and the new observation. First observation, it is the 158, 58 and m, and the Monica observation that was 161 and 61 kg. So 161 minus 158 because new observation it's a 161 and the first observation that was 158. So we have to provide to power of that one plus we have to take in 61 minus 58. 61 it's coming from the first observation, sorry, the new observation, and 58 it will come from the first observation. So that's how we are finding out this Euclidean distance over here. So similarly, we calculate the things and we have to explore some more thing like we will to calculate the distance of all training cases with the new case and they calculate the rank in terms of the particularly distance, and the smallest distance value will be ranked as 1 and considered as the nearest neighbor. Now let's talk about the step number 2. So what type of thing we have to done in a step number two? Step number two is depends upon the find k nearest neighbor. In a step number two, we have to work based upon a nearest neighbor. So for example, here I have to take an k is equals to 5. So then the algorithm searches for the five customer closest to Monica. Like for example, we have to find out those five customers parameter specification. Those are very related to the Monica parameter. Like Monica has size of 161 centimeter and 61 kgs is there. So we have to find out that more five customers that they have specification related to Monica. So according to that one, we are getting an idea which type of t-shirt size will Monica will have. So, for example, most similar to Monica in terms of the attributes and see what categories those five customer wearing. If four of them had medium t-shirt size and one had large t-shirt size, then your best guess for Monica is medium t-shirt size. So see the calculation in particular snapshot. So here I can provide everything like according to the snapshot. Like Monica are having 161. So here from over here we have taken these five samples at the same time the height is 160, 160, 163 and 163. It's around like 160 to 163 is there, and Monica are having 61. Again, similarly in a weight, Monica having 61 kg of weight, and here we have to take on 60, 60, 61, 61, and 61. So samples are very nearer to that one. And if you can see this diagram, so in this diagram, yellow point will represent the Monica, okay, and also the blue pointer represent this particular type of the medium t-shirt size, and orange will represent the orange square will represent the large sizes there. So here out of five, the 4 point will represent like Monica will fitted with the blue size, so Monica will go with the medium size. So in the above graph, binary dependent variable is displayed in the blue and the orange color. So medium t-shirt size is in blue color, and the large t-shirt size is, it comes in an orange color. So new customer information is exhibits in a yellow color for blue highlighted data points, and orange highlighted data points are close to yellow circle. So the prediction for the new case is blue highlighted data point, which is medium t-shirt size. So that's how we are able to explore the k nearest neighbor classification over here. Okay, so that's how this of the knn method is completed over here, because the knn method is not very longest or very toughest, it is very smallest and very easiest technique is there in classification part. So knn should be ended over here. In this practical session, we have to implement a k nearest neighbor with the same data set that we can use already use for the logistic regression. So we are getting an idea how the output should differ from the logistic regression and the k nearest neighbor, because at the same time we are getting the true positive around 63. So here we have to find out what type of number of true positive, it means on what type of the condition and on what level of the condition we are getting the same in predicted output and the actual output. So at the same time we are getting idea about the accuracy. So let's start it with the first step, that is the import the libraries. So first we have to import the NumPy as np. Second we have to import Pandas as PD. Third library is based upon a import Matplotlib dot pyplot as PLT. Also, we have to use this backend line, that is the Matplotlib inline. So after applying this one, next step that is the import the dataset. But still we are getting an error. Matplotlib spelling was wrong over here. Okay, so now it's time to import the dataset. Again, I want to use the same dataset that I already used for the logistic regression. That's why you already aware about how to import the dataset with the pandas dot read dot underscore CSV. Particularly, we have to use the social network advertisement dataset. That's why we have to take an social network advertisement dataset ADV dot CSV. So that's how we have to do the things. And now based upon that same input parameter I want to use over here, that I can use for the logistic regression. See here I want to just only find out to do the difference between the logistic regression and the KNAS neighbor in terms of the output or the accuracy or the confusion matrix, whatever things you can understand. That's why same input I should taken for the k nearest neighbor what I already taken for the logistic regression. So that's why again here we have to take a data set dot I location, and particular with that I location we have to take a number of rows, and with that Also, we have to take in 2 and 3. That is the position of the columns. At the end, we have to provide the values over here. Then we have to take in y is equals to dataset dot I location. In particular, with that I location, we have to take in semicolon, and then again we have to take in a square bracket. But if you just want to select single parameter as a y parameter, no need to provide any type of the square bracket over here. And after applying this one, we have to take in the values again over here. So we're already getting an idea. I think again we are not finding out the social network advertisement data. I think the spelling was wrong. ADS. ADS. There is that ADS. Yes. Now it's correct. So we are getting X and Y is there. If you want to do some basics analysis, you can do it. That is depends upon you. But if you are getting what are the X values, so X are coming in two ways based upon the particular the parameter of the age over here and as well as estimated salary. So 19 will represent the age and 19,000 that is represent the estimated salary. And Y will represent the person will purchase the product or not throughout the online advertisement. So after applying these things, if you want to find out the missing values, you can also find out that part. And if you don't want to do the same thing, you can't do it. Otherwise, next step that is the training and testing split. So again, we are using the same process over here, like sklearn dot model selection, and based upon that model selection over here, we have to import a train, test, and split. So after applying train, test, and split, we have to take on over here the x train, second parameter that is the x test. Then we have to take on a y train and the y test. Then we have to take on over here the y train and the y test over here, and we have to equal to with the train underscore test underscore split. And inside we have to take on a parameter of x. Also we have to take on of y parameter. Also we have to take on of test size, and here we have to take on test the size is equals to again similarly to the logistic regression 25% as a test size, and then I want to take it random state is equals to 0. So now it's time to run this code, but here we are getting an error. I think again we are getting an error. Yes, that is the model selection are there. So that's why we have to take on a model selection over here. So till now we had completed the things. In the next part, we have to apply how to do the feature scaling with the standardization parameter and so on. We can learn about how to create a KNN model over here. So now after splitting the training set and testing set, particular with the KNN nearest neighbor, now it's time to apply the feature scaling based upon the KNN. So for that, we have to apply the next step that is based upon a KNN. So here, first of all, for applying KNN, we have to import the libraries like sklearn dot preprocessing, and based upon this preprocessing library, we have to import a standard scaler over here. So that's why we have to take a standard scaler. So after applying standard scaler, now in the next things, we have to create a one more parameter based upon the standard scaler, and that is the SC, is the short form of the standard scaler. So that's why we have to take away the standard scaler of the bracket, and then we have to apply the enter over here. And now we have to transform our x train and also the x test with the transformation of the standard scaler. So that's why we have to take an sc dot fit of transform of x train. Same thing we have to apply it for the x test as well as. So here we have to again take sc dot fit transform of x test. So now the feature scaling already applied over here. We have to take an sklearn. We have to take this one, and feature scaling is already applied over here. After applying the feature scaling, now it's time to apply it for a k nearest neighbor of model. Basically, during the theory, we are using the Euclidean distance. So at the same time, we have to don't forget that part, like how to apply the Euclidean distance as compared to the Manhattan distance. Okay, so same thing. What are the concept we had learned during the theory? Similarly, that type of concept we should provide during the practical as well as. So for the for doing the KNN algorithm, we have to import the k from the sklearn dot neighbors file, we have to import over here the KNN algorithms. So that's why based upon the KNN neighbors. So from the KNN, sklearn neighbors, we have to import KNN neighbor classifier. So KN, we have to take capital neighbors classifier we have to import over here. So please be careful with the spelling of this one, because somewhere we have to use capitals and somewhere we have to use small letters, and everything is depends upon the standard documentation of the scikit-learn particular algorithms. Okay, so that's why we have to follow that part. It's not my algorithm, like I have to take in KNN capital and then other parameter I have to use as a small. That is not on hand my own my. So because I have to follow the scikit-learn documentations. And now we have to try to create a model based upon the KNN. So you can also copy this code and you have to paste it over here, and based upon that you have to create this parameter like of things. So first of all, that is depends upon you how many k you want to select over here. So standardly during the theory we have to use k is equals to 5. So here also I have to use n neighbors is equals to 5, the things I can use over here. And after applying that one, now we have to select what type of metric or what type of technique you want to use, like you want to use Manhattan distance or you want to use the Euclidean distance. So according to that, here we have to provide the main cover schemes. Actually, if you can prefer the scikit-learn documentation more and more, so you will get an idea how you can make it some specified things. And as well as with the help of with the Euclidean distance, here we have to use p is equals to 2. If you can again use p is equals to 1, so at the same time it should work with the Manhattan distance. But here we want to work with the particularly Euclidean distance, because already in theory example we are using that one. That's why here I have to take on this one of p is equals to 2. So now we have to apply model dot fit, and we have to fit this model with the X train and also with the Y train. So now it's time to run this code, and we are getting an error. Let's check it out. I think we are getting an error based upon some spelling. I think yes, metric. Yes, spelling of metric was wrong. It's metric, not a metric. Still, we are getting an error. I think we have to check min Kowalski spelling was correct. P is equals to 2 is also correct. Let's check it out. What are the error we are getting over here? The metric min Kowalski is not valid over here. Let's check it out. Why it is not valid over here? We have to find out any type of the reason for that. It's a min Kowalski. I have to write down the mini Kowalski. Yes, now it's working over here. The min Kowalski, that is a function, but by mistake I had taken mini Kowalski. Okay, so after applying these things, we can see over here like k nearest neighbor, that was make it over here. And next step that is based upon that is we have to predicting the test result as well as. So for that over here we have to provide the y prediction over here. So y prediction is equals to, here we have to take on a model dot predict, and particularly with the predict we have to use x test over here. So we have to use x test, and after getting x test we have to run this code, and now we can call up y prediction over here. So that is the output of the y prediction. So after applying that thing, next thing that is the making a confusion matrix. So let's make a confusion matrix. So for that we have to write one code of for that, but before that we have to import one library to applying a confusion matrix, and that library is the from sklearn dot matrices. From sklearn dot matrices we have to import a confusion matrix. So that's why we have to take a confusion and then matrix, enter CM. It is a short form of the confusion matrix. So based upon the confusion matrix here in the packet we have to take a y test and y prediction. So now it's time to run this code, and we are getting an CM. So if you can remember the things, whenever we should work with the logistic regression, at the same time we are getting the true positive is equals to 63, but here we are getting two true positive is equals to 64. So easily we are getting an idea as compared to the particular logistic regression in the KNN nearest neighbor algorithm, we are getting the good accuracy or the good result as compared to that one. So in the next things, we have to see about how to visualize the training set result and the testing set results. So for the visualization of the training set results, here I can use the same code, what the code I already use it for the logistic regression, because this code is taken lots of time to prepare that. That's why I have to copy the code from the logistic regression file. And here if you can see, everything is looks similar to the logistic regression file, but just only we have to apply one change over here, that is based upon the title. Here we have to take an KNN regression test over here. Otherwise we are going with the same parameter, what the parameter we can already use for the training set of the logistic regression. So based upon that, here we are getting an output, but before that it will take some time to run this code, because the code length is very large. That's why it will take an time, but it will not take an more than like 1 minute. So now if you can see, this thing should complete it over here, and we are getting an output over here with the KNN. So whenever we should work with the logistic regression, at the same time we are getting one linear line over here, because particularly in a logistic regression should be worked based upon the sigmoid function. So that's why according to sigmoid function of S curve, we are getting that type of output. But here if you can see with the KNN neighbor algorithm, we are getting different type of the decision boundary. Basically this line is called as a decision boundary. And again here the same concept we can provide it, those concept we already provided based upon a particularly x-train and x-trace with the logistic regression. Now after getting the result based upon a training set, now it's time to take a result based upon the, after getting training set result, now we have to find out the result based upon a testing set. So to get the result based upon a testing set, here we have to take an a y test and x test. Here we have to take an x test as well as, and rather than, again here we have to take an knn testing set, knn testing set. And now we have to run this code. Again it will take 30 seconds. Okay, so here we are getting an output related to the testing set of the KNN. So the decision boundary still look like similar, but here if you can see in a green region there are very few samples are there that is related to the red sample. So and also similarly to that, in a red region we are just only having the three samples related to the green regions or the green sample, but all the samples are very nearer to the decision boundary. So that's why we are getting an idea as compared to logistic regression, the KNN algorithm are given the better result as compared to the accuracy as well as compared to the confusion matrix. Decision tree can be used for both classification regression. We already find out during the regression part. Still, we can talk about in a classification thing. So the advantage of decision tree is that they require very little data preparation. They do not require feature scaling or centering at all. So whenever we are working with the decision tree as a classifier, so no need to apply any type of the standard scaler or the mean scaler. During the practical thing related to the logistic regression or the KNN, we are doing every time standard scaling. But whenever we are working with the decision tree classifier, so there is no need to apply any type of the standard scaler. They are also the fundamental component of random forest and one of the most powerful machine learning algorithm. Unlike the random forest and neural network, like which two black box modeling is there, decision tree are the white box modeling. So which means that inner workings of these models are clearly understood. In case of classification, the data is segregated based on a series of questions. Any new data point is assigned to selected the leaf node. Decision tree builds the classification or a regression model in the form of a tree structure, and it breaks down a data set into smaller and smaller subset, while at the same time an associated decision tree is incrementally developed. The final result is a tree with decision nodes and leaf node. Start at the tree root and split the data on the feature using a decision tree algorithm, resulting in the largest information gain. And particular, what are the splitting we are getting over here? Splitting procedure is then repeated in an iterative process at each child node until leaves are the pure. So that's how these things are working over here. And according to the similar, we are getting some more idea about, like, this means that the samples at each node belongs to the same class. So whenever we are working with the decision tree as a classifier, so it should work in terms of the decision boundaries. So decision trees should create a boundaries, and throughout the boundaries, we are able to classify the samples among our hyperplane. So basically, in practice, you can get or set a limit on a depth of the tree to prevent the overfitting, and the purity is compromised here as the final leaves may still have some impurity. And this figure shows the classification of iris dataset. We already talked about like iris are having the three type of classification is this like iris setosa is there, iris virginica and iris imagica is there. So that's how the thing are working. So but basically the iris is the multi-class classification problem, so that's why it is very suitable with the decision tree classification technique. So after discussing about this one, let's talk about the cart algorithm with the respect of the classification. So basically, again, you already know like the things like cart algorithm, it stands for the classification and regression trees. And the cart algorithm creates a binary tree. Each node has exactly two outing edge. So based upon two outing edge, the cart algorithm should be worked over here in classification part. So finding the best numerical or categorical feature to split using an appropriate impurity criterion. Let's talk about some of the main element of the cart algorithm. So here the cart algorithm, it's first of all comes within like rules for splitting data at a node based on the value of one variable. The second thing is that stopping rules for deciding when a branch is terminal and it can be split no more. And finally, the third rule that is based upon like a prediction for the target variable in each terminal node. So that's how cart algorithm should be worked. The representation used for the cart algorithm is the binary tree, and the prediction are made with the cart by traversing the binary tree given in a new input record. The tree is learning using a greedy algorithm on the training data to pick splits in the tree. But that is not more considered like greedy algorithm and all, because we have to just focus over here the cart algorithm. So here with the cart algorithm in the classification problem, the basic idea to tree growing is to choose a split among all the possible state at each node so that resulting child nodes are the purest. In this algorithm, only univariate split are considered. That is, each split depends on the value of only one predictor value. So that's why it's called as univariate splitting are there. Whenever we have to talk about the bivariate split or the more than multivariate split. So at the same time, from the one node, we are getting some lots of splitting node is there, but here we are just only talking about the univariate split it. So all possible split consist of possible split of each predictor. So this prediction or this splitting can coming within three steps like pick the variable that gives the best split based upon the lowest gene index. So in the next slide we can also talk about what is the importance of gene index, and at the end we have to discuss about what is a gene index. Then once we can find out the Gini index, according to that one, we have to find out the lowest value of Gini among all the parameters, and which we can select like partition the data based upon the value of this variable. And in the last step, again we have to repeat the step number one and step number two with the splitting stop when card detects no further gain can be made or some preset stopping rules are met. So also in the next we have to also talk about the stopping rules, then we can go with the Gini index. So alternatively, the data are split as much as possible, and then the tree is later pruned. It means after that we are able to avoid the pruning or the overfitting. So let's talk about the some of the important stopping rules. So there are here I just only mentioned five stopping rules, but if you want to research about some more stopping rules, you can go with that, because stopping rules is very important whenever we are talking about the decision tree as a regression or the classification, because throughout the stopping rules we are able to work with the regularization things. So that's why stopping rules is very important according to us one. So let's start it with the first stopping rules. So first one is if a node becomes pure. So if node becomes pure at the same time we are having as a gene index or we are having impurities equals to zero. So at the same time our splitting should be stopped. So that is all cases in a node have identical values of the dependent variable and the node will not be split. Second rule is like that if all cases in a node have identical values for each predictor. So each predictor are having their own identical values. So at the same time, still the node will not be split. Third rule is that if current tree depth reaches the user specified maximum tree depth limit, the tree is growing process will be stopped. If the problem will complex and if I can provide the maximum tree depth is equals to 5, and according to the model it can reach that depth of 5, so then again it should stop. So that type of thing is different thing are there, like it is not stopped by automatically, but according to our criteria it should stop. If the size of a node is less than the user specified minimum node size, again node will be stopped. So those things are given by the users. So at the same time, the expansion of the node it should be automatically stopped. So that's how it should work over there. If the split of a node results in a child node whose node size is less than the user specified minimum child node size, then still the node will not be split. So again, it is defined by the user specified. So whenever the things are defined by the user, at the same time it should be stopped over there. So these all are the stopping rules for the decision tree as a classifier. After talking about the decision tree as a classifier with the stopping rules, let's start it with the thing based upon a gene impurity. So what is the gene impurity and how it can defined by us? Gene impurity is a measurement of a likelihood of an incorrect classification of a new instance of a random variable. If that new instance were randomly classified according to the distribution of class labels from the dataset, then the Gini index is a measure of distribution of income across a population. A higher index indicates greater inequality, with high income individual receiving much larger percentage of the total income of the population. So the Gini index measures impurity in node. It varies between 0 and 1 minus 1 upon n. So what can stand with the n? N will come with the number of records. So how many number of samples are there? Or sometimes it can also consider as how many number of classes is there. So where n is the number of categories in a dependent variable. For example, we are having three categories. So at the same time, it should look like 1 minus 1 upon 3. So 1 upon 3, it look like 0.33. 1 minus 33, we are getting 0.33. So always the gene impurity comes within between 0 to 1 because 1 upon n is there. That's why. So that's why we can also getting idea about the what are the maximums are there and what are the minimum are there. So when a node P is split into the K partition like in children partitions, so that the quality of split can be computed as Ni and N. I stand for the number of records at child I. Like for example, we are having 100 numbers and splitting can done within 70 and 30. So after next time Genie, we have to find one individual 30 samples and 70 samples. After if we can take in 30, so 30 can again split in 20 and 10. So again we have to find Gini between 20 and 10. Okay, so that's how the whole process should be worked whenever we are trying to work with the Gini impurity or the Gini index. Now after discussion about the Gini impurity and Gini index, let's have to discuss something about a pruning of the related to the correct overfitting. So it is a technique to correct overfitting problem whenever, because here we are working with the stopping rules, genius, lots of things is there. So that's why overfitting is also again important part is there. So pruning is a data compression technique in machine learning and search algorithms that reduces the size of decision trees by removing sections of the tree that are non-critical and redundant to classify instance. It reduces the size of decision trees by removing sections of the tree that provide little power to classify instance, and it is used to remove anomalies in the training data due to the noise or the outliers. We already seen a regularization in a decision tree in in a regression topic. So when we talk about the regression part, at the same time we already discussed many type of things based upon the regularization, but the same concept we have to apply it over here about the regularization. So if you can see over here the figure, so you will get in some more idea. Whenever the no restriction are coming with the make model making, at the same time it goes with the leads to overfitting. So whenever we are getting overfitting, so decision boundaries are too complicated. But when we are going to work with the regularization thing, like set the minimum sample leaf is equals to 4, so at the same time it will not consider with any type of the regularization, or it goes with the particular thing. So it's not going for the overfitting, it's avoid the pruning or the overfitting, but it easily comes within regulation whenever we can set the minimum sample leaf or whatever the stopping rules if we can provide. At the same time we can have some good things related to that one. So that is important part we can see over here to lead the overfitting. So while the model on the right generalized better is there, so that's how things are working over here. So that's how mainly things we already discussed about the decision tree, about the technical point related to how cart algorithm should build, how the different other things should be worked over there. And in this session, the last thing what we have to discuss, and that is just simply based upon a business scenario and advantage of the decision tree. So first of all, the first scenario or the advantage related to the medicine, like among the patient's profile, who will respond better with such treatment? So by putting the rest of them into another kind of treatment, and among the customer, find of those who will write, who will attract versus those will stay with the business. So by targeting such customer, you can reduce the attrition as well as. And in the last one, among the applicants, find which are the applicants is there and who can be fraud or who cannot be fraud. So that's why the bank is there, or they can get the idea, like they can give the loan, or somebody if they are taken for the interview. So like few selected applications can avoid lots of account takeover, the fraud cases are there. So multiple things are there in business scenario and advantage, and that's how decision tree should be. Very very good applications are available in business development side as well as. So this session is ended over here. From next session we can start it with the random forest classifier. In this practical session, we have to learn about decision tree classifier. Okay, so first of all, we have to import the libraries in a step number one. So here the library is the import NumPy as NP. So after importing library of NumPy, second library, that is the import Pandas as PD. And after that, we have to import the last library, that is the Matplotlib. So import Matplotlib dot pyplot as PLT. If you want to do some more things based upon the statistical analysis for the data analysis or the data exploration, you can also use the Seaborn library. Here, my main focus is currently is based upon the machine learning algorithm. So that's why I'm not showing to you how you can develop the data analysis things. So the last we have to take in some backend line for this one. So matplotlib in line. So after making this one, second thing that is depends upon the data set. So again here I have to use the similar data set. So why I'm using the similar data set for all the classification techniques, that is just only because of the comparison things. So if we are using the same data set with the different algorithm, so at the same time we are getting an idea with the same data set, like how and which algorithm are more appropriate for the particularly problem statement. If we are taken the different data set with the different algorithm, so at the same time we are not capable like which algorithm is better or which algorithm is not better. So that's why we have to do the same thing. Now in this step we have to apply the data set. So that's why we have to take a data set is equals to pd dot read slash csv to read the csv data set, and then we have to use the data set name, that is the social network advertisement data set. Social network ads data set. Here we have to use that part, so that's why we have to use ads, and then we have to use csv extension over here. After applying data set, we have to find out the x and y. So you already known in last two times with the linear logistic regression and as well as with the knn, what are the x and y I had to taken over here. So the column number 2 and 3 I have to selected as a x, and column number 4 I have to selected as a dependent parameter y. So that's why first of all we have to take an x is equals to data set dot I location, and with that particular I location we have to first of all use all the number of records in terms of rows, and in terms of columns we are just only using the two second and third column. After applying that we have to take in dot values, and particular with the y we have to using the same logic over here, and with that same logic also here I have to using all number of records or the rows, and particular from the column side I just only wants to access the number fourth position of column. After applying everything, now I have to take a dot values with that particularly access the things. After applying this step, next step that is based upon a training and testing set. After applying training and testing set, we have to go with the feature scaling. So training and testing split and the feature scaling, this process you already know. So that is your task. I just give you the 10 minutes, and within 10 minutes you can create the training set and testing set according to you, and then from the next session we can talk about or we can implement decision tree classifier. I hope you can complete it. The training and testing splitting look like similarly the logistic regression and the KNN algorithm. So now after applying training and testing splitting, after we have to do the feature scaling and also after applying feature scaling, now it's time to make fitting the decision tree classification to the training set. So let's see how we can apply the decision tree algorithm to our data set. So first of all, we have to start from the sklearn, and with that sklearn we have to take an sklearn dot tree, and from that tree we have to import decision tree classifier. So let's write down the decision tree classifier with the same thing. Also here we have to take one more I over here, and after classifier now we have to create the model, and over here the model is based upon a decision tree classifier. That's why we have to take a decision tree classifier. And after applying decision tree classifier, now it's time to apply some additional information, like how many type of the particularly which type of the criterion you want to use. Basically when you basically with the decision tree we are using the cart algorithm. So basically cart algorithm should be worked based upon the Gini impurity. So that's why that is depends upon you, like how you want to use Gini impurity. Otherwise if you are not providing any type of the criterion, so automatically it should follow the cart algorithm. Also if you want to apply things related to the like mean sample leaf, mean sample split, all the mean impurity split. So what are the stopping rules related to criteria we discussed in the theory, so that all type of stuff you can add it over here. For example here I want to take it as a mean sample leaf. So here I want to take it mean sample leaf is equals to 1. So here we have to take a steps to regularize the overfitting. So that's why if you don't want to get with the regularize overfitting, or you are having some issues with the pruning or the overfitting, so that's why you can provide this type of stuff to regularize your model. And after you can also take it a random state is equals to 0. Also the here you are able to, if you want you can also make it many more parameter over here to regularize your model. But when we are getting an output of these models, at the same time we are getting rather than all the parameter related to the that one. So after that here we have to fit it our model. So model dot fit we are applying over here the x train and y train. So here we have to use X train and Y train. Also here I want to clear one main thing. If you are working with the decision tree and if you don't want to apply the feature scaling type of stuff over here, so you didn't apply, that is depends upon you. But still we are continue with everything everywhere and which each step. That's why I also applied over here the feature scaling step. So now the thing was completed, but still I'm getting an error, like initiated got an unexpected keyword argument mean sample leaf. So we have to check it out the thing was correct or not, like we have to taken some capital or small type of issues or not, because basically we are getting that type of issue samples. Yes, here we have to take samples. Now it's perfect. Yes. So if you can see over here, this type of criterion, if you want to apply it over here, you can apply it. Basically, we are using the cart algorithm. So that's why by default, they are using criterion is equals to Gini criterion. Basically, with the decision tree classifier, the one more algorithm is very popular. That is the ID3 algorithm is there. That is the iterative dichotomizer third algorithm. If you are using the ID3 algorithm, at the same time, you have to change the criterion is equals to Gini to the entropy, because the ID3 algorithm is totally based upon the entropy and the information gain. But here we are just only learn about the cart algorithm. That's why I should use the criterion is equals to Gini, but that is based upon by default with the cart algorithm. So that's why no need to mention the same thing like criterion is equals to Gini, because it is automatically by default applied. So after getting idea about the decision tree as a classifier, in the next thing we have to create the Y prediction. So here we have to write the code for the Y prediction, and Y prediction that is based upon the model dot predict of Y test. Sorry, that is just only depends upon the X test, because confusion matrix depends upon the Y test and Y prediction. So here we are just only using the X test, and based upon that we are simply find out the prediction. So here we are already getting in prediction. So after getting in prediction, let's check it out for the confusion matrix as well as So for getting the confusion matrix, we have to write down the scikit-learn dot matrices, and from that import the confusion matrix. So after applying confusion matrix over here, in the next things we have to take in cm is equals to confusion matrix of y test and y prediction. So you already know now how to use the confusion matrix and how to get the parameter from the confusion matrix. And you can also call up over here. So here we are just only getting the 61. So the as compared to logistic regression and the KNN algorithm, the decision tree are having some more powerful algorithm. But still, if you can see over here, so decision tree are not able to get the true positive as good as compared to the logistic regression and as well as from the KNN, because in a KNN we are getting the 65 number as a true positive. In a particular logistic regression we are getting the 63 samples as a true positive, but here we are just only getting the 61 sample as a true positive. So as compared to that logistic regression or the KNN nearest neighbor, the decision tree are not good much powerful, or they are not able to provide some good output with the particular this data set, because according to the concept the decision tree are more most powerful algorithm as comparison with the logistic regression and the KNN algorithm, but we are using same data set. That is the reason behind that. For this particular information I want to evaluate, that's why I can use the same data set for all the algorithms, so we are get an idea like in particular when you are having the task related to the binary classification, so at the same time decision tree is not good. But if you can provide the multi-class classification with the decision tree as a classifier, so decision tree can provide you the good results. So that's why this type of importance you can find with the same data set. Now after completion of this one, now it's time to create the training set visualization and as well as testing set visualization. So here again we are using the same code what we had provided already with the logistic regression. So here just only I have to apply one change, and that is change depends upon the decision tree training set, and now I have to run this code. So here if you can see the idea about this one, so the decision boundary as compared to the logistic regression and KNN, it is very complex things are there. And also whenever you are getting this type of decision boundary, so you are also get an idea I think of a problem is try to goes with the overfitting. So that's why if you can provide the more detailed information during the making the model of decision tree, so they are and with the help of the stopping rules, they are not gone with the pruning things or the overfitting, and they are trying to make it some regularization things. So that's why here we are getting this type of decision boundary with the decision tree techniques. Also now we can see the same thing with the training set as well as. So for that here we have to apply one change in based upon the train we have to using test over here, and after applying test over here again we have to take an dt for the decision tree, and also here we have to take in testing set. So when we apply the decision tree testing set, so basically in a testing set we are just only having the 25 percentage of testing data, but still if you can see as compared to the KNN, here the total 4 to 5 samples are converged with the green area, red samples are total 5 samples are there, in particular the green area of the red samples. So that's why we already seen the diagram of the KNN algorithm. So in a KNN algorithm output we are just only getting the 2 to 3 samples are red samples are converged with the green area, but here more than 4 samples are converged with the green area. So that's how we are getting an idea. For the multi-class classification, decision tree are not providing, decision tree classifier is not providing as much as good result as compared to the logistic regression and the KNN algorithm. So that's here supervised learning with the regression and the classification techniques in terms of practical is ended over here. And in the next things we have to say about the deep learning practicals. As before that we have to learn about the introduction of the deep learning. Hello students. In this module, we have to talk about a decision tree. Let's take a look about a module objective. First of all, we can start with the decision tree as a regression. Basically, decision tree technique it's used for the regression and classification for both. So that's why we can consideration first of all regression, and then we can find out how regression algorithm should work over here. After that, we have to find about some features of regularization with the cart algorithm for the regression. Decision tree is just a technique, but in that technique, we are able to implement many algorithms. But here we are just only following about the cart algorithm because cart algorithm will represent with the regression and the classification for both. That's why. So in classification, also we are using a cart algorithm. After in a classification, we have to talk about again regularization, overfitting, and stopping rules. And at the end of this session, or particular this module, we have to discuss about a random forest classifier. In similar way, random forest is also followed by the decision tree. That's why we can learn random forest classifier in the last thing. First of all, before that, we have to complete our whole knowledge related to the decision tree. So let's start it with the first point, and that is based upon a decision tree regression. A decision tree is a graphical representation of all the possible solutions to a decision based on a few conditions. So, a decision tree is a flowchart like structure in which each internal node represents a taste on an attribute. For example, whether a coin flip comes up has a head or tail, like that. So each branch represents the outcomes of the taste, and each leaf node represents a class label like decision taken after computing all attributes. So that's why here we can get an idea like decision tree should be worked for both, like regression and classification for both. But here, first of all, we are just only given consideration based upon decision tree as a regressor. So decision tree builds regression or the classification model in the form of a tree structure, and it breaks down a data set into a smaller and smaller subset. While at the same time an associated decision tree is incrementally developed and the final result is a tree with decision nodes and leaf nodes. So let's talk about some of related to the algorithm of for the decision tree. So first of all, it should consider data with two independent variables, x1 and x2. So the algorithm splits data into two parts. Split boundaries are decided based on a reduction in leaf impurity. The algorithm keeps on splitting subset of data till it finds that further split will not give any further value. So that's why we have to first of all calculate average of dependent variables of each leaf, and the value represent the regression prediction of that leaf. These tree splits leaves based on x1 being lower than 0.1973, and at second level it splits based upon x1 value again and again. Here we are not talking about any type of the problem statement. Here just I only talk about the one type of the basic thing, like these are the sample trees there, and based upon that we can try to get out some idea based upon a decision tree with the regression algorithm, because 0.193 come from the x1 greater than or equal to 0.1973. That's how. So at each node, the MSE or the mean square error or the average distance of data samples from their mean of all data samples in that node is calculated. The mean value for that node is provided as a value attribute, and the decision tree can perform regression tasks, and coding structure is look like this particular diagram. In the next topic, we have to discuss about like how decision tree should be worked over there. But before that, we are just only just simple take an idea about like how it should implement in practically. So we can see over here. So from these two coding are there. So whatever the machine learning model we can implement, everything is based upon a scikit-learn. So that's why scikit-learn library is very important. And further things we can discuss throughout the practical sessions. Let's talk about like how the decision tree should perform over here. So the data set looks similar to the classification of the decision tree. Till now, we are not explored the classification of decision tree, but still it's related to that one. You can get idea at the same time. The main difference is that instead of predicting the class, each node predicts the value. Whenever we are working with the same concept in the same thing with the classification problems, at the same time, decision tree should try to predict classes like class 1, class 2, or class 3. But whenever we have to talk about the prediction things at the same time, it should try to predict a continuous number. So this value represent the average target value of all instance in this particular node, and this prediction has an associated mean square error or MSE over the node instance. This mean value of the node is predicted value for a new data instance that ends up in that particular node. Now we have to see how to particular decision tree regression plot we are able to do plot. So the regression plot is shown here, and notice that predicted value for each region is the average of the values of instance in that particular region. It can work according to their depth. Okay, so it can work according to their depth. So you can getting idea. See, whenever the depth is equals to 1 and depth is equals to 2, both the things are different. Okay, and also we can provide throughout the maximum depth is equals to 2. That's why it can follow the depth 1, depth 0. But whenever maximum depth is equals to 3, so at the same time it should follow the depth is equals to 2 or the depth is equals to 0 and 1. So there's a difference are there whenever we are trying to implement some more depth in them. So that's why for these things better understanding, we have to look at about the regularization, like how we can apply decision tree as a regression with the regularization. Decision tree are non-parametric model, which means that the number of parameter is not determined prior to the training. Such model will normally overfit the data, but in contrast, a parametric model such as a linear model has predetermined number of parameters, so thereby reducing its degree of freedom. This in turn prevents the overfitting. And according to that one, to prevent the overfitting, one must restrict the degree of freedom of a decision tree. This is called as a regularization. In the decision tree, regularization can be done by pruning the tree, and if left to its own device, the tree can contribute to fit till each data point is differently in tree. This obviously will not generalize well, so you have to put in different criteria to stop splitting the nodes beyond the point. This can be done by specifying how many minimum data points are needed at each node for splitting. This can be various as some similar criteria is there. So for that, let's understand some of the important features based upon the regularization. Regularization consists in adding penalty to the different parameter of a machine learning model to reduce the freedom of the model, and in other words, to avoid the overfitting. In linear model regularization, the penalty is applied over the coefficient that multiply each of the predictors. Regularization is any modification made to the learning algorithm that reduce its generalization error but not its training error. In addition to varying the set of function or the set of features possible for training an algorithm to achieve optimal capacity, one can resort to other ways to achieve the regularization. So that's why we have to get some feature idea about the features of regularization. Now we have to check it out, like what are the different ways are there to regularize a decision tree. So that is the things we are able to apply during the coding part, like what or how much maximum depth you want to provide, and what are the mean sample split, mean sample leaf are there. So let's understand all the regularized criteria one by one. The first one, that is the maximum depth is there. So in that maximum depth we are able to finalize the limit, the maximum depth of the tree. In a second thing, we are able to do the things related to the minimum number of sample a node must have before it can be split. In min sample leaf, the minimum number of samples a list node must have. In minimum weight fraction leaf, sample as minimum samples leaf but expressed as a fraction of total instance. Max leaf node, it represent with the maximum number of leaf node. And in the last we are having the maximum feature, that should depends upon how many features you are taking to evaluate for a splitting at each node. So that is depends upon the number of attribute. So basically in a decision tree as a regressor, we are going to learn about something based upon a cart algorithm. So what is the full form of cart algorithm? Cart algorithm should be stand for the classification and regression tree. So that is the full form of the cart algorithm. That's why this cart algorithm can work for the classification as well as for the regression task. To achieve a regression task, the cart algorithm follows the logic as in similar like classification part. However, instead of trying to minimize the leaf impurity, it tries to minimize the MSE or the mean square error, which represent the difference between observed and target output. Y minus y hat, it is again look like actual and predicted thing are there. So here, if you can see over here, the particular cart algorithm equation is written over here. If you can get some more idea like J of K and TK, so that will stand for the cost function. MS is already there, and also we have to do everything based upon first sample to the last sample. MSC left and MSC right, the meaning of that one is like from the one node, if you can split your tree, you are getting some left part is there and also right part is there. So at the end, for finding out the cost function, you have to have making some addition between right and left part. So it is the sum of weight by the number of sample MAC for the left and right node after the splits. So that's how we are going with the same thing, and we are getting some more idea about this plot. So these are the plot is there whenever we are trying to see something overfitting is there, some underfitting is there, and how regularization should work. So that is again important thing is there. So here, the graph will represent the regression line if the decision tree is allowed to split continuously and go deeper and deeper without any stoppage. So this is then coming with an overfitted situation. So if you can see here, left hand side graph, it's going to going to think about the leads to overfitting, because here we are not providing any type of the stopping criteria. So that's why the model will not know like when to stop their learning. So that's why it's going with continue learning. So that's why it leads with the overfitting. So what type of take thing we have to go with the for the do not provide the overfitting or to avoid the pruning or overfitting. So for that, the graph represents the regularization where a decision tree is not allowed to split any further if the number of sample in a node falls below 10. So it prevents the overfitting and is more practical to use. So based upon that one, like whenever we can provide the proper regularization throughout the any type of the stopping rules or the ways to regularize the things, if we can work upon that one, so we are able to get some complete idea to avoid the pruning or the overfitting. So that's how decision tree as a regressor should work within the cart algorithm. From the next session we can learn about how decision tree should be worked with the classifier. In this practical session, we have to learn about decision tree as a regressor. So already library is imported over here and also the data set is imported over here. Basically for this practical, we have to use insurance data set. So that's why I can also see now the worst look about the data set. So basically in this data set, we are having a particularly age, average claim per year in terms of the rupees. So totally here basically we are just only having the two parameter. So based upon two parameter, we have to select first parameter as a independent variable and second parameter we have to use as a dependent variable. So here is equals to age and y is equals to average claim per year. So let's make it things according to over here, and for that we have to take an here we have to create x. So x is equals to dataset dot I location, and particularly in I location I want to select all the rows, but in terms of column I want to select just only the zero position of column. That's why I have to take semicolon 1, so it should automatically select the zero position column. And here we have to take the values over here. After applying this one, we have to take an y is equals to dataset dot I location, and particularly in this bracket we have to use all the rows, and particularly in terms of the column we have to take in just only the one column. And after applying that we have to use values. So here x is created and also the y is created. So x will represent the ages and y will represent the particularly average claim per year in terms of the rupees. So now after applying these things, we can also find out some basic information based upon the data type or based upon the data set, and that is the dataset.info. So according to info, we are getting information about the data sets. So totally 10 number of sample is there, and also 10 non-null are there, and also all the samples are related to the integer term with the 64 bit. Many more information we are getting in terms of the particularly basic data analysis stuff. So after applying that thing, now it's time to provide the training set and the testing set. And for the applying training set, testing set, we have to use scikit-learn dot model selection. So with the help of scikit-learn dot model selection, here we have to import a train, test, and split. So we have to use train, test, and split over here. So after applying train, test, and split, now we have to create the x train, y x test, y train, and y test. So we have to take x train. Second thing, that is the x test. Then we have to take y train and y test. So these are the four parameter, and we have to create this four parameter based upon the train, test, and the split. So we have to take train, test, and last one, that is the split. And also here inside we have to take an x, y, and also we have to finalize the test size. So here I want to take it test size is equals to again 0.2. It is also represent training set. It's 80 percentage. And also we have to provide random state is equals to 0. So these are the training and testing split are already done. And after applying this, now it's time to create a first of all decision tree. Once we can create the model, after creating model, we can visualize the regression algorithm in particular based upon the training set and testing set. And at the end, we are trying to create a decision tree with the help of the MSE. So at the end we have to also create particular type of the decision tree regarding to their structure. But now first of all we have to create over here the model of decision tree. For creating decision tree, first of all here we have to import a tree algorithm from the sklearn. So that's why we have to import from sklearn, we have to import the tree module over here. After importing tree module, also we have to import another module that is based upon a decision tree regressor. So sklearn dot tree, we have to import over here the decision tree regressor. So once it was completed, now it's time to create the model. So that's why model name, that is I just only use the model thing over here. And again I have to use decision tree, and then we have to take regressor. Basically, decision tree are also available with the regression and classification. So that's why first of all we have to import the tree, and in the next we have to import the decision tree regressor. If we can work with the decision tree for the classification, so that's why first of all we have to import the tree, and then we have to import the decision tree classifier. So now after applying everything, we can also take it some type of random state, but still we can take it random state is equals to 0 because I don't want to apply any additional thing in my model. That's why. Now at the end we have to apply the model dot feed with the x and y. Here we are not using any type of the x train and y train. Here we are just only apply the model based upon the x and y, because further change we can doing in the next thing. Again we are seeing some more parameter based upon the decision tree. That's why we are using decision tree, then regressor. So here we are getting the same information what we are getting in previous one. Now it's time to visualize the regressor algorithm outcome. So like how it should follow the steps. So for the starting of visualization, first of all, we can start it with the plot dot scatter. So in particular with the scatter plot, we have to provide x values, y values, and also we have to provide the some type of the color over here. So here I have to provide color as well as. So here for sample, always I just refer the red color. After applying these things, in the next things we have to create the plot. So plot dot plot. So plot is the shortcut of the Matplotlib, and inside this function we have to give an x and the second parameter that is depends upon the model dot predict, and with that predict we have to again use of x. So after applying this one, my hypothesis color, like line of hypothesis color is equals to the blue color. So here we are using a blue color in terms of the hypothesis things. And now next thing that is we have to provide the title, x label and y label. I hope now you are easily getting idea how to provide the x label, y label and the title. So you can do it to your own that part. And now I'm trying to show the plot now. So now we have to run these things, and you are getting an idea how decision tree is very correct, providing the regularization according to the samples. So as compared to the regular in particular things of the simple linear regression, decision tree regression are having the more accuracy as compared to the linear regression. Let's check it about based upon one sample checking. We have to check one sample test based upon x test and y test. So particular in terms of age, I can provide one of the inputs over here, and particular I have to take an age of 34. First age is the 34, and in particular second sample I have to take on the second age, that is the 47. So age is 34 and 47, and based upon that I want to make it one prediction. So prediction is based upon the y prediction is equals to model dot predict of age. So here we are getting prediction based upon the age of 34 and 47. So now it's time to test our model. So that's why we are getting some perfect answer. So when the age was 34, so at the same time the claim according to age in terms of rupees, that is the 6,000 rupees, and when the age was 47, so claim was 11,000. So you can also check it the same thing from the data set, so you will get a better idea. So if you can scroll up the things, so you will get an idea about the Yes, when the age was 47. So for whenever the age was 47, so it should between the 45 and 50. So it's related to the 11,000. So we are getting some nearly answer according to the data set. So till now we are getting idea how the decision tree should work. But in next part, in the second part of the decision tree as a regressor, we are trying to plot the decision tree. Now let's see how to create a decision tree. We already implemented an algorithm. Now for making the decision tree, first of all, we have to import many libraries based upon the many different stuff, and we can also learn about what are the things we have to use over here. To create a decision tree, first of all, we are using some external libraries or some extra power of libraries in terms of the scikit-learn. So here we have to import sklearn.external.6, and based upon that library, we are trying to import string I0. So what is the meaning of string I0? Basically, string I0 should be helpful to creating this type of external sources to create this type of the image things based. So we are using most of things related to the string IO. So here we are seeing some long code based upon the string IO. So whenever you want to create a decision tree as a regressor, and then if you want to get decision tree structure, so at the same time you have to use this string IO. String IO, it means it work for the string input and out. So we have to also import many libraries support to get the result based upon the decision tree. So for that we have to use IPython display, because tree is depends upon the display, because all the structure of the tree we are getting in terms of the image. That's why we are getting some more support from the sklearn. Again, we are trying to import sklearn dot tree, and particular from there I want to import the graph viz. We have to use export graph viz. So graph viz, that is a basically visualization library is there that will helpful to get the visualization. So graph viz is based upon the visualization library. That's why the graph viz is very important. Also, we are working with the py dot. Whenever you want to get the images type of things, at the same time we are using with many libraries. So that's why we are importing lots of libraries over here. And last one, import OS. It is the meaning of import the operating system. So here we have to take and given one error, but I think that is depends upon this one. Now it's running. Now in the second part of things, what are the things we are still generated over here? So all the things, first of all, we have to convert into the decision tree algorithm, and once it should convert it, then also we have to convert it all the things in terms of the images. And once we are getting images, and if you want to convert these images into the PDF format, you can also make it that thing as well as. So let's see. For that, we have to create one dot data. So these are the basically Python structure to getting some programming things. This type of stuff we are just only doing with the decision tree things. Otherwise, in other machine learning method, we are not using this type of stuff. So again, we are using here we are using this one, export the graph viz. Also here, particularly in this comma, the bracket, we are trying to using the model of the decision tree, and also we are finding out any files is there or not, and what are the particularly things we are generated over here. Everything can stored in the dot data. So dot data is very important stuff over here. So out file is equals to dot data. Now it's time to create the graph. So to create the decision tree as a regression, and then when we are getting the particular structure of the decision tree, it was a very long process, and you have to keep calm during that process, because sometimes we are getting lots of errors during the make of this type of the code. So again, we are working with the dot data, and after applying of that, we are taken dot data, and with that we have to taken get value. Also, we are using over here the bracket, and now again we are using the graph things, because the code was very long, but it's a standard code is there. It's not look like that whenever you are trying to create a different problem with the decision tree as a regression, so it's not look like that you have to write the again new code. So this code is a very standard code. You are also getting this type of code from the sklearn documentation. Okay, so that is not particularly made by me, but it is the standard code is there. So when you want to get the decision tree data structure or decision tree particular algorithm structure according to your problem statement, so you have to follow the same value or same thing. So everything is completed over here, and now at the end we are just try to get the image of that, and based upon that we are getting some graph, and we have to take and create in terms of the jpg format. So final image I want to get it in the form of the jpg. Now I'm trying to this one, and let's check it out, we are getting an error or not. So we have to check it the things because it looks difficult. Here we are getting an error in terms of the dot data, so we have to check it out where we did the mistake. So the here pi dot graph from the dot data, so that is everything is looks better. Then why we are getting an error, like again dot data dot get value we are having. Also we have to check some previous code as well, as like when first time we are using a get values, so we have to check this code still. So here we have to checking something again and again, so we are getting an error like this one. So yes, now it's created over here, and if you can see over here, so these are the total data decision tree structure. So how it's get, and at the end we are getting the mean square error is equals to 0.0. So that's how the decision tree can provide this type of structure, and according to this structure we are getting an idea how it should work. So at the end we can also write one code like based upon the model dot predict with the help of the x test. So you can also call this these things in terms of the y prediction, so that will gives an idea like y prediction one, because for testing we already created one y prediction, but this is the final y prediction are there. And if you can make it this one y prediction one, so you will get an idea according to your y test all the samples you are getting over here, like in terms of the results. So that's how the decision tree as a regressor should work. And there is a last algorithm in particular with the decision tree in terms of the regression part. In the next, we have to see about the classification techniques, and we should learn about many more things in terms of as well as practically with the classification technique. In this session, we have to talk everything based upon a random forest classifier. In other words, random forest is again depends upon a decision tree. So in the last session, we already completed decision tree. So let's start with the random forest classifier. First of all, we can start with the introduction, basic information, and then we can start about like how the random forest algorithm should work. Random forest algorithm is a supervised classification and regression algorithm. Why it is supervised regression and classification? Because a random forest is again depends upon a decision tree, and decision tree is also able to work with the regression and classification. That's why we are also able to do random forest with the regression and classification. As the name suggests, this algorithm randomly creates a forest with several trees. Whenever we are working with the decision tree, at the same time, our goal is just create one single decision tree. But whenever we are working with the random forest, at the same time, our goal is to create multiple trees. So multiple times we have to create the trees. At the same time, we are getting one forest, and from that forest, we have to select one random tree, and that random tree will give it output, and everything is called as a random forest. Generally, the more trees in the forest, the more robust the forest look like. So similarly, in the random forest classifier, the higher the number of trees in the forest, greater is the accuracy of the result. So in the simple words, random forest build the multiple decision trees called as the forest, and the glues them together to get more accurate and stable prediction. So the forest is built is a collection of decision tree trained with the bagging method. Before we discuss random forest in depth, we need to understand how decision tree work. But that things we already completed, like how to learn decision tree. But when we talk about the decision tree and random forest, so in my mind, the one question will arise. So what is the question of that one? What is the difference between random forest and decision tree? Why we need random forest among the decision tree? Because we already know how to create a decision tree. So let's take one example. For example, you are looking to buy one house, but you are unable to decide which one to buy. So I think you have multiple options, but you are confused like which one you can buy. So you consult a few agents, and they give you a list of parameters that you should consider before the buying house. So what type of parameter they will give to you, like price of house, locality, number of bedrooms, parking space, available facilities. So this type of things are coming over here, and then these parameters are known as predictor variables, which are used to find the response variable. Here's a diagrammatic illustration of how you can represent the problem statement using a decision tree. So this type of things how you can solve. So that is again important thing is there. And again one important point is note to here like the decision trees are built on entire data set by making use of all the predictor variables. But in again in another word if you can understand like after creating multiple decision trees using these methods each tree selects or votes the classes. So whenever we are working with the random forest at the same time what is happening like that we have to try to create multiple trees and at the end we have to getting some average of that all the accuracies. Okay, so average will get getting some more regarding to the all the trees. Okay, so that is the different thing we are getting over here. Like practically we can call like decision tree will choose whether house will buy or not buy. Okay, and the class receiving the most of votes by simple majority is termed as predicted class. Like according to majority we are getting an idea like yes we have to buy this house, this type of thing. And as a conclusion of that one, decision trees are built on entire data set using all the predicted variables, whereas a random forest technique are used to create multiple decision trees. Okay, basically the decision tree should build upon a input data set, but random forest will build upon a decision tree. First we have to build up decision tree and then we are able to make a random forest, so such that each decision tree is built only on a part of the data set. I hope you have to get some better idea about like difference between the decision tree and the random forest. I think these things is clear for you. Now after that the thing is that like why you have we have to use random forest, as well as there is many more consideration are there based upon a random forest. So let's talk about that one, like why we have to use random forest. And we already cleared the idea about like what are the difference between the random forest and the decision tree. So I think many of things is already cleared with this diagram as well. As so we have to create three or four number of times of decision tree and then we have to go with the majority voting or the averaging. Like one can give it to like and the class one is the output, second one gives class two output, and third one can give me answer like again class one. So class one are having majority, so final result was the class one. That's how random forest classifier should be worked over here. But you might be wondering why we use random forest when we can solve the same problem using the decision tree. Because yes, a decision tree, because here we have to create multiple time of decision tree. Okay, so that is the just thing, but those problem can solve by the decision tree, as well as you can also solve that problem with the random forest as well. As but here we have to get some more idea about that. Like even thought like decision tree are convenient and easily implemented, they lack accuracy, but the decision tree work very effectively with the training data that was used to build them, but they are not flexible when it comes to classifying the new samples. So that is the thing we are not getting from decision tree, but here we are getting in random forest. So which means that the accuracy during the testing phase is very low, and this happened due to the process called of overfitting. See, whenever we learn about the decision tree, we have to lots of talk about the regularization, overfitting, pruning. Why? Because of this one. So overfitting occurs when a model studies the training data to such an extent that it negatively influences the performance of the model on a new data. So this means that the disturbance in the training data is recorded and learned as concept by the model. But the problem here is that these concepts do not apply to testing data and negatively impact the model's ability to classify new data, hence reducing the accuracy on the testing data. This is where random forest comes in, and it is based on idea of bagging, like averaging type of thing is there, and which is used to reduce the variation in the prediction by combining the result of multiple decision trees on a different sample of data set. So that's how we are getting idea about the random forest classifier, like how it should applied and how it is more important and more unique things we are getting over here. Again, look like similarly decision tree random forest can also come in terms of the decision boundary type of classes. So how to create a random forest according to the steps. So step one is create a bootstrap data set. So according to data set, it should first of all we have to making some subset from the data set. Then second step we have to creating a decision tree. Decision tree is again based upon a cart algorithm. So what are the steps or what are the process we had done in a cart algorithm as a decision tree? Same thing we have to do again and again over here. Again go back to step one. Again you have to create multiple decision trees, because it's not look like we have to just only around like create one or two decision tree. We have to create multiple decision trees. Then in step 4, we have to go with the predicting the outcome of new data point. Again, we have to evaluate the model. That's how we are able to make a random forest classifier. Again, Those advantage we are getting from the decision tree, same advantage we are getting from the random forest, same applications are there, because the random forest are the advanced version or advanced level of the decision tree. That's why. So this session is ended over here. Till now in this session we have to just focus on the two things, decision tree and the random forest. In a decision tree we can work with the classifier as well as regression, but in random forest we just only discuss about the classifier, because that is the important, because also regression is working look like similarly looks a classifier. In this session we have to do some practical things related to the random forest classification. Before that, we already discussed about like how random forest theory should be worked, and how does the random forest should be much and much depends upon the decision tree. Okay. So basically, whenever we are doing two practical things related to the random forest, the here the mainly things is done by your side. Okay. I just do from my side just only the basic how to create the modeling with the random forest. Otherwise, the visualizing training result as well as visualizing the testing result, and also the basic steps like import the data sets, libraries, everything is decided by your side, or it is done by your side. Okay, so I just guide you like how we can do in these steps. Okay, so for that I can just only show you the what are the basic steps in terms of the comments. So basically, first of all, we are just simply give the name of the file, that is the random forest. So that's why we have to follow with the rf over here. And then I just want to show the some basic steps, like what type of steps we have to gone through this one. Okay, so first step, that is based upon a importer libraries. Okay, so we have to taken the steps related to the import library. You already know like which type of library is necessary over here. So that step can done by your side, that is based upon import numpy and as np, import matplotlib .pyplot as pld, import pandas as pd, and import seaborn as sns. So these four library, it should be imported by your side. So that is our first step. So after that I just give you the time like to complete these things. Okay, so you can take it 10-15 minutes of time to complete all the steps. After that, the second step is based upon a data set. So I just provide the comment over here. We have to go with the import a data set. Many times we already seen how to import a data set, as well as we already seen about like how to import some further things as well as. So here I want to use data set as a social network advertisement data set. Okay, so that is popular data set. We already use the same data set for the KNN method, as well as some logistic regression as well as. So we have to first of all create the data set, and based upon the data set, we have to take an x and y. So that is based upon data set with the I location. So according to that, we can get some better idea. Okay. So once that part should be completed, then we are going to split the training set and testing set. So we can go with the splitting training and train and test. So here you have to remember the things related to the like training set should be train part should be like 0.75, and the testing part should be a test is equals to 0.25. So you don't forget, you have to follow this specification as well as. I can provide the same thing in terms of the markdown. Okay, so it should contain as some type of notes as well as. Okay, and also I don't want to take any type of the random state. Okay, so that's why we have to go with the like random state is equals to 0. So this type of things we have to remember during the coding. Okay, after that what we have to do, we have to apply feature scaling. So feature scaling, basically we are able to apply it with the sklearn pre-processing, and based upon that we are trying to do the things related to the standard scaler. Okay, so we have to import sklearn processing from import the standard scaler, and sc standard scaler is there, and then we have to fit it with the we have to fit it the transform with the xtrain and xtrace. So that's how we are able to complete our feature scaling. So I can also provide the note over here like what type of task we have to done through the feature scaling. Okay. So till now, whatever the work we had seen, so that is just basically depends upon what we already learned things till now. Okay. So everything you already know like how to do the things. Okay. So I just give you the time. You can complete the things. Okay. I just give you some of the time, and also if you want, you can pause the video, and then you can try to solve this. Till then, what are the things we had done? Okay. So based upon that, you can try to do the things, and further things we can see from the next session, like how to and how we are going with the fitting random forest classification to the training set. So that type of stuff we can see in from the next session. But still, you can take some time because I just take some pause over here. Okay, so I think you had completed the task till then. Okay, so now from next session we can start to do how to fitting with the random forest classification to the training set. Okay, so in this random forest practical session, we have to see how we are able to provide the practical things related to the random forest. Okay, so if you can see the input number 5, so from the input number 5, we are getting an idea like how we can settle the things. So here, similarly, like whenever we want to work with the decision tree classifier, so at the same time we have to take an sklearn.tree, import the decision tree classifier. But here we want to work with the random forest classifier, that's why we can go with the sklearn.ensemble, import the random forest classifier. Okay, so here the new thing I was taken over here, like every time I'm trying to return every code, but here random forest technique is coming from the decision tree. Okay, so that's why I'm not spending much time to type the code. That's why directly I was taken the things what are already we had done many times. Okay, so that's why I was directly taken random forest classification code over here. But the main thing is over whenever we are trying to create some new classifier. Okay, so classifier is again depends upon the random forest classifier, and also it is again depends upon like from the decision tree classifier which algorithm you wants to use. Okay, so basically we had seen like decision tree algorithm are working with the cart algorithm. Okay, decision tree technique should work with the cart algorithm. So similarly here I want to work with the random forest, should we create multiple decision tree, but how many decision tree should be created. So whenever we can decide the n estimator is equals to 10, so at the same time, the random forest classifier should try to create 10 decision tree. After that, we have to take on criterion is equals to Gini. It means again, inside the random forest, the particular decision tree technique should be worked. And inside the decision tree technique, it should be cart algorithm should be run over here. So again, we have to provide random state is equals to 0. And after once model should be created, we have to train the model based upon X train and Y train. So here we are getting the things like number of estimator is equals to 10. So based upon that, we are trying to create the predicting the test results. So for that, we are trying to create the Y prediction. So again, Y prediction is based upon classifier dot predict of X test, because what are the prediction coming from the X test, it should become the Y prediction. And from the Y test and Y prediction, we are already known how to create the confusion matrix. Once the if here we have to, if you want to see like what are the values of confusion matrix, you can get the confusion matrix like this one. And once you can complete this one, then again similarly code we have to use like training set results, and as well as for the testing set results. We already learned the logic behind this long code in from the logistic regression, like why we have to taken this uh, very huge things over here. So now simply I have to run this code, and whenever I'm trying to run this code, so I'm getting this type of result during the training set. Okay, so majority we are seeing like in particularly mostly in green area we are having some green point, and in a red area we are getting some red points. So no, not a much misclassification are seen over here, because everything is looks perfect over here. So after training set, now we have to visualize the testing set results. We already seen the training set results, and basically in a training set results we had taken 75 percentage, and in a testing set results we had taken just only 25% results, so 25% of data. So that's why we are having less data sets over here, so that's why we are not getting much samples over here. And also the accuracy of the training set as compared to training set results, we are getting high accuracy in testing set results, because due to the sample is less. Okay, so that's how random forest solution we are getting over here. Like this how big, but basically the random forest is mainly depends upon the decision tree techniques. So that's why we are not able to find out many more coding difference between decision tree and classic random forest, because here we are not able to getting one of the tree, because whenever we are doing some practical things based upon a decision tree classifier, so at the same time we are getting the tree structure as well as, but in a random forest we are not able to getting any type of the tree structure. So the basically the coding based upon a random forest technique that should be ended over here. First of all, we can start with the support vector machine as an introduction. Once we get an introduction about the support vector machine, that's after that we can take it some mathematical aspects related to the support vector machine. Once mathematical completed, then we can go with the SVM, hard margin and soft margin classification. Once hard margin and soft margin classification should be done, then we go with the regularization. After regularization, we can see about some non-linear support vector machine classification things with the different type of kernel tricks, and at the end we can discuss about how kernel work with the support vector machine. Let's start with the introduction of support vector machine. So here, a support vector machine was first introduced in the 1960s and later improvised in the 1990s. It is supervised learning machine classification algorithm that has become extremely popular nowadays owing to its extremely efficient results. And support vector machine is implemented in a slightly different way than other machine learning algorithms. It is capable of performing classification, regression, and outlier detection. Support vector machine is a discriminative classifier that is formally designed by a separative hyperplanes, and it is a representation of example as point in space that are mapped so that the points of different categories are separated by a gap as wide as possible. In addition to this, support vector machine can also perform nonlinear classification. Let's take a look about at how support vector machine should work. Support vector machine classification algorithm used to assign data to various classes, and they involve detecting hyperplanes which segregate data into the classes. Support vector machine are very versatile and also capable of performing linear and nonlinear classification, regression, and outlier detection that we already discussed about that. Once idle hyperplanes are discovered, new data points can be easily classified. The optimization objective is to find the maximum margin hyperplane that is the farthest from the closest point into the two classes. So these points are called as a support vector that is already determined in this diagram. In the given figure, the middle line represents the hyperplane. So from the middle line, we are able to classify what data are positive and what data are the negative is there. The main objective of a support vector machine is to segregate the given data in the best possible way. When the segregation is done, the distance between the nearest point is known as the margin. So the approach is to select a hyperplane with the maximum possible margin between the support vectors in the given data sets. To select a maximum hyperplanes in the given sets, the support vector machine follows some particular type of the set, like generate the hyperplanes, which segregates the classes in the best possible way, as well as select the right hyperplane with the maximum segregation from the either nearest data point. So that's how support vector machine basically should work. Now, from the next session, we have to discuss about how support vector machine should work in terms of the mathematically. In this session, we have to talk about how mathematically we are working with the support vector machine. So the hyperplanes with the larger margins have lower generalization error. So higher margin or the maximum margin, it's a good condition because at the same time we are not getting any type of the generalization error. So it should fit it as an regularization. So the positive and the negative hyperplane are represent look like W0 plus W transpose X of positive. So whenever we are getting some positive samples, it represent within 1. And whenever the things are related to the negative, we are getting something based upon minus 1. So the same information are already provided over here. The classification of any input sample X test, it is work look like if W0 plus W transpose into X positive or X test is greater than 1. So those values are greater than 1. Those sample of X test is said to be in the class towards the right of the positive hyperplane, and those are considered as a minus 1 that should consider from the towards the left of the negative hyperplane. So right hyperplane and left hyperplane should work as a positive hyperplane and the negative hyperplane. So that's how it should work. But when you subtract the two equation, you will get this one. So which two equation? When you subtract W0 plus W transpose, X positive and the X negative, this equation, if you subtract, you are getting X positive minus X negative is equals to 2. So see, Here again we are getting some lots of mathematical equation, but during the practical we are not writing any type of the equation because we are having the scikit-learn library. So based upon that we are doing everything. Length of vector w is considered as L2 norm of length. So w is equals to summation j is equals to 1 to m. Again we have to provide w square of j. So at the same time we are getting idea over here. And once you normalize with the length of wt0, arrive at this w transpose of x positive minus x negative, and magnitude of weight, it's w. So w will represent the magnitude of weight. Okay. So and also we are also having some biases as well as, so b will represent the bias, but w will represent the weight over here. So 2 by w, so that should work over here. After taking about the knowledge related to the mathematical, next thing what we have to discuss, that is the hard margin classification and the soft margin classification. It is again an important part is there. So the left side of equation for the support vector machine 1 is given above, can be interpreted as the distance between the positive and negative hyperplanes, and in other words it is the margin can be maximized. So what are the hard margin? Whenever the positive hyperplane, like a from the hyperplane, positive samples and negative samples are having large distance. Okay, so if they are having large distance, it is called as a hard margin. But if it is margin is not hard, margin is just a little bit okay, but how you can maximize that margin? So for that you have to take an 2 divided by magnitude of weight. So at the same time it's try to maximize that margin with the constraint that the samples are classified correctly, which is represented like that one, like w0 plus w transpose x, w transpose x of I greater than or equal to 1 if y of I is equals to 1. And also 1 and minus 1 are again working over here, and this means that you are minimizing the magnitude of weight. So for minimizing magnitude of weight you have to go like that one. Still in the same thing, this also means that all positive samples are on one side of the positive hyperplane and all negative samples are on the other side of the negative hyperplane. And this can be written consistently like as what here mentioned. If you want to minimizing magnitude of weight is the same as minimizing the one half weight square. So this figure is better as it consider differentiable even at w is equals to 0. And the approach listed above is called as hard margin linear support vector classifier. So that's how hard margin classifier should be worked in a support vector machine. After hard margin, let's talk about how soft margin classification should be worked. To allow for the linear constraint to be relaxed for the non-linearly separable data, a slack variable, so there is a theta, that is a one notation is there, so that can notate the slack variable. And so for that we have to introduce a slack variable, and slack variable measures how much input instance is allowed to violate this margin. So see, whenever the hard margin is there, so that is okay, so that is look like a linearly separable. But whenever we are getting some soft margin, like near the hyperplane or near the hypothesis, if we are getting any type of the sample, so those sample we have to provide to that sample to the slack variable. So slack variable is simply added to linear constraint. So after adding the slack variable, the not those vectors are related to the hyperplane, that should go away, and subject to above constraint to the new objective to be minimized becomes. So that's how it should work over the soft margin classification. Again same thing is there, like how to maximize the margin and how to minimize the margin. Like you have two conflicting objectives are there, like minimizing the slack variable to reduce the margin violation, and minimizing one half w square to increase the margin as well as. And the pi and the hyper parameter c allows us to define the trade-off as well as. And large values of c correspond to large error penalties, whereas smaller values of c allow for higher misclassification errors and the large margins as well as. So that's how we are getting an idea like how it should work over there. Okay, so once you can get idea about that one, so from the next session we can also discuss about like how we can apply the regularization in the support vector machine. So we can get idea about support vector machine with the regularization. In this session, we have to discuss about SVM regularization. So the concept of C is a reverse of regularization, and higher C means lower regularization. So whenever we are getting the value of C is higher, so it means regularization is not coming properly. And when the C value is lower, so it means regularization is higher. So similarly, which increase the bias and lowers the variance, causing to the overfitting. So if you can see over here, the left hand side image at the same time the red samples and green sample both are very nearly to the hyperplane. So at the same time, large value of C. So we are not getting proper regularization over that. But if you can see the small value for C, so at the same time we are having some hard margin or large margin. So maximum margin you can also consider that one. So at the same time, the value of C should be small, but the regularization it should looks very good. Let's see something based upon iris data set. So the iris dataset contains the measurement of 150 iris flowers from three different species: Setosa, versicolor, and the Virginica. So here we are having three color, and based upon these three colors, so here we are just only these three color. These three classes is there. It's not color, but it's three classes is there. So based upon these three classes, we have to create one type of the decision boundary based upon a support vector machine. So each row represent one sample. So flower measurement in centimeter are stored as a columns, so these are called as features. So we already know like sepal length, sepal width, petal length, and petal width are the features, as well as class label is targeted as a Y, but these four targeted as a input X. So that's how we are getting an idea. But if we have to do make some model based upon a support vector machine over here, so we can make it like this one. So from sklearn.svm import svc. Svc stand for the support vector classifier. Here we are going with the linear classification. Okay, support vector machine should work for the linear model as well as non-linear model. When you want to go with the non-linear model, you have to use some kernel trick or kernel svm. But whenever we are going with the things, whenever we are going with the things like a particularly linear thing, so at the same time what we have to do, we have to go with the kernel of linear thing. So after applying linear classification with the linear kernel, then we have to fit it X train and Y train together, and then we have to find some decision boundary, and then we have to take an X label, Y label, and legend, and then we have to show everything together. So that's how iris with that iris dataset we are getting SVM. This is just for your information, that's why I just taken very fastly regarding to this one, for because you are getting an idea like how it should goes with the support vector machine in linear way, because also we have to see like how it should work within non-linear way. So let's start it with how we can find out same thing in a non-linear classification. So that is a non-linear support vector machine classification. In some cases, hyperplane cannot be very efficient. In those cases, the support vector machine uses a kernel trick to transform the input into a higher dimensional space. With this, it becomes easier to segregate the points. Let us take a look at this SVM kernel after, but first of all, we have to discuss some basic thing related to that one. There are two ways to solve the nonlinear support vector machine, either by adding polynomial features or by adding similarity of the features. So the polynomial features can be added to the data set. In some cases, this can be create linearly separable data set as well as. If you can see over here, so that is the left hand side we are getting just as an overview of things. But if this same thing we have to convert it into the two dimension or the three dimension, so we are getting this type of thing. And also we are able to draw the particularly inversely bell curve. So throughout the inversely bell curve, through this red line, we are creating one hyperplane. So that hyperplane can separate the blue samples and the green samples. So that type of thing we are able to do over here. So in this figure on the left, there is just only one and feature x1 is there, but in right, whenever we are trying to convert into the two dimension or three dimension, we are getting this type of stuff. And if you add x2 is equals to x1 of 2, so the data becomes linearly separable. So that type of difference we are able to generate over here in this particular nonlinear support vector machine classification. So in a support vector machine or the nonlinear support vector machine classification, we can also get in polynomial kernel. So polynomial kernel, that is one of the important approach from the nonlinear SVM side. So in a scikit-learn, one can use a pipeline class for creating polynomial features. So the classification results for the moons data set are shown in this particular figure. So here we are getting one of the like waves or type of shape is there, but that shape is nothing but it's coming from the polynomial kernel, and polynomial kernel depends upon the number of degrees. So degree can depends upon that one. So due to the degree, we are getting this type of output over here. So for large dimensional data set, adding too many polynomial feature can slow down the model. Okay, so if we are having large of data set is there, and if I can provide the lot a degree like degree to 10, so it's not work properly because it's try to coming as a overfitting, so it's not proper. So you can apply kernel trick with the effect of polynomial features without actually adding them. And the code shown below trains an SVM classifier using a three degree polynomial kernel, but with a kernel trick. So here, if you can see on a first diagram, so it looks proper. But whenever we have taken d is equals to 10, so the difference or the shape is totally different, and it's also trying to overfitting. So that is not I want during the nonlinear SVM. So that is again important thing is that. So after that, let's talk about some of the more thing about polynomial kernel. As a just equation, the coding is there. Like whenever we have to take in with linear, like linear kernel is there. So here we are able to take kernel is equals to polynomial. So throughout this type of polynomial kernel, we are getting an idea like how it should work. So the hyperparameter coefficient of theta controls the influence of high degree polynomials. That how it should work over there. After that, the next topic related to that in non-linear part, that is a kernel, as we mentioned. It's very very important part is there, because an support vector machine kernel basically adds more dimension to a low dimension space to make it easier to segregate the data. So here we have to convert the things from low dimension to high dimension, and once we are getting from high dimension, and at the level of high dimension we have to create hyperplane, and again high dimension to we have to convert into the low dimension. So we have to provide the power, and again we have to do square root to get some proper solution. So it converts the inseparable problem to separable problem by adding more dimension using the kernel trick. A support vector machine is implemented in practice by a kernel, and the kernel tricks helps to make a more accurate classifier. Let's take a look about the different type of kernel in the support vector machine. So the kernel SVMs are used for the classification of nonlinear data. We already talked about the polynomial kernel, but now we introduce like how properly kernel SVM, because just only not a polynomial kernel is there, Gaussian kernel is there, then also quadratic kernel, cubic kernel, lots of kernel is there based upon like powers of things are there. So in this chart of this particular image, nonlinear data is projected into the higher dimensional space via the mapping function. So theta, it's represent with the mapping function. If you can see in this diagram, we are just only having this data points is there. With these data points we have to convert into the three dimension we have to provide the hyperplane. Once we can provide the hyperplane, again we are getting this type of things, so where it becomes like linearly separable, how it should work over there. In the higher dimension, whenever we are getting some three dimension is there, so in a higher dimension a linearly separating hyperplane can be derived, and it is used for classification. Because hyperplane, what is the actual work of hyperplane? The actual work of hyperplane, that is the classification. So a reverse projection of the higher dimension back to the original feature space take it back to nonlinear shape, and that's how it should work over there. Also, if you can get some more idea about like how it should goes when it's combined. See, if you can see over here, again it's representing two dimension. If I should convert this image into the three dimension, so I'm able to classify this thing. If I can convert into three dimension, but in two dimension it looks very difficult to classify, but in three dimension it looks easy to classify. So we are getting four type of classes over there, so that's how we are doing the same thing over there. So as mentioned previously, support vector machine can be kernelized to solve the nonlinear classification problem, and that is the just coding for that one. Like how this is just only code like how to implement these data points, just only that one. Otherwise it is not much related to the nonlinear SVM. This is just how with the help of which code you can plot this type of points over there. Okay, otherwise after you are getting this one, based upon that you can also provide the kernel approach, and you are getting some proper solution over there. So it is again use the kernel trick to classify. Yes, so this is this one. So once we are getting this one, and again based upon this we have to we are providing any type of the kernel trick over here, and after applying kernel trick we I'm getting this type of binary classification. But it is not depends upon the logistic regression, it is depends upon the kernel support vector machine. And if you can see over here, kernel is equals to RBF. So meaning of RBF is a radial bias function. So radial bias function is nothing but a Gaussian function is there. So that's why there is a multiple mathematical function are working over here. So at the same time, whenever we have to take an RBF function, we have to use some gamma value, C value. But when we are going with the polynomial kernel, we have to find out some degree value, like degree is equals to 1, 2, 3, whatever the degree you can take, that is depends upon you. But that you have to take on that one. So after discussion about all the things related to the support vector machine in terms of linear classification and non-linear classification, let's end it with all the things with the machine learning application or the use cases. Basically machine learning in the particularly in the machine learning support vector machine, it's working as an advanced level of the logistic regression. When we want some beginner level of application, we are using logistic regression, but we want whenever we want some advanced level application, so after next level of logistic regression, that is a support vector machine is there. So in the support vector machine, we can use face detection is there, text and hypertext categorization is there, classification of images is there, bioinformatics is there, protein fold and remote homology detection is there, handwriting recognition, generalized predictive control is there. So many more tasks is there. It's not look like just only one or two tasks is there. Also there is a many tasks is there. Let's talk about some of the advantage and the disadvantage of the SVM. So first we can start with the advantage. So effective in high dimensional spaces, also still effective in cases where the number of dimension is greater than the number of samples. Okay, like we have to work with the 2 dimension to 3 dimension, and again from 3 dimension to 2 dimension we have to come. It uses a subset of training points in the decision function that makes it memory efficient, and a different kernel function can be specified for the decision function that also make it versatile. So this all task is very important related to the advantage of SVM. Let's talk about some of the disadvantage of SVM. So if the number of features is much larger than the number of sample features is larger than the sample. Like we are having 10 samples, but the feature are like parameters are having 20, 30 parameters is there. That's why. And avoid the overfitting in choosing kernel functions and regularization term is crucial. So the support vector machine do not directly provide the probability estimates, and these are calculated using five-fold cross validation. So there is a depends upon multiple type of dimension is there, and we are not able to provide the probability estimates. So that's why we can go with the five-fold, like k is equals to 5 cross validation. We can go with like that one. So that is depends upon the data set part of that. Okay, so basically the whole the SVM module or the session is completed over here, and we discuss everything related to linear and non-linearity in terms of kernel as well as the further things we can learn in particular practical session of the SVM. In this session, we have to learn about a support vector machine practical things. During the theory part of the support vector machine, we already discussed about a linear classification and non-linear classification. Basically, in this problem or in these practical things, we have to go with the social network advertisement data set, and that is work as a linear classification. But also with that, similarly we can also try the non-linear approach over here. So during the linear approach and non-linear approach, we are getting both the times the different output. So that's why we are getting some more idea about like what are the variations we are getting during the different approach like linear and non-linear. We already known about the basic steps related to the import the libraries. So same libraries I can import it over here, and after that we have to import the same thing what we can done in a further all classification techniques. Okay, whenever we are trying to learn any type of the project, or whenever we have to do the at the end of these course we have to try some projects. So at the same time in that project we can explore some more things, because here we have to do some classification, or we have to do some find out some difference between all the techniques. So that's why we have to use same data sets for all the classification techniques, so it should give the better idea like which technique is best for this particular suitable data sets. So first of all we can start with the import the library, then second step that is the import the data set. After importing the data set we have to do some training and testing split, and then we know we have to apply the feature scaling. Now the main part is coming over here when we talk about the fitting support vector machine to the training set. Okay, so till now whenever we have to tested like decision tree as a classifier, so decision tree classifier we have to use random forest classifier, we have to also use the k nearest neighbor, that type of things we have to use. But whenever we are working with the support vector machine, so support vector machine it's a technique, but it is known as the support vector classifier. So that's why from scikit-learn.svm we have to import svc, and after that we are trying to coding with the classifier is equals to svc, it's stand for the support vector classifier. And the main thing is started from over here. First of all we have to see about some linear approach. Okay, so when we want to go with the linear approach, at the same time we are just only simply applied over here the linear. Okay, here, okay, yeah, that is the correct. So we have to just simply apply the kernel is equals to linear and random state is equals to 0. So that's how in a simple manner we have to go from over here, and simple we have to run these things. So we are getting kernel is equals to linear because we have to solve applied over here the linear approach. In a non-linear we are also using the polynomial kernel, we are also able to use radial bias function in terms of Gaussian kernel type of things. Okay, but first of all let's see what type of output we are getting during the linear kernel. That is the main thing is there. After defining these things, now we have to try to define the y prediction as well as. So during the y prediction, we are getting some results based upon y prediction, and at then we are trying to predict the confusion matrix. So let's say in a confusion matrix, we have to see like what type of output we are getting over here. So basically, true positive are 66 are there, and the false negative is 24. So mainly, I just concern with the true positive. Like among the 100 samples, in how many samples it should provide the correct actual output, and it means like we have to define the things like how many times actual output and predicted output should be similar. So 66 times it should happen over here. So similarly, regarding to the linear kernel, now we have to test it the things like what are the graphs we are getting during the training set and testing set. Okay, so this type of like a sigmoid we are getting over here. So whenever at the same time we are getting some type of idea like whenever we are trying to apply the support vector classifier with the linear kernel or the linear approach, we are getting similarly output look like a logistic regression. Okay, in terms of the binary classifier. So this type of output we are getting from training set based upon training set and as well as with the help of the testing setup. So in a both way we are getting the same output. But now the main things we have to see, like till now we are still I can only apply the linear approach. Now I want to apply over here the non-linear approach, and that is based upon a Gaussian function. So Gaussian function stand with the RBF. Okay, and when we are going with the RBF at the same time, if you want to provide the value of gamma, so we can also able to provide the value of gamma over here. So let's check it out. Yes, so we are able to over here the value of gamma. So what type of value we have to taken? So whatever the value we can taken like 0.3, that type of value we are also able to taken. I just forgot to take comma. Yeah. Yes. So that is based upon gamma. You can also increase the values of gamma. I just for simply taken, I have to take an RBF. RBF which stand for the radial bias function. It is also known as the Gaussian function. But now we are getting some main idea over here. So here the true positive was 66, but after applying over here the radial bias function, I'm getting the 64 true positive. Okay, so what I can do over here, I'm also able to do these things over here. Like I can increase the gamma. So let's see what type of changes we are getting. No, I was trying to increase the gamma, but still the true positive is 64. But if you can see over here, it should become 26 to 29. So this type of difference should be created whenever you can apply the different approach. Let's check it out the same thing based upon training and testing set visualization. Okay, so when we go with the linear approach, at the same time we are getting some sigmoid type of curve. But when we are trying to apply the RBF, it's a Gaussian or Bell curve. So at the same time we are not getting any type of the sigmoid curve. It's related to the Bell curve is that in part of the training set. As well as if we can check the testing set, so same type of shape we are getting over here in terms of the RBF function with the training set. Sorry, testing set. Similar way, we are also able to provide the polynomial kernel as well as. Let's see how to apply the polynomial kernel. So simply we have to replace the polynomial is equals to kernel, and whenever we are working with the polynomial, at the same time we are also able to take degree over here. So we if we can take a degree, so it should provide the more flexibility. If I currently I have to take degree is equals to 3. So polynomial kernel should work in terms of the degree. That's why. So let's check it out what type of true positive we are getting. Yes, now at the same time we are getting highest true positive with the polynomial kernel, because when we apply the linear approach we are getting 66, but when we apply the RBF kernel we are getting 64 true positive. But when we applied the polynomial kernel at the same time, the true positive should become a 67, and if you can compare with the false negative it should become 19. So it's a very low. In previous one we are getting 26, 29, that type of true negative, the false negative we are getting, but here we are getting less false negative. So that is again important part is there. And also we have to check some output based upon training result. Yes, now it's trying to more fitted over here in terms of the polynomial kernel. The same changes applied over here as well as. But still let's apply the degree is equals to as replacement 3 I have to take on 6 and try to do some more thing over here. Yes, now again it should become 64, and again it should also reflect over here. Yes, so whenever we are trying to change the angle of this one, so it can also affect our accuracy and true positive and all the parameter based upon a confusion matrix. So that is again based upon a degree. So every degree can provide you the different shape. So that's why let's go with the degree is equals to 5. So we have to get idea like it should provide better thing or not. Okay, it should again provide the two positive is equals to 67. So basically, it should become based upon a degree. So let's take a very small degree, like degree is equals to 2. It should provide us the good output or not. Okay, it should provide not good output because the 60 it should become. Yes, yes, it shouldn't be good. Okay, so that's why whenever you are applying a different type of the kernel, and with the kernel, if you can go with the radial bias function kernel, and in that particular kernel, if you can change the value of gamma, so it should also depends upon your output. So that's why during the coding of this type of stuff, so it is very important, like in which manner and what the way you are going ahead with this codings. Okay, so basically over here the support vector machine practical should be completed over here. So, what is our task during this project of HR analytics with that job change of data scientists? So, at the same time, we are trying to predict who will be moved to a new job. So, basically, it look like it is some type of classification problem because we have to find out which employee will continue with the job and which employee will going with the new job. So, let's talk about what are the context and content are available related to this project. So let's talk about some background related to the HR analytics project. So we can start with like a company which is active in big data and data science wants to hire data scientists among people who successfully pass some courses which conducted by the company, and many people sign up for their trainings. So company wants to know which of these candidates are really wants to work for the company after training or looking for a new employment, because it helps to reduce the cost and time as well as the quality of training or planning the courses and categorization of the candidates. Information related to the demographics, education, and experience is enhanced from the candidate sign up and enrollment. So basically, for this, we are using this one type of the HR analytics data set, and this data set is designed to understand the factors that lead a person to leave current job for HR researches too as well as. So by the model, like by the machine learning model that uses the current credentials, demographics, experience data, you will predict the probability of a candidate to look for a new job or will work with the company, as well as interpreting affected factors on employee decision. So basically for that, in this project we are getting an idea. We are trying to discuss about some classification models like logistic regression, are there decision tree, random forest, that type of classification model we can evaluate. But before that, we have to get some data pre-processing, data analysis, and data preparation process as well as. So let's talk about some more related to this project, like what we want regarding to this project. So basically, currently we are discussing about the summary of the problem statement. We are not discussing about the really what challenges we can find during the machine learning modeling, but we are just only talking about the summary related to data set information. So there is one note is where data set is imbalanced. Okay, so we have to do some more data pre-processing things or data preparation process because data is imbalanced. That's why. The second thing is most feature are categorical, nominal, ordinary, and binary is there, and some with high cardinality is there. So still we can play with some type of feature with in terms of category wise, and missing imputations can be a part of your pipeline as well as. Okay, so basically these data sets are also having some missing values, so we have to also balance some missing value as well as. So lots of, I think regarding to this thing, when I'm getting an idea, I have to work lots of things based upon some data pre-processing part. And what are the inspiration of this task, like what are the objective and motive of this task, like predict the probability of a candidate will work for a company and interpret the model such a way that illustrate which feature affect the candidate decision. So we have to take a decision like candidate can take the data scientist or machine learning job or not. So that type of things are coming over here in terms of inspiration. But still, whenever we can learn about some of the practical things, so we can get some more idea about this project, like how the project should work over here. So this session is ended over here, and from next session we can start the work based upon practical. Like first of all, we can start with the implement the libraries, like how library should work, and then so on we can trying to import the data set and go on we can work on that. So basically in this session we are just only discuss about like how the problem statement should be work and what are the summary related to the data set information and what is our final inspiration, like what is our objective to complete this project. So Let's start the practical thing based upon HR analytics project. So I already provide the name over here, HR analytics of this file. So whereas we can work based upon a job change prediction. So already in previous session we can discuss about like how what are the content are there and what are the context are there, and how we can go further with this project. Okay, so still we can discuss about like the how abstract should define over here. Data science is attracting a growing number of professionals in a managerial or the analytical role, especially those interested in the directing their careers to the new digital life. Okay, so based upon the one big company is there, and that they can assign some roles for related to the big data and data science, and everything we can discuss like how it can helpful to us. And from a human source management perspective, the company wants to know like which of the these candidates really want to work for the company, or they are looking for a new jobs as it helps to reduce the cost and time, as well as for the quality of training or planning for courses and candidate classification. So important information may pertain the demographics is their education experience and hand from the register and enroll the candidates. Therefore, basically, in this notebook, what we have to decide, or in this particular session, based upon this practical project number one, what we have to decide. So, in particular, we have to attempt to understand what factors that lead to a person to work for the company or switch his or her career path to the data scientist. And in the particularly next step we can also apply some different model using the existing credential demographics experience data to the predict the probability of candidates looking for a new job, or it will work for the company. And basically this notebook or this project is synthesize the model that can be used to predict employee possibility to switch their careers to a data scientist. So basically we have to find out the probability related to how many candidates can switch their career into the data science. So first part is based upon import the libraries, because here we have to work based upon some data cleaning, model creating, prediction, recommendation, submission, many more things are there. But first step it's based upon import the libraries. So that's why we can start with the library part. So all the whole project we can see in part of the steps like first step, second step. That's how according to the steps we can trying to solve this whole project. Okay, so first part is based upon a library. So I can provide over here the comment like import libraries. Okay, so you can get idea like how the step by step schedule should be worked over here. So basic library we have to talk about. So first library, that is the NumPy as NP. Second library we already known, yes, there is a NumPy as NP, not ANS. Okay, so second thing is the import pandas as PD. So these are the basic two library are there. Every time we have to use this library, but still according to the pandas, NumPy, still there is a Seaborn Matplotlib is still important is there. Okay, so let's import the Matplotlib library. Import Matplotlib dot pyplot. We already know why we are using dot pyplot and everything. Okay, as PLT, and the last library, basic library, that is the import Seaborn as SNS. Okay, so that is the basic four libraries there. Also, if you want to remove some warning during your code, so you can also import one more library that is based upon import warnings. So that is your individual choices there. If you don't want to take this type of library, you can't take it. But if you want to like remove some basic warnings based upon your coding, so you can take it import warnings. And whenever you can try to import the warning, at the same time you can also try to ignore warning. So how you can ignore the warning? So for that again you have to call the warnings dot, you have to provide some ignore comments. Okay, ignore things. So that's why we have to take an warning dot filter warnings we have to taken, and then according to the comments double quotes we have to provide the ignore over here. So that's how we are getting some better things. Let's check it out, everything was going correct or not. So I have to run this code. So basically it should take some of the little couple of seconds to run this code, but everything is looks proper, and the code was running properly like NumPy, NP, Pandas, Matplotlib. We already know like what is the objective behind the NumPy, Pandas, Matplotlib, and all the libraries. Okay, so that's how we are going. Okay, so once we can completing with the import the library, the next thing is depends upon import the data set. Okay, and once we can trying with the import data set, then we are focusing based upon a data cleaning. because we already learn about some part related to like what are the inspiration are there, what are the context and content and important notes are there, because data is imbalanced, okay, also missing values are there. So we have to understand about all that parameter, like what are the important things and what are not important things. So let's see how to import a data set. So here I just want to import a data. And once the data import thing should be completed over here, the next thing that is what we have to do over here. Here we have to just a simple concern about like what and how many data sets available. Okay. Till now, whenever we are working with the machine learning modeling, at the same time, I just only try to implement one input data. Okay. But here we are working with the 70% training data and 30% testing data, but different data set. Okay. So for this particular task, I want to use two data set. One data set prefer the training data set and second data set prefer the testing data set. Okay. So training data set it's refer as a data is equals to, we have to use pd dot read underscore csv. We already know why we have to take an pd dot read csv, because pandas library can do everything related to the reading the on input data set. That's why we have to take an pd dot read csv. And now I have to provide the data name like augmentation are there. So ogle, then train is there because training file is there and based upon csv. So don't worry, in this course section you are getting every details related to that one. Okay. So whenever we can share with you like course material. So in course material data set you are already having this train csv and test csv. Okay, and you already know how you can arrange, how to arrange this file in your location folder. Okay, so that's how you are able to easily located your coding file or located your data sets easily in particular current folder. So that is the input data is there. And now let's talk about the test data. So that is the train data is there, it's known as data, but test data is again look like similarly read pd dot read csv. And inside again we have to take an aug, and then we have to take an taste dot csv. Now we have to run this code. So data and taste both things are evaluated over here. So let's check it out, like a data dot head of 5. So here whenever we have to take this one, so we are getting the first 5 samples in our training data set. So first 5 sample you are getting like this one. If you want to find out first 3 or first 4, you can also take it like this one, like data set or the data dot head of 2. So you are getting over here just only first 2 samples over here. If you can see over here in training data set or testing data set, both the data sets are having same features. Okay, but now it's time to talk about the features. What type of features we are having during this coding or in this from this data sets? The first feature, that is the enroll id is there. So enroll id, it stand for the unique id for enroll, like how many candidates or employees should enroll for this one. So their individual ids is there. City, so city will stand for the city code. City development index is there. So development index in the particular city according to the scale. Gender for of the enrollment, like which gender will represent with the enroll, like male are there, female are there. So relevant experience, because we have to find out the candidate are having experience related to the data science or machine learning. So that type of thing we have to evaluate over here. So relevant experience for the enroll. Next thing, that is the enrolled university. So if sometime if university that was good or high university, premium minister university is there, so that's why universities matter, like the what are the name of the university. After that, education level is again important, because if the particular student or candidate can do some courses or do some degrees in particular data science field, so that helpful for them. So that's why education level of the enroll, major discipline like related to the education, major discipline of enrollment. Experience are there, so enroll total experience in years, so candidate total experience related to that one. Company size, number of employee in current employee, company type of current employer, like which type of employment they can done till now. So that type of things we are getting over. Training hours, if some employee can take on training related to the data science in 20 hours, 30 hours, so that can also important over here. And last one, that is based upon a target. So target consider 0 and 1. So what is the meaning behind the 0 and what is the meaning behind the 1? So basically those all are the thing related to the candidate or the employee. Okay, so employee, whenever employee are having 0, so it is meaning is like not looking for a job change. So those employee are having the zero things. I think they are don't want to convert their job into the data science engineer or the data scientist or machine learning engineer. But whenever we are getting one, so it is the meaning is like that, looking for a job change with the data science. So for example, the employee before they are done tasks related to the software engineer, but if target is one, it means in future he wants to connect it with the data science role. So that type of things we are getting over here according to these features. Let's talk about some more thing related to the basic information extraction are there, and some part of the things we can see in the next session. But let's see, find out data types over here. So we are getting an idea how many floats are there. And sorry, we are just only taking data types is there. It's a data d type should command is work. Okay, so I forgot to d. Okay, yeah. So these type of things are there. How many integers are there? How many objects are there? And how many floating point is there? So float is related to the city development index, and target is there 0 and 1. So that are the floats. Otherwise, mainly we are getting over here the objects are there. Like these all are the objects are there. But here the one main thing is that, but the categorical variables for that what things we can apply. Like yes, first I need to deal with the categorical variables, okay, because those are categorical variables. First we have to deal with that. So columns which have values different than numbers, okay. So a simple way of selecting all categorical columns is by checking their type. And thus in the databases only four columns are the four numerical data. So based upon that we are having the four columns are there that can consider the numerical data, okay. And up to 10 columns are the categorical variable type, because if you can see mainly you are getting object, okay. So that's why we are getting idea these are based upon some categorical variables. And whenever if you can see the integer 64 is very less time is there, so around four column are related to the numerical data. Still let's find out how on where we are getting some missing values, okay. Missing values or is the like zeros values, okay. So let's find out how many missing values or zeros value we are getting over here. So for that, again we are using one of the important function from Panda, that is the is null function. So according to the is null function, we are getting an idea how many times we are getting some missing values. Let's check it out through this code, because this code is half completed is there, but still we are getting the things related to the false too. But the data set size is very long. So how I can find out, like particularly from Android ID, how many missing values are there? From city, how many missing values are there? For that, once we can apply data dot is null, at the same time we have to again add one more function, and that is the sum. So after applying the sum function, if we can run this code, so we are getting over here the base idea. So from Android ID column we are having zero missing values or zero null values. In city, zero null value. But when we talk about the gender, enroll university, education level, major discipline, company size, company type, latest last new job, so at the same time we are getting some number. So that is nothing but is the like zeros values are there, okay. So we are getting zeros values like, and in some of the column are having zero, so none of the value related to the zero. But in some of the value we are getting zeros values is there. It means it's also represent and not available any number of type things is still available over there. Okay, let's start with some further things related to the same thing. We already learned about the correlation matrix during the statistics and probability module. Okay, let's do the something based upon that practical as well as. So here we are going with the data correlation over here. So for the function for the data correlation, it's a data dot co is there, and also we have to provide the blank brackets for functions. Okay, so once we can run this code, so we are getting the correlation matrix. But here in correlation matrix, we are just only getting these four parameters. Why? Because the correlation matrix are just only work with the particularly those are dealing with the numerical values. Okay, so whenever the numerical values are present at the same time, we have to work with the data correlation matrix. Okay, so that's why correlation matrix only access this four values, four features. Those who are work with the numerical values. So after discussing about this how it should work related to some data features and as well as data pre-processing things, let's look at the frequency of each category separated the histogram charts to check if there is any special information to distinguish whether the result of the target is zero or not looking for job change, or a one, it means looking for a job change. Okay, so till now we are finding out some information, but now it's time to do some visualization. Okay, So whenever we are trying to implement any type of the visualization, so we are getting some more idea like what type of things we are doing till now. Okay, so let's make a one histogram chart, not a one, but we have to create some bundle of histogram chart. But in that we have to create one of the logic. Okay, so logic is related to like frequency of each category separated by their label. Label it means in their features as well as. Okay, so let's start with that. But before that, I can provide one comment over here. So whenever you are trying to learn these things, so it is easy for you understanding the same thing. Okay, so frequency of each category is, or you can also go with separated by the label. Okay, okay, so now we can start code from over here. Basically, when we are trying to create the histogram, so that is based upon a Matplotlib. Okay, so we have to go with the PLT, so that is a shortcut of Matplotlib. And first of all, let's find out some figure size over here because we are trying to create a bundle of histogram charts. Okay, so that's why we have to go with some proper size. Okay, size is very matter over here. So that's why let's take a plot dot figure is there, and based upon the figure, now it's time to decide the figure size over here. So we have to find out what type of figure size I want in terms of the length and width as well as. Okay, we have to find out some height and width. Okay, so for that one, let's take 15 and 18. I think that was better over here. So simply we have to take in 15 and 18. If we want a higher size, we can change this one, and if the things are not fitted in my screen, so I can reduce the size as well as. Okay, so that's how we have to go further. Now let's find out the what are the features I want. Okay, so let's get something based upon a feature. So features are nothing but what are the basically the categorical things are there. Okay, so at that point we have to take on as a feature. Okay, we are not able to take on some enrollment ID because these all are the numerical values is there. Okay, so that's why we are not able to take on that one. So let's start it with the first parameter. So again I have to scroll up the things because here we are getting that output like how many null object. No, that is a data type. Yeah, that is important. So first thing we have to take and that is the gender, and from gender we have to take relevant experience, enrolled university, education level, major discipline. So these all things we have to take. Let's just check it out. We are able to do some copy paste over here. I think that looks not too perfect, but still we have to save our time. So that's how I want to take on this one. Let's see what type of things we are getting over here. Okay, we are getting this one. So this object is not necessary over here, so we have to remove these object things over here. So the code is very complex. The code is not looks very small over here, so it will take time to editing the things, because again if I try to write down everything, so again it should take a lots of time over here. Okay, so let's start with the first thing, that is the gender is there. So we have to provide the gender within single quotes because now we are trying to create one thing parameter, that is the features is there. So that's why again, from here we have to provide the same thing within single quotes. So it should take lots of time. So I have to take on something like that one. You can also take on double quotes as well as. Okay, here I have to take on the single quotes, but that is your choice is there. If you want to take on a double quotes, so you can also take it that one. So there is lots of parameters are there that already exist in our data sets. So that's why whenever we are trying to do some coding based upon this data pre-processing, so always it should take lots of time for us. Okay, because we are working with lots of things. Okay, so company size is there. After there is a company type is there. So we have to take on from again over here. Again we have to provide the same thing. Company type is there, and after company type there is the last thing, that is the last new job is there. Otherwise all the things we are already taken from there. Okay, so that is also depends you, like if you want to like simply provide the enter over here, so it should take some time new line. Okay, so you have to follow some alignment as well as, so that's why it is important, like follow the some of the alignment. Okay, and last things you have to provide the square bracket, so the bracket is completed over here, and then you can remove this whole thing. Now it is not necessary. Yes, now it's the thing are perfect over here. So once these things was completed, now you have to take in some of the samples. Like first of all, we have to take an n is equals to 1, like from first sample to you can start. And now let's create one of the for loop. Okay, so why the for loop is needed? Because we are having some multiple features, and according to the multiple features, we are applying the target according to all the features, and then we are getting an idea how the feature should work over there. Okay, so for f in the features, and then basically here I'm not creating any much thing, but we are just only creating simple for loop over here. And now you already known during the matplotlib, like what is the meaning behind the subplot. Yes, here we have to taken 5 for the rows and 2 for the columns. Okay, so according to 5 columns I want to sorry, the 5 rows I want to create, 2 column I want to create, and according to the number of samples. So here I have to simple taken n is equals to 1, and now I want to develop something based upon seaborn library. Okay, so that's why inside the histogram I also want to look like similar thing related to the count plot. Okay, so count plot and histogram, it's again look similar, is that that's why I have to take on also the count plot over here. So sns dot count plot, here I have to equate x is equals to f, and then we are also taken to able hui function. Okay, so hui function you already known, like why and in what time we are using hui function. So here we can implement hui function with the target. Okay, target are having two classes, 0 and 1, so that's why hui function is better option for that. Then alpha is there. Alpha is representing nothing but some parameter related to the size. Okay, and then we have to take in data. So here I want to use training data. That's why data is equals to data I have to take it. And now let's editing something related to the some title or axis. Okay, so the title of this plot is coming as count plot. Okay, so count plot of, here I have to taken a curly brackets because whatever the things I want to add it over here, like that by target. And once this should complete it, then here in this curly bracket I want to add the value of f, so that's why format of f should be necessary. And everything I want to work during the iteration, so that's why n is equals to n plus 1, so that looks better during the iteration. So now the loop was completed over here, and finally I want to find out the chart over here, so that's why everything looks completely within perfect size. So that's why I want to go with the tight layout, so everything looks fitted in our my basically in my computer size. Okay, so that's why. And then for showing the plot, you have to go with the plot dot show. Let's get some idea, like the thing was running correctly or not. So we are getting one error. Yes, yes, we have to take it, this one. I think still we are getting an error. So don't worry, it is happen whenever we are trying to do this type of things, like coding part. During the coding part we are getting an error. So I think yes, yes, some of the part we are getting output, but somewhere we are not getting, like could not interpret measure discipline. Okay, so where is the major discipline? I think yes, yes. Okay, so we have to try to run 3 4 times to this one, because every time we are getting some small errors. Okay, yeah. Now the things are completely perfect. Okay, so this is the output of code. Yeah. So here you are getting an idea, like according to the every feature you are getting an idea. Like see, whenever here we have to take an x-axis as a gender, so male and female is there. So how many the target is 0, it means so here if you are getting an idea, the total candidates, male candidate is more as compared to female candidate. But the thing is that, like around 10,000 of candidates, it's denied to change their role from software engineer or some particular engineer to the data science. So they are not interested to change their job role. Okay, but some of the things are related to some of the male are interested to change their role as well. So that is a good idea is there. Also in female, there is a gender is again important over here, like male and female is there. So the female candidates is very less, around like 100 or 200. Okay, so that type of idea we are getting from this chart of count plot. Okay, also many more the relevant ideas is there, like relevant experiences there, like people are having the highest experience, and the people are not having the related some more experience, but still the criteria look similar, like the ratio is 1000 and 2000, so it's not big differences there. full-time courses, how many people can do four full-time courses, and still those people are not done any type of courses, still they are interested to change their job role. So experiences also matter. So that's how we are getting an idea which parameter you can use on which way. Okay, so I hope we already done many of tasks related to the Matplotlib and the Seaborn, so you will get an idea like how we can go with the same thing. Okay, so from this histogram chart or the count plot, okay, so it can be seen there is no spatial correlation between the variables with the target function to the distinguish the value of target. So furthermore, with this categorical variable cannot determine the correlation factor between this variable and the target variable. Okay, so still we have to see about the model fitting and how prediction should be work. Okay, so good to know that that is correlation can't be calculated for the categorical variables. So dealing with them before what is the important. Okay, so now it's time to start the pre-processing the categorical data by removing the numerical column and using the map things. Okay. Okay, so let's start data treatment over here. Okay, so okay, so that is the one part of the data pre-processing. That's why. So here once basically I can provide one of the comment over here so that easy to understand. Like now it's time to we are starting a data treatment. Also in histogram or count plot, you if you want to provide some of the color according to your thinking, you can provide your own color. Okay. So yeah, let's start it with the same thing. And here again I can provide the one comment. So here we have to take on some current versus normal things. Okay, so that's why. Okay, so let's set the coding over here. So basically, we can create one parameter related to the counts is there. Okay, so based upon count, we are getting an idea how many target values are there according to the counts. Okay, so for that we have to take an target data dot target to value of counts, so we can get better idea. And then once count is there, so now we have to find out how many things are not changed till that. Okay, so not change, and then counts of we have to take in square bracket within this counts over here, and then change is equals to again we have to take counts of 1. Okay, so change is equals to counts of 1 is there, and now we have to precisely find out the how many things are available over here. Okay, so what type of things we don't want to change over here, so for that we have to try to write one code over here. So we have to use normal brackets over here, like not change divided by the not change plus change. So that type of equation we are using over here. We already created not change before one, that's why. And now we have to take divide function, and again we have to take an not change plus change. So both the things we already created like change and not change. Okay, so that's why we have to follow the same thing, because somewhere what is happening like that, like if we can left the one of the bracket, so it can create any type of the error. So that's why bracket is more important. So again then we have to take p first of change is equals to, again we have to write down the things in terms of bracket, like change by not change the things plus change. And again we have to take and multiply with 100 over here. So again we have to take an print off. So here we have to take an there was, or you can also taken like there where we are taken this one. And also we have to use over here again curly brackets, because we have to provide one of the value related to the precision values as well as a precision for not changing values. Okay, so that's why it is important over here. So that's why we have to take an curly bracket over here, and then no not change. So here we have to use some multiple brackets. That is the important thing over here. Also we have to follow some semicolons to get some better idea related to that one. And once this should completed, we have to provide the percentage over here, and after that we have to take an and again we have to take an this curly bracket over here, and then we have to take and change. Again we have to use some same thing what we used previously related to the semicolon and point off with the 3 decimal point we have to take on over here. And then again once we can take on this one, we have to provide one percentage sign, so it should give us better idea related to that one. So now once it should completed, after that what we have to do, so here once the thing was completed over here, then we are trying to work with the format part. Okay, so again here we have to use format function. Okay, so you already know, like whenever we are using format function, so at the same time we are trying to settle down some values over here. Okay, so in that format, first of all we have to take a not change, because we already used that part. Not change, first thing is not change. The second thing is based upon the precision about that one. Okay, so again we have to take precision, not change, and then last thing, that is just change in percentage of change is there, and percentage of changes there. I think everything we should take on over here. Let's run this code. If we are getting an idea error, so we are idea like on what line of error, on which line of code we did mistakes. Okay, so basically percentage not change at the same time. Okay, I think we had taken one or more brackets, or according to the space we are getting an idea error, like let's check it out. Yes, okay, not not change. Sometimes what is happening like that, if we can do some minor error like in capital or small spelling, still we are getting an error. Let's find out. Not change is not defined. Okay, not change is already defined over here. Okay, the spelling of CHANG. Okay, so there is a mistakes in spelling, so that's why we are getting an error. Yes, now it's perfect. Okay, so that's why during the project, see, because we have to do some complex coding, and during when we are trying to do some complex coding at the same time, the mainly the error should come in during this type of small spelling errors are there, or sometime it should error will come in terms of the some spaces are there, or basically that type of error should every time coming during when we are trying to do some projects. Okay, so once these things should completed, now the again the same thing we can find out throughout the NumPy. Okay, so that's why let's tested NumPy array function, and with that array function, let's find out what are the columns are there. So that is columns, and we have to take in data dot d types, and also here I want to take a relationship like not equals to. Okay, so that's why we have to take in this one not equals to over here, and then we have to take an object. So now everything is completed. Okay, so this type of things I don't want to include over here. So these are the parameters that is treated as a not objected like, and it is treated as a numerical things. Okay, so that's why whenever we provide like is not equals to objected, so we are getting this type of stuff over here. So again it is a important thing over here, so we can get some idea like which things are considered as if you're not easily idea getting idea about like which parameters are looking as a numerical or which parameter looking as object, so you can also use this type of codes. Okay, so import related to same thing, I want to do some still I want to complete some more coding related to that type in this particular session. But still now it's time to using new library, and that is the copy library. Okay, I want to made these changes related to the object and numerical things in my data set as well as. Okay, so that's why let's make one new data frame, and that is a copy of train data set and testing data set. Okay, so that's why the name of that data set is this train df of train. Df it stand for the data frame of train, and here I want to make a copy of train data. Okay, so that's why copy dot dip copy. Dip copy is the function of copying the data, and inside this function we have to provide the train data. So train data is called as a just only data, and testing data is known as the test data. Okay, so df dot test is equals to again copy dot dip copy. Okay, dip copy is the function for that one, and inside we have to provide the test over here. Okay, so that's how we are going for the next one. So once these things should completed, again so we can recall our columns with the same code what we had already applied is not equals to that one. So the basic and easy thing is that let's copy this code overall, so we can get idea about that one. Okay, so no need to typing everything for all the time. Okay, and according to that one, let's write one for loop, simple for loop. Okay, for all the input samples for I in like a df of train, like training data set, in the particular training data set columns we have to work with that one. So basically enroll id, city development index, training hours, and target. These four columns I want to remove from my training and testing both the data set. Okay, so whatever the things currently I can do, just only for removing that part. Okay, so that's why I can try to write down this whole long code for that one. Okay, so once they should complete it over here, now I have to take in some if statement related to that one. If I not in the columns, then again we have to take semicolon, and we have to now work with the df of train over here. And with that train I have to select the input samples I, so that's why I have to take an I over here is equals to, again we have to take an df of train over here. So in that train I have to take an again I, we have to take an over here, and according to that mapping we have to using inside the string, so that's why we have to take an str. Again here we have to take an df of taste, and inside the taste we have to take an I. So here we have to again use this one like data frame of taste and taste of I, and with that again we are trying to mapping with the string over here. So same type of thing we are using over here like df of train and df for the test. Now it's time to end this for loop as well as if statement, and finally we are implementing all the changes in my data frame from the train, and from the train I want to training data set I want to drop these columns. Okay, so that's why df dot train dot drop function we are trying to remove these columns. So that's why columns is equals to calls, because after removing these four parameter, the new thing that is that will commonly complete as a column calls and calls is equals to columns. So that's why we are working with that. And what are the changes we are applied over here? In that we are trying to complete with the implace is equals to true over here. Once this should completed over here, df of taste of drop we have to taken, and inside that we have to again taken the columns over here, and columns again we have to remove some part over here. So that's why np dot delete function we have to use, and inside that delete function again we have to taken columns over here. And then it's time to wherever we are trying to work with the testing data set. Okay, so that's why target parameter is not important. Okay, so for removing the target parameter we have to take in columns minus one. Okay, so here we have to take in columns minus one, so at the same time last column is replaced over here. So once we can complete it over here, and in the last we are just only applying in place is equals to true. So the things are completed over here. Let's check it out. We are getting error or not. So here we are not getting any type of error. So let's find what type of final training parameter we are getting over here. So let's check it out. tf underscore train dot columns. So now I have to run this code. Okay, so here we are getting city, gender, relevant experience, enrolled university, education level, major disciplines of experience, company size. Okay, so based upon that, let's find out what are the data types is there. Okay, just a second. So if you can see over here, I think index has no attribute. Okay, df. Okay, yeah. I have to remove this one. Still series not callable over here. We have to find out what type of stuff we are getting over here, because till now we had done things are correctly. Df dot train. So yes, now with that. Okay, so if you can see over here, we are not getting any type of the integer over here. We are not getting any type of float 64 integer 64. Now my data set it's look like very clean. Okay, because we are having just only objects over here. So that's how we are able to remove some of the parameter those who are not required, because we are able to remove that one. Okay, so that's how we are doing some of the cleaning over here based upon data treatment plan part. How to convert this string into the code. Okay, yeah, so that's how we can go with that one. So now according to that one we will assign each categorical variable value a number. So let's say a b a f and name value map to the 1 2 1 3. To do that we will use the label encoder from the sklearn pre-processing package. Okay, so data treatment thing was completed. Now it's time to implement some of the things related to the data sklearn pre-processing part. Okay, so let's use the sklearn library, and based upon that we are trying to complete the how we are able to go with the data pre-processing part. So we are getting some better idea related to that one, like how we are able to convert the things into the, because see, still we are getting object, but still we are able to convert this object into the numerical things. Okay, so that part it's able to do with the sklearn pre-processing part, whereas we have to convert a is equals to 1, b is equals to 2, c is equals to 3, and that's how we are able to convert the things over here. So let's start with the things related to the sklearn pre-processing. So first of all, we have to import the model based upon sklearn pre-processing. That's why we have to take on from sklearn dot pre-processing. We have to try to import label encoder. So that's why we have to take label encoder. Also from the collection, and we have to import the default dictionaries, like basic stuff is there, so we have to take on that one. That is important over here. So from the collections, we have to import over here, that is the default dictionary is there, so that type of thing we have to use it over here. So let's take it that one. If you want to run this code, you can run it, because sometime what is happening if a library is not properly installed, or we are not getting the libraries are there, so that's why we have to use this type of things over here. So similarly things I can facing over here, like cannot import name the default dict. So why we are not getting, I think the spelling is wrong, otherwise thing is completed over here. The default dictionary is there, yes, now it's perfect. So the spelling is wrong over here, the default dictionary. Okay, so you can still continue with this own string is there. Okay, now we have to build a dictionary function, so that's why again I can write down one comments over here for that one. So build the dictionary function, so just simply have to take dict and function over here. So let's take that one, and the parameter for that one, that is the columns is equals to columns is there, and numpy dot array, and based upon that array we have to take data dot columns, and in the square bracket we have to take an data dot you can take data of d types, like data types it can consider as, and not equals to object. Okay, so again we are trying to work with the same thing related to the numerical things. Okay, the things are completed over here related to columns. Okay, the same line we had written many times. Okay, so same thing we had written over here, but based upon that, like those are just only numerical values are there. So based upon that one, I want to create a one of the dictionary, and dictionary I want to convert into the 1 2 3 4 like that one. Okay, so that's why I can use this one. So again, now we have to take default, I think it's a default is there, fault, spelling is just mismatched. Okay, so default, yes, dictionary I want to use over here, and with that I have to use label encoder. Yes, it's perfect. Now it's time to run this code. So still we are not getting any error, and everything is looks perfect. Okay, so in the next part we have to do the, like, only for categorical columns apply dictionary by calling for fit transform. Okay, so we are creating this dictionaries. Okay, but now it's time to fitting this dictionary with the label encoding. Okay, so for fitting we have to use some fitting transform function, and based upon that one we are getting idea how this fit transform function can fit everything in our training data frame and as well as testing data frame. Okay, again I can provide one more comment over here to getting some better idea related to the code. Okay, otherwise no need to apply every time this comments. Okay, only for categorical columns apply dictionary by calling fit transform function. Okay, so there is a fit transform function. Okay, so let's write down the fit transform function over here. So let's start it with the df of train, because it is the main parameter is there, and again we have to use like a copy function over here according to df train dot copy, not copy, but here after copy we are to trying to apply the same thing. And during the methods and functions of python chapter we had learned about the lambda expression. Okay, so here we are trying to use lambda expression over here, because it should applied very easily, and the length of code should be reduced whenever we are trying to use lambda expression. Okay, so dictionary we already created, and based upon that one we have to taken the input name based upon x name. Okay, so once it should completed, now it's time to apply the fit transform over here. So fit transform is the function coming from the label encoder, so that's why it should working easily and appropriately over here. So same once we can do the things related to df train, and similar things we have to apply with the taste. Okay, so no need to return everything again and again. We have to just replace train with the taste. Okay, so that's why we have to copy the same code over here, and just we have to take on over here just only taste, and also from over here we have to just only taken taste over here. Otherwise, after we have to take in lambda x name dot transform of x, so everything is looks similar, so no need to do the same thing again and again. Just only the one thing it should come like df train, and as a place to train we have to take in taste over here. Okay, so once it should complete it again, and we have to just find out the simple thing at the last related to the train. Okay, so df train, we have to take on over here the columns, and based upon that columns we have to take on over here the data of columns, and in a df of taste we have to take on some complex things, because we have to use np dot delete whatever the things we had already done. See, let's check it out what type of things we have to take in. Again here we, if you want, we have to take an np dot delete, and again we have to use this same thing over here. Okay, so let's copy this code over here from over here to that one. Okay, so in this particular df taste, we have to provide this one np dot delete, and according to that one we have to also take in columns, length of columns and -1, and at the end once the thing is completed over here, we have to equate with the taste of, again we have to take on over here the same thing what we can put over here. So same thing I can take on over here. So now it's perfect look like df taste np of delete columns and length of column -1. Same thing I can take on a right hand side and left hand side, so it's equals to taste as well as. So let's run this code so we can get some idea like we are getting an error. No, we are not getting any type of error. And once we can complete this part, now it's time to examining the results, considering the correlation between the pseudo categorical variables and the target objective function. So let's for that one we have to write down one main code like related to df train, like df train with that data types, because in the last thing we already seen how we are able to find out the data types. So at the same time everything is looks related to the object. Now everything is looks related to the integer 32. Why? Because we are using label encoder. So label encoder are converting a into 1, b into 2, c into 3. So that type of concept we can implement it over here. And then let's check it out the same thing with that one, like df underscore we have to take an taste dot columns. So we are getting some better idea about the tasting side as well as, so what are the parameters are available in a tasting side. So if you can see in a tasting side we are getting again more important parameter is there, ct, gender, relevant. So all the parameters are available over here still. Okay, so that is the again important thing are there. So it's not look like that ki what type of changes we made in a testing side, so what type of change we made in a training side, same change we are already made in a tested side. So tested side, okay, side, okay, it looks different in training side as well as the testing side. Let's start to plot about heat map. Okay, so already we imported a library related to heat map, like Matplotlib library is already imported over here, Seaborn library is already imported, but still based upon one of the style libraries that it's coming from the Matplotlib, that is not imported. So let's import that one library. So for that, that is the import matplotlib dot style, because it's refer for the style library. Okay, so that's why we have to use matplotlib dot style as style, because it can provide the style function. That's why it is important over here. So after that one the library is already used, but during that style plot we have to use one of the function, one of the library related to the style or matplotlib, that is a ggplot. Basically the ggplot function is much popular with the r programming. Okay, whenever we are working with the r programming or r studio, at the same time for doing visualization we are using a ggplot library, but here still we are using ggplot function with this style map. Okay, so once we can import it with the matplotlib style, then next part of style can done with the cbon. Okay, so that's why we have to take on over here sns dot set this style over here. Because see, basically whenever we are getting heat map, so heat map are getting like 10 cross 10, 20 cross 20, 15 cross 50, 16 cross 16, that's how we are getting. But whenever we are using some style thing, then style according to style we are setting this one, so at the same time we are getting just only diagonal thing are there. Okay, so that's why you are getting, whenever once we are implement the output, you can get the idea like how the output will look like as compared to normal things. Okay, and in the style we are providing the white grid over here. Okay, so once white grid is provided over here, and then we have to take a plot with the subplots. Okay, so plot dot subplots we have to take an, and inside this subplot we have to take on this figure sizes as well as, so figure size is equals to, we have to take under the bracket 12 and 7. So that's how it should work over here. So this is just initial part is there. After once you completed this initial part, we have to just try to run this part. So any type of, yes, style, yes. I think I have to take to write wrong question, wrong spelling. Okay, yeah. So once we can get the style, so we are getting the idea about this one. So 12 cross 7. So our output is coming in between this one. Okay, so 12 cross 7. So that type of basic simple chart paper we already created. Okay, but in the chart paper we have to implement still some of the parameters related to our data set. Okay, so let's try to that one, because we have to plot the heat map, and here we have to generate a mask for upper triangle. Okay, so that's why this style is important over here I can also provide the comment over here, generate the upper mask. Okay, so whenever you are getting output, you will get an idea like upper mask triangle, how it can generate it, upper mask triangle. Okay, so let's do coding over here after this one. Okay, yeah. So first of all, we have to create the parameter for the mask over here, and in that mask, we can starting with the np of np dot zeros. Okay, because in terms of zeros, we are getting an output. That's why we have to take an np dot zeros with the like function, and inside the like function, we have to provide the df dot train with the correlation function. Okay, so df underscore train, and with that we have to take an correlation over here. Once correlation should be completed, then after that we have to provide the data type over here, and in this data type we have to take an numpy with the boolean is there. Okay, so that type of stuff we have to take on over here. Once after that one, now we have to use this mask parameter inside another code, and for that again we are using numpy library with the that triangle function. Okay, so we have to use triangle over here, and with that particular indices we have to use underscore to refer the indices from the mask. So from mask we have to take an over here. So mask is considered within normal brackets, and once it should completed, we can provide one of the condition related to the true over here. So that is a true condition is this. Then again we have to take an SNS dot heat map over here, and inside the heat map we have to take on df underscore train dot correlation. Thing is completed over here, but still I want to work with some of the color map. Okay, so color is important over here, so let's change some of the color over here, or some of the theme over here. Okay, so that's why this comes with the Seaborn library. Okay, so here SNS with the diverging thing I want to use over here. So there is a diverging is there, and inside the diverging I have to take on some of the palette. Okay, so palette should be work like PALETT, because palette spelling is again there is a different type of spelling is there. So that's why we have to carefully with the spellings. Okay, and once we have to take on palette, we have to again define the proper size and how many number of samples you want to take in during this practical. Okay, so I want to go with the 200 numbers. Also during the C1 we discuss about many more things like what are the meaning of anode, like if you want to go with the some proper specification or proper information or not. So that type of thing is working over here. So that type of idea we are getting from over there are regarding to anode is there. Also there is a mask is equals to, you can also take it mask is equals to mask. If you want to change the name, you can change it. That is depends upon your thinking as well as. And after that we have to, at the end we have to take on center is equals to 0. Still if you want to provide any type of this stuff over here, you are able to provide over here. That is individually your choice is there. Okay, so I can ended the things over here, but also in this palette we have to close this over here, and then we have to just simply take a semicolon and enter. Okay, so everything is completed over here, and it just at the end we have to just simple provide the title over here. So there is a plot title is there. Okay, so title is there. and whatever the title you want to provide over here, you can provide over here. But at the end, we have to provide some of the things related to the how many font size you want to take in. Okay, so that type of thing you also have to provide over here. So let's take the title of this one, that is the heat map of all the features of train data set. Okay, so that is the thing is working over here, train data set. And now it's time to apply the size over here. Font size is equals to 25. Okay, but here what are the brackets quotes you had taken, you are trying to enter it over here, because font size is applied in terms of the coding. Okay, the things are completed over here, and then you have to provide the semicolon, and now it's time to run this code. But we are getting an error. Yes, I think I forgot to provide over the comma. Yeah, now I think it's completely provided output. Yes, it is perfect. Okay, so whenever we are taken some upper triangle mask, okay, so at the same time we are just only getting values over here. Okay, we are not getting values from over this side, we are just only getting values from over this side. So that is the just difference we are getting during this type of coding. Okay, so the result are not bad, but try to limit some of the variables with the low correlation result by setting the limits. Okay, for example, we choose the correlation only if it's above 0.01 or only it's below the 0.01. So if you want to do that type of an analysis, you are also able to do that type of analysis in terms of the coding. If during the coding, if you can provide some of the logic related to the like correlation observement is greater than 0.01, or correlation observement is greater than 0.01 or less than 0.01, so you will get some better idea about that one. Okay, because at the same time from that heat map, you can clearly observe the things, or you are getting the idea the target has a high dependence on the city development index, which means the candidate from the city with higher amount of development index tends to move towards the field of data science. So those candidates or those employees are related to the city development index. So they, if they are having some higher amount of development index are there, so they are easily getting the idea related to the data science, and in future they are joining the job related to the data science. Still many type of visualization we have to do here. We are just only complete this one of the heat map related visualization. Let's start to visualize feature with high positive and negative correlation. So for that I can provide over here the one of the comment to get better idea, like visualizing the feature which positive and negative correlation. So that is looks very easiest to understand. So here the code is not very difficult, but the code looks lengthy because we have to trying to create the box plot to getting idea about the feature with high positive and negative correlation. So for that, first of all we have to take an f and axis over here, axis. So according to that one we are using the Matplotlib and Seaborn together. So plot dot subplot, because according to subplot wise I want to find out the things in terms of number of rows and number of columns. So at the same time we are getting some different plots similarly look like a count plot. Previously we can see about how we are able to create count plot over here, so that should looks easy to visualize as well as. And then we have to trying to set some figure over here, figure size. So figure size is equals to, we have to take an 20 as a length, and in particular width I have to take on 15. Till we can check like what are the perfect length is over there, but till we can go with this one. So if I can run this one, so in the particular output we are getting all the subplots over here, so you will get an idea like how it looks whenever the output should come over here. Also if you want to change the number of rows and number of columns according to your thinking, you are able to change that one, but still I want to go with the same thing. So now it's time next further coding I can add some parameter over here. So first of all let's go with the f with the subtitle. Okay, so that's why we have to take an subtitle over here, and in that subtitle I have to provide the main subtitles look like a title of this particular coding, and that is the feature what we already taken over here. So that is nothing but new thing is there, so we are also able to take copy from over here. So that should be time saving thing is over here, like feature with positive and negative correlation. We can also take in feature with high positive and negative correlation. So that is important. And once this should completed, then we have to find out the size of this one. So here I have to take in size is equals to 30 over here. I think that looks better for reading the things. Okay, now let's start it with the subplot, and that should work in terms of the with the box plot and cbond. Okay, so we have to take an sns dot box plot. So in that particular box plot, first of all we have to select what are the x and what are the y's there. Okay, every time we have to take an x is equals to target, so target of as x is equals to target, that is the fixed is there. But every time we have to change y. Okay, so in a first thing we have to go with the y is equals to city over here. After we have to take on some gender, relevant experience, education level, many more parameter we have to take on, but started with the just only basic city. So let's start with the city y is equals to city. And also here we have to create our data. So data is equals to, already we had to take a df of train. So df underscore train, it is my data input training set is there. And find out the axis related to that one. So ax is equals to axis, and in that axis we have to trying to find out what are the number of columns and rows is there. So this is for first one, so that's why we have to go with the 0 and 0. So once I can run this code, so just only I'm getting output for a single one. Okay, the further one that are the blank, but this was fulfilled over here because I already implemented for this one. So for according to this target versus city over here, so I'm getting an idea like what are the positive correlation is there and what are the negative correlation is there. Also we can provide the color is there, like red will stand for the 0 and 1. So 0 will negative correlation and 1 will stand for the high positive correlation. So that's how thing was working. Now step by step we have to do same thing for everyone. Okay, so because this is for standing for the target and city. Okay, again now we have to take on for second parameter. So that's how we are able to apply the in all the parameter like similar one. Okay, this one for the city. Now we have to take in same thing for the gender, but whenever we are working with the gender parameters, at the same time here we have to take in one over here. Now it's time to run this code. So still in last one we are just only getting the things related to target and city, but now we are getting the same thing with the target and gender as well. So here second plot is completed over here. In a similar way we are trying to do the third, fourth, fifth, and many more things is that, like we are having some multiple parameters there. So after that we are having relevant experiences there. So let's check it out how it should work for that one. But the main thing is spelling is there, because the spelling is different sometimes. If you are taking a dog is equals to dog, but some in some data set the dog spelling is also taking like dog, like dog. So you have to follow the correct spelling according to your data set, not the correct spelling according to the english. Okay, so there is a relevant experiences there. And also here we have to take in 0, 1, and 2. Let's spelling is correct or not. Yes, I think spelling is correct. Yes, yes. So that's how the things we are getting over here. So what are the positive and negative correlation we are getting like this one. Also there is company size is there, company type is there, many more things are there. So that should related in terms of the rows and columns. Okay. So still till now we are just only complete the first three. Okay. So now we are going with the next thing, that is the enrolled university. So at the same time here we have to take on 1 and 0, because this will represent the row and this 2 will represent the column. Okay, so this 0, 1, and 2, so the 2 position of the column is there, but the 0 position of rows. Okay, let's do the same thing in the next one. And now we have to change the yct to in comparison of city. Now it's time to take an enrolled university. Okay, so again we have to take in this one, and we have to take in this one, university. And over here we have to take in like 1 and 0. Now we are not taking 0 and 0, but now it's time to take in 1 and 0. So now if you can see, it's loaded. Now it's loaded. Yes, so now you are getting the output over here, enrolled university for this one. So that's how whenever we are doing this type of all the things for the training set, testing set, so it should take lots of time. Okay, it should take lots of time. Okay, so I can do for all. Also I just give you the 5 to 10 minutes. You can also do from your side as well, as you can try to complete this one as well as. Okay, so I can complete all the things related to this whole all 3x3 matrices. Okay, so I'm trying to write down all the code, but I can request to you, you can also pause this video and you can try to complete this whole thing to your own, because similarly we are going further like 10, 12, 20, 21, and 22. So that's how we are going for further things. Okay, so I just request to you, please pause your video and and then you can check it like your code and my code is similar or not, and you are getting some similar output or not. So that's why it can give you a better idea regarding this one. Okay, so please pause your video over here. Okay, so I think you had done the same thing from your end as well as okay. So let's see how we can do for further things as well as okay. So first of all, I can try to rechange this everything over here, and as compared to Android City, now I have to take education level over here. So now I have to take one. I have to taken over here the education level, and from over here I have to taken one and one. So that's give you the better idea, one and one. So whenever I was added some more things, so at the same time I'm getting some more output over here, and that can reflect on my coding as well as, and it's giving me the beneficial thing like how I can add the things and how step by step I'm getting some better idea related to that one. Okay, so they should complete it till now like education level for that one. Okay, the same thing. Now the next parameter, that is the company size is there, company type is there, and many more things is there. So let's make a copy of this one and try to complete this whole thing. Company type and company size. First we have to take in company size over here. So that is the company size, and in that company size we have to take in 1 and 2, and in the next line we have to take in company size, and then we have to take in company type. So we can complete it for the both the things. T is the smallest one is there, so we have to don't have to forget that one as well as. So now we have to take on 2 and 0, because again the row and column parameter dimension should be changed over there. Okay, so already 75% should be completed. So I hope the remaining part you are getting an idea like how we can go with that further things. Okay, so after that one, if you want to do the same thing what we already done in heat map of all the feature of train data set, same thing we have to develop over here. But at the same time, we have to replace the train with the taste part. Okay, so let's see the same thing over here. So we have to again go upward, and we have to find out like this coding over here, like generate the upper mask is there. Okay, so I have to copy this one, and now again, because till now here we have to create for the train data set. Okay, so now I want to do the heat map of all feature related to test data set. So that's why we have to change some of the coding part, otherwise mainly thing was similar, but some of the things we have to change over here. So what type of things we have to change over here first of all? So like Matplotlib, Seaborn, the style, white grid or subplot or that type of things is already completed over here. Whenever we are trying to create the mask, okay, so in that mask we have to take on df.train. Okay, so as compared to train, automatically here we have to take on the taste over here, because we have to do some similar of things. That's why. Okay, and once the mask with the np try indices it's true, that should correct. Okay, so still that is the perfect thing is there. But still here I want to add one more thing, and that is related to correlation, because we are doing the things based upon a tasting part. Okay, so that's why we have to again take it over here, the df of taste, and with that we have to try to find out the correlation things over that. Okay, so that should complete it. And in the second line everything is look like simple and different, not a too much different. We have to do some small changes over here. The CMAP, SNS diverging palette and 20, that all things are correct, but just only one thing we have to change over here. We already discussed about that one, like greater than 0.01 or less than minus 0.01. So that type of change if you can made it, so that gives the better idea regarding to your visualization as well as. Okay, so let's make that change as well as from over here. So we have to remove this one, and inside this one we have to simple take correlation over here, and inside the square bracket of correlation, first of all I have to just simply take correlation absorb function, and with that absorbent function we have to also take on the greater than 0.01, and also we have to complete, or that we have to end it with the circle bracket as well as the square bracket. So we have to check it out everything get completed or not, because in starting we have to create one bracket also. Okay, so that bracket is completed over here, but at then we had taken one more bracket, so we have to check that bracket is applied or not. Okay, so after correlation we have to also taken over one more bracket to complete this one. Yes, now it's perfect, and we have to try to run this code. I hope yes, we are getting an output, and perfect output we are getting over here. So if you can see this output, you will get an idea like how we can do the same thing for the train data and how we can go the same thing with the test data. But here the everything is we changed, but just only one thing is remaining for changing, and that is the name of the test data. Okay. So according to that one, we are getting in over here the idea based upon this heat map, like the correlation between the variables in the data sets and the test data is nearly the same. So after lots of experiments and after lots of coding, we are getting an idea like yes, now it's time everything is look similar to try out the same thing, and the good predictive result could be expected if a good train result is obtained. So if we are getting some good train results then and then it should come over here. So let's check it out that code as well as like train results are good or not and how much the things are related to the class 0 and as well as with the class number 1. So that's why let's type the one code related tf train, and also we have to consider with the target things, and with that target we have to take an value as well over here, and according to value we have to count like how many samples related to the 0 and how many samples are related to the class number 1. So related to 0, there is a 14,381 samples are there, and related to class 1, just only 4,777 samples is there. Okay, so from this, we can clearly see that the target 0 is in majority, which will affect on our model. So we will use the smart modeling. So what is smart modeling? Smart modeling is known as the synthetic minority oversampling technique. Is there that technique we had not learned during the machine learning, because whenever we are trying to solve particular type of the problem statement or particular type of problem, so at the same time we are trying to test some different algorithm. Okay, because this is not a machine learning algorithm like smart algorithm, it's not machine learning algorithm, it's artificial intelligence algorithm is there. So many type of algorithms are there you can implement in different project as well as. Okay, so here we have to work with the synthetic minority oversampling technique, which will help us to create more synthetic data for the minority class one. Okay, because minority class are having just only 4,077, it's compared to that one the more 10,000 samples are there. Okay, so in the first part we have to see about how data treatment should be worked. So similarly in second part we are trying to get with the deal with the imbalanced data using the smart function or the smart algorithm. Okay, so smart algorithm full form, that is the synthetic minority oversampling technique. Let's start with the second part. So second part is I can already also provide over here the command, so we can get idea like the second part is based upon deal with imbalanced data. So here we are going with that one, deal with imbalanced data, and for that we have to using a smooth method. We already discussed about smooth algorithm like a synthetic minority oversampling technique is there. Okay, so based upon that, let's find out what are the total features we are already having. Okay, so df.train based upon columns. So based upon that, we are getting an idea. These all are the features we are having. Okay. So based upon that, we have to develop the mode. So mode is the, for that we have to create the define the function, and based upon that we are able to create that one. But before that, we have to create one more thing related to the app train and app test. So what are the parameter you want to take it with the continue. Okay, so from the training part as well as from the testing part you have to select the both the things. Okay, so from the training part I have to select the things that is called as f train, and from the testing part that is known as f test. But the mainly we have to select some of the things like city, gender, relevant experiences there, also the enrolled university is there, education level, company size, company type is there. So some of the things we are not taken like major disciplines. We don't want to work with the major disciplines. So let's see what we have to do for that. For that, first of all I have to copy this whole thing. So that should be easiest thing for me to write down everything. Before that, that should be easiest option for me. Like I can have to go with the city, there is a city is the correct one is there. Then I also want to take it the gender. Third, relevant experience is also necessary. Enrolled university, education level is there. But after that I want company size and the company type. I don't want to work with the like major discipline and experience. So what I have to do, I have to just simply remove this one from over here. So I have to neglect that one from over here. After that there is a company type. I want company type. Also after company type I want to take it as a next thing, that is the last new job. That is not necessary, last new job. So that will not necessary, as well as enrollment ID is also not necessary. So I have to remove this one from over here. So I have to remove that. City development index, that was necessary after training hours, and target should be necessary in F train. So yeah, that is the complete thing is that. So that's how I have to create the F train. So after once creating F train, the next thing that I have to create, that is the F test is equals to. So in F test, I have to again use what are the things I have to take on over here. Same thing I have to use again over here. So for that, what I have to do, I have to copy over here and paste it over here. But the one thing is different over here. So in this part, I have to remove one thing, and that is the target. Okay. So otherwise, target everything I have to taken as similar as what we had taken for previous one. So yes, now we have to create an F train in Access, and that will perfectly run over here. So based upon that, I want to create one function. So that's why we are going to function in the particularly Python modules. We learn about the methods and functions. So different type of functions means we seen how to define the function. Okay. So but here first of all, I want to define the data set based upon F train and F test. Till now, df train columns, we know how what type of things we already done. Okay, but here we have to work with the imbalanced data. Okay, so that's why we have to trying to do something new over here, like what type of things are necessary over here. So for that, I'm trying to create define the data. So that's why first of all, you already know, like we have to take on some def function, def, define the function for that one, and then we are going with this one. And if you want to provide the any type of the comment over here, so you can also take it like define data, that type of comment is necessary or helpful to you. So now this data set name is the data 2, because we already created data, test data, and many more type of thing. Okay, already we know how to create a df train columns. Okay, so I have to use the same thing over here. So from that one, df train, and inside the df train, I have to take a square bracket, and in the square bracket I have to simple take fdf f train. We already created f train over here, and then we have to create over here the x is equals to data to dot drop, because we want to drop something from over here. And that's why we have to again take columns over here, and from columns I have to select the target parameter over here. Okay, so here from here I have to remove the target parameter, and then also I have to go with the values. Okay, so that's how y axis is created. Now we have to create the y again over here. So for that, we have to take y as a data 2. Inside the bracket again, we have to take it over here the target, and then after applying a target, we have to take the values over here, and then at the end we have to return with the x and y. Now it's time to run this code, and we are not getting any type of error during the running of this code. So now that is perfect. Now it's time to create the smart function. Okay, so for that, synthetic some majority over the sampling technique. For that, first of all, we have to create the function def smote. That is my function over here. So for that, I have to write down some of the things like borderline smart for the imbalanced data set. Okay, so for whenever we are trying to create any type of the extra algorithms or functions, also we have to try to import some new libraries. Okay, that will require for that one. Okay, before that, I can provide over here the one comment regarding to that one, like borderline smot smart for imbalanced data set. Once this should complete it, then we have to go with the from collections import counter. So that is again important library is there. Then second library is the from scikit-learn. Once I have to take an scikit-learn, then I have to press the tab. So at the same time, it should be again we already discussed about this one, but again I can explore this function. Like it can provide us to like a different things. So if I can do the model, so they can refer me the model selection. Okay, so due to this we are trying to reduce our spelling error. Okay, and then again we are trying to import train. Again I have to take a tab, so automatically it can fulfill like this one, train test and split. Enter. Again we have to take in some more libraries based upon sklearn. So from sklearn dot data set, because here we have to use data set type of thing. So that's why again I have to press the tab. So again it will take time to recommend me. No, I have to learn, I have to write the whole spelling. Okay, now it's try to recommend me. and I have to take in this data sets, and from that I have to take an import make classification. So that's why it can give me the idea about the classification. Yes, perfect. Still from the imbalance oversampling thing, we have to import the smart algorithms. Okay. So for that, it's not look like that I have to create, I have to return down whole SMOTE smart algorithm. Okay, no, that is not necessary to return all the things. Okay. So from libraries, we are getting directly the things. Okay. So for that, we have to use IMB learn. Okay. So imbalance learn things we have to learn. Imbalance learn dot, again we are able to do this one, then again we have to oversampling thing is there. Okay, so overthink sampling, and from that we have to import SMO. If I can press the tab, so they can show me like which type of option we are having. So SMOTE. Okay, so that's how we are going with that. And again we have to need some Matplotlib library. We already import the Matplotlib library, but still we can import that one like Matplotlib, and from that one we have to import a pyplot. After that, the last thing we already done like NumPy is there, but still from NumPy I want one small library, and that is the where. Okay, so from NumPy import WHERE where library. So that's how we are going with the further things related to this related to the smart algorithm. Okay, so we done till now, but also we already created x and y. So again we are using this x and y parameter what we already created, and the thing is coming from the defined data part. Okay, so that's why we have to again use that one, and now we have to try to run this code, and everything is looks perfectly tried running. So we are getting an idea like all the libraries already available in my system. That's why we are not getting any type of error during the importing of library. If any one of the library is missing, at the same time I'm getting an error like particular smart library is not available or smart packages is not available, that type of thing we are getting over here. But everything is completed over here and all the libraries is provided over here, that's why we are not getting any type of error based upon a library. Now let's see how to summarize a class distribution. So here we have to summarize the class distribution. Okay, so I have to just simply take a dist. Okay, and again we have to take a counter over here, so that's why we have to create the parameter for the counter. So again for the counter we have to take a counter of y, and then we have to simply print a counter. Okay, so here the counter was over. Then after that we have to transform the data set over here. So again we have to provide the comments over here, and with that we have to go with the transform the data. So here we are working with the smart function, so that's why smt is equals to, we have to use smart function what already created over here, define of smart in various library we already used. Here if you want to take any type of the random state you can go with that, but here I don't want to take it any type of the random state, so that's why I have to take a simple thing, random state is equals to 0. So after applying random state is equals to 0, now I have to take x and y, and x and y is equals to smt dot fit, because we have to fit it smart with the particular sample, that's why. Okay, so we have to take sample, and in the sample we have to take and just simply x and y over here. So same thing we are already provided over here. And after that now it's time to, we have to write down x train, y train, or x test and y test. Okay, so we have to create it that parameter, that's why. So they can recommend as well as if you can press the tab at the same time they can recommend us like we have to take in some x train, then second we have to take x test, after we have to take in y train, and at the end we have to take in y test. It's simple. If you can take on all the letter as in small letter, so that should gives a better idea during this type of coding. Okay, if you are taken everything in a small letter, so that benefit for you as well, as because you, if you once you forward like capital X you taken or small x you taken or a small y you taken, so at the same time it should also create an error for the capital X or small x. Okay, so that's why every time I was using small x or small y or whatever the letter I was written, everything is come within small letter. So no need no any type of issue will create it related to the like small letter we had used or capital letter we had used. So that type of basic idea you have to remember every time during this type of coding. So test size we have to take on like 0.33, it means we have to take 66 percentage of testing data, sorry training data, and testing set data, that is the 33 percentage. And here for our checking, I have to take a random state is equals to 2. If you want to go with the random state is equals to 0, that is your decided things are there. We already run this code and everything is run perfectly, so still I want to add some more thing in this code. So that's why if you are running code at every step or every instance, so that will beneficial for you. Okay, because if you are having any type of error, so you can resolve it on that particular level. Once you can written whole the code and then you are getting an error, so it is very difficult for you to identify the error and how you can solve that error. Okay, so that's why I can prefer like every step you can try to find out your results as well as. Okay, now again, what we have to do? Again, we have to summarize the new class distribution. Okay, so now I have to summarize the new class distribution. But in this new class, what we have to taken? We have to again taken the same code what we taken over here. So I have to just only apply the control C for this one, and then I have to directly apply it over here. Okay, so again we have to do the same thing, and that's how we can complete this step. And based upon that one, lastly we have to try to plot the scatter plot. Okay, so scatter plot of example by that individual class label. So let's do the same thing, like scatter plot lot of examples by class labels. Okay, so once again we have to follow some of the indentations over here, and again for that one we have to take on for loop over here, and for with that label I have to take on this one, and I have to use the particular in function with this one counter dot items, and once it should complete it, again we have to follow some more indentation for the for loop, because here I want to try to create the indexing things related to the row, not a column, just only with the row. And again I have to use over here the where library, what comes from the NumPy library. And when we use equals to, we have to use two time equals to for for equal the things, and then at the end you have to take on 0 within square bracket. Yes, so it looks like somewhere it looks complicated to during this coding, like lots of type of indentations we have to follow. So now we have to take an pie plot with the scatter thing, and in the scatter we have to fit at our input x with the sum of the row of ix 0, and many type of things we have to follow, like row ix. And second thing, that is the 1 is there, so in a square bracket we have to adding everything. And second thing, we have to add also the label over here, so label is equals to string of label. So once you can complete this one, so here the for loop was ended over here, and now you have to then provide the something related to the matplotlib, like simple thing like legend type of function you have to provide, as well as if you can already taken like matplotlib, so you can also go follow with the plot.show. But here previously we can use like matplotlib like import. Okay, so that's why we have to use pyplot. So pyplot dot show, and everything should return from x train and y train. Okay, so that's why we have to coming with the x train x test, y train y test, so no need to return again and again. I have to directly copy this code from over here, and I have to end it over here, and I have to run this code. Here I'm getting an error like label after that in counter. Okay, yes, I think I follow the I was in counter is perfect. Okay, what type of issues? Yes, I do follow. Yeah, now it's better. And also I think indentations. Yes. Yeah, now it's perfect, and the code was running till now. And see if you can get an idea like borderline SMT, like a sampling minority over the sampling techniques. Okay, so a new oversampling method in imbalanced dataset learning, it is developed in 2005. Okay, so we can implement the borderline SMT class from the imbalance learn. Okay, so there is multiple thing is that. Okay, but till now we are just only implement the SMOT. Okay, but the another one of the important method related to the like BSMOT is also there. Okay, so multiple methods is there. If you want to learn about the like how BSMOT method is works, so also we have to do some more coding and who can develop this one, so we can get some better idea related to that work. Okay, like how it should work in different things, like how SMOT should be work, and how the BSMOT should be work, so we can get some better idea related to that one, like individual thing, how it can work and how it can work for the so on some different things. Okay, so if you want to develop, so at the same time you have to also learn about the how BSMOT should be work, or how also the SMOT SVM it should be work. So there's a multiple methods is there. Okay, so that's how you can get an idea like how you can go with the different things. So let's start with the machine learning model. Okay, so before starting in this problem, machine learning modeling. So broadly, there are three types of machine learning algorithms are there. So we are just taken a review or recap related to the machine learning algorithms, because we already learn everything in a depth with the supervised, unsupervised, and reinforcement learning. But still, as an overview, we can talk about the machine learning algorithms. So basically, in a supervised learning, algorithms are consist of a target or outcome variable. So it's work in terms of the outcome variable as a dependent variable, which is to be predicted from a given set of the predictors are called as the independent variables. So using this set of variables, we generate a function that map inputs to desired outputs, and the training process continues until the model achieves a desired level of accuracy on the training data. Example of supervised learning like regression algorithms are there, decision tree, random forest, KNN, logistic regression, support vector machine. These all are the part of the supervised learning. Also, second part of the learning, that is the unsupervised learning. So in the unsupervised learning algorithm, we do not have any target or outcome variable to predict or estimate, and it is used for clustering population in different groups, which is widely used for something customers in different groups for specific interventions. Example of unsupervised learning are a priori algorithms, k-means algorithm, and anomaly detection, and that type of things are considered as an unsupervised learning. But the last learning type, that is the reinforcement learning. So in the particularly reinforcement learning, the machine is trained to make the specific decision. It works this way, like the machine is exposed to an environment where it trains itself continuously using trial and error. So this machine learns from past experience and tries to capture the best possible knowledge to make accurate business decision. Example of reinforcement learning such as the Markov decision process, the Bayesian network is there. Also, some few learning institutions are working as in reinforcement learning. So after talking about the supervised learning, unsupervised learning, and the reinforcement learning, these three are related to that three type of learning. We have to here just working as a supervised learning. So basically, these are looks as a classification problem. So particularly with this problem, we are trying to solve the things related to logistic regression, decision tree, and the k nearest neighbor. So let's start to making machine learning modeling on the same project. So first of all, for that we have to simply import a library based upon a machine learning and sklearn. Okay, so first of all I have to provide over here the comment, like from here we are going to start machine learning modeling. That's why we are taken machine learning modeling over here, and simply I have to run this code. And from the sklearn, now it's time to we have to import lots of things over here step by step. So from sklearn, first of all we have to import extra trees over here. So basically I have to run just only sklearn dot, and I have to just simply press the tab, and then I have to taken some ensemble to sklearn dot ensemble is there, and from that we have to import extra, and again you have to press the tab, so they can show you what type of things you want. So I want to work as a decision tree classifier, so that's why I have to take extra tree classifier as well. As also, to make a decision tree I have to use some more libraries based upon sklearn, like sklearn sklearn dot, again I have to press the tab, and I have to just simply find out the tree, and from this tree I have to find out the decision tree classifier. So I have to simple write down the tab and easily getting out the decision tree classifier. So after decision tree classifier, also once model will be completed, then I have to go with the model evaluation. To find out the model evaluation, I have to require confusion matrix, as well as I want to require accuracy score, matrices, and many more things. So let's import all the things step by step over here. So from sklearn dot, now again I have to press the tab, and I have to find out the where is the matrices, and from the matrices I have to find out the basically the accuracy score. Also I have to find out the matrices as well as, but that things I can write down in next line, like from sklearn. You can directly type down the from sklearn import matrices. So that is also the one of the ways is there to import the libraries. Okay, let's import now the basically the logistic regression. Okay, so logistic regression is the part of the linear model. So sklearn dot linear. Now you are able to press the tab, so you are getting better idea like what are the different options is there. Okay, so there is a linear model is there, sklearn. Now yes. Pairing is wrong, that's why the tab should not work over here. And from the sklearn linear model we have to import. Okay, so this logistic regression is then logistic regression, cross validation is there, but I want to just simply go with the logistic regression. After logistic regression, it is your base. If you want to import the navy base algorithm or the random forest, you can also do, but here I don't want to go with the navy base or random forest. I just after that I want to go with the k nearest neighbor. So from sklearn dot neighbors, from sklearn dot, now again I have to paste the tab, and so I have to find out where is the neighbors. And from this neighbor I want to k and k nearest neighbor. So that's why simply k and you have to write. So k nearest classifier you are able to import over here. Also from the matrices, if you already import the matrices over here, and if you can take a comma, so after that one you can also find out the confusion matrix over here. Okay, so that's why we have to take an, so yes, that is a confusion matrix is there. So in a confusion matrix, you have to simply take a confusion matrix. After confusion matrix, many more things you can also take it over there. Like if you want to go with the classification report, you can also find out that one. So again, you have to press, and then you have to find out the classification report as well as classification report. If you want to plot the confusion matrix matrices, you can also take it that one. So one is the confusion matrix. So when you take a confusion matrix, at the same time they are just shown the number of what number is available in a confusion matrix. They are just only shown that one. But when you take a plot confusion matrix, at the same time according to color it should settle down, and according to that one it will represent to you, like you can use this type of color or this type of palette you can used over here. Already among this one we can also use Seaborn library, Matplotlib library, that is already implemented over already imported many times before these work. Okay, so that's why I'm not trying to run same in same library many times. Okay, so all the library we already imported over here related to the machine learning model, and now it's time to make a model. So to make a model, first of all I have to settle still some of the basic things I have to settle over here. So that's why I have to define over here the models, and in that model I have to take on multiple things. First of all I have to take models as well as aspects to model. I have to take on x train, y train, and many more things are there. So we already write down over here, so we directly pasted over here, and then we have to take on title over here. So the title is standard over here, and then at the end of this bracket we have to just simplify the syntax, and then over here we have to find out the models is equals to models. Okay, and then we have to fit it this model to our x train and y train. So models dot fitted with the x train and the y train. So till now things were looks very easiest things, but still we are not completed in this coding. Okay, because still lots of work we have to do related to the small things related to if you want to import any type of the matrices, or we have to create it many more work till now. Okay, till then. So let's again we have to use x and y over here, and based upon x and y we already once do one thing like define data type of stuff we already done. So again we are using some of the similar things what we already used. So now based upon that one we are trying to create train matrix over here, and to create a train matrix I have to use pandas library to apply some cross tab. Okay, so that's why we have to use that one, and inside that bracket we have to take in some multiple things like based upon y train is that. Also we have to take in model dot predict based upon x train. So the things are not just only depends upon the input or training set, it is also depends upon the testing set as well as. Okay, so that's why during the coding we have to concern about the many type of topics or many type of stuff related to the problem statements. Also here we have to again taken some row names over here, like what names are actual and what are the desired one is there. That is depends upon you, like how you want to take these all the names over here. Also we have to take some column names as well as, okay. So when we take some column names, at the same time that is your individual choices, like how you want to go with the column names, okay, like how you approach with that column names, like predicted are there or prediction are there, so that is depends upon you. I have to go with the like simple one, and that is the predicted is there. But the once you can complete this type of course, so at the end you have to also follow any type of the semicolon you have to provide or not. So that type of stuff you have to mention when you are trying to complete this type of code. Okay. So till now we completed the train matrix. Okay. So once train matrix should be completed, again we have to follow some of the identations, and now we have to try to create the test matrix as well as. So again we are starting to code with the train matrix, sorry, test matrix. But when we are trying to do test matrix, at the same time what type of thing we already taken over here, so same thing we have to again use over here. But only one thing or one change we have to apply it over here, as compared to y train we have to taken y test. And based upon extra sorry, the train matrix and test matrix, we are able to create one more matrix, that is named as simple matrix is there. And again here we have to take pd dot cross tab over here, and in that we have to just simple take an y is there, and after y we have to simply take model dot predict, and under that predict we have to take an input x. Also we have to provide the row names over here, and row names is equals to we have to take an actual over here. Okay, so we have to take an that one. Same parameter we have to taken again over here, like what type of predicted we have to taken and what type of the actual we had taken. Okay, so train matrix, test matrix, everything is created over here. Now we have to run this code, so we are getting an idea like any type of error we had made or not. Okay, so still everything is looks perfect and very well formed. Okay, so no need to change anything because everything has worked perfectly. Now we have to create during the practical or during the visualization we have to create some parameter like axis 1, axis 2, and axis 3 to get some different particular thing, like how many employee can do some total carrier switches are there, and what are the accuracy according to the total set. So that's why we have to create three axes, so axis 1, axis 2, and axis 3, and according to axis 1, 2, and 3 also we are trying to create some of the heat map. Okay, so according to heat map, at then whenever we are trying to create any type of the models according to sorry, logistic regression or the decision tree or the knn, so we are getting every time some proper results. That's why this type of stuff is necessary for us during coding. So let's start with the f, and in particular the f we have to take an f of x is 1, then we have to take an f of x is 2 is there, and then x is 3 is there. So based upon x is 1, 2, and 3, we are trying to create some of the subplots. Okay, so plot dot subplots is there, and in that particular subplots we have to settle some parameter 1 and 3, so it will represent the total number of rows and total number of column as well as. So again we have to take share y, and share y is equals to, we have to take it over here, the true is there. And also we have to settle out the figure size, like how much size is required for this one. So we have to take on 20 and 3 over here. So once we taken this one, now we have to evaluate the g1. Okay, so g1 is important. Once we can create the g1, then we are easily able to create a g2 and g3, because all g1 will take in 3 lines to add some x label, y label, and the title. That's why. But that is depends upon the heat map. So we have to take a heat map over here, and in that particular parameter we have to first of all we have to take train matrix over here. So we have to take a train matrix, then we have to take an and not is equals to true, but in a true we have to take a capital T, because if we can take a small t at the same time, it is not applied properly. Okay, so it is neglect, it is shown as an error. And then we have to take a figure size, so figure size is equals to, also figure size is important. Okay, but we already imported the figure size in before line. Okay, so no need to apply it over here the figure size. If you didn't apply it in over the first line of this f of x1, x2 and x3, at the same time we are not applied over here, so here we have to apply it. But it is common for all three axes, so that's why we already applied over here. So simply we have to apply it over here the fmt, and based upon that one we have to use one of the decimal points, so that's why we have to take dot 1f. Otherwise the thing is clearly. Also, if you want to add some more editing options like c bar and all, so I don't want to take it c bar, that's why to directly apply the c bar is equals to false. And still we have to apply some k arguments, so that's why we have to take an kws is equals to, here we, if you want to add some more size for the just only the arguments, so we can add like size is equals to 10. So I want to take it size is equals to 10 over here. And it is depends upon if you want to take more size. Okay, so let's take size is equals to 18, but I want to apply that size, so that's why to end it over here. Yeah, now it's applied. And then we have to take an ax is equals to ax1. So that's how we are able to create our first thing. But yes, now I have to end this bracket over here. Let's apply some of the title to g1 of this one, so g1 of set, and with that set I have to provide the title over here, and title of title we have to given over here. After applying this one, now it's time to set the y label as well as, so let's set that one g1 dot set of y label and x label of both the things we have to settle over here. First of all, we can start with the y label, and in the y label it is our choice what are the output we want to apply it over here in the comment. So total carrier switch, that is the comments over here, total carrier switch is there. And also we have to take in this curly bracket over here to represent the perfect things. And also we have to provide the format method over here, because we have to also provide some of the input things over here. So we have to take in simply format. Also we have to take on over here the y train dot sum with the function. Okay, so after applying the function, again here we have to take on font size, and font size that is a 14. And also at the same time we have to take on some rotations as well as. Okay, so rotations, or the rotation, the spelling mistake can also create an issue, so that's why rotation is equals to 90. Okay, so that is just thing is done with the y label. Okay, so still we have to do the things based upon a x label, but no need to write down everything again and again, because the code is to be too lengthy and it will take lots of time to complete this work. Okay, so that's why I have to complete take a copy of this one. Actually the carrier spelling is carrier, yes. And now here I have to take an just only x, and the comment of x label, that is accuracy score train set is there. So accuracy score range set is there. Okay, so that's how it is looks understanding for that one. So again I have to provide the curly brackets over here, and then I have to end this bracket over here. Okay, again we have to provide the format function over here, because format function is again important over here. And inside the format function we have to provide the accuracy score, and accuracy score of the particularly model predict of x train. Okay, so first of all we have to take an accuracy score, and inside that accuracy score we have to basically provide a model predict. Okay, because that is the important part over here. So according to that one we have to take an model, and with that model we have to take an predict of x train over here. And once x train should be applied, again second part we have to take an y train over here. And after y train, if you can see over here, so there is multiple brackets are off over here, so we have to take an basically the three brackets at the end. Okay, because it looks very complex. Okay, and okay I have to take one more bracket over here. Okay, I think it should complete it over here, because it looks very complex whenever we are applying any type of the brackets and all. Where we are getting an error, yes, we are getting an error over this point. Okay, so Yes. Here we are not using equals to, we have to use semicolon to get some better idea. F of, okay, again at this point we are getting an error. Okay, we have to take an as comments of this one. Yes, now it's better. After completion of lots of work, at the end we are getting an idea like how it should work, and it looks complex during the coding as well as. Okay, so now I can make again copy of this one. Okay, like I have to make a copy of G1 to start the coding based upon a G2. First of all, we have to try to complete this G2 coding over here. Okay, so that looks better for us to understanding everything. To provide over here the, okay, so G2 is equals to SNS hit map. Again we have to work with the taste matrix. Okay, so whenever we are working with the G2, at the same time here I'm not taking train matrix. Here I have to take a taste matrix. Also anode is equals to true, and some of the parameter we have to provide is the same, but at the end we have to provide ax is equals to ax2. So after that one, no need to apply this one like set and title and everything. No need to apply this one. Simply we have to settle down the y label and x label. The both the things are similar, but here we have to simple take it as a taste. Okay, so here we have to take a taste of some, and font size, rotations, everything is look similar. Also here as well as everything looks similar, but here at the same time we have to take on over here again x taste. Okay, and then whatever white rain we had taken, so as replacement of that one we have to again take it over here the white taste. Okay, so again I have to copy this one, and now I have to add this so whole code to over here. So everything is looks perfect, so look like similar G1 and G2 we already created, but at the end now we have to try to create the G3 as well as. Okay, so G3 is again looks based upon a matrix. Okay, like G1 is based upon a train part, then G2 is based upon a taste part, but now we have to do the third part, and that is based upon a matrix. So let's again use this one, because we have to copy that one over here, and over here we have to take on a G3. So we have to replace everywhere G3 over here. Okay, so here we have to take a taste set. We didn't change that part over here, the taste set. And again here we have to take a matrix, simple matrix we have to take a, not we have to take a taste matrix or any type of things. We have to take a simple one, and at then we have to just simply take an ax is equals to ax3. And after that here we have to take just only y sum, not we have to take y dot sum and many more things. And here we have to simple take x and y. No need to apply the lots of thing over here. Okay, so x and y is simple. And also here we have to just a simple take on a total set, so control n control x. So that part should be entered over here, so getting better idea. So G1, G2 and G3, the all three things is already created over here. Still we have to work with some of the feature importance part, but first of all we have to run this code, and this code is running clearly and properly. Okay, so let's check it about the how the plot should be worked over here. So that's why we have to just simply go with the plot dot show, and after showing if we can run over here, so it should be run over here. But we are not trying to just only run, we have to coming as a return. Okay, so return y, we have to take a model dot predict of x. So that's how we have to again come over here, and now it's running, so now it's completed over here. Also similarly how we can create the model. Okay, so in the same way I also wants to create a feature importance of the model. Okay, okay, so let's see how to create a function for the feature importance. Okay, so for that, first of all I can start with this one, like define the function, and with that we have to go with the feature importance. So we have to take an feature importance over here, like feature importance, and inside the feature into importance we have to use the things related to the models. So that's why once we can already created a model, then and then we are able to create this one. So based upon models, again we have to do the same thing related to the models. And now it's time to again create the models fitted with the particularly x train and the y train. Okay, but here I have to take an x train 1 and x train y train 1. So we have to find out when we taken or when we created x train 1 or x train y train 1. Okay, so that is again important over here, because based upon a model fitting we are trying to create x train 1 and y train 1. So that's why we have to take an x train 1, and then second thing, that is the y train 1. So once we created X train 1 and Y train 1, now in the importance, we have to find out the things related to over here, like importance is equals to model dot feature, model dot the feature we have to take on over here, and also we have to find out the feature importances over here. So once we can find out model and feature importances, and then we can again merge up with the features as well as. So features is equals to df dot taste of column. So here we have to take a df dot taste, and with that taste, uh, here we have to take a underscore. So that is the perfectly worked over here, and then we have to take columns, and in that columns we have to take a semicolon with 9. So that's how it should work. So now we have to run this code. So it is run, this code is run properly over here. So it's getting an idea like everything is going in a perfect manner. So now we have to find out some important thing. So that things we are getting from pd dot data frame. So here we are getting data frame, and particularly in that data frame, we have to getting over here the features as well. So first thing, that is the features, and in these features we have to take an f test, and once we have to take an f test, now the things is related to the importance is there. So if you can see, I have to once in feature I have to use single quotes, but now I have to use double quotes. So that is okay. It will not creating any type of issue during the coding if you are using some different things. Okay, so it is not an create any type of issue over the during the coding. Okay. Okay, so the things is both the things I've already taken, and again I have to take an importance, and inside the importance on square bracket I have to take some importance. Okay, I have to take some importance is there. Okay, and some importance I have to equate with the importance of important. Okay, so inside that one, what I have to taken over here, so that things I have to taken over here importance, and with that I have to use come sum function over here. We already discussed about during the machine learning part, like what is the meaning behind the come sum options. So now I have to apply some type of the sorting on importance, and according that I have to take on the values, and inside values I have to provide some sorting this by the category related to the importance over here. So yeah, now it's working properly, but also we have to checking out like we are getting any type of error or not. If we are getting an error, so it can create trouble. No, we are not getting any type of errors. So now it's time to test it our model, like how it should work. See, here we are just only creating the SA motif type of the algorithm, but it's also you are also able to create the b smart function or also the s smart function. Many type of algorithms are available with the sklearn library, so you can test it many more. So at the same time, in resource I can provide you the multi more comparison as well as, but here we are doing some projects first time, so that's why I'm not taking everything together. So because if we can take an everything together, so it should create an type of issue during the understanding. Okay, so that's why I'm not taking everything as an continuously. So we have to take an y train 1, and then we have to take on the y test 1. So once everything should be completed, now we have to just simply take smo, t is the smart function, and let's time to check it out like how smart function can give an output. But if you can see over here, they cannot import name like make classification from sklearn data set. So here little bit type of issues we are getting over here. So we have to check it out like what type of issues we are facing over this time, like basically cannot import the name like make classification that type of from the sklearn data sets. So let's check it out where we use sklearn data sets. So where is the sklearn data sets is there, because everything is related to that one. Okay, yes, so sklearn data sets is there, and they can show the issue based upon this one. So let's check it out what type of issues created over here from the sklearn, because sometimes it is also shown you like what type of things are overing over here. So make the classification, I think everything is looks completely okay. Don't worry, we have to run again and again so we can get some more idea like why it should not work. Okay, cannot import the name again, it is not easily evaluate or it is not easily find out the name. Okay, so basically throughout the errors we are getting some more idea like why we are getting an error during this type of things. Because see, whenever we already run the code related to the sklearn data sets and import the make classifications, at the same time it should already work, okay. But now whenever we are going to do this one, we are not getting an output. So reasons are there, like we have to take classification, okay. Okay, but still now we are getting different error. So that's how the error we are getting over here, okay, because different every time we are getting some different error, okay. So that is nothing but that is different, depends upon, like, yes, now I was using smooth function, that's why I'm getting an error over here. Don't worry, we can solve each and every error. So that's how we are getting in more and more idea, like what type of issues we are having over here. Yes, counter reference before assignment. So why we are getting again error? Let's replace something over here. So that is the counter. Here we have to take capital C over here. So I think everything is based upon that one. Again, we are trying to run this code. Yes. So still, what type of things we are facing over here? Again, we are getting error from the counter. Why? Okay, let's check it out. What type of things? Again, we had done summarize the class distribution. Okay, so yes, we are getting error over here. Okay, let's check it out now. Still we are getting an error. Yes, still we are getting an error, but now we are getting different error. So here we are getting an error, like x and y is there, and also smt dot fit example. Okay, okay, so fitted sample with the x and y again. Okay, okay, okay. So during the sample, yes, I think I told you, like, we are having some spelling mistakes are there. So that's why nothing but difficult are there. So sample is there, so that's why we are getting an error over there. Still we are getting, so it's during the coding we are getting the things, like what type of error we are done it over there. So there is a label is there, so not a labels. So yes, basically in which line we are getting an error, we have to find out that one. Okay, okay, so row of ix, okay. Yes. The scatter plot of the example by class is okay. So first of all, we have to find out, yes. So here we have to take a label, yes. But here I have to take labels, yes. That's why we are getting an error. So that's how multiple times we have to train this one. So at the end we are getting an error, getting an idea, like on what level we are getting an error. Okay, so again here we are getting error scatter missing one required positional argument. So I think we have to check it this line, so get some better idea, like which type of issues I had done on this line. Okay, so if you can see that pi plot is there, dot scatter is there, x of row ix is there, and also yes, we done one mistake over here, like when we are running this code. So we are just only applying one argument over here. I forgot to apply the second argument. I already taken first argument over here. We have to apply it over here the two arguments. Okay, so first argument is 0, and then again we have to taken second argument. So second argument is again look like this one. Like again we have to take a row of ix, we have to taken, and same side we have to taken also one, and then with that one we have to provide the label is equals to string of label. So that things is missing, that's why we are getting just only one argument. Yes, now everything looks perfect, and now you are getting an idea what type of things we had done till now. So based upon that one, there is the just output of smot. If we can apply it some more algorithm, we are getting some difference between another algorithms. Okay, so what are the things are there? So counter 0 14,381 is there, and 1 4,777, and counter, so multiple counter we are getting, because here we are getting making some different training and testing sets. Okay. Okay, so let's start with the logistic regression. It is a classification, not a regression algorithm. Basically, logistic regression follows the classification things, and it is used to estimate the discrete values, binary values like 0, 1, yes, no, true, false, and it is based on a given set of the independent variables. In simple words, it predicts the probability of occurrence of an event by fitting the data to a logic function or a sigmoid function. It's look like a S curve. So hence it is also known as a logic regression, since it predicts the probability and its output values lies between 0 and 1 as expected, like it is binary, that's why. So the logistic regression is a fundamental classification technique, and it's belong to the group of the linear classifier and is somewhat similar to a polynomial and linear regression. So the logistic regression is fast and relatively uncomplicated, and it is convenient for you if you are beginner or if you are learning about the machine learning to in particular that one area to interpret the results. So all through it is essentially a method for a binary classification, and it can also be applied for multi-class problem. But basically throughout the binary classification, it can provide you the good output. During the multi-class classification, it shouldn't provide you the perfect output. So let's see what are the results we are getting during the logistic regression. So for that, first of all, we are going with the title things. Like this one, we have to create one parameter that is a title, and here we are trying to implement a logistic regression. So that's why spelling is again important over here, because we already taken this one many times, like logistic regression. Among that, we are trying to implement logistic regression with the smart function. That's why we have to taken this one. Now it's the main time, like we are trying to import or we are trying to working with the models. So logistic regression are again imported over here. So we have to taken the logistic regression over here, and inside the logistic regression much making the model, we are using like xtrain and many more things like xtrain, y x test, y train, and y test one. So this is the important thing. That's why I just directly copied from over here you and directly pasted over here. So we are getting this much of parameter, and at the end we have to provide one over here, the title. Okay, so we can see everything is looks perfect. Let's see, we are getting error or okay. So who the models is not defined. Yes, yes, we have to take it capital M, because previously we are using capital M. Again, we are. I think we are having again some of the spelling mistakes. So that's why the model is not defined. Where is the model is not defined over here? We have to checking the things like code is perfect or not again and again, because see, you have already seen in last session, whenever we are getting some type of the error, we have to again check the code, like on what level of status we are getting an error. Okay, so the logistic regression is there, so the name model is not defined over here. So we have to check it, like why the name model is not defined. Okay, so here we have to go on over here, like xy define data. So we have to scroll up something, like now it's time to check this code totally and probably and thoroughly. We have to checking this one. Let's see what type of issue we had done over here. So train matrix is there, and we already taken. Okay. Here we have to take models. So that's why we have to just simply have to take a model over here. We can take a model over here. Now it's running perfectly. Yeah, I think now it's going perfectly. Okay, still I'm getting an error. Don't worry, we have to checking somewhere else. We are still done some mistakes, small of the mistakes. So that's why we are getting an error. So don't worry, arrays must all be the same length. Okay, arrays should be come in same length. Okay, so we are not getting array within same length. Okay. Again, we have to check it out the test matrix. I think some of the arrays should not come properly. Again, we have to check the code why and what type of issue should generate over here. So basically, whatever the model you will make in real world, also you are trying to make it any type of the problem or project. So at the same time, you are getting this type of issue. So don't worry regarding to that one, because it is happen every time. It is not just only happen in this project. Every time it should happens. So column names is there. Also the test matrix. It depends upon the y train, and it is also depends upon the y test. A model based thing is there, and also we have to predict. Yes. Here we have to take an X test as well as. Okay. Let's see. Still we are getting error or not. Okay, so now we are not getting any type of error, and perfectly we are getting an output over here. So similarly, here we are just only create the logistic regression for the smart function. Okay, similarly we are also able to create the k nearest neighbor and decision tree. Also we have to see in same session like how to create the knn with the same thing. Okay, but before that you have to check it this one, like how the things are working over here with the smart function. Okay, like total carrier switch is 9656 is there, and how many samples are considered as a true positive, how many considered as a true negative, because basically it should represent a true positive, true negative, false positive, and false negative. And we already learned about like what are the importance of the true positive and true negative, false positive, and false negative in terms of the confusion matrix. Okay, because confusion matrix is the main parameter things during the evaluation of the classification problem. So that's why it is important thing is there. So after so here we are getting this type of stuff over here also. If you want to find out some of the accuracy score or classification report, we are still getting the things, but that type of things we are finding out at the end of this session. Okay. So still we are just only completing the logistic regression. The next machine learning model, that is the k nearest neighbor. Let's take a review about like how knn should be worked over there. So the KNN, if we can talk about the KNN, so it can be used for both classification and regression problem. Logistic regression just only used for the classification, but KNN should be used for the classification and regression. However, it is more widely used in classification problem in the industry. So K nearest neighbor is a simple algorithm that stores all available cases and classifies new cases by a majority vote of its K neighbors. The case being assigned to the class is most common amongst its k nearest neighbor measured by the distance function. We already know like what type of distance functions we can find out, like Euclidean distance function we have to find out. So the k nearest neighbor is a very simple and easy to understand, versatile and one of the topmost machine learning algorithm. KNN is used in the variety of applications such as finance, healthcare, political science, handwriting detection, image recognition, and the video recognition. In credit rating, the financial institutes will predict the credit rating of the customer, and in loan disbursement, banking institute will predict whether the loan is safe or risky. But in political science, classifying the potential voters in two classes, will vote or won't be vote. So KNN algorithm is used for both the classification and the regression problem, whereas KNN algorithm based on the feature similarity approach. But however, still we can talk about more related to KNN. So KNN method is the computationally expensive. Okay, so variables should be normalized as higher range variables can be the biased. Or for better results, normalizing data on the same scale is highly recommended. So let's start with the KNN, like how KNN classic KNN neighbors technique can give us the different output over here. So for that, no need to changing everything over and over. Just we have to provide over here the one comment that we trying to implement KNN method or the KNN technique. Otherwise, we are using the same code what we already using over here because the parameter should be same. Just we have to replace the logistic regression with that KNN neighbors. So that's why here you have to provide the titles simple. We have to take an KNN title over here, but here we have to change the everything like K nearest neighbor. So for that we have to take an K and so here we have to just only taken the k nearest neighbors. Okay, so k neighbors is there. So and also inside the k neighbors we have to do provide some of the neighbors, like how many neighbors you want, like k is equals to 5 or k is equals to 1 or 2. Okay, so that is depends upon us, like how many things we have to decide over here. So so neighbors is equals to, I want to take an as a 1. Also here we have to take and just removing this. Let's see. Yes, I think the spelling was wrong. K, I think there is a lots of things is based upon the spelling, so that's why you have to follow the proper spelling of neighbors. Okay, so we have to take in the neighbor spelling over here, like K neighbors classifier, because some part is look coming from capital and some is coming from the negative, and the sometimes spelling is should also different is there, that's why. Okay, so now we are getting the perfect output over here based upon the KNN. It should taken some time to run the things. Yes, now it's run, and KNN should provide the better output as compared to the logistic regression. So if you can visualize the things, you will getting some better idea like how the KNN should be worked over here in terms of the true positive. So here if you can see the true positive is less as compared to this one. So here we are getting the 9,500 around true positive is there. Here just only we are having the 3,000 sorry 6,500. So more 3,000 samples are trying to correct on their own. Okay, so accuracy should be improved during the KNN method. So that's how whenever whatever the problem or whatever the project we are doing, so at the same time you can take in some different things and making some comparison, so you will get some better and better idea like how you can go with the further things. Now we have to implement a third method, and that is the decision tree. So let's make a note over here first of all. Like now we are starting to work with the decision tree. But before starting a decision tree, let's take a general overview. Already we discussed many times and we briefly discuss about the decision tree as a regression and decision tree as a classifier. But still here again we have to do this one, so that's why we can just take a small overview about the decision tree classifier. So basically, decision tree classifier is a type of supervised learning algorithm that is mostly used for a classification problem. It is also used for the regression problem. But here our objective is related to the classification problem. Surprisingly, it works for both the categorical and continuous dependent variable. It's related to like that regression and classification. But in this algorithm, we split the population into two or more homogeneous data. This is done based on most significant attributes or independent variables to make as distinct group as possible. A decision tree is a flowchart like tree structure where an internal node represents feature or attribute and the branch of represent a decision tree rule, and each leaf node represents the outcome. The topmost node in a decision tree is known as the root node, and it learns to partition on the basis of the attribute value. It partitions the tree in recursively manner called recursive partitioning, and this flowchart like structure help you in decision making. It's a visualization like a flowchart diagram which easily mimics the human level thinking. That is why decision tree are easy to understand and interrupt. Decision tree is a white box type of machine learning algorithms, and it shares internal decision making logic which is not available in the black box type of algorithms such as the neural network. Its training time is faster compared to the neural network algorithm, and the time of complexity of decision tree is function of number of records and the number of attributes in the particular what of the data you can taken for that one. So let's see how we can do the same thing during the practical. But again, I have to just copy this code over here because we have to just simply replace the decision tree over here from the library like one. So basically here I have to take a simple decision tree, and after that we have to simple take a decision tree classifier over here. So for that one we have to take an decision tree classifier. So that's how we can develop this one. And also whenever we have to provide some more criteria, so we are able to take some depth. So here I want to taking maximum depth is equals to 14. So that is your individual choice, like what type of depth you want to take it, you can further take it that one. So based upon that, if you can see here, if you can compare the comparison between the KNN and the decision tree. So here we are getting an idea, somewhere decision tree was good and somewhere KNN was good, but as compared to KNN and decision tree, the logistic regression are not good because in every sections there somewhere, see if you can see, just only compare this and this one, so at the same time KNN should be better, but further tables the particularly decision tree classifier should be work good. In fact, with the result of 81.6 percentage, this is the level of accuracy expected for a simple one as well. So let's find out some of the feature importance based upon a decision tree. So we already created the things like a feature importance, a particular type of parameter we already created, or a functions we already created like feature importance. Here we have to evaluate the feature importance based upon a decision tree classifier. Okay, so that's why it should imported, yeah, important over here, like, and also we are able to try to provide any type of the depth, and that is the maximum depth is there. So maximum depth is equals to 14 is there, and now we have to run this code, but we are getting an error. I think there is some error, something is based upon a particular spelling. So again, name model is not defined and importance is equals to model. Okay, because we have to further we have to always use models. Okay, so that's why it should not be worked. Okay, so here we are just only use, or we have to change the name as well, as if we can change in first and second line as model and model, so we can also do the same thing. So here we have to do just simple model is equals to models, and then from also we have to remove as, and now we have to run this code and let's check it out, we are getting proper output or not. So here if you can see, here we are getting everything should be run and it should take some time to running completion. Okay, so once the running should completed, yes, now we are getting some final output. So here you are getting idea like what are the features and what are the importance and what are the some importance. So that's how we can get an idea which features are more important and which features are not much important. So basically this type of chart can give us an idea like which whatever the features are important during our any type of the coding. So feature importance is a very important part over this project. Okay, so basically this project is completed over here because these projects are having some different variations are there. In the starting of this project, we can start with the data set handling, and also first of all import the libraries, then import the data set. And many times we are working with the data pre-processing part, data treatment part, as well as we can work with the visualization part as well as. And in that particular visualization part, we can also discuss something based upon how imbalanced data set should be handled, because basically here we had worked with the imbalanced data set with the smooth things, like at the same time sampling over technique we should use. And based upon that we have to create modeling, and on a modeling we can test it logistic regression as well as decision tree and the k-nearest neighbor type of the machine learning techniques we can implement it.